Hello everyone, welcome to this video on DevOps course for beginners. Today in this video, you will be learning on how to become a DevOps engineer and how you can prepare for the DevOps jobs for 2025. So let's get started. So the first thing that you will be learning is why DevOps and what is DevOps exactly, followed by the different tools that you have to learn in order to create a DevOps pipeline. Once that is done, we'll go ahead and talk about the most important concept in DevOps, which is version control. So we'll understand why version control, what is version control exactly, and how you can use version control to enable your development team to work on different workflows and make them work more collaboratively. Once that is done, we'll move on and talk about containerization using Docker. So here you'll understand how you can containerize any web application or application for that matter and containerize it and finally orchestrate it so that it can deploy on tools like Docker Swarm or Kubernetes. Once that is done, you'll go ahead and understand CI/CD, and that CI/CD is nothing but DevOps pipelines and how you can create that using Jenkins. Once that is done, we'll move on and talk about Terraform. So Terraform is basically infrastructure as a code tool, which will help you to automate your infrastructure and deploy thousands of servers just by writing code, right? And that is possible using Terraform. So how to do that is something that you will learn in this particular section. Once that is done, we'll understand the most important concept in a DevOps pipeline, which is monitoring. So how you can monitor your applications, how you can give notifications to the required stakeholders once your application goes down is something that you'll learn in this section. And you're going to learn monitoring using tools like Prometheus and Grafana. So guys, this is the agenda for this video. I hope it is clear to you. Now let's go ahead and get started with the first topic, which is what is DevOps. Alright guys, so before we go ahead and understand what is DevOps exactly, let's go and see why DevOps is actually required in the industry, right? So for this example, let's take the example of a tech team where there are two kind of profiles. One set of people are developers and one set of people are operations people. Who are developers? Developers are people who are basically going to code, right? And the operations team is going to help the developers take that code and deploy on the production system. Now, in this workflow, there are a lot of problems. Let's understand what those problems are. And through these problems, you will understand what is DevOps. Okay. So please pay attention. So the first thing is, of course, the developer will code the application and he will give it to the operations team. Okay, brother, this code is done. Can you go ahead and deploy it on either your test server or your production server, right? So operations team will try it and they will say, yeah, my code is not running. What is it that is wrong in your code because of which it is not running on my system? The developer will say it is running on my system. It doesn't matter to me if it is not running on your system. Definitely there is some problem with your system. Go ahead and fix it. And like this back and forth keeps on continuing. Now add to this the problem of the developers finishing the code at 11 p.m. in the night and the operations guy not available at that moment to deploy the code, right? So imagine yourself being the developer and your manager has told you that you have to finish this work today and get it deployed on the test server so that he can come in the morning and he can approve it. Now, the problem is you cannot deploy the code without the help of the operations team if you're not in a DevOps setup. So the two problems that we discussed, one, that the code is running on the developer system, but not on the test system or the production server. This is where problem number one is. And why this problem happens is usually because the environment mismatches, right? For example, you probably are running Python 3.13 and probably on the production server, it is some older version of Python, right? Similarly, if you are dependent on the operations team, then you have to deploy the code when the operations team is present, right? Which again creates a bottleneck, creates a problem for you where you are dependent on somebody else to know whether your code is actually going to work also or not, right? And this is the problem that we are trying to solve using DevOps. Now, how is it solved using DevOps? Let's go ahead and understand, right? So what is DevOps exactly and how it is helping the developers of the new age? Let's discuss that. So DevOps is a life cycle wherein you have a certain set of tools which basically solve whatever you see on the diagram, right? So you have a specific tool which can help you to code and do a version control on it. There is a specific tool which can help you to plan things out, right? There's a specific tool which can help you to build applications, test applications, release applications, deploy applications, operate applications, and even monitor them, right? The first step in DevOps is code, right? And here the tool that we're using is Git. So in the next video, what you're going to see is what is Git exactly, how you can use it in DevOps, and how you can do version control with Git, which is actually solving one more important hurdle in development, which you're going to understand as we move along. Today in this session, we are going to understand Git, which is a very essential skill set for DevOps engineers, right? In anything in life, if you have to do with code, you should know Git. So how we are going to learn it? Let's go ahead and understand. So we're going to start this session by first understanding what is version control and then move on to discuss the different types of version control systems which are out there, right? Then you're going to get introduced to Git. You'll understand Git lifecycle, the common Git commands, merging in Git, resolving merge conflicts, and finally Git workflow. So if you are able to do this, guys, you know enough in Git to get started as a career in DevOps engineer. All right. So let's go ahead and get started with the first topic, which is what is version control. So what is version control? So guys, imagine if you are working on a document, right? Let's put aside code. Let's say you're working on a document and you're writing an article. Okay. If you are writing an article on your own, whatever time it will take you to bring that article, you know what to put there, you know what your thoughts are. And by the end of it, when you complete it, you will have it exactly as you planned, right? You will do the revisions, you will check for errors, etc. You will do that on your own. But imagine now you have to work in a team. You have 3 to 4 people that you have to work with, and all of them you have tasked with helping you in this article. So obviously, you would not want them to go ahead and straight away work on the sections of that article. You would want them to write it and then probably get it reviewed by you, right? And since 4 people are going to work on it, I'm assuming everybody will have a separate section that they will work on. And final article would be after your approval when you merge all the changes, when you merge all the sections of the different people who have written them, and then you'll get an article. This is what you will do, right? Now think of it in code when you have thousands of files and you have hundreds of developers who have to work with you, right? And this is where version control comes as the biggest blessing. So what is version control? Version control helps you to record and manage changes to your documents, right? Computer programs. It basically will help you to track changes when there are multiple people who work on a particular project. Very simple. This is what version control is. Now, let's understand what were the problems before version control. I gave you a very good example of articles. Let's understand from a developer's perspective what were the problems. So let's say you are developer A, right? You are basically opening your own startup and you want to develop a software. So what do? You create the first version of the software on your own and everything looks perfect according to you. Now you probably launch that software and now a lot of people are using it, but you know there are a lot of unfinished things or there are a lot of features which can be added to this software. So what do? You hire a team and you give every one of your team members your code and tell them, okay, so you develop the login area, you probably develop some part of the website, you develop the other part of the website, right? So you will do that. Now, when you do this, what will happen? So the developer B will work on your code, developer C will work on your code, and developer D will work on your code. Now they will do their own changes. Okay. So let's take a scenario that developer B is done with their work, right? Let's say they call their version 2. So they're done with their work and they give it to you for approval. You check the code, you think everything is fine. You move it to the production server, and now there's a version 2 which is deployed on your production server. Okay. Now, when this was happening, developer C was also done with his work. Now, what is the task that you have to do here? First, you have to check the developer C's work. If it is good, you have to integrate it with developer B's work, right? Because whatever changes he has done, he doesn't have the changes that developer B has, right? So both their changes you will have to take into account and then you'll have to deploy it onto production server. Similarly, that would be the case for developer D as well. Now, what are the problems here, right? First of all, the versioning is manual. So obviously, whatever work developer B has given or C has given or D has given, you're probably logging it in an Excel sheet and everything is manual, right? You're merging it manually, etc. So team collaboration is a time consuming task because imagine you just have 3 people right now and your time is just going in merging code, right? Approving changes and just uploading to production server. But imagine when you have hundreds of developers who are working on a certain product, what is going to happen? So that is again a problem. Third is there's no easy access to previous versions. So let's say developer D did some mess up. You checked his code 3 days back, it was working, but now he did some changes because of his code is not working, right? So now you want to revert it to 3 days back when the code was actually working because you have a deadline for today. How will you do it? Now, if developer D probably had saved everything, save all the files, in a sequential order. Okay, so this is what I did on day 2, day 3, day 4, day 5, day 6. Maybe in that case you'd be able to recover it, but it is very difficult if there is no software who's taking a track of whatever you're doing, right? So these are some problems which were there before version control, and these are very real problems which will happen if you don't track your software, right? Now, why did version control come into the place? So first of all, it does versioning automatically. It's a no-brainer. Very good. Team collaboration is simple. Why? Because it merges the code also for you. You don't have to spend your time in, merging the files, checking if they're working. Git understands, okay, so these are the lines that have been changed. So it automatically merges the code, and wherever it is not able to merge, it tells you, okay, I'm not able to merge here, please help. So that's basically called a merge conflict. We'll talk about it as we move along. There's easy access to previous versions. Everything that you commit, let's say I'm ending my day today, I'll commit on Git. So every day if I'm doing the same, even 100 days back, if I want to go back to my code, I can easily do that, right? And storage, right? So if you were talking about before version control, multiple versions were taking a lot of space, right? Why were they taking a lot of space? Because every day's code probably you were saving in a new file. But here, what is going to happen is only the changes which you have done. Let's say you've added 3 lines of code today. Only those 3 lines will be saved as a new version, not the entire code again, right? So this actually saves a lot of space when you look at it from a long end. So these were the advantages that version control has, and it's a no-brainer. So version control is very important, and all the things which were problems before version control, they are actually being solved using version control, right? So up till now, what we understand is version control is something that is required. Now, when we understand, okay, version control is something that I want to do, which version control system should I go for? There are 2 types of version control system. One is a central version control system, which is this one. And then we have a distributed version control system, which is this one. Okay. So what is the difference between the two? So in central version control system, what happens is there is one server which has your entire code. Okay. So what you have to do is just take the files, do the changes in the files, directly upload it on the remote. Then your manager will probably approve what files to take, what not to take. And this way, this server saves all your changes. So this is what central version control system is. Then you have a distributed version control system. Now here what happened? You have a central server. What you can do with the central server is you cannot just send one file. What you'll have to do is you'll have to first take an exact copy of that remote repository on your local system. So on your local system, you'll have the exact copy of the code which is there on the remote repository. And in that exact copy, you will just take the files that you have to change and then commit and then save it in this local repository. Once your local repository is clean, once it has the code that you want, it is working perfectly, then you sync it with your remote repository. Okay. Now, both these architectures have their advantages and their disadvantages. Let's talk a little about them. So, what is central version control system? What did we discuss? It has one single copy of code in the central server, and the developers will have to commit their changes in this central server itself. They don't have an option to save it on their local repository, the entire code, and then push the code, right? They will have to only send the changes which they have done, right? Third is committing a change simply means recording the change in the, okay. So if I changed a file and I know this file is working now, it has been approved by my manager, all I have to do is I have to just send it to the remote repository and it will keep a track of, okay, this file has been sent by developer A or B or C, whoever you are. And then it keeps a version. Okay, previous version was this is the new version. Okay. Now comes distributed version control system. Okay, now very big disadvantage in central version control system is that if you are not connected to the internet, right, you will not be able to commit to remote repository or you will not be able to save your code. Okay, remote repository, of course, you need internet connection, but if you do not have internet connection, your versioning cannot happen. However, when you talk about distributed version control system, since you're taking a copy of the remote repository on your system, it's like your remote repository exists in your system also, and you can do versioning over there. And once the versioning is complete, whenever you want, you can actually sync it with the remote repository. So let's say you committed 4 times or you created 4 versions in your local system today or maybe in 3 days, right? After the third day, what you can do is you can upload all these 3 versions to your remote repository, and remote repository will take these 3 versions separate. So it will know, okay, on May, let's say you worked on May 1st and 2nd and 3rd. It will know on May 1st you did this, on May 2nd you did this, and in May 3rd you did this. Okay. So this is what distributed version control system is. Now, if you were to just bifurcate it, understand the exact differences between the two, everything except pushing and pulling can be done without internet connection. Okay. Pushing and pulling basically means pushing to the remote repository, pulling from the remote repository, except that everything can be done on distributed version control system. However, in central version control system, you need a dedicated internet connection. Second is every developer has full version history on the local hard drive. That basically means if I want to know what you did on a previous day, I will have that version history also, so that I can check with you probably. Okay, you made these changes. Can you help me out? But in centralized, developers just have the working copy. In a centralized version control system, I will not have the version history of everyone. I will just have my working copy. If I have to check the version history, I'll have to go to the central version control system, and only from there I can see like the entire version history. So this is again one difference. Third is committing and retrieving action is faster because, of course, you're dealing with your local repository in the distributed version control system. So if you have to change a file, if you have to version that file, all these actions will happen very fast because you're doing it on your local repo. However, when you're doing it on a centralized version control system, these things will take a little time because you are dealing with internet. Correct? So distributed version control system is not good for storing large files, which are binary in nature. Binary files basically means, let's say your photos or your videos or your PPTs or your Excel sheets. These are all binary files, right? Non-binary files basically means your code files. So distributed version control system is not good for storing large files. Why? Because if you are storing on your local the exact copy which is there on the remote repository, the size is actually going to be very large, right? When you compare it with the centralized version control system, it is good for storing large files because you will just have your files on your system. You don't have to have the entire repository from the so that's an advantage in centralized VCS. And in distributed VCS, if a project has a lot of commits, downloading them may take a lot of time. Now, if let's say there's a project which has been going on since 10 years, of course there'll be thousands of commits which have been happened on that, right? So it might be a problem on a distributed version control system, but because on a centralized version control system you don't have those problems, so it you just have to download the file, work on the file, and then upload it. So these problems do not come there. Okay. So what are the examples of central version control system? You have a software called Apache Subversion. Then you have something called Helix Core, right? What is Apache Subversion? It is a centralized version control system. You can use it to probably handle binary files, like I said. If you have Excel sheets, anything which is non-code, if you are dealing with it, you can probably use Subversion for that. Disadvantage we've already discussed. We need an internet connection. Is not version history is not downloaded. It is slower than distributed version control system because you would have to directly deal with the central server, and conflicts have to be resolved manually, right? Even in distributed version control systems, some conflicts will have to be resolved manually, but most of the conflicts will, it's a simple addition. In let's say in 100 line of code, you want to add 5 lines of code, that automatically it can take care. But here, even if you're changing, let's say you have an Excel sheet and you added one row, so here you have to take care of that merge conflict yourself, right? You have to see, okay, this is the change, this is the file that I have to add, and that is how you be managing it. Okay, now what are the examples of distributed version control system? You have a software called Perforce, you have Mercurial, you have Git, right? But today we are going to talk about Git. Why are we going to talk about Git? Simple reason is, if you just take Perforce and if you take Mercurial, and if you do a Google Trends search, which term is actually being searched more on Google, the straight away answer over here is Git, right? Why? Because probably if you want to download Git, you'll be searching Git. If you probably want to search something that you were not understanding in Git, you'll have to search for Git. So by this, we can keep a very good estimate. There are a lot of people who are using Git compared to Mercurial or Perforce. So that gives you an idea. Okay, since a lot of people are making use of Git, chances are if you are also going to make use of Git, the jobs that you would be applying for, right? Probably most of those jobs would be using Git. Why? Because most people use Git. Okay. So that is why we're going to start with Git. So that is the only reason. It's not like the other tools are bad. It's nothing like that. It's just that Git is more adopted, and that is why we want to learn about it. Okay. So what is Git? Git is a version control system, which is a distributed version control system, which can help you to track code files right? And like I said, it works exactly as how we discussed a distributed version control system works. You have a local repository where you'll be keeping changes or you'll be keeping a track of the files. And that local repository at the end is synced with the remote repository when you need to save the files. Okay. All right. So now you have an introduction. You know what Git is. Very good. Now there's a time, enough with theory. Now there's a time that you have to understand how Git works. Okay. So be very attentive over here. So what is the Git lifecycle? So there are three stages in the Git lifecycle. First stage is the working directory stage. Then you have the staging area stage, and then you have the commit stage. Okay. If any code file you are working on, it has to go through all these three stages in order for it to get versioned, right? Or get saved or get tracked by Git. So let's understand one by one what each of these stages are. Okay, let's start with working directory. So imagine it like this. If you have a folder, a simple folder, you just go on your desktop, create a folder. That folder is not a working directory, even if you have code in it. Okay. According to Git, a working directory is a directory where you tell Git, okay, I am going to save my code over here. How will that happen? There is a command called git init, which basically means initialize Git in this folder. Okay. So what you have to do is you have to do a git init, and through that, that directory will become a Git directory, right? If I were to quickly show you how that works, okay, so this is my VS code. Okay, there's a folder called Git here. All right, let's create a file here. Let's create a text file, and let's call this file, let's say hello.py. All right. Now, what does this hello.py will do? Let's say it will print hello world. Okay. Now, what will I do? I just save this file. So once I've saved this, now what do I do? So this is still not a Git repository, by the way. The moment I type in git init, this is a command which will help you to tell Git that I want to track this folder. Okay. If I do a git init, it says initialized empty Git repository in whatever folder we are in. And there is a .git file which gets created inside this folder. The moment you have a .git file in your folder, you call it a working directory. Okay. So now I've not saved anything in Git right now. This file is saved on my local hard disk, but Git is not tracking this as of now. How do you know? I'll just have to type in git status, right? And you can see here that these files are untracked currently. So if you want to track it, the next stage is that you'll have to do a staging area. How do you track this file in the staging area? There is a command called git add. Now, as of now, nothing is saved in Git. Okay. This is a clean working directory. Git is not tracking my hello.py file. If I wanted to track, then I will have to use a command called git add. And if I track it, then basically it's called my staging area. So I can have multiple files there, right? I can have hello1.py as well. I can have hello2.py as well, right? But what I can do is I can tell Git that I only want to track one file. So let's say I want to only track git add.py, right? So now if I do a git status, what is happening? Hello1 and hello2 are not tracked, and this is tracked. And it is saying changes to be committed. So this is my staging area and this is my working directory. Okay, coming back to my slide. So I hope this is clear that what is a staging area and what is a working directory. If you don't have to get into commands, I'll anyways discuss those commands with you in detail. As of now, just understand what is a working directory and what is a staging area. So what is a working directory? A folder where you have done git init is called your working directory. Okay. A folder where you do not have git init, even though your code is there, is not called a working directory. Then what is the staging area? Once we put files which are ready to be committed by using the command git add, once we say, okay, among all the 1,000 files that I have, I actually want to track only one file. So that one file goes into your staging area. Okay. So that's what staging area is. So basically it's a safe area where we tell, okay, if I am at any point in time, if I'm doing git commit, I actually want to just save the files which are there in my staging area, not other places. Now, why do we have a staging area? Why do we have a working directory separately? Is because sometimes in code, you do not have all the essential files. Like for example, there can be build files. Sometimes there can be images, right? For images, let's say you are actually putting it in some other kind of storage, maybe let's say S3 or somewhere else. So in those cases, I do not want to track all my repository, because in that case, what will happen is my images will also get uploaded to Git, which I do not want, right? Because I just want to keep my code over there. So to do this segregation, we have a working directory and we have a staging area. Now, of course, if you don't put your images in your folder, your file which you have to run, let's say we are developing a website, your file will show a lot of errors. Why will it show a lot of errors? Because it needs those images to run, correct? So that's why when you're staging only the code and then you commit it, right? But you keep those other files also in your working directory in order for the code to run. So those are just supporting files which need not be uploaded to Git. Okay. Now, once staging area is done, the next thing that you have to know about is commit. What is commit? So once you have put the files which according to you are done, you're done with your work, and you want to tell Git, okay, please save this version. I may need it in the future, or please save this version. I want to give it to my manager for review. Then you commit it. Okay. Once you commit it, it is still on your local disk. It has not gone anywhere. It has not gone to a remote repository. It is still on your system, but Git is now considering it as tracked. So tomorrow, if you sync your local repository with your remote repository, then all these files will go to your remote repository. Which files? Which are committed in your local repository. Okay. So that is why you commit it. It will become more clear to you as we move along. But just to show you, if you were to do the same thing on a Git terminal. So you see now hello.py is staged. So I'll just type in git commit -m. -m basically means message. And let's say this is my first commit. Okay. Commit is done. So now if you want to check if your files are committed, you just have to do a git status. And here you can see that hello1 and hello.2.py are untracked files. And on branch master, nothing added to commit. Why? Because it has already been committed. Now, how can you check whether it has been committed? Just type git log and it will show you that this is the commit that has happened and this is the message that I have given. And in this commit, my files are stored, right? You will see in the future how we can see these files, but good. You have successfully committed your file. So coming back to my slide, you understood what commit is, you understood what staging area is, you understood what a working directory is. Good. Now your basics are clear about Git. Okay. Now I want you to understand how it will work once you connect it to production environment, right? Once you have saved it on your local file, what will happen now? So you had your program workspace, right? You made it a working directory by initializing Git. After that, you stage files by doing a Git add, and then you committed it to your local repository. But what is the next step? How will you give it to your manager now? So to give to your manager, you will have to upload it to GitHub. Now, how will you upload it to GitHub? First of all, why your manager will be able to see it on GitHub? Because GitHub is basically a website which is there on the internet, right? If you want other people to access, for example, you would have used Google Drive. If you have any document on your local and you want it to be shared with your friends or with your teachers or with your colleagues, what do you have to do? You have to upload that file on Google Drive. You'll get a link. You share that link with those people. So similarly, I'll have to upload whatever commit I've done to GitHub, and then only my team will be able to see it. Okay. So that is what Git pushes, and this is the last step in Git life cycle. All right, guys. So now let's go ahead and understand how Git actually works, right? So any project which is saved on Git is saved using a commit. All right. So let's say there are 6 files. You have a website which you are creating, and there are 6 files in that website, right? If you want to save it on Git, what you will do, you will go ahead and type in git commit and it will get saved as a commit. Every commit will have an ID, and that ID is basically an alphanumeric number which uniquely identifies that particular commit. Okay. So you save those files. In this commit, all these files are saved. Now you go ahead and add another file. Let's say you change some code or you add another file. And when you go ahead and you save it on Git, again, it will be saved as a new commit ID. Okay. Any change, any minute change, even if you're changing a character, even if you're changing one line, even if you're changing 10,000 lines, if you're going to commit after that, it will be going to save into one extra commit, which is going to come out, right? Now, these commits are arranged on a timeline. What is this timeline called? It's basically called a branch. And the head compartment, the head of the Git basically points to the latest commit, right? So if whatever you're seeing in your workspace or whatever you're seeing in your folder, that folder you're able to see because the head is pointing towards that commit. Now the head can point towards the previous commit also. If the head is pointing towards the previous commit, you will see the files which were there in the previous commit. All right. So that's what a branch and a head is. So by default, when you create, when you do a commit on Git, the very first branch is the master branch. After that, you can create as many branches as you want, but there's always a master branch in Git, right? What is a branch? Branch is nothing but a timeline of commits. Okay. But why do we need a branch? Let's shed a light on that. So let's say you have the master branch and now you have 3, 4 developers whom you want to collaborate with, right? So what do? You take your website and you say, okay, so there are 4 features that I want to develop. And these 4 features, I want it to be distributed among whatever number of developers you have. So all these features, what you can do is you can divide it among branches. Why branches? Because when you will be learning DevOps, you will understand that the master branch is always the branch which has the live code, which has code which is deployed on the production server, right? So let's, for simplicity's sake, understand it like this, that whatever is there on the master branch, it will automatically be there on your production server. Now, if that is the case, you obviously would not want your master branch to have test code, right? So let's say you're developing feature A. Now, obviously, you cannot work like this that whatever you write becomes a feature. Obviously, you'll test it first. You'll encounter some problems. You'll try out different ways to reach a particular solution, right? So all that testing, all that research, all that development that has to happen, it happens on a separate branch and not the master branch, just to isolate between real working code and code which is work in progress, right? So this is why you have a separate branch other than master branch. Now let's talk about why will we have different feature branches? Why can't we have just one branch where everybody is doing their own work, right? So simple reason for that is, let's say I am developer A and you are developer B, right? I have been assigned to work on the login task. You have been assigned to work on the, let's say, the footer of the website. So when I'm designing the login page, obviously I will need a code reference which is working, right? And on top of that, I'm going to develop. You also will need a code reference on top of which you will be developing. Now, every day you come and you constantly see changes that I am doing, you'll probably end up getting demotivated because every time you'll have to change the logic of your work. Why? Because whatever I'm doing, it is changing that dependency of the previous code that you had, right? So that's why all features are basically separated on different feature branches. And once a feature is completed, that in isolation, it is checked. If it is perfect, it is moved to the master branch, and other features, if they are also perfect, they are also moved to the master branch. When I say they are moved to the master branch, what I basically mean is that they are merged with the master branch. All these features are combined and they are merged with the master branch. This combination is basically called a merge, right? Okay. So let's say you have the master branch, you basically create a feature branch out of it. So what this feature branch will look like is it will have the same commit as the master branch, and anything that you change here now, it is going to be on a separate timeline, not on the timeline of the master branch, but on a separate timeline, which is isolated from the master branch. Okay. And once this feature is verified, it is approved by a manager, you merge it with the master, and now the master has all the changes that you had on your feature A branch. And of course, since this is synced with your production server, now your production server will also have the feature A included in the website, right? So now let's go ahead and talk about the common Git commands that you have to use in order to be a pro in Git, right? So let's start and understand like what are the different type of commands which are out there. Now there are 4 types of command, guys. One is create repository. There are commands which help you to create a repository. There are commands which help you to make changes in a repository. There are commands which help you to do parallel development, and there are commands which help you to sync repositories. So we'll go one by one, we'll understand each of these commands, and then we'll go ahead and implement it. All right, so let's start with creating a repository. So if you have to create a repository, the command is git init. What you have to do is open any folder, open any code, and if you want to track it, just type it git init in that folder, and now that folder becomes your working directory, right? We discussed about Git lifecycle. There are 3 stages. We have working directory, we have staging area, and then you have commit, right? Where you commit the code. So working directory is when you initialize the Git repository. Staging area is where you finalize the files which are ready to be Git committed, and then you commit the files. All right. So these are 3 stages. So again, when you're creating a repository, what you're basically doing is you're creating a working directory. Now in this working directory, now you will be staging the files which basically you want to commit, and those commands will actually come under making changes, because now you're making changes to the Git file system. So you created the Git file system using git init, and now in making changes, the first command that you have to know is git status. What does git status tell you? Git status basically helps you to identify what is the tracking status of the files. Are the files untracked? Are the files staged? Are the files committed? So all these things you can know using the git status command. The next command is git add. What does git add do? And don't worry guys, we will be showing you hands-on for this. This is just for your understanding so that when we do the hands-on, all of these will make sense to you. So what is the git add command? Git add command basically helps you to stage the files, right? So we'll take a pause here. We'll quickly go to our VS Code, and there are a few folders created here. So let me just remove everything. Okay. So let me just come out of this folder as well. So for our current hands-on, what we'll do is let's go to a new window. Let me open a new folder. And let's say on desktop, I am going to create a new folder. Let's call that folder as Git tutorial. Okay. Let's call this as Git tutorial. All right. Let's select this folder. And now we are in Git tutorial. So let's create different folders for understanding what we have to do, right? So first, let's create a folder for me, and then I'll create folders for my developers. So basically, these are different workspaces that we'll be working with. Okay. So let's create a folder for me. Let's say I'm developer main. Okay. I am the guy who probably creates the first version of the code. So I'm the main developer. And here, let me add a file. Let me add index.html. Okay. And here, let me quickly put the HTML text. So let's say HTML, then I'll put a body tag, right? And body tag, let me write hello from GitHub, hello from Git, okay? And let me put this under H1 so that it will be a little bigger. Great, I'll save this. And if we go ahead and see this on a browser, so this is your website, okay? Now, this is my version 1 of the website, and I want to track it using Git. And then I want to give it to my developers so that they can go ahead and start working on it on basis the features that I asked them to develop, okay? So coming back to my VS Code, let me open the terminal. So let me open Git Bash. Perfect. So now I'm in Git Bash. I am in the Git tutorial folder. Let me go to the developer main folder, okay? And what is the first thing that I'll do? I'll basically initialize it as a Git repository. So let me do a Git init. Perfect. I've done Git init. What is the next step that I have to do? So I'll check a Git status. Okay, I can see that I have one file which is index.html that I just created, and it is untracked. Now, how do I stage it? The command is git add. What will this do? This will stage the file. This will tell Git, okay, these files are ready to get committed. Now, if I do a git status, you can see the file is staged. So what did we learn? We learned git init, we learned git status, and we learned git add. Git init will initialize a repository for you. Git status will basically tell you what is the status of the files which are there in your Git repository. And then git add will actually stage the files for you. Okay. Now let's go ahead. Okay. I spoke to you about git add. What will git add do? Since no files are being tracked right now, let us stage these files. And for that, enter the command git add. What will git add do? If you want to track all the files in the project folder, we can type the command git add dot. Now it will stage the files, and now Git has started tracking these files. Now, what is the next step? Next step is to commit these files. Now, to commit, the command is git commit -m, and then you put a custom message which will commit these files. And after that, once you've committed the file, the next step would be to share it over GitHub or share it over the internet so that your other developers can actually copy from it. And we are going to do this in a while, right? So let's do everything that we have learned so far. For syncing repositories, the command is git remote add origin, and then you add the URL of the repository. With what URL of the repository are we speaking about? So let's go to our browser. Okay. So these are all the repositories that you have. So let's create a repository for ourselves. Let's create a new repository. Let's call this repository as test-website. Okay. We'll be uploading all our code over here. This is the repository. Even you guys can visit this particular link and you can see this repository. Okay. So right now there's nothing on this repository, and we're going to upload our code which we have just created on this repository in a while. All right. So let's go ahead and see how we can do that. So let me go to my VS Code. So I have staged the files. Now let me commit it. So git commit -m, and this I'll just pass a message. Maven website. This is the version 1 of the website. I've committed it. Now will it be there on the GitHub? Well, the answer is no, because now everything is saved on my local. Okay. Now from my local, I want to go ahead and upload it on GitHub. So first of all, let me show what git status will now show you. Git status will say everything is okay, working tree is clean. There are no files which are not committed. Okay. Now let's go ahead and add origin. So git remote is nothing but a remote repository. Add origin. Origin is nothing but a variable name. Okay. So git remote add origin, and now you enter the URL of the repository. Let me enter the URL of the repository. So this is the URL. Let me copy this. Great. Now the URL has been added. What is the next step? Next step is to push our code on this repository. How can we do that? So let's do a git push origin master. Now I'll get an error and we'll see how we can resolve that error. First, tell me what this error says. Git push origin master. It says permission to HSHAR test website.git denied to HSHAR. HSHAR is nothing but my account. I have been denied access to this particular Git repository. Why? Well, the reason is my Git terminal is not authenticated to GitHub as of now. Let's see how we can do that. So usually if you pass this command again, okay, it will still give you an error, no problem. So now what we can do is we can go ahead and give permission to ourselves. For that, what you'll have to do is you'll have to click on top right, you'll have to go to settings, okay? Then you will have to go to developer settings. And here you'll have to click on personal access tokens. Click on tokens classic. Or actually, let's go with fine-grained tokens. Difference between token classic is token classic gives you a blanket access. Fine-grained tokens give you very specific access. Now, this is a token that I created a while back. Okay, so if you want to create a just new token, just click here, enter the token name, right? Just click on generate token, a token will be created. Now, I already have a token, but this token is also not working. The reason is that it has access to a different repository. So I'll have to give it access to my repository. My repository is test website. So test-website. Okay. Let me move this. Let me check what is the name of my repository. So for that, I'll probably just push it again. And here it will tell me, okay, my website name is testwebsite.git. Okay, no problem. So select repositories, test-website. Okay, it says there are no repositories. Let me see why that is the case. So I'll go to this token again. I'll click on edit. I'll click on repositories, type in HSHAR, or let me just type in test. Yeah. So I have test website here. Let me select that. Okay. So I have access to website. Now I have access to test website also. Repository permissions. Now this is very important. You have to give yourself permission to edit the content. So read and write the content, select this, and then finally click on update. Okay. Verify that you have access to the repository. Just click on your token again. It says you have access. Perfect. Now what I can do is let me just regenerate this token. Regenerate token. And here you can see I've got a token again. Okay. So this token I have to enter here. So if I do a git push origin master, it says authentication failed. No problem. If I do it again, now it will give me a pop-up. Okay. So let's wait for that pop-up. Here's the pop-up. You have to click on token and then you have to enter this token. Okay. Enter this token, click on sign in, and if everything goes well, it will write your files to this particular repository. So it has written the file. It says writing objects 100% 3 out of 3. Everything has been published. If I go back to my repository, let's go to test website. Okay. You can see in test website, now I have an index.html, but it says 5 minutes ago. Why is it saying 5 minutes ago? Because 5 minutes ago, the commit was made. So it will always show you the time when the commit was made, not when it was pushed. Okay. So now on this particular link, if you guys are also going, you will be able to see this index.html. Now, what do I want? I want my developers also to be able to work on it. How can they work on it? Let's go ahead and understand. So let's say this is my workspace. Now let's take a scenario. Let's create a folder or let's create a workspace for my developer also. And let's assume he's on some other system. He basically is having his workspace and he creates a folder, which is developer 2. Okay, let's close everything. And in our terminal also, let me go inside developer 2 folder now. So cd developer 2, cd developer. I want to go to, okay, developer -2. Great. So I'm in the developer 2 folder. And I want whatever the main developer has worked on, I want that to come into my repository. Now, how will it come? It will come by git clone. If I do a git clone, what will happen? I can copy this repository. So let me do a git clone. What happened? See, in developer 2, automatically there's a folder which has been created, which is called test website. And there's a index.html which has come. So now what we are able to do is from a repository which is there on the internet, we have been able to get the code in my VS Code. And now I can go ahead and play around with it. So right now, let me go inside developer 2 folder. So I have index.html in it. Now inside this, I have a folder called test website. Well, let's go inside it. And here I have the index.html. Okay. Now what do I want to check? I want to check git status. It says your branch is up to date with origin master. Now remember guys, we are in developer 2 folder. We did not do git init, but it says your branch is up to date with origin master. How is it able to know that it is up to date with the origin master? The reason is when you do a git clone, along with the files, the git configuration also comes, right? The .git file, which holds all your git data, that also comes. So you don't have to do a git in it in case you're doing a git clone. All right. So now, as a developer, I have been tasked, let's say my feature is that I have to add a background color. So again, let me just copy this path and let me go to my browser. This is basically the main developer's website, and this is the website of developer 2. Okay. So I have been tasked of adding a background color. So let me go ahead and add a background color. So style would be equal to background color, and let's give probably a color. Let's give a blue added color. Okay. Let's go back. Let's refresh. And as you can see, now I've added a background color. All right. So my work is done. So if I do a git status, what does it tell me? It will tell me that there's a modified file. What is modified? Index.html is modified. Why? Because I've added this line over there. So I'll say, okay, stage this piece and commit it. But I am on master, guys, right? So what should I do? Let me go ahead and first uncommit. Unstage this. How can I unstage this? Just use this git restore. So let's use this command, git restore dot. Now what would it do? It will unstage all the commands, right? So if I do a git status, okay, it didn't. So git restore staged and then the file name. Yes, done. So now if I do a git status, this file should be untracked, right? So this file is untracked. It is not being tracked. And now what I want to do is I want to go ahead and update this on a branch. So how can I do it? So there is a command called git branch. And through this, what I can do is I can create a branch. So let me create a branch for myself. I'll call this F1, right? And how do you switch to a branch? The command is git checkout. Git checkout F1. Through this, I can switch to this new branch, which is the F1 branch. So now that I'm on the F1 branch, what is there on the F1 branch? If I do an ls, nothing is there. If I do a git status, I still have modified index.html. Now, once I do it, guys, you will realize the power of branching. So now if I do git add dot and git commit, and I'll add my message, added the background. Cool, done. Changes are committed, right? Now, just see the magic here, guys. So I am in F1 branch and I am on the browser and I do refresh. Nothing changes. Purple color. This is what I did. But what will happen if I check out to master? So the git checkout master, I'll go here, refresh. Again, the white background comes. Why is the white background coming? Why? Because on the master branch, still I have the code which is there on my production server. Okay. So on my master branch, nothing is changing. What has changed is on my F1 branch. So if I again do a git checkout on F1, right? I'll go to my browser, do a refresh, and then I'll see the new changes. Okay. Now, what I want to do is I want to tell my manager or the main developer that, dude, I'm done with my job. Please go ahead and check the code. And if you like it, go ahead and merge it with the master. So how do I tell him, right? So for him to view my code, obviously I'll have to push this branch to my repository. How will I do that? Git push. Where do I want to push it? I want to push it to origin. Origin is, I told you, is the variable where you have the link stored of the repository. And I want to upload to F1. F1 is nothing but the branch that I was working on, the feature 1 branch, right? I hit enter. It'll take some time. And now my code has been pushed to the F1 branch. So if I go to GitHub, right? If I refresh, do you see? There's an index.html, but this is the master branch. If I click here, now I will find the F1 branch also here. If I click on F1 and if I click on index.html, I can see there's a background color blue violet, okay, which has been added. Perfect. Now you will see there's also notification here. F1 had recent pushes 34 seconds in ago. Compare and pull request. What does that mean? So if I do a compare, I can see, okay, there has been a change in this body line. And in this, basically, a style statement has been added. Okay, according to me, this code looks good. So what I do is I'll create a pull request, added the background. This was the title of the message. Okay, I have reviewed the file and the changes look good to me, right? This is the pull request that I'll create now. Now, GitHub is merging this file automatic, right? So merge pull request, confirm merge, and perfect. My file has been merged. So now if I go ahead to my code, right? If I go to my code And if I go to master branches index.html, you will find the background color is now blue violet, right? Now, as a manager, I've done my job. Now, if I go ahead, now this is the manager's workspace. We are in the developer main folder. We are index.html. If I go to the browser, you will still see I have the old code, right? So if I go to the browser, this is the developer main folder. If I refresh, I still have the old code. I want the new code now. So how can I find the new code? I'll just go ahead. I'll switch to my workspace. So let me just close this and let me add a new git bash. Perfect. So let me go to developer main, developer space main or developer main. Okay. I'm in developer main folder. Now in developer main folder, if I do a git status, obviously it will show there's nothing to commit. Everything is okay. So there is a command called git fetch. And what do I want to fetch? I want to fetch the master branch. So if I do a git fetch master, okay, git fetch origin master, what it will do, it will fetch the new changes which have happened. So according to this, you can see the log over here. It says from github.com /test website, branch master, fetch head, and this is probably the commit ID, which is there on the origin master, right? So if I do a git status now, it says nothing to commit. So what I'll have to do is so I understood there is a new change. So git pull origin master. Let me do this. Now my new changes have come to my website and automatically you see my code also has been updated in the developer main, right? So if I go ahead and if I refresh the website, now my local also has the new code, right? So guys, this is how Git basically works. So what I just showed you is how collaboration happens between developers and how they're able to share code between each other for review, and how after review you're able to merge the code in GitHub itself, right? Now there are ways to merge the code on the terminal also, and we're going to talk about it because there is a little science about which code to merge, how to merge it. There are also various ways through which you will be merging the code. So we're going to talk about it in a little while. For now, let's go back to our PPTs. So what did we learn? So we went ahead, we basically added an origin to our repository. Origin is nothing but a variable. We added a URL, right? We then went ahead and pushed our code onto the origin on the master branch. And then we saw on GitHub that we were able to see the files. After that, we cloned the URL. So we became the second developer and I wanted to work on the website that the main developer or my manager wanted me to work on. I cloned the repository. After cloning the repository, I made the changes. I pushed the repository. Then as a manager, now once the changes were pushed, I pulled those changes onto my repository, right? Because as a manager, if you have pushed something on GitHub, how will I know that you pushed something on GitHub? So first I will do a git fetch to check if there's anything new on the GitHub. I see there is something new, then I pull those changes onto my folder. So the command is git pull for that. The git pull command is also used for pulling the latest changes from the repository. And this is exactly what we did, right? Then we also created a git branch, right? Why we wanted to create a git branch was because when I, the developer 2, was working on the feature of adding a background, obviously I did not want to touch the master branch. Why? Because I did not want to change the production server. The production server was pointing to the master branch, right? So what I did was, instead of changing the master branch, I created a F1 branch, and on that I did my changes. And then I pushed this F1 branch onto the GitHub. Then the manager checked the F1 branch. He said, okay, the code looks good. He merged it with the master. And then when he pulled the changes, it got upgraded to my production server or on the link where the main developer's website was also visible. Okay, now there is one more command. In case I want to delete branches, I can delete it using git branch -d. Now, again, if I come back to my terminal, there are two ways to delete a branch, guys. One is git branch -small d, and then there is git branch -D. Now, what is the difference? If I use small d, so I am in main developers branch right now. So let's see if we have any branch right now. We just have the master because we didn't pull F1, right? So if let's say I want to pull F1, so I'll have to do a git branch F1. And here, let me git checkout to F1. And now let me git pull origin F1. Great. So now there is an F1 branch here. So let me check out again to the master, right? I am the main developer, right? I don't need a branch F1. It's good that I see it. It is there, but I don't have any use because I've already merged the changes on master. So how can I delete it? So I'll have to do a git merge -d F1, hit enter. Okay, it says, okay, not git merge, sorry, git branch -d and then F1. Now it deleted the branch. So in case there are new changes on the branch which have not been committed, if I use this command, I'll get an error. Let me show you that. Let me create a new branch, git branch, let's say test. Okay. So in this branch, I will have index.html, same as the master branch. And in this index.html, let me go ahead and make this some other color. Let me make this, or not white, actually, let me make it red. Okay. So if I do a git status here now, git status, I can see that index.html has been modified. So git status, it states, so I'll do a git restore -hyphen stage, and then the file name is index.html. I don't want to stage it. I actually want to commit this in my new branch. So git checkout test. This is my branch, right? Here I want to stage and I want to commit, changed color to red, right? And now if I check out to my master, now obviously on my master, okay, if I do a git status, okay. Now, if I want to go ahead and do a git log will tell me that the last change that we did was a merge pull request to number one from shr/f1, right? This is what my git logs tells me. Now, what I want to do is I want to delete branch. So git branch -d, and I want to delete the test branch. Now, it will give me an error. It says the branch test is not fully merged. If you are sure you want to delete it, run git branch -D and then test. What -D does is it force deletes a branch so that even if you have not merged it, it will still get deleted, right? So let's see if you want to do that. So if I open my main branch index.html, it's still blue violet. And if I show you the test branch, right, it is red. So what it is trying to tell me is that you have a branch where the color you have already changed to red, right? And in your master branch, you have not updated the color to red. Are you sure you want to delete this branch? So yes, I want to delete this branch. So again, if you're trying to delete a branch in which you are, so right now I'm on the test branch, as you can see. If I delete this branch which I'm on, it will again give me an error, even if I'm trying to force delete it. See? Cannot delete branch test used by a work tree. That basically means you are in that branch. So how can you delete it? So I'll have to check out to master first, and then I can delete this branch. But again, if I do a small d, I will not be able to delete it. It'll tell me the branch is not merged. So what I can do is git branch -D test, and then it will delete this branch. See, deleted branches test. So if I do a git branch now, there's only master. So what did we learn? We learned what are branches. We learned how to delete a branch. We learned if I am working as a developer, how I can assign a work to any other developer who can work on his own branch. And once it's done with his work, he can just upload it to GitHub. I will see the changes. I will approve those changes, merge it to master. Then if I want to work again on the file, I can just pull those changes onto my laptop using git pull, right? And once I've pulled those changes, I can again start working on it and do changes and again push it to GitHub in case I want to, right? So this is what branches are. Next command is git checkout. I've already told you if you want to switch your branch, the command is git checkout. Then you have git log. Okay, git log is a very important command, guys. So if I do a git log on the master, you can see I have, this is my latest commit when there was a merge pull request number one from hshir/f1. This merge pull request was created by GitHub, right? So this has also been logged. Then you have a second commit, which is where you basically added a background. This was added on the F1 branch, and this is the same computer. That's why it's showing the author as me. Otherwise, if I was a developer, it would have shown the second developer's name over here. So that basically tells me who changed the background. The background was changed by this particular developer. It also tells me when it was basically changed, which is again amazing, right? Then at this particular time, the V1 of the website was created, which is again amazing, right? So git log gives you an entire history of all the things which have happened on this particular repository. Now there is one more thing, guys. You can git log has a lot of options using which you can actually make things a little more easy for you. For example, there's a command called pretty, and what it does is it can help you to make all the git logs in one line, right? So instead of a verbose explanation, you can see you just get a clean log like this where you will get the message, you will get the commit ID, and it will probably get the branches as well. You also have an option you can actually see the timeline, right? On the PPT, I showed you a timeline like this, right? If you want to see it in the log also, you can see it. So the command is git log and hyphen graph. So if you do hyphen graph, it can basically show you the graph. For example, what happened here? This is my master branch. Okay, on my master branch, I created the V1 website. Then I asked another developer to work on it. What did the developer do? Developer basically created a branch out of the master branch, right? And he added the background on this particular branch, which is the F1 branch. What happened after that? So after that, this F1 branch was merged with master, right? Here in this particular commit, it was merged. And after this, again, there was a commit. So in this particular commit, we had the V1 of the website, right? In this particular commit, we added the background. The developer added the blue violet background. In this particular commit, we basically did a merge request with the master. And who did this? Basically, as you can see, GitHub did it. And that's why the author says hshar@users.noreply.github.com. So it did it. And hence it got merged over here. And when you do a graph, you can clearly see what happened, right? So you added the master branch, it got broken into a branch. That branch, once the commit was done, it got merged back into the master branch, right? So this gives a very good idea to you as to how things are working, right? Perfect. Git log is clear. Now let's go ahead. Let's go back to our slides and let's see after git log what all are there, right? So there is again a command called git stash. Amazing command, guys. So what is git stash? Let's say I am the main developer. I am on my master branch. Do I have any other branches? I don't have any other branch. So let's say I want to go ahead and I want to create a feature too. Okay, so I'll do a git branch F2. Perfect. Now in this F2, let me check out to F2. Now what do I want to do? On the F2 branch, I want to go ahead and let's say I want to add a CSS. So touch style.css. I've added this file. Now in this file, I'm working. Okay. I'm writing code. So I'm adding hash ID and then I'm defining everything. And midway, I get a very important work. Okay. Now I save this file, but I don't want to commit it. So what I do is I actually have to commit something else on this branch. So maybe my manager has asked me to change the color again. So what I do is I'll go to index.html. I'll say, okay, I have to change this color. Let me change it to beige. Okay. Let me save it. So this is done and my style.cs is also saved. Now if I do a git status, what will it say? It says that index.html has been modified and there's a new file called style.css. So if index.html has been modified, this is the change my manager wanted. So I want to go ahead and commit it. So what I can do is I can git add index.html. Only my index.html will be stayed. And now when I do a git commit, my HTML will be saved in F2. Okay. Add the background. Now, my manager tells me actually go to the master branch and there I want you to change something, right? Now, if I have to do that, I obviously do not want my style.css to get lost. So what I do is I'll stash all the files which I have not yet committed to Git. So the command, what is stash? Stash basically says, okay, you have untracked files. Let me clear your working directory of all the files which you have not saved in Git right now. And if you want it later, I'll give it back to you. Why? Because if you have a file which is basically not tracked in Git, it might create problems for the other files which are there. Reason being, maybe this file is not complete yet. And that's why you don't want to actually keep a part of Git, because obviously whatever you're committing in Git should be complete in some sense so that that particular commit becomes the milestone for you. Right. But this is something which I am working on. And suddenly, because I got some work which I have to change, I went ahead and let's say I want to now go to master. I want to do some work. Okay. I'll do that work. And you can see I don't see the style.css over here anywhere. Even if I do a git status, I can't see anything. Even if I git checkout to F2 and if I do a git status here also, I can't see the style.css. It says nothing to commit. Working tree is clean. Why? Because it has stashed that file. It has kept it for me for later. Now I find time from my busy day and I want to go ahead and work on that file again. So what I can do is git stash pop. And now my style.css is back in the repository. Now I can continue working on it. And once I feel, yes, now file is ready, I'll go ahead, I'll stage this, git add style.css, right? I'll commit it, added the style sheet. Perfect. And now again, my git log will show that I have a style sheet wala commit, right? Similarly, if I do a git status, it will show that working tree is clean. So guys, this is what stash command can do for you. In case you want to just hide a file because you have not been able to work on it and you don't want to get any errors, because the moment you have a new file, right? Let me create a new file. Let's say trust3.txt. If you are not tracking it in Git, every time you do a Git status, it will actually give you an error that there are untracked files. Correct. So in case you do not want to see these kind of errors, you can actually stash that file. So let me just remove 3.txt as of now. And again, if you do a Git status, now working tree will be clean again. Okay. So this is how you use Git stash. Then you have something called as Git revert. Okay. Now what I did, I added a style sheet, and then I realized, okay, actually this style sheet is causing some problems. So I don't want this. Remember, I told you about head, right? Head is basically where your repository is currently, right? I can also do a checkout on this commit ID, guys. So I'll show you git checkout. And then if I enter this commit ID, what will happen now? It says head is now at another commit. And here you see the style.css is not there, correct? Why it is not there? Because now I'm in a different commit. So if I do a git log again, I can see my head is here, right? The head is over here. The head is on this commit, and even the log that I'm seeing is showing me the logs of what I would see when I was at that particular commit, right? So now, if I want to basically revert a particular commit, let's see how we can do that. So if you want to go to a certain commit, I told you you can use the checkout command to go to that certain commit. Now, if I want to come back to my main head or the latest commit, I'll just do a git checkout F2, right? And I again have that style.css. And if I do a git log, again, you can see I have the latest commit now. Now I want to revert to this particular commit, right? And I want to set this commit as the main commit of my branch. So how can I do that? Maybe because this style.css is causing me problems. So I don't want to deal with the changes. I want to straight away go ahead and revert. So I'll do a git revert. And now I'll paste the commit ID, hit enter. It says this reverts commit. Please enter the commit message for your changes. So commit message that I want to give is added style.css by mistake. Okay. One file changed. And now if I do a git status, it says nothing to commit. And if I do a git log, okay. So what you have to do is you have to enter the commit ID that you want to revert. Sorry, what I did was I reverted the background itself. So probably now you'll see blue added again. I added bees, you remember? So now I don't see the bees thing again. So let's say I want to revert the style sheet. So again, I just copy this. Let me type git revert. Let me type the commit ID. Now here I'll added the style sheet by mistake, right? I'll write and save it. Done. Now if I do a git status, and you can see automatically my style sheet is now gone. It's no longer there. And if I do a git log, I will see revert added the style sheet. This reverts commit, this particular commit, it has been reverted. Now if I want to go back to that particular style sheet again, I can go back, of course. I can just check out this particular commit and I can again merge it to my F1 branch, F2 branch, but I don't want to do that. So what happens is when you do a git revert, automatically a new commit gets created, which now points to the previous commit that you have reverted, right? So guys, this is how you can revert a commit that you don't like. And you can also do a diff. So if I want to know the difference between two commits, I can just type in git diff and the two commit IDs, and I can know the difference between the two. As you can see in the screenshot, it tells you line by line, like what is the difference between the two commits. All right, guys. Understand what is merging branches and how can we go about it. So guys, there are two methods to merge branches. One method is called git merge and the other method is called git rebase. Now let's understand what is the difference between these two. So guys, when you do a git merge, so as a general rule of thumb, when will you use git merge and when will you use git rebase? So git merge is always used on a remote branch. Why? Because it does not change the log or it does not change the history which is there of the particular branch. Remote branch in the sense a branch which is visible to other people also. So if a branch is visible to other people also, that means the history cannot get changed, because if you change the history, other people might get confused as to what is happening, right? So to avoid confusion, we always use git merge on a remote branch, all right? But what is the drawback? The drawback is, you remember I showed you a graph that there'll be a lot of branching and it might get confusing to understand. All right. So that is what git merge is. What does it do? It basically creates a new commit, which is a merger of all the things which has happened on the feature branch, whatever has happened on the secondary branch, and wherever you're merging, those changes come inside one particular commit. And this is a diagram which can help you understand this. Let's say this is the master branch, right? You branched a feature branch from the second commit, and then you added two more commits here. Now, what you want to do is on the master branch, you want to have this commit also, and you want to have these two commits also. How will you have it? You will merge the branch, and when you merge the branch, a new commit is created, and this commit has both these changes. Along with that, this commit also has a track of the previous change, which is there on the master, and of course, the other things as well. Now, on the feature branch, you can go ahead and create more commits, which is going to be independent of what is going to happen on master. But this is what happens when you merge, right? So this is your master branch. This is the timeline for the master branch. This is the timeline for the feature branch. From here, you finalize, okay, feature branch is looking good. Let's merge the changes on master. When you decide to merge the changes on master, whatever you merge, it is created as another new commit. And this new commit is going to have all the changes of whatever is there on the master and whatever is going to be there on the feature branch up till here. Okay. So this is what, in a layman term, what a merge is, right? How do you merge? You basically go to the branch where you have the code, where you want the changes to be made. Then you just type in that particular branch, you type in the command git merge, and then you mention the branch where the updated code is there, right? You mention that branch, you hit enter, and automatically that change happens. Okay. And if you see the log of it, this is how it will look. Problem is, it is not very easy to understand. Like, for example, what is this commit ID for? Is this commit ID for this particular commit, or is this commit ID for this particular commit? Not very clear, right? But there's no option. We use this because whatever will happen, the history will not change. And that is very important when you're dealing with a lot of people who are working on a particular branch. Okay. Then comes Git rebase. But before we go to Git rebase, let's reinforce whatever I've just told you in the practical, right? So let me quickly go to VS Code. All right, now let's understand what a merge really is, right? So let's say I'm on a master branch. Let's create a branch. Let's call it Git checkout F1. Okay. Git branch F1, and then let's git checkout on F1, right? So let's say I add a feature, and that feature is H2 hello from Intellipaat. Okay. I save this, and now I do a git stage, I do a git commit, and now I check out on my master. So as you can see on my master, I don't have the H2. What I want is on my master, this H2 should come. So what I'll do a git merge, and I'll do a merge from F1. And now what will happen is automatically my H2 will come. Okay. So if I show you git log, yeah. See, what you can understand over here is that we created a branch, right? So first we had the V1 website, then we created a branch, we added the background, we merged the branch. This was merged using merged pull request by GitHub. After that, we added the H2 feature. Now, in order for this to become complicated, or in order for this to have this kind of a graph, what we can do is we have to basically move the master also by one commit and move the F1 also by one to commit, right? So let's go ahead and first check out an F1. Okay. So this is my F1. Let's add an H3 over here. Hello. So right, DevOps is the best. Okay. So this is done. So this I'll stage. Yeah. So I'm in F1. So let me just stage the changes. Let me commit added H3. Okay. So if I do a git status, perfect. So now if I do a git log, do I have H3? Okay, I think this is not saved. So I'll save it, and then I'll do a git add, then I'll do a git commit, added H3 feature, right? So now F1 is ahead of master by one commit. Now let's check out master. We don't have H3 over here, but what we do is we'll create a login page. So login.html. Okay. In login, what we'll do is we'll create an HTML, a small HTML file, and in body, we'll add one H1, which says this is the login page. Okay. Now we'll go ahead and stage this. We'll go ahead and commit this. Now observe guys what will happen. So now if you see the git log, right, it's clean right now. Okay, so if I now git merge f1, what is going to happen? So my index now has h3 also, and my login also is present. Now if I see the git log again, can you see again a graph has been created? Why? Because when we were on master, we created one branch, and while we did this commit, we did one more commit. So to combine both these commits, it created one more commit. Okay, now this is a little difficult to understand, or it is a little complex to understand. And that is the reason you have something called as rebase. So let's go ahead and now understand git rebase. So we understood git merge. Git merge is clear. Now let's go ahead and talk about git rebase. So guys, git rebase is basically used when you want to change the history, or you're okay if the history of the file changes. Okay. Why will you be okay that the history of the file changes? Simply because you do not want the graph to look like this. You want a linear graph, so that when you are merging it with master, not a lot of confusion is happening. Now, the advice is that you always do this on a local branch. You never do this on a remote branch, because on a remote branch, the history will change. And if the history changes, people might get confused. All right. So what we want is we do this on a local branch, so that even if the history changes, I am aware about it. But when I'm merging it on the master, everything will be clean. Okay. So let me show you how rebase works with a similar scenario. So here, now what I'm going to do is I'm on the master. So let me create one file called logout.html. All right. And let me enter the same HTML over here. And here I'll say this is the logout page. All right. Let me save it and let me stage it now. Let me commit it now. And let me now go ahead and check out on F1. So now on F1, what I'm going to do is let me add an H4. And what does the H4 say? Git is the best tool in DevOps. Okay, let me save this. Let me stage this. Let me commit this. Added H4, right? And now let me check out to master. And now I'll not merge, I'll do a rebase. So git rebase F1. So when we did a merge, we saw a graph. Now see what will we see when we do an F1, git rebase F1. So it rebased, and now just check. Let's do a git log. Can you see? There is no branch which has been created. What it says added logout page. It says added H4, right? So it should have ideally shown H4 and logout page as parallel, and then it should have created a new merge, but it just created a linear history. It changed the history because login page was actually there before H4, if you remember, right? But now it is showing the login page after H4, and then after that, it is showing the logout page. It changed the history. And why did it change? Because this is our own branch that we were working with, and it doesn't know that it's our own branch, but it assumed it's our own branch, and it doesn't matter if the history gets changed. And that is why you have to be very careful when you're working with Git rebase. So to show you in a graphical format what just happened. So this was the test branch. The test branch, the previous node, it took the line from the previous node and it attached itself to the node after that. All right. And then it resulted in a linear timeline. Otherwise, if you would have done a git merge, what would have happened? It would have created a new commit and it would have combined these two changes in this particular commit. But if that happens, the history doesn't change. But in this case, the history changed. And that is why you should always do this on a local branch and you should not do this on a remote branch. All right, guys. Now let's go ahead and talk about merge conflicts. So what are merge conflicts? Merge conflicts happen when on the same file, you are making some changes. Let's say on the master branch also, you do a commit on the same file. On the F1 branch also, you do a commit on the same file. And then you try to merge the files. Then a merge conflict basically happens, right? So if I were to explain it to you, let's say this is our master branch. Now, from a master branch, I create a feature A branch and I create a feature B branch. Okay. Now, let's say this is a code which is there on a master branch and it just has function 1. So I ask developer A to create feature A, and how he creates feature A is he basically creates function 2, which is basically developer A. He creates a function 2 which he has already merged on the master branch, and now developer 2 created a function 3, right? But notice guys, he doesn't have function 2 obviously, because when it was created, right, it started from here where only this code was there, where only function 1 was there, right? So now when you try to merge both these files, it'll give you a merge conflict because both function 2 and function 3 are new, and Git doesn't know how to merge these files, right? So comparing the two code, what you'll have to do is you'll probably have to add function 3 after function 2, and then you will be able to resolve the merge conflict. But Git can't do that. Git asks your help in this, and that is how it basically results in a merge conflict. So let's see how we can simulate this merge conflict. The idea is on the index.html, let's make two changes. Let's add an h5, which says this is an h5 to cause merge conflict. Let me save it, right? And before I stage it, actually, I want to check out another branch. Let me check out f2. Okay, get branch f2. Cool. Now let me stage this. Let me commit this, added h5. And now let me check out to F2 where obviously H5 is not there. But what I'll do is I'll probably add a H6 here. So let me add a H6. This is an H6 to cause a merge conflict. Let me save this, come back here, stage this, commit this. Now let me go ahead to the master and let me now merge, right? You'll see this error now. Git merge F2. And the moment I do this, what happens? It says there's a merge conflict. Now, in order to resolve this merge conflict, there are two methods. One is VS Code itself is showing resolve in merge editor. And for this, you'll have to install this source control plugin in VS Code. Okay. Or what you can do is it said there is a merge conflict. You type in git merge tool. It'll open a tool in the terminal itself. Okay. Hit return to start, merge tool resolution. Okay, didn't start. It's okay. We'll do it here. Let's solve it here. So resolve in merge editor. We'll have to accept this file. So right now there are no changes accepted. So I'll accept this file and I'll accept this file as well, and I'll complete the merge. Now, as you can see, H6 has been added, H5 has been added, and now if you go here and if you do a simple git status, you will see there are a lot of files which have been created. So some backup files have been created, right? But your index.html has been modified. These backup files are just in case you want to see what were the previous code changes or what was the actual code which was there. You can actually delete them later. But you have the modified index.html file and you can see it has both h5 and h6, right? So this way you have solved the merge conflict. So although this is a very complex term, merge conflict, but merge conflict basically means when on the same file you make changes and you try to merge, right? So Git doesn't know what to do in that case. So now let's go ahead and do a git commit, merge conflict resolved. And now if you do a git log, you can see there's a commit which has both these changes. We have successfully solved a merge conflict. Congratulations to you. Next, what we will cover is we resolve the merge conflict also. So how did we resolve it? It's similar to what you saw on VS Code, right? If you open the git merge tool, it will show you the left file, which is the new file, which probably is there on master. This is the new file, which is there on the F2 branch. And this is the original code, how it used to be, right? So you go ahead here, you change the code exactly how you want it, you save it, and that's how a merge conflict is resolved. Okay. Now, again, these are some files which have been created, and these are basically a copy of the files that you merged. In case you want to refer them later, you can refer them or you can delete them if the merge conflict is resolved successfully. Okay.
So, quick info, guys. Intellipaat, in collaboration with Microsoft, offers an advanced DevOps certification course. This course is designed for both beginners and experienced professionals, featuring live instructor led sessions along with self paced video content to help you become a skilled DevOps engineer. You'll master modern DevOps methodologies, practical DevSecOps practices, and also the use of generative AI tools in CI CD pipelines, automation, and infrastructure management. You'll also work on 60 plus hours of industry relevant projects and case studies, real time labs powered by AWS, simulating production level environment, 15 plus in demand tools used across the industry. With 24/7 support, placement assistance, and EMI payment option, this course, without a doubt, can set your career to new heights. You can check out the testimonials on our Achievers channel, whose link is given in the description below. Also, visit the course page given below in the description and take a first step towards career growth in the field of DevOps.
I hope you understand how Git helps us to manage code and collaborate without any kind of chaos. Now, the next challenge here is How do we run that code reliably across different machines or servers and prevent it from breaking into the production? Because honestly, just because it works on your system doesn't mean it will work in the production environment just as smoothly, right? And that's where we need the containerization tool, or specifically Docker. Docker lets us package our app along with all of its dependencies into a single unit that runs in the same way everywhere. So now that we have got our code under the control with the Git, now let's move with the Docker, which helps us to take that code and actually run it cleanly, consistently, and without the classic "but it worked on my system" problem.
Container, and we found like what is the main purpose, like this is what happens in software or any IT industry or company, like somebody is writing a code. Okay, this is the code, and that code we want to be running. Okay, if you take any example, this code sometimes becomes an application, an app, or any website or anything, like it is running, whether it's Facebook, whether it's Insta, whether it's Zomato, Swiggy, Zerodha, whatever it is at the end of the day, it's a program, a code that is running. When it is running, people like end user like you and me access it. Okay, and company has some mechanism and they generate revenue out of it. This is what more or less happens with any software development. Point here is how we are going to run this code. There are a couple of ways we can run this code. First is like we have this hardware where we'll have dedicated hardware. On this hardware, we have some amount of RAM and some amount of CPU, and we have operating system running on top of it. All right. Now, here there are, if I'm running an application on this particular setup, and my application is consuming 2 GB of a RAM and 2 CPU, my operating system is also consuming 2 GB of a RAM and 2 CPU. This setup, we said that it's not a good deployment, it's not a good architecture, because we are wasting our resources, right? We are over provisioned, right? We are paying for 10 GB and we are hardly utilizing 40% of it, right? So that's something, waste of money, waste of resource. So this is not a good architecture. What can be further done to improve? Like what could be the better way? Better way is like on the same hardware, okay, and same operating system, instead of running one application, run multiple application, right? That is one of the better way, because here we are at least utilizing 80% of the resource, right? Out of 10 GB, we are utilizing 6 GB on application, 2 GB on for operating system. So almost 80% utilization. That is much better way of utilizing the resource. Yes, no doubt this is a better way of utilizing the resource, but there are some challenges with this. What are the challenges? Challenges of security and resource allocation, right? I mean, some application which is someone who belongs to the application A, someone who belongs to the application B, both will get operating system access from the application. Yes, these folks can now access each other application. Is it possible? Yes, it is possible, quite possible. And this is one of the challenge. Another challenge is, say for example, application A is kind of a malfunctioning, and it is consuming 8 GB of RAM and 8 CPU alone. What about other application? So there is no capping or restriction out of the box that we can put, like one application can get this much of maximum RAM, this much of maximum CPU, this much of maximum disk space, this much of maximum network IO. There's no such capping, right? I mean, there is no control here. So this is another problem. So first the problem is of security, right? First is the problem is security. Okay. Second issue is basically is resource allocation. Okay. And the third issue is like application dependencies, like apps dependency. What do you mean by apps dependencies? Say for example, whatever is required to run application A, this is not required to run application B. That may cause another issue, right? So that could be an issue. I'm not saying 100%, but that could be also an issue. So if we want to utilize our application in much better way, we can see that So this could be a challenge. Okay. So we try to utilize the hardware in much better way, more efficient way, but we encounter some other challenges that is not going to solve our purpose of better utilizing the hardware or allocation. I mean, fully utilizing the hardware, underlying hardware. Okay. Well, then people started thinking, okay, let's do something else. And somewhere in 2007ish, 6, close to that era, people come with a solution of virtualization. Okay, this we call virtualization. In virtualization, what happened? In virtualization, we have same hardware. Okay, we have the hardware, we have the operating system. There is a tiny layer of another piece of software on top of this that we call hypervisor. Okay, this we called hypervisor. And applications are coming along with, like, when you want to run your application, the application is coming along with their operating system, app plus operating system, app plus operating system. These machines we call virtual machine, like an EC2 instance, it's a virtual machine. This is also a virtual machine, right? Application and operating system. But here is the important thing, you can say, then what about security and the resource allocation? Yes, security and resource allocation we can solve. This virtual machine will get only this portion of hardware. Means he will get dedicated portion of CPU, RAM, hard disk, everything. This folk will get dedicated portion of hardware, only this portion of hardware, and this for so on and so forth. But who is allocating dedicated portion? It is hypervisor who is allocating this machine, this portion of hardware, this machine, this portion of hardware, this machine, this portion of hardware. Okay. And one more thing, it is, if this portion of hardware is accessible to this application team, anyone coming to application A and can access this hardware, but he cannot access this portion of hardware. This is completely isolated. You can't go there. And who does all those things? It's hypervisor. Okay. And the most interesting thing is, this machine will assume that I am the only machine and this is the full hardware and I am getting the full hardware. They will assume like this. Okay, this is the total hardware and I am getting all the hardware. Similarly, this virtual machine will assume that, okay, I am the only virtual machine that is running and this is the full hardware and I am getting the full hardware, so on and so forth. They even don't know that other virtual machine is running. One EC2 doesn't know that another EC2 is running on the same hardware. They don't know. For them, it's an independent machine. I mean, if they want to talk to each other, they cannot talk like this. Okay, they need to talk to, like, over the network. They need to connect to the router, switches, network, and they can talk like this, like in two different machine. Okay, they cannot connect like internally. It's not possible. Okay, just like one hardware connect with another hardware. Okay, same way they will connect. All right, this is the concept of virtual machine. Now, this is the best way of deploying the application? I mean, it is not the best way, but it is little, I mean, I will say it's much better way of deploying the application, as instead of like this, right? Because here we don't have any isolation mechanism. Here we have isolation mechanism. But what would be the challenges can I see here? I can see only few challenges here. First is, like, we have now multiple operating system, right? Here, how many operating system we have? Only one operating system, right? Here, how many operating system? 1, 2, 3, 4 operating system. And if we increase the virtual machine, there will be operating system will increase. So in order to manage these many operating system, we need to hire more system admin. Okay. So we need to apply more patches, security patches, licenses, blah, 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 so many things. So my operational cost increase, like my operational cost is higher, right? That is the challenge that I can see with this particular architecture. Okay. Okay. Now we after that we thought of, okay, fine, let's try to understand what actually we want to do, from where we started. We started from here, right? We have a code or application that we want to run somewhere. That's it. Now, for this, we took an analogy. We try to understand, okay, fine. Let me know if I want to run only Zoom on this my laptop. This is my system. This is my desktop, laptop, whatever you want to say. This is my system. Okay. Over this system, I want to run only Zoom. No other software. Zoom, everybody knows, like WebEx, we have Zoom software or any software for that. In order to run Zoom, do we need Teams running on this machine? Teams require? Do we need Teams to be running if we want to run Zoom? No, right? Do we need MS Office to be running if you want to run Zoom here? No, not at all. Do we need printer driver to be running on this machine if you want to run Zoom? No. Similarly, do we need any other software like Adobe or something? No, not at all. It's not required. So what actually required to run Zoom? In order to run Zoom on any machine, it requires Zoom the exe file plus dependency, right? That's it. Whatever the, say for example, Zoom requires some Java version. Just imagine, I'm just hypothetically telling you. Then what is this? This is basically those binaries and libraries, those dependencies. Apart from that, nothing else is required to run Zoom, right? Similarly, if we come back here, this guy, what this guy want to run? This guy just want to run its app, its code. In order to run this code, what is required? Just if my whole sole aim is to just run this code, if I just want to run this code, what is required? Code plus dependency. Okay, and this is what is container. Container will give you, what is container? Container is equal to code plus dependency. Okay, nothing more than that, nothing less than that. Whatever is required, that only and only those things. Nothing, not a single software, not a single package more than this. I don't require printer driver, but in my laptop right now, the laptop you're seeing right now, it has so many package drivers and software that I never use. Almost 60% of package I never use in my machine, right? So it happens. There's so many things. When you start your machine, a lot of things will start, and we don't use all those things, but it is running. Okay, that makes my machine bulky. That makes my machine slow. That makes that they consume my RAM, they consume my CPU, they consume my disk space, they consume my network, everything they consume, but they are running. In container, this is not the case. You will only run that is required. That will make your machine light. That will make your machine more efficient utilization of hardware, right? So this is why if we have this concept, instead of running 3 virtual machine on the same 10 GB of a RAM and 10 CPU, because this virtual machine will consume more amount of CPU and RAM as compared to this container. Why? Because this contains the full operating system. The full operating system will contain n number of other software and packages that is not at all required for this app, right? So those will consume more memory and CPU. So that is why we can run more container on the same piece of hardware as compared to virtual machine or as compared to this guy. So no doubt this is more efficient way, more better way of running the application, proper utilization of hardware. Now the question comes, okay, this concept looks good on paper, this concept looks good, but what about these 3 things? How you are going to solve this, right? How you are going to solve security, how you are going to solve other these 3 things. What about these? So this is what we are going to understand, how container offers security, how container offer resource allocation, how container offer apps dependency, everything. All right. We are going to understand this, how container offer security, how container offer resource allocation, and how container offer apps dependency. So in container, the architecture, this is not actually the architecture. We will discuss architecture in detail in a minute. We have something known as hardware, we have operating system, and there is a run C. What is this run C? This is nothing but a container software. Like if you want to install Docker, we have to install Docker D. Okay, Docker D. What is Docker D? Let me explain you. Okay, so this is kind of an overview of container. Okay, Now let's try to understand types of container. There are multiple types of container. The one that very famous is Docker. Okay, Docker is invented by a company known as Docker D. Okay, Docker Incorporation, sorry. Okay, Docker Inc. Docker, their container product name is also Docker, company name is also Docker. Okay, so don't get confused. Sometimes it's little confusing because company name is also Docker, product name is also Docker, but this is container. And 90% of the time, whenever we are saying Docker, we are talking about container. Okay, there are a few other types of container, like there is something known as cryo. Okay, there is something known as container D. All right, there is something known as rocket, and there are a few others. Okay. But we will be focusing on Docker because that kind of captured almost 80 to 90% of market, and it's most widely. I mean, Docker is kind of a synonym, I mean, of container. The real product is container. Okay, these are the types of container, but people say whenever you say container, people say Docker. So it's like that much popular. I'm going to first install Docker. Let's first try to understand how to install Docker. Okay, Docker installation. So we can install Docker many ways. Okay, we can install Docker on Linux. Okay, we can install Docker on Windows. We can install Docker on Mac. That is perfectly fine. Okay, and the document that we are going to follow is docs.docker.com. Okay, document is docs.docker.com. This is the place that we should start. Okay, make a bookmark this page. This is the place where we'll come every now and then for anything and everything in Docker. And here we'll have like getting started. This is like from what is Docker. Okay, what is Docker? You can just have start reading it. Introduction. Okay, some Docker concept. All these things are important. I mean, you can just go slowly. Okay, just go slowly with this documentation. Okay, and what is Docker? I mean, this is really important. They have a YouTube channel also. You can follow that channel. Okay, follow the official channel. Please don't follow anyone's channel like some, because nowadays everyone is creating a lot of stuff, content, but what is the authenticity of those content? Nobody knows. Okay, so it's better always to follow some official channel. Okay, so this is, they will explain you about all these concepts, and this is what we are going to discuss in a minute. And they will also tell you how to install step-by-step document and what is image registry. This is what we are going to cover in a minute. But you can also follow along the official document. This will give you some more confidence, some more content, right? Well-written content. And another thing is you can also try something known as Docker desktop. Okay, and there is something known as a website. Okay, play hyphen with hyphen Docker. This is a website that you can use to run Docker. Okay, what is how to log in here? Play hyphen with Docker. Without, if you don't want to install Docker and you want to learn Docker, this website is going to help you. Okay, you can run all the Docker command here. But how to log in here, I will tell you in a minute. Okay, there is a version of Docker that you can install that is known as Docker desktop. Okay, where is that? Yeah, this one. So you can see here, this is Docker desktop. Okay, that you can install on your machine. If you're just like Git Bash, it's good for Windows. Okay, you can install Docker desktop on your machine and install Docker desktop Mac, Windows, or Linux. You can install anywhere. This is good, but again, I mean, I generally don't install all these things because if I keep installing all these things, there will be a lot of software, and I realize that it makes my machine, my desktop, little slow. Okay, but if you are learning, you can install it because I prefer everything on Linux. Okay, there is a Linux machine. I'll do everything here. But for your practice purpose, for your day-to-day activity, you should go definitely install this. This is simple installation. You can just go here for Windows, you click here. It will give you step-by-step documentation to install Docker Desktop on your Windows. Okay. Docker Desktop for Windows. Okay. Because you will miss some concept and you will focus only on installation. It's very simple, just like in exe file. You can see it's given step-by-step documentation. You can just install it. And after that, you can install it like this. Even from the go to Windows CMD, and you can install like this also. That will install your Docker. And how to install Docker Desktop? A startup is, you can go to desktop, and a Docker Desktop will see here just like an icon, and you can just start accessing it. Okay. So now what we are going to do is I'm going to show you the more important, like more professional way of installing Docker, generally what we do in organization. So we'll say install Docker. So install Docker is this is the install Docker. What is the difference? That is a desktop version. That is more. This is a community edition. Okay, that we can install. And there is one more edition that is known as professional edition. That is for that Docker charges. Docker Incorporation company will charge some money for that. But we are not going to pay for this. We will use a community edition, and community edition has all the feature. So here you can see. If you want, I can give it right now, but I generally don't give it because people get diverted. Yeah. So what I was telling, like, what is the what is your operating system? Say, for example, Ubuntu, Debian, Red Hat, Fedora, CentOS, whatever this, you can select any of your operating system version from here and you can install. Say, for example, for Ubuntu, if you click on Ubuntu, it will take you like how to install Ubuntu. Okay. These are the steps. Okay. Run the following command to uninstall config packages. If you have any config packages, it will uninstall any previous version of Docker from your machine. That is your choice. If you want to run it, you can just copy this command. I'll just prepare a doc. Okay. Docker installation steps. Okay. So what we'll do, we'll say this is step number 1. Just run it. And the second step is like installation method. It says like setting up the Docker repository. First, you need to add the this is basically what we can say. This is step number 0, right? This is prerequisite. Okay. What is the step number 1? Step number 1 is install setup Docker app repository. So you just click here, everything will get copied. No need to select and copy. Just click here, it will get copied. Paste it here. So what it is doing, it is updating, it is adding some certificate, it is adding the keys, and it is adding the all those things, and it is basically here it is adding the repository, the Docker repository. Okay. So that repository will get connected. Once it will get connected, okay, next thing is install. This is the main command to install Docker. This is going to be step number 3 for us, right? 2 for us. This is going to be step number 2 to actually install the Docker package. And the command is like, you can just click here. You will see like this. Okay. This is the command to install Docker. This is more official way, more professional way of installing Docker. Okay. But if you want to install, if you want to learn, if you're learning Docker and you are doing it first time, you feel like this is very complex. What you can do here is, on the same Ubuntu machine, you can just type Docker and press enter. You'll see that Docker is not installed. So this is the command also you can run to install Docker. Docker in app install docker.io. That's it. With single command also you can install Docker, or you can install like this. Then you will say, what is the difference between this and this? This will only install Docker. This is installing so many other things. Okay. That is sometimes not required for us. But if you want, you can install the full software. It's totally fine. So let's follow the documentation, because I just want to show you one time Okay, so let me run this command from here, copy, and I'll go here. Let me become root, let me bring the prompt. This is my Docker machine. It's done, nothing to delete. Now let me run these commands. I'm just selecting multiple commands and running it one shot, so it's not a problem. Now, what is the next thing? We will add this repository. So we'll say echo from here. You need to copy till here, right? I mean, line number 415. Is this copied correctly? Line number 415 echo. This is also dollar. This is also dollar. No, I need to till here. I need to copy till this is the whole command. All right. So this is done. We have added the repository. Now, second thing is apt update one more time because the repository got added. Everything is okay. Now, this is the main command to run Docker sudo apt-get install Docker plugin. The installation maybe looks very complex, but if you want to make it simple, you just run this command. Okay, no need to run all these commands for Ubuntu. You can just run this command. It's done. But I'm showing you the whole official. Make sure that Docker got installed or not. If you run Docker here now, you will see this output, some syntax and all. So it means that Docker got installed. But if you want to see what version of Docker got installed, you say Docker --version. It will give you this output like, yes, Docker got installed. Okay, this is the Docker installation version. Okay, 27.5.0, and this shows that Docker got installed. Apart from that, what you can do, you can just copy some piece of this command, just like we copied in Git, right? We copy all this one line explanation of the command, right? So we can copy till here. Okay, these are the commands that got copied. Now what you can do, like, the Docker command syntax. Let's try to understand this. Docker syntax. What is the syntax of this Docker command? Just like Git, every command of Docker is going to start with Docker. Okay, every command of Docker is going to start with Docker plus some verb. Okay, so what are the verbs here? The verbs are like this. These are the verbs: run, exe, ps, build, pull, all. Say for example, if I want to run Docker run, so command will become what? Docker run. Okay, and some syntax. All right, so this is Docker run. The command. What is the syntax? Docker plus some verb. What are the verbs? These are the possible verbs. From line number 439 to line number 497, all these are the verbs. Okay. Now we are going to launch a container. We are going to launch a container. Before launching a container, I will tell you one simple scenario, like, very simple, an example. Docker installation, we have done it. Like, let me tell you this is the most important concept in Docker. Okay, the concept says, I mean, what we have done here, like from where the thing started. The thing started from here, right? I mean, we want to run this code, right? we want to run this code. This code we can run in multiple ways, right? This code I have shown you. If we want to run any application code, we can run the code on the following. These are the ways, right? I can run on a machine like server like this. I can run on an EC2 instance. I can run on a Docker, Lambda. Just ignore these two things right now. Okay. We can run on a physical machine. When I'm saying physical machine, like we can go to our data center and we can run the servers, images like this, right? These are the server, right? In any data center, we have these are the server, right? You may have seen in movies and all, hackers is like something is doing, but these are the server. These are the physical machine where you can run your application, right? This is one of the way. And another way of running your application that I'm showing you is on EC2, or that is basically on any cloud, the virtual machine. This is EC2, right? Where you can run your application. Till here, everyone is with me? Either on a physical machine or on a virtual machine. These are the couple of ways we can run our application. Now, in order to, if you want to run your application here, if you have to build a server, what are the things required if you want to install a server? Have you installed operating system in EC2 or on your laptop or in your any server? What is the first thing that is required? Operating system image, right? We say, where is OS image, right? Maybe in a physical machine, it is in the form of ISO image. Okay, maybe in a pen drive or over the network. I don't know, but we need an operating system image, right? Storage and network, that is fine, but most important thing is operating system image. All right. Similarly, if you want to install EC2, what is the most important thing to install? AMI, Amazon Machine Images. Once we get an AMI, and then after that we install an operating system, or once we get an operating system image, we install operating system and we configure it. All right. And our code will start running. Like then we install our application code on top of it, maybe here or maybe here, and our application will start running it, right? This is what happens. Similarly, if you want to containerize any application, if you want to run in the form of container, like you want to run your application in this container, what are the things that are required? First of all, from your code, you have to create a file that is known as Docker file. Docker file is a text file where we define all the dependency. Code plus dependency, we write it. Say for example, if this code require Python to run, we will mention that this code require Python to run inside the Docker file. Okay. So what is Docker file? Docker file is a simple plain text file that take the code and define all the dependency. From this Docker file, we build something known as Docker image. We build something known as Docker image. Okay, this is image and this is Docker image. What is this image? This image is concept wise same as like ISO image, AMI, like this, because for any machine to run, we need an image. And what that image will contain? The code and the dependency in that image. From this image, we create something known as container. All right, this process you need to remember. This is the main process, and we are going to image as an image we call like this dependency, code plus dependency, we create an image out of it. Read only image is what? Read only file, right? Can you say what is ISO image? It's a read only file. You may have remember this disk, right? This in our college days we ask for like who is having Windows ISO image, who is having Windows disk, right? That whatever written inside that disk, you cannot change it, right? It's a read only file. You cannot overwrite it. Similarly, this image is close to ISO image and AMI, but the only thing is it's very small in size. It's not full operating system. This image is containing what? Code and the dependency. That's it. Very light version of image. Okay, this is the process of containerizing any application. Just remember this diagram. This is the process. Okay, so now we are going to launch a container. For launching a container, what is required now? Tell me. For launching a container, what is required? Goes, I want to launch this guy. What is required? Image. That's it. Image, right? First thing we require image. Docker file, we'll see how to build Docker file, but first thing is require image. So the command to launch a container is this. If you scroll it up, line number 439 says run, create and run a new container from an image. Yes, this is the command I want. So the command will become docker run and some image name. Some image name. Okay, say for example, I want to create a Nginx container. Nginx is a web server. So I'll say, or something like, docker run Nginx. Or I want to create a Ubuntu container. I'll say docker run Ubuntu. I want to create another container, say hello world. I'll say docker run hello world. Okay, these all are images. Okay, and we'll talk more detail about it when we'll discuss about the architecture of Docker container. But because I need to explain you this command, why this command is required, because I need to explain you how this happens. We have not yet explored security, resource allocation, and apps dependency. So I'm doing a little bit of reverse engineering so that we will reach here. All right. So if I go and run like, docker run hello world. Okay. So we'll get some message like this, and this is the output. Okay, and don't worry about these output. I will explain you everything. So let me first run couple of commands and show you. So this is one of the container that we have launched. Okay, and it says docker run hello world. It says unable to find the image locally. Okay, and then it started pulling the image from somewhere, and it says pull complete and says status downloaded image is there. Something happened. All right, so let's see what happened. So there's a command that is known as docker ps. Okay, so docker ps is basically, if you run this command, it will tell you like the containers running. What is the word I'm using here? Container running on the system. If you run docker ps -a, it will tell you all the container running as well as stopped. You can see this is one container that is start from this hello world image. It got exited. Exited means it is right now not running. It is stopped. Okay. Let me run one more container. Docker. I'll say docker run. I'll say -d. I'll say hyphen name. I want to give name of the container. I'll say my web app, and the image I'm using is Nginx image. Okay, I'm running this container. It's again I'm getting the same message, unable to find the image locally. Something is getting downloaded, and once that is download is complete, okay, status download is complete, and then some ID is a big number I'm getting like this. And if I do docker ps now, I can say yes, one container is running, and this ID something is there. It is initial of the same, right? It is the same container. It is created from Nginx image. It is running from last 13 seconds. Okay, and the name is my web app, the name that we have given here, my web app. All right, so this, let me copy this command as well, because I'm going to explain you this command as well. So one thing for sure, we can from this command, we are getting that whenever I am running docker run, it is creating a container for me, right? And that container is right now it is running also. Okay, why the hello world container got stopped, we will also see that one. But right now Nginx container is right now running. Nginx container is running because we can see with the docker ps command, right? Okay, let me do one thing. Let me take a, so far what we have done, let me make a note of it. Here, step number 1, we have launched container using Nginx image. Okay, what was the command? Docker run. Okay, the command was docker run and image name, some syntax we have followed. The main command was docker run, right? What is step number 2? Step number 2 is basically, we see that container is running, right? We have seen that container is running. With what was the command? Docker ps, right? We run docker ps, we can see that container is running. All right. Now let me take a duplicate session of it. Okay, let me go here and say duplicate session. This is the same machine. Okay, this is also the same machine. I'm connecting twice. Okay, I'll say my password. Okay, this is the same machine. Okay, if I can do sudo, I became root of that machine, admin of that machine. This is the same machine. How to list down the process in Linux? What is the command to list down the process in Linux? Let me Google it if you don't know. PS, right? Yes. Okay, so if I say list down the process in Linux command, if you don't know, okay, that is why I'm typing it. So you can see here, these are the commands, some commands to list down the process. PS is the command actually. If you do PS and some option, you will get like all the commands. PS-aux, that is also a command. If I want to list down the image, I mean, I'm coming to content of image and all. I'll tell you later. Okay, just give me some more time. We'll see everything. There is a dedicated section over the image. So now let me list down the process. PS-aux. So this basically lists down all the processes that are running on this machine. Okay, this command lists down all the processes. You can say process, the process ID, 1, 2, 3, all the processes. Almost 4,201 processes are running, and it lists down all the processes of my machine. But if I'm interested in a specific process, if I say PS-aux pipe grep -i, I'm interested in Nginx process. I'll say Nginx. Is there any Nginx process running on my, what this is a filter, grep is a filter. Out of 4,000 processes, I filtered out only all the processes that are running Nginx. Is there any Nginx process running on my machine? -i for case insensitive. Whether you type in uppercase or lowercase, it will make it insensitive. Okay, Vaibhav, case insensitive. The same command if I type grep -i capital Nginx, okay, it will still list down. Okay, but if you type the same command capital Nginx without -i, it will say nothing is running. Are you getting it? So -i is a case insensitive. Webho, you are getting it. So we have Nginx process running here. Can you see that this is an Nginx master process running? Are you folks with me? What is the process ID for this? What is the process ID? 3983. The ID is 3983. Yes. If I want to kill any process, stop any process in Linux, what is the command? Command is kill. Okay, kill. Yeah, -9 is sometimes not required, or kill -9 and the process ID. So if I do kill -9 is like forcefully. Kill -9 3983. Can I kill this process? Let's kill this process. Kill. Let me grep this process again. Is there any Nginx process running now in my machine? No, because this is just a grep command. This is the same command ka process. No Nginx process is running. So can I make another note? What we did after that? After that, step number 3, we list down all the Nginx processes. Okay, with what is the command that we have used? ts-aux, right? This is the command grep Linux, grep Nginx that we have used. After that, what we did? Step number 4, what we did? We killed Nginx master process that killed all the Nginx child process. What do you mean by child process? If you go here, this is master process. Worker process are the child. This is parent, this is child. Worker are child. So this, when we killed parent, child automatically get killed. You can see we were having 1, 2, 3 processes running. Right now, all the processes got killed when I killed this master 3983. Okay. So that is for sure we have killed the process. Now let's see any container is running here. Earlier when we were here, container was running. Let me do docker ps. No container is running. If I want to see all the stopped and running container, what is the command? Docker ps -a. A means all. Yes, I can see that my this Nginx container is also got stopped, got killed. Stop means got killed. But who killed this process? We didn't kill this container. We killed the process, right? So can we make an assumption here from this statement? Okay, when we kill the process, when we kill the process, container got killed. Container also got killed. Is this fair statement to make? Is this correct statement? Is my observation is correct? So from here, can I make a statement that containers are nothing but operating system process? Is this correct statement? Yes, obviously. This is operating system process only, right? So now next question is in my mind is, if it is if it is an OS process, how it can run my code within it? How it is possible? How a process can run my code? Because I want to containerize my code, right? I want to run code inside container, and container, now you are saying that container is a process. How it is possible a process can run my code inside it? Is it possible? It is absolutely possible. Now that is what we are going to explore. This observation is correct. What we did, let me go step by step one more time. We have launched one Nginx container. When we launch the container, we see that container is running docker ps command. It is showing me as a running container. Then we list down all the Nginx process using ps-aux. Then we killed that same Nginx process. The moment we killed this Nginx process, the container also got killed. Okay, it means there is a direct relation between these two guys. So it means that when we killed the process, container got killed. So can we make a statement that container is nothing but an operating system process only? Yes, that is correct. If it is a process, then how a process can run a code within it? That is what the question is. Are you folks with me so far? Is it interesting? Are you finding it interesting? Okay, now let's figure it out how it happened. For this, let's go few years back. Okay, step back. You go to your college days. You have studied a subject that is known as operating system? Maybe, I'm not sure everyone, but maybe some of you have studied a subject known as operating system, Tannenbaum, or what is Dontainer? I don't get the question. There is somewhere typo. If somewhere typo, it is container, not step number 2. What is this? Oh, we see that container. Okay, that's a type. So how Linux work? So what happens in Linux, that this is a hardware. Okay. Over the hardware we have what? RAM, CPU, hard disk, like this everything comes under the hardware. Suppose this is a hard disk. Okay, just imagine, and I have a process. Okay, I initialize a process in Linux. I'm talking about Linux operating system. Okay. In order to run process requires some hardware, maybe RAM, CPU, or hard disk. Is it required? Yes, obviously required, right? Any process requires some hardware to run. Is this process going to get this hardware directly? No. There is one more component in Linux that we call kernel. Have you heard this word kernel? Kernel is, you have heard this word, kernel is heart of operating system, right? So this is kernel. What happens? Process will interact with kernel and kernel will allocate the hardware. This is how it happens. But one more thing, process is not going to interact directly with kernel. There is something known as system call, or we call sys call. Somebody even doesn't know that is the operating, not learn operating system. This is what happens in operating system. Process will generate something known as system call. System call will interact with kernel and kernel will allocate the hardware. Okay, say for example, just imagine you are running, you are opening your CV. Okay, you are opening your CV. Okay, your CV is basically need to process, then you will see your CV. That document need to process, then you can see your CV. Whenever you want to open a CV, this will generate a process. This process require this RAM, CPU and everything, then you will able to see your CV. Okay, otherwise you won't able to. Sometimes you may observe your computer is super busy, like CPU and everything. When you double click your some process, CV or something, it won't open. It will take some time to open. Why? Because they are not getting the required amount of hardware. When you open any file, it requires some amount of CPU and memory and all. That is known as hardware. Okay, so just this is how a Linux operating system works. If you have another process, what will happen? Okay, another process. This process will generate its own system call. Every process will have its own system call. System call will interact with kernel. We have only one kernel. That kernel will allocate hardware. Say for example, along with CV, I want to listen a song. So song will also generate its own process. Okay, I want to watch movie. That will generate its own process. That process also requires some part of RAM, CPU, memory, hard disk, all those things. Who will allocate? Kernel will allocate. This is what the architecture of an operating system. This is, we can say, how Linux works. This is how Linux works. Now imagine, this is concept. Now imagine I have two processes. This is a hypothetical condition to explain you what is. Okay, this is, say for example, process underscore A, and this is another process underscore B. Okay, this process will generate system call, this process will generate system call. This is my kernel, that is okay, and this is my hardware. Just imagine, because of any reason, this process A require Python version 2. What version? Python v2, and this process B require Python v3. All right, Python v2 and Python v3. Okay, because of any, and this is my hard disk. Just imagine this is my hard disk. Hardware is hard disk. Because of any reason, any hypothetical reason, I am not able to install Python v2 and v3 on the same machine. It is not allowing me. Technically, we can install it. Just imagine if it is not allowing me to install. So what happens in this case? If I install Python v2, what will happen? If I install Python v2, then only process A will run, because Python v2 got installed here. If I install Python v3, then only process B will run here. Agree? Now suppose if I have some mechanism where I can partition this hard disk, where I can partition this hard disk in such a way that they are completely isolated from each other. I put a partition that they are isolated. So what we can do, in this portion I can install v2. I can say install Python v2. Okay, and this portion I can install Python v3 if they are completely isolated. If I got some mechanism so that I can completely isolate. So in that case, what will happen? Both the process can run. How? When a request system call coming from process A, it will go to kernel. kernel will see, okay, this is coming from process A, so let me allocate this portion of hard disk. Similarly, a request coming from system call from process B, it will go to kernel. Kernel will see, okay, this is coming from process B, let me allocate this portion of hard disk. If this is mechanism is available, can we do this? Yes, obviously we can do this. We can very well do this. All right. So actually, this is what the container does. Okay? This container will have, this is one container, okay, and this is another container. Okay, this is one container and this is another container. It's not working because it's an image. It's a screenshot. Okay, so this is just imagine this is one container. Okay, this is what I'm trying to say. This is one container and this is another container. But who will partition this thing? Who will partition the hard disk in such a way? So there is a feature of Linux kernel that is known as namespace. Okay, let me show you. Linux namespace. Wiki. What Linux namespace wiki says, let me copy it for you. Linux namespace wiki says, what is namespace? Namespace, just read it. I mean, carefully read it. It says, namespace are the feature of Linux kernel. They are the feature of Linux kernel. Okay, this is the feature of Linux kernel that is already there in Linux. That partition a kernel resource. Resource mean hard disk, RAM, CPU, those hard disks, such that one set of process sees one set of resource while another set of process sees different set of resource. It means that if I have an hard disk here with the namespace, I can partition this hard disk in such a way, if I can create as many as partition, that one partition is going to visible to one set of process, another set of partition is going to visible to another set of process, another set of partition is going so on and so forth. I mean, we are here allocating a dedicated hardware to a process, dedicated RAM, dedicated portion of CPU, dedicated portion of hard disk, all those things. This is what exactly aren't we doing with the virtual machine using hypervisor? We were giving the same thing, right? We say this portion belongs to this portion belongs to this portion belongs to this. Are we doing same in container, in process? Yes, and process, what is process? Process is container. Now your container can run your code like a virtual machine, like a, like a virtual machine. Are you getting it? Because process is going to get a dedicated portion of hard disk, dedicated portion of CPU that it is not going to share. Similar thing happening in the virtual machine, isn't it? We are giving this hardware portion of hardware to this virtual machine, this portion of hardware to this virtual machine using help of hypervisor. Here same thing we are doing because that feature is already available in Linux. Okay, so namespace is one of the feature. There is one more feature that container uses, that is known as C group. What is C group then? C group, or no, sorry, C group. Linux C group, not B group, C group. C group or the control group. Let me copy it and then I will tell you what is this. C group is like a capping, like a cap. What C group says? C group says, C groups or control group. It says it's a feature of Linux kernel that limits, means put a cap of resources like CPU, memory, disk, IO, and blah 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 blah. What is the meaning of it? Namespace says I can partition the hard resource in such a way that one partition is visible to one process only. But how big is the partition? If the partition is going to be that big, okay, or the partition is going to be that big, or the partition is going to be that big, is defined by C group. It should not be happen like, if this is my hard disk, one process will get this big partition and all the rest process are like dying for a small portion of it. It's not like that. That capping is done by C group. So that is what's a feature that limits limits account for the isolated resource usage. Namespace is what you can see. C group is how much you can see. Are you guys getting it? Using these two features of Linux and C group, your process start behaving like a virtual machine. And what is process? A container. Now, what is the definition of container then? Container is basically, now if I ask this definition in 10-year, 15-year folks, they will say, what is container? They will say container is a virtual machine. That is wrong definition. Absolutely wrong. Container is not a virtual machine. Virtual machine is different, container is different. What is the correct definition? You can say container is an operating system process that behaves like a virtual machine using the concept of name, space, and C group. Are you getting it now? What is container? Your definition. So we started, this security thing is now solved about this security and isolation app dependency, because they are now getting a separate area. So security is solved. It's not possible that one process will interact with other process because they are running in a dedicated portion. Everything, apps dependency and everything, we can solve it. Okay. What was that? Security, resource allocation. Yeah, resource allocation also we have solved, right? All right. So what is, we started from here, just try to understand the whole process, because that is what I need. I have created a container. We have listed down the container. We have killed the process and the container got killed. From here we made a assumption. We made, like, we identified that container is nothing but an operating system process. That is absolutely fine. But the question was how container is going to run my application, because if in order to run any application you need CPU, you need RAM, right? You need disk, lot of other hardware, right? These are the things required. If it is a process and it is running my app, then how it will get a dedicated portion of CPU, dedicated portion of RAM and hardware or hard disk, so that it can run my code like an independent, isolated way, right? This is what the problem was. For that, we understood that how Linux work. Linux, everything in Linux is a basically kind, we can say, process. Process has a system call interact with kernel, and kernel allocate the hardware like anything, CPU, RAM, disk, all these things. Okay. Now, using the namespace feature of a Linux kernel, we can partition. Namespace is what? Namespace is a feature that is available in Linux kernel. Yahan par, like this is where that feature is already available. What this does, partition a kernel resource, means hardware, such that one set of process, means one process will see one set of resource, another process will see another set of resource, means it will see dedicated portion of CPU, RAM, disk. That is not going to seen by this guy. It is only and only belong to this guy. That is an isolation that offers by namespace. And this is the area where my code is going to run. How big is this area? That is determined by C group. Whether this area is going to this much or this much, that we can define with C group. Docker architecture basically. Okay, so Docker architecture has three components. First we call Docker CLI. Okay. Second we call Docker daemon. Third component is Docker hub. Okay. And what is the process of containerization? The process of containerization is this. Right, we have code. From code we create Docker file we create Docker image and contain. Don't worry, we'll have a lab on this. Okay, we will understand this in detail. Okay, so what is Docker CLI, what is Docker daemon, and what is Docker name is Docker hub. When you install Docker, where you run this Docker command, right, where you go and run this Docker command, Docker ps -a All these things we are doing at Docker CLI. This is known as Docker CLI. Okay, this is Docker CLI, where you run the command. What command we ran? We ran Docker run Nginx, right? This is what something we ran. We ran Docker run Nginx. There are a couple of option -d and all, but this is about the CLI, where we run this command. When you run this command is handled by main Docker process that is known as Docker daemon, or sometimes equal to Docker D. This is the main Docker where how it is running. When you install Docker, this process got installed. This daemon started running. When you install Docker using these commands, this basically started this process. And if you want to see this process, you can just list down it. ES-AUX by grep-I Docker. So you can see that Docker D is running here, right? This is the main process that got started. This is the Docker D process, main process. Okay, this is Docker D that is running like here. This does all the heavy lifting. This does all the hard work. When you run this command reaches to Docker D in the form of API. It is a REST API over HTTPS protocol. Okay, and Docker daemon sees this API and try to understand what you want to achieve. It is with this command, in this example, Docker understood, okay, this guy want to launch a container using Nginx image, because for container, image is required. And the image here is Nginx. So first, it will search the image locally. It will start searching the image locally on this machine. Is there an image available, image available, image available? It will search local, scan the local machine where the Docker is running. That is why it says the message. And there was no image, so it says unable to find the image locally. In this command also, it says unable to find the image locally. Locally means on the same machine, not able to find the image. Actually, if image is not available locally, there is something known as a repository known as Docker Hub. That is maintained by Docker Incorporation, the company behind Docker. There is a repository that is known as Docker Hub. Docker Hub is like GitHub as a repository only, but for only to store images. The location is hub.docker.com. This is maintained by Docker Incorporation. This is Docker repository. Okay. Docker Hub. Can you see that? This is Docker Hub. This is maintained by which company? Docker Incorporation, the company behind Docker. This is Docker Hub. It stores all the images. Okay. If you see, if I say Nginx, this image is here. You can see this is the Nginx image. We will talk more about it, like, how to store, how to upload and everything. We'll do all those things. Don't worry about it. So the image is available at Nginx. When Docker daemon not able to find the image locally, because the message, what it print, unable to find the image locally. Then what it will do, it will go, first step is the request will go to Docker D. Docker D will scan, it's not able to find the image locally. Then it will go to Docker Hub and download the image. That is why we were able to see this message, downloading, pulling, and then we got downloaded the newer version of Nginx latest image. So image is now from here, it got downloaded here. When the image is available, then a container started running out of this image, and we were able to see Docker ps command, yes, container is run. Okay, so it will connect this, then it will download the image. Okay, so this is step number 1. That is going to this. When you run this command, it will get converted into API. It will go to Docker Hub, Docker D. Docker D will run, scan, and understand and perform the job locally. But in this case, a container need to be launched because that container require an image. Image was not available. So what it did, it connect with Docker Hub. Step number 3. And step number 4, it downloaded the image first, and then step number 5, a container get created. So this is Docker architecture. Docker architecture has 3 components. Okay, what are those components? CLI, daemon, and hub. CLI is where you run all the Docker command. Daemon is the main process. Most of the time, CLI and daemon run on the same machine. In our case, CLI is running on that Linux machine. Daemon is also running on the same machine. When you type anything at the CLI, that command get converted into an API request and it's go to Docker D. Whatever you mention in the command, Docker D will do all the heavy lifting. In this case, in this particular example, we want to create a container. For container, an image is required. Okay. So Docker D will see this command and understood, okay, this guy want to run an Nginx container using Nginx image. But that image was not available locally. So it went to Docker Hub, download that image and create a container for it. Are you folks getting it? If I go here, okay, and if I do Docker images, it will list me the Nginx image and the hello world, everything. This image is already available locally now. Now, if I want to create one more container, okay, using Nginx image, you can see Docker run -d -name. I'll say -name new web server using Nginx image. This time image is already available locally, right? If I run this command, you can see directly the container got created. If I do Docker ps, the new web server got created, right? Why it is not downloading the image this time? Because image is already available locally. It is using the same image to create my another container. Same AMI can you use to create multiple EC2 instance? Yes, right. Same ISO image can you use to create multiple server, laptop, desktop? Yes. So that concept is still same image, because earlier first time the image was not available, so it downloaded from the and it got pulled and it got downloaded. But right now image is available. But if I create any another container, say for example, I am using web server 2 and I'm using different image this time. Say for example, I'm using Alpine or Ubuntu. Okay. What is message I'm getting? Image is not available locally. So what it will do? It will start downloading. From where it is downloading? It is downloading from Docker Hub. Are you guys getting it? -d to run in the background. Right now it's like running in the background. Otherwise, what will happen? If you don't run -d, let me show you. Let me run web server. Let me go here. Web server 3. Okay. And if I don't use this -d, my terminal will get locked. You can see this. I'm inside the container now. My terminal is locked now. Okay. I'm here. It's locked. So that is why we run in the background and get free our terminal.
Just a quick info, guys. Intellipaat offers a DevOps course where you can master skills like Git, Jenkins, Maven, Kubernetes, Terraform, and Docker by receiving training from the world's top 1% industry experts. With this course, we have already helped thousands of professionals to successfully transition their careers. You can check out their testimonials on our Achievers channel, the link of which is given in the description below. Without a doubt, this course can set your career to new heights. So visit the course page link given below in the description and take the first step towards career growth in DevOps.
Okay, so we will see some of more commands of Docker. So let me give you some list of commands of Docker. Let me go and log into my GitHub. Okay, so here, I have written down some of the commands that you can definitely use it. Docker commands here. Okay, so these are some set of commands that you should practice. Okay, what I'm showing you just the notes first so that you can understand. Yes, the commands are here. Okay, you can run it. We will use most of these commands one by one. Okay, but what is this command? How to run this command? What is the use of the command? I have mentioned everything here. All right, so let me start with now what we like in order to Okay, in order to run a command container, let's say for example, if you do Docker PS, okay, Docker PS, it will list down what is Docker PS and what is Docker PS -a. What is the difference? Docker PS will list down only the running container. Docker PS -a will list down the running plus stop container. If you mention -a, you can see whatever the container that we have created, all our status exited, 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 and exited. It means these containers are stopped, not running. Okay, these containers are stopped, not running. So if I want to start any container, the command is docker start. Okay, and the container ID. And here in this particular case, you can see this is like your whole output. This is container ID. Okay, Docker assign a container ID to all the container. Okay, this is a hash basically that it assign. This is the name of the container. By default, when you don't give name, Docker will give you some funny name. Okay, but we have given some name, and if you don't give name, it will give some funny name, and it will tell you like what is the image, from which image they have got built. Okay, when they got created, till what time they are running and all. Okay, what is this command? We will see this command meaning in Docker file. Okay, what is the meaning of this command? We'll see in Docker file. So Docker PS will display the output of running container. Docker PS -a will display the output of container that are running as well as stop, all the containers. In order to start a container, Docker start and the container name or container ID. Say for example, I want to start my web app. This is the container. So either I can give this or even ID will also work. Okay. So let's start with Docker start my web app. So container got started. Now if I do Docker PS without -a, I can see that yes, container is, earlier the output was blank. Now I can see that container is running. Okay. There are a couple of things like, this is the container running, like how this container is running. So what happens here, just try to understand. We have this as a Linux machine. Okay. Over this machine, what we have installed? We have installed Docker. Okay. We have installed Docker here. Now, when the Docker install means Docker D is running. Okay. Docker D is running. The daemon is running. Install Docker means Docker D is running. On top of which we have created a container. That container is running like this. This container, okay, my web app is running on top of this machine. This is the container. Okay, this is how it is running. Can we create multiple container on a machine? Yes, we can create multiple container on a machine. Okay, say for example, let me run one more container. Let me start from scratch. Docker run -d IT -name. What is D? What is D? I'll tell you. Okay. -name. I'll say my Alpine, and I can use an image Alpine ASH. So it says unable to find the image Alpine locally. What is this Alpine? Alpine is a Linux image specially designed for container. Okay, it's a very light version of Linux that is specially designed for container. I'll show you this image here. This in the Docker Hub. So here what happened, when the moment you run this command is handled by Docker D, and it says it understood, okay, you want to create a container using Alpine image, but the image is not available here locally. So let me download it. It downloaded the image and then the container got created. Now if you see Docker images, you can see the Alpine image is got downloaded. Earlier, the Alpine image was not there. Okay, only we have Linux, Ubuntu, and Nginx, Ubuntu, and Hello World. Now we have Alpine image also. Okay, so and if I do Docker PS, okay, Docker PS. So I have two container right now running. First one was my web app from Nginx image. Second container my Alpine from Alpine image. So what happened in this diagram? I have one more container running here, and this container name is my Alpine. Okay, so what is happening here? We are kind of this diagram, where we have an hardware, where we have an operating system, where we have a run C, that is Docker D, that is installed. We are creating this container, this container, this container, like this. All are these container are independent application. This is okay. This is independent application created from Nginx image. This is independent application created from Alpine image. Can we create more containers? Yes, we can create more containers. But till how many containers we can create depending upon the size of the instance. If instance has, say for example, 10 GB of RAM and 20 CPU or something like that, then by default how much this container will contain, based upon that resource we can create the container. But the point here that I want to tell you, to understand the concept, this is how it is running. There is a base machine. This has a hardware plus operating system. Over this we have installed this run C, and on the run C, these are the containers. Over this the containers are running. I am just trying to explain you this diagram. This diagram is now getting clear. What is the meaning of it? Okay. Now we will perform this exercise. So what we are going to do, we'll have a code, okay, and we'll have a Docker file. So first, let's understand about Docker file, because code anyway developer is going to write. So what is Docker file? Okay, so Docker file is a text file that contains instruction, okay, that contain instruction how to build this image. Okay, Docker file is a text file that contains instructions. Okay, but instructions for what? Instruction how to build this Docker file. Okay, how to build this Docker image. Okay, I mean, what are the things that require to build an image? An image is something like that will make this code running. Actually, it will define all the dependencies that are required for this code. Every Docker file is going to start. I mean, when I mentioned that it has some of instruction, what do you mean by instruction? Instructions are set of commands, and commands are nothing but simple instruction, like what is required, how it is required, and all. So this is what we are going to see. Just let me go to the text file, then here I can explain. And Docker file is a single word with capital D. Okay, there's no extension, not txt, not py, not php, nothing. It has no extension, just Docker file. Okay, so it is a Docker file is a text file that contain instruction to build Docker image, and these instructions are define the environment inside the container, including what software to install, what files to copy, what commands to run. Everything we define, because these are the instructions that is actually going to install your code, run your code the way you want. Okay, everything we define in the file. And every Docker command is going to start with a statement from. Okay, from is basically that is going to specify the base image that Docker is using. What do you mean by base image that Docker is going to use? Tell me one thing. If I am writing a code in Python, okay, if I am writing this code is written in Python, okay, what is the first, and if you want to run a code on your laptop or on your machine, say for example, this is my laptop, okay, and I am telling you run this particular code, and this code is written in Python. What is the first thing that is required for my laptop to run this code? If it is written in Python, Python must be installed. Compiler and all that is fine, but Python must be installed. If it is a C program, C must be installed here. If it is a Java program, Java must be installed here. Otherwise, I won't be able to run this code. Are you getting it? In college days, in your school days, whenever you run a C program or something, first thing what we do, we install C, right? Similar like that. Okay, so from is actually specify the base image. Okay, base image is like what is required to run this code. If I am writing a Python code, if I'm writing a Java code, the base image I will take a Python. So what it will do, it will create a simple, very first layer of my base image. It is going to create a base image like this. Okay, say if I go here, it will, from statement will create my base image, the first image here. It could be any, what should be the base image depending upon what is my use case. Okay, that is what the from statement specifies. So what is this specify? This specify your base image used to be. All right. And say, for example, I want to use Ubuntu image. I can say something like this, from Ubuntu 20.4. Okay, this is an example. Second instructions, like there are a couple of handful of instructions, 10 and 12 instructions are there only. Second instruction is run. Again, all the instruction of Docker file written in uppercase. Okay, all the instructions are written in uppercase. So what run is going to do, whatever the command that you want to execute, whatever the software that you want to install within your Docker. I mean, say for example, when I'm installing a code, okay, on Ubuntu, I want to upgrade my code or I want to install any software. So that we can specify with the run command. So what run does basically, run is a set of commands. This execute the command within the Docker image in the process of build. Okay, whatever it is telling, I will give you when I'll write a Docker file, it will become more clear, but just let me first explain the description. Okay, say for example, I want to install something like this, run apt-get update or install Docker image. Okay, next command is copy or add. Copy or add is basically copy the files that are required to copy the content from your base machine inside the container. All right. There is one more instruction that is known as work dir. Work dir is, this is a command that specifies the working directory inside the Docker file. What is the meaning of working directory? Say for example, most of the time when you install any software in Windows, what is the default location of installation of software? C program files, right? Most of the time it is a C program files, right? Where the softwares get installed by default. Similarly, work dir is the thing where we specify where we want to install our code within the container. Okay, if you don't specify the work dir, by default everything will get installed over the root. Okay, so it's a good practice to specify the work dir. All your configuration file, all your software, everything will get installed inside this directory, whatever you are specifying. You're setting the path, or you can say specifying the location where I want to install everything. Okay, and how we specify, we'll specify something like this. We'll say work dir space app. So inside /app directory, everything will get installed. Okay, what do you mean by everything will get installed? Say for example, this is a container right now running, right? Docker PS. I have two containers running. This is one container, this is another container. Okay, this is one machine, this is another machine. Okay, when I'm saying inside the container, what is the meaning of it? If I have to go inside the container, the command is docker exec -it, and let me go inside the nginx container. So I'll say container ID, and I'll say for example, bash command. What is the meaning of this command? I will tell you in a minute. First, let me show you something. So you can see my prompt got changed. Earlier, I have a prompt like docker this. Now I have a root @ this. My prompt got changed. Right now, where I am inside the container. I am here inside this machine. I was here. Okay. I was here. From here, I went inside this machine. I'm here inside a space, because container is also kind of a machine only, right? So I can go inside, I can log in inside, I can install software inside, I can open port, whatever thing that you can do on this machine, similar activity we can perform here. Okay, we are here right now. And what is the meaning of this command? Don't worry, I will tell you. If you give me some time, I will explain each and everything I'll connect at the end. Okay, but we are inside the container. Whenever I'm saying that /app is in this Docker file, basically /app we are creating here, okay, inside this directory. Something like if I do df-h, this is the file system of container. So there will be /app directory that will create and everything will get installed here. Okay. If I have to come outside the container, okay, there is control PQ. If you press the key in the same sequence, control plus P plus Q, press your control key, press P and press Q, you will come outside the container. Okay, and if you do docker PS, the container is still running. Okay. So this is what I'm talking about. So exec, I will explain this command in a minute. Okay, but you are getting it what I'm trying to say. Creating a directory, it means creating inside the container. Run something, installing something inside the container. Okay. Whatever you want to install inside the container, that you specify run command. Whatever you want to copy inside a container, that you specify with copy command. Work dir is where you want to install all your code and everything, that you specify with work dir command. From is the base image on which you want to install everything. Okay. And now there is one more command. I mean, that we specify is known as expose. Expose is like if you want to open any port within the container, that is known as expose, exposing the port of a container. Okay. Like say, for example, if I'm running a web server, I want to expose a port number 80. So I'll say expose port 80. Then port 80 will open inside the container on this machine. Okay. Not here, on this machine. Okay. Now there is one more very important command is known as CMD. Okay. CMD is basically, or the entry point. We will understand the difference of CMD and entry point. Okay. CMD is specify what is the command that you want to your container with to start with. Say for example, you are creating a code. Okay. This code you want to containerize, right? This code you want to containerize. You want to containerize this code, right? So when your container gets started, you want to actually run this code. That code must be running. This is what the whole purpose is. When the container somebody do docker run, actually this code should get started, right? This is what the main purpose. I want my application to be running. So that we specify in the CMD command. When the container gets started, what you want to run? When somebody that docker run, which software, which application it should start, that we specify in the CMD command. Okay, these commands specify that should executed when your container gets started. All right, and you will get all those things. I think you are getting 20% to 30%, that I know, and that is very good if you are getting 20% of it. When you will create an example, your understanding level will further improve. Okay, even if you are getting some part of it. Okay, these are some commands that we use to create a Docker file. Before creating a Docker file, let me write something here to explain you this command. If I have to go inside Docker, the command is docker exec, execute, go inside the Docker. If you want to see what is exec, if you come here in our notepad and we have exec, what is this line number 440 says? Execute a command in a running container. If you want to execute a command in a running container, that is what you can do. Okay. So what we can do here is, if you want to go inside a container, the command is docker exec -i and -t. -i for interactive, T for terminal. Okay. I for interactive and T for terminal. Let me explain this command. Interactive means what is the meaning of interactive and what is the meaning of terminal. Terminal has same meaning. Okay. I is interactive and terminal T is for terminal. Terminal is like, this is a terminal. This is a terminal. Okay. So you are getting, when you run this command, you are getting a terminal of container. This is container terminal command prompt that we generally call. This is a terminal of container where you run all the commands. So T for that. Now, can I interact with this container? Yes, I am pressing ls command. I am getting the output. I am pressing I am typing df-h. I can interact with container. Yes, you can interact with container. Let me come outside, control PQ. I came outside. I'll make sure that my docker ps is running. Yes, it is running. Let me go inside again. Docker exe without -i, only -t. Am I inside the container? Yes. Am I able to interact anything? Nothing. Whatever I am typing is, I'm getting no response. Container is stop interacting with me. So because I have not specified -I, even control PQ is not working. So I have to do control C. Are you getting it? What is interactive means? If the moment you stop I, it will stop interacting with you. It will stop talking to you. T is for terminal. Now the question is, okay, fine, but what is this at the end? You type bash. Why? Because when I go inside the container, I need to tell what command I want to run. Generally, bash is a shell. Like, in Linux, there is a concept of shell. You get shell here. I mean, to interact, a platform to interact with container. Okay. This is bash shell. This prompt you're getting is a bash shell. If you don't type this one, I mean, it will give you the default one. Okay. So let me show you. Control P, Q, Control P and Q. Oh, I have not typed I. Okay. Sorry. And let me do -I. Okay. And if I remove this bash, let me see what is happening. Can you see what it says? Docker exe option, you need to specify a command. Otherwise, Docker has no specific command for you to give. Docker doesn't know when you land what to give you. So you need to tell, because it's a container, it will contain only the things that is required to run your code, nothing more than. It is not going to entertain you to come inside and play with me. It's not for that. Only this code is whatever required for this code. I will contain only those things. And where I will define those things in Docker file. Okay. We are defining everything in Docker file. So when you go inside the container doesn't know how to interact, what to give you. So for that, you have to specify give me bash shell so that I can interact with you. -I is important if you want to interact. There is one more command now. If you do Docker PS, if you are not familiar with exe, there is one more command that is known as Docker attach. Okay, Docker attach. And you have to give, say, for example, Alpine. And if I want to go inside this, I can give ASH. Attach, Docker attach, 1 second. So here you can see I am directly inside the container, ASH, attach. Because for creation of this container, I have already given ASH shell. Remember when I created this container, Docker run. I have given already the ASH shell. So I have specified the container. Whenever somebody log in, you should give an ASH shell. So D for daemon, run as a backend, I for interactive, T for terminal. I have given at the time of creation of the container. If you have given like this, you can directly do attach. Okay, Docker attach and the container name. What is the container name? MyAlpine. So I got directly the prompt. ls, this is the output of this container. Which container? The Alpine container. Okay. Now let me create a container. All right. Now say for example, we now here at some level, like understanding some components of Docker and all. Now let's try to replicate the whole process. Okay, this whole process: code, Docker file, Docker image, and container. So code is something that is written by developer. Code is like code. Remember what is code? Code is from where we started our discussion, right? Somebody has a business idea and you write a code. Code is like application source code. Okay. Any program that you are using, Ramu, like you are using Zomato, you are using Chrome. Okay. Are you using Chrome? Chrome for you is an application, right? For you is an application. You are downloading the exe file, you are installing it. But Chrome, somebody has written the code, like, in some programming language, they have coded this application. How this application is going to behave, how people will log in, how authentication happens, everything, how the UI will look like, everything they have defined in the code in some language. That we call code. Okay. So, and who writes this code? Most of the time, it's a developer who writes the code. All right. So, say for example, we want to containerize an application. So let me create, I'll say mkdir. I'm going to create a directory for my project. I'll say I want to use a Python code. Okay, I'll say mkdir Python Docker app. I have created my project directory. I'm working on a Python code. I'm for a Python application. I want to develop a Python application. So next thing is CD to that. So this is my project directory. This is where I am right now. First thing first, we have to write a code. I'm going to take a very simple code. Okay. And the file name is, say, for example, app.py, vi app.py. Okay. App.py. This is a Python program, and Python program ends with an extension py. Okay. And then we will write a program here, a code here. Don't worry about this code. If you understood, that is okay. If you don't understood, that is absolutely fine, because this is something we are going to not, as a DevOps, you are not going to write a code. Developer will write a code. Okay. So this is very simple application. It is going to print an output, hello Dockerized Python application, and it is listening on the port number 5000. Okay. Let me copy this code also at the notepad so that it has little more visibility. Our app.py is a file, and this is a code. Okay, let me save it here. So the file is here. Okay, this is our code. This is our code. This code is what, whenever you run this code will display this output. Okay, and it is going to listen on the port number 5000. Okay, that is fine. Till here, everyone is good. All right, this is our code and this is right. Who will write this code? Don't worry, it's a developer job. If you understood this code, that is fine. If you don't, it's perfectly fine. It's a developer responsibility. Then we create something known as another file, vi requirement.txt. Okay, requirement.txt is like now whatever the things that is required in order to run this code, that we define in the requirement.txt. Say, for example, this code uses the Flask framework. I'll define Flask. Okay, and there is one more kind of a code application that is required for this one. So this is a Flask framework. You can see here, this is a Flask framework that is used by this particular application. So this is going to be a requirement in Python. How we define the requirement? We create a file that is known as requirement.txt and the Flask. Responsibility of these two files is with developer. Developer will write this particular two files. Okay. App.py, everything is here. Yes, everything is here. Let me see. Okay, vi requirement.txt. Let me also write a requirement.txt. We'll say, where is my requirement.txt? Right. And what is the requirement for my code? Who will know that what is the requirement? Developer's responsibility. Developer will know that what is the requirement of this code. Okay. He will only know, and he will write all those things. Don't worry about it. Now, these two files are here. Okay. These two files are here, app.py and requirement.txt. So what is happening here? We have a folder where we have two files, app.py and requirement.txt. In this folder, we have two files. First one is app.py, and we have another file that is requirement.txt. Now we are going to create another file that is Docker file. Okay, we are going to create our Docker file. Docker file is what? Capital D. And it's a single word, no extension. Okay, this is Docker file. We are going to write a Docker file to utilize these two things inside my Docker file. And using this Docker file, I am going to build an image. This is going to be the process. Are you folks getting it something? Initially, the image will also in the same machine. Okay. But first, let me create a local image. Then what we will do, we will check that we will try to run a container out from this image. We will create a container using this image. This is what I want to achieve. All right, so let's start with Docker file. So what we will do, we'll go to our terminal. We'll say vi Docker file. All right, so first thing first, we are going to write the base image. Like this application is created. This application is written in what? This application is written in Python. So we'll say from, okay, we'll say from Python 3.9 Slim. Okay, 3.9 Slim. So this is Python 3.9 Slim. Where is this Python 3.9 Slim? If you go here and say Python, okay, and if you go to this Python, this is the Python image, okay, Python Docker official image. And if you go here, like, there are so many versions of Python is available. There is Python 3.14, 3.some, 3.14 Slim. Okay, out of these many version, what version is useful for you? You should ask your developer. Okay, you should ask your developer, like, I should use this image, which image, which version of Python. Okay, that we need to ask. Okay, so once we have that clarity, we can go ahead and choose the base image. Okay, say for example, I'm using 3.9, right? So 3.9 maybe somewhere here, 3.21, 3.12, 3.11, 10, 9, right? So this is one of the image that we are using, 3.9 Slim, this one. Okay, this is the image that I'm using here. Okay, so this also we need to understand. So I'm using 3.9 base image, and then we are specifying like what are the files that I need to copy here. So I'll use copy what? Copy, or let me first specify the work dir. I'll say work dir, okay, and I'll say /app. So I want to install everything in /app inside the container, okay, and there are some requirements, like we'll say copy. I want to copy what? I want to copy requirement.txt, because this is something I want to copy. Okay, say this one. Let me go to diagram here. So these are the files that I want to copy, right? app.py and requirement.txt. So okay, inside this file, inside the Docker file. So for that I can use copy. So this is the from statement that we are creating the base image. We are specifying the directory. This is what it is, the directory is, okay. Now after that, what we are going to do, we are going to write a, we are going to tell, like, this is what my app dir, work dir. Now we want to copy what? I want to copy, tell me what should I copy inside the Docker file? What is required to copy inside this Docker file? Do I need to copy app.py? Yes or no? Yes. Do I need to copy requirement.txt? Yes or no? Yes. I need to copy these two files. Okay. So what is the copy command syntax? Any copy command syntax is source and destination, right? So what we will do, we will say copy dot to dot, or you can say copy dot to /app if you have any issue. Okay. But you can say this is a more professional way. What is this? We are specifying to install everything on /app. This is become our work dir. Copy dot means whatever in the current directory. Dot is the current directory in Linux. Whatever inside here in this directory, copy everything to Docker file. I mean /app. It will copy everything to your Docker file. This is what I want. Okay, inside the Docker file means here in /app. Why these two files are required? Because these are the two main application that is required to run my code. This is my code. This is the dependency of the code. All right. Next thing is what we need to copy or we need to say, for example, let me write it very simple. Otherwise, what we can do here is we can say copy requirement.txt to dot one file, and then I want to run. Yeah, that is why I changed it. Okay, I just mentioned one file. Requirement.txt to dot, okay, to the app.dir. Then I want to install whatever mentioned in the requirement.txt. I want to run those things. For that, there is something known as pip, is a package manager. So I'll say run, okay, pip install. Let me copy this thing. So this is whatever mentioned in the requirement.txt. I want to install that. For installation, where I want to install inside the container, right? When the container will get created, whatever mentioned in the requirement.txt, it should get installed here inside the container. For that, I am mentioning a command pip install no cache dir means flush the cache, and whatever mentioned in the requirement.txt, install it. What is pip here? pip is a Python package manager. Okay, Python package manager that will, whatever you mention in the requirement.txt, it will install it. Okay, so this will install it here, the package. Then what is next thing? We'll do copy of dot, and we'll say, or we can say copy of app.py, or copy of what you can say, copy of app.py, or copy of dot to dot. Basically, we are copying all the content of our application app.py to here. Okay, then what is the thing? We need to expose the port. Our application listens on the port number 5000. So I'll say expose port 5000. You can see here it mentioned that port is 5000. So I'm opening that port in the container. Okay, then we are specifying cmd command to run, like at the start I am telling that you should run a pipe. You can run this one. Okay, cmd python app.py. App.py is already copied here in app using this command. Okay, so whenever my container gets started, you should run any Python program. If you want to run, you have to, let me open this Docker file one more time. Any Python program that you want to run, you have to run Python and the program name. So this is what I'm telling you. Run Python and run this program when container gets started. What is cmd? Cmd will only run when a program, this command will specify the command that should executed when the container gets start. So when your container gets start, which application is going to run? This code is going to run. Your code is going to run. Okay, so we have a Docker file that is ready. Okay, so we have a Docker file that is ready. So if I clear my screen, if I do ls, we have Docker file app.py requirement.txt in the same directory. I'm at the base machine. From this Docker file, the next step is to create image. And folks, if you are not able to understand each and every part of Docker file, that is completely fine. I will again explain it. First, let me run through this whole process so that your concept should become clear. I will write couple of more Docker files and it will become clear. Okay, so don't worry about it. So what is the next step from Docker file? What we want to create? We want to create image. Okay, we want to create an image. So let's create an image. Before that, let me delete all the previous images. Docker images. I can see I have couple of images, Alpine, Nginx, blah, blah, blah. So, and if anything is running, Docker PS, there's some container running. So what I'll do, I'll do Docker stop, and I'll stop these two containers. I'll say stop, stop. I'm stopping both the containers. It got stopped. Let's wait. It will be stopped. So it got stopped. Can you see that? Yes. So let's delete everything from my container. Like, I want to delete all the container, all the images and everything. So for that, there's a command is known as docker prune. Okay. So let me run docker system prune - all. Don't run this command in your production box or anywhere. Okay. This is dangerous command. It's my test machine. I want to delete all these images, all these container, everything from my machine. So that is a command. Otherwise, if you just want to delete images, okay, and if you want to delete even docker rmi, remove image, and you can delete Alpine. So it will remove the image because right now the container is holding. So first you need to delete the container, docker ps-a. You can see there are so many containers because this container is holding that image. So what we need to do, we need to first delete the container. So how to delete the container? Docker rm and the container name. Container, docker spelling is wrong. Docker rm and the container name. Container is gone. Whether container depends upon other container. Okay, there is another container. So let me delete Ubuntu. So what we'll do docker ps docker ps-a. I'm just cleaning my system so that you should not get confused. So I want to delete everything. So this is exited. Let me delete one of the container and docker images. Okay. So first, if you want to delete image, let me first stop docker rm and the container name. What is the container name? Ubuntu. This is the container. You can give container name or the container ID. It will remove the container. Now if you do docker ps-a, you will see that Ubuntu is gone, right? Ubuntu is gone. So that is fine. Ubuntu is gone. So now what you can do, then you have to delete the image. Then you say docker rmi remove image. What is the image? Ubuntu image. You can say delete image. First you need to delete the container, then image. Then this image is also got deleted. If you do docker images, okay, it will say you can see Ubuntu is gone. But this step you have to follow for each container, each image. If you want to delete everything in one shot, then the command is docker, okay, system prune -r. If you want to delete all the container, all the images in one shot, okay, then it will delete everything. But it is a dangerous command because it will delete everything. Now if you do docker ps-a, there is no container, okay, docker images, there is no container. I mean images, there is no images. So our system is blank, okay. Okay, so system prune is little dangerous. So now we have, if I do ls, I have docker file, app and requirement. Do we have any image in our system? Images? No system, no image. Do we have any container running on our system? No, there is no container. Our system is almost kind of a brand new system. Now we are going to create our own image using docker file. So command is for that, docker build, okay, and you can give some tag, like say I'll say -t, I'll say Python docker app, something like that. Okay, I'll say Python docker app, and dot is like your context. Where is your docker file? Where are all those images? You can just give, because we are at the same location. Okay, so we can just give dot. If you run this one, it will start building an image. Can you see that it start building an image here? Okay, let me see what happens here. Do we have image created? Let me copy this command, docker build, and copy this command from here to here. So what, oops, so what happened to this command? Something happened or what? Control Z. Do we have copied all this command? Yeah, but here you can see this is got copied. This is created, naming, porting images, copy something, exporting, writing image, naming docker app, caching something. It happened, but let me see what is the message. It's something weird, right? I mean, it doesn't look copied good. Doesn't look good. It's something weird. I'm not copying it. First, let me see. Image got created. Docker images. Yes, an image got created. Can you see that this is our image got created? Are you folks able to see it? This is just got created. That is why it's giving me a minute ago. So we are till here. We have Docker file. We have images. Now from image we want to create container. Okay. So let's create a container. Docker. What is the command to create container from an image? Docker run, right? So we have docker images. Yes, we will create docker run -d. I want to run in a background. I'll use one more option, that is known as -p. -p 5000:5000. What is the meaning of this -p 5000:5000? I will explain you in a minute. Okay, and I will give you the image. Yeah, but there are two ports, right? But what is the meaning? I will tell you in a minute. First, let me create a app. Okay, so this is docker run -d, the command to create a container. Let's see. A container got created. Let me see. Docker ps. Yes, container got created and it is running. Okay. Now I want to access my application. I want to access my application here from this. For that, let me just log into my virtual machine. The virtual machine has a public IP address. This, the VM over which we have installed Docker. This is an EC2 public IP address. Okay, let me open a port on the security group. Okay, then I will tell you one in a minute. All right, so it is something like this. Okay, this is our container. That is our EC2 instance. Okay, This is our container that is running inside this EC2 instance like this. Okay. And we are sitting here. We want to access our application. So first thing first, your request will go to the physical machine. I mean that VM, and from VM it will go to the container. Okay, something like this. It will go like this to container. For that, we have given the IP address of this guy. So let me copy this IP address. Go here, type it and mention colon 5000. Can you see that hello Dockerized Python application output? This was our same application output. So let me quickly revise it whatever we have covered. देखो सबसे the most important thing that you need to understand is this. We have a code. That code I want to run inside the container. That's it. This is what actually we want to achieve, right? But can we run this code directly inside the container? No, there is a process for that. From that code, we have to create a Docker file. Docker file is a text file that will have some set of instruction. That instruction is basically we write how this code is going to run, what are the dependency of the code, what are the package that is required to run this code, whatever it is. What is the port number required, what is the command, what is the application that I want to, what is the command, what is the program that I want to start when we launch the container, everything we specify in Docker file. Okay, when Docker file is a text file. From it is just a text file. From this file we cannot do anything. I mean, we just define it. But from Docker file, using this Docker file, we create Docker image. So whatever the mention in Docker file, it's get recorded here in the form of image. When the image is ready, we create container out of it. That is the process for any and every container. In our case, we have a code that is app.py. It's a very simple code. This code will generate this as an output. This is a web application. This will generate this output. How this code is written, why Flask, it's all developer responsibility. Leave it. Okay. And apart from that, developer also mentioned, because in Python, if you have any dependency that you want to use in your code, that you have to define in requirement.txt. All right. I want to run this code. And for that, there is some requirement. Everything I have mentioned in the Docker file. Now let me copy the Docker file here. Let me put it side by side. This is our Docker file, right? In this Docker file, we mentioned that this program is written in Python. So we say that we will use a Python base image. That is fine. This will create one base image like this. Okay, this is the first layer of my image. Then I said create a app directory /app. So it will create a /app directory here inside this image. Okay, forget about this one. It will create a /app directory like this. Okay. Then it says copy requirement.txt. So whatever the requirement.txt, it will get copy inside the /app. Then I said pip install requirement.txt. Whatever mentioned in the requirement.txt, it will install that one. That is Flask will install, because in requirement.txt Flask we have mentioned. Then we mentioned copy dot. So whatever available inside this directory, you can see also Docker file is also got copied. So this directory has 3 files: app, requirement, Docker. Everything will get copied inside /app. Why /app? Because we have already defined it. Then we mention expose port number 5000. Then a port will get open, 5000 will get open over this. Now after that we mention cmd. This command will only execute when you run docker run. The moment you run docker run command, it will start creating container and it will see what you have mentioned in the cmd. Okay, you mentioned run app.py, so it will run app.py. And what is the output of app.py? The output of app.py to display this message. This is what the output of this command. It will say print this, define this, and we are calling it and it will define it. That is why the moment we created the container, we got this out. Now the question here is, what is this :p.p, right? P dot, what is this? Where is this command, right? What is the meaning of -p and p? This is what the next thing that we are going to learn. Okay. We have p -p 5000 : 5000. Okay. To the second one, the second 5000 is telling about the container port that is mentioned in our code. And the first 5000 is telling me the base node, this node code. This is the VM on which we have installed Docker. So what happened? Let me tell you about the Docker network. The moment you have a machine, let me stop the container. Okay. See Docker ps. Let me stop this container. I'll say Docker stop. Container name Docker got stopped. And if we do Docker ps, nothing is running. Okay. Now this is my Linux machine. How to see the IP information of Linux machine? What is the IP address and what is the port? The command is IP addr show. I want to see the IP addresses of my machine. The command is IP addr show. If I run this command, you will see that I have a couple of things. This is L0, this is ETH0, this is some more port. There is something known as Docker 0 also, right? This is the basic. But if you install just ifconfig is also, that's a I would say previous generation of Linux. Now they have changed it, IP addr show. ifconfig will also work, not a problem. If you just install a Linux machine without installing Docker, you will see this command only. Okay, I can show you. Maybe tomorrow we'll launch a new machine and I'll show you. But if Docker is not installed, Docker not installed. Remember, we have installed Docker yesterday. You will see only these output. Okay, this is loopback address that we call, that is for 127.0.0.1. Every machine will have a loopback address. You can go to your Windows, you can go to CMD, and there you can type ipconfig. Okay, config/all, ipconfig/all. You will see all those things. Okay, IP address of your Windows machine, loopback address, everything. Okay, same thing in Linux. We can see like this. This is the ETH interface. ETH is an interface. Okay, that is, every machine will have a network interface card that is called NIC, network interface card. Okay, if you go here and you to type NIC, and if you see the images, this is NIC, network interface card, that your laptop has an NIC. But right now in our case, in our home and everyone, we have Wi-Fi NIC. Right, we don't have wire nowadays, right? Earlier we used to put RJ45 cable and all. In your home, if this is your TV, this is your smart TV or mobile phone, your mobile phone also has a Wi-Fi NIC. Your TV has an NIC if it is a smart TV. And you have in your home, there is a router, right? Airtel router, AT&T router, or whatever, it is a router. Okay. When you connect your NIC, give your password, and for this you connect to this router and then you connect to the outside world, right? This is what happens. You can see Facebook, all those things, Netflix and everything like this. Are you getting it? But for that, NIC is required. That's a network interface card. This is what NIC for the virtual machine, ETH0. This one is for cloud specific because it's in Azure cloud. Just ignore this because they kind of install one more interface for other connection and other processes, other services as well. Right now, I'm just ignoring it, okay? Because most of the time you'll see only this. Cloud specific, I'm just ignoring it because we are not learning cloud here. Okay, so this is the interface card of this machine. Okay, the moment you install, we will talk about cloud here. So Wi-Fi, you understood. This is the network interface of the card. The moment you install Docker, there is a bridge get created that is known as Docker 0, like this. This is a network driver, Docker 0. What is this Docker 0? This is a network driver that get installed when you install Docker. So now that is why we are able to see this Docker 0, because we have already installed Docker here. Okay. When you create container, let me create container now. That our container. Where is that? Docker run. Yeah, this is the command, right? We have run this container. We got a container got created. Yes, container got created. If I do Docker PS, container is running. Now let me show you the IP address. IP ADDR show. Can you see that L0 was there, ETH was there? We have ignored this guy. Docker 0 was there, but there is one more interface. VETH something got created. So what happened when you create a container will get created like this. This container will have its own network interface card, NIC. That is VETH something. I'm not giving this much long name. It is very difficult. VETH, I'm just mentioning VETH, virtual interface, and some number. This will also have an interface. Now we want to access application. Our application is running where? Our application is running inside this guy, right? This app.py is running here, right? It is running here, and I am sitting here. I want to see this application over the internet using my laptop. I have used this. This is my laptop, right? This Firefox is my laptop, right? I am having my laptop. I am running here. Okay, I want to use Firefox for that. I want to connect this guy, app.py. So how the connection will work? Let's try to understand. The moment I'll make a request, the first request will goes to NIC. Okay, let me make a little bit more professional. Instead of curve, I'll use rounded. Okay, so this is, it will go to NIC. From NIC, I have opened a port 5000. 5000. That is why I mentioned Docker run first 5000 is for this guy. Can I use any port? Yes, you can use any port. It is not necessary that whatever open in the container, you can use the same container. It's not required. It's not at all necessary. Okay, I can show you. I can run one more container using the same image. This time I'll use some other ports. I'll say 8080. Is it created another container? Docker PS? Yes, two containers are created. Okay. Can I access the application on 8080 as well? Let's try. Copy this thing. Go here. Put it here and mention colon 8080. I get the output. But this is a different container. Okay. I'm not attaching with the same container. Though both are running the same application, but app.py is running here, and this guy will also have its VTH. If you want to see, let me show you. Right now I have only one VETH, right? Docker 0, one VETH. Now let me run IPADDR show. Can you see that I have two VETH? Second container ka virtual interface. So when I'm hitting this, now let me tell you how traffic flows. Okay. So when I'm hitting this IP address at the port 5000, when I'm hitting this application at the port 5000, okay, my traffic is going and hitting here, and I see of that 5000. 5000 is matched with this container. So it will go to Docker 0 to this VTH, and we are able to access our application. When I'm hitting this IP address at the port, 8080, it will go to Docker 0, it will go to VTH, and you can see app.py running on this container. Because the application is same, so we are getting the same output. Now let me go here. Let me take two sessions here. Okay, I will take duplicate session. I will go to this machine as well. Okay, so these are the two machines. This is one, and let me also do sudo sudo here, and I will say Docker PS, and here also Docker PS. Okay. Oops, sorry. Same machine, we have two containers running. Here also two containers running. I am going to log in one container at a time, okay, on these machines. So here on this machine, I will log into this container. I'll say Docker exec-it. This container, I'll say /bin/bash. I'm inside this container. In this machine, in this terminal, I log into second container. Docker exec-it. This one, and I'll say give me bash shell. I'll say bin bash. This container I am at 9b3. This one I am at 670. Two containers running, I am logging into. Let me clear the screen. Clear. Now let me run IP-addr show. Okay, sorry. I mean, the package itself is not installed. I mean, IP-addr is package must be netutil package must be installed. So in our machine, we have not installed netutil. We have just installed Python application. Are you getting it? Because IP-addr is a command that must be installed. In our Linux file, in our here, we have just mentioned to install this, right? Pip install to run.txt. So the package is not there. So let me run docker run -dit. I'll say container A. Okay. Alpine ash -. So it is creating one container here. Let me create another container on the same machine with container B. I am creating container B. So I have 4 container running here. Docker PS, if you see, I have 4 container. Okay, let me show you the output like this. Otherwise, you will get confused. Can you see that I have 4 containers running? Container A, container B, and this one. Let me log into inside this container. Docker exec, or let me do docker attach. Docker attach to this container. attach. And inside this container, let me log into another container here. And I'll say docker attach this container. If I do IP-addr show, this container has this package. Can you see this interfaces? Let me make big screen, otherwise it's not very clear. IP-addr show. This is a loopback address of the container. This is ETH of that container. But this ETH is like this. We are here. Okay. And from this container, if I want to ping google.com, am I getting the response? Yes, I'm getting the response from google.com. Okay. Now, how the traffic is flowing in this time? I'm inside this container. Okay. I'm right now inside the container and I want to connect Google. Google is somewhere running over the internet, some in the Google cloud, right? How the traffic is flow? It will go to Docker 0, from Docker 0 to NIC to internet, and internet to tada. If somebody wants to connect me, it will come like this, NIC, Docker 0, and this. If I want from inside the container, if I want to connect like this, that is one. Okay.
Just a quick info, guys. Intellipaat, in collaboration with Microsoft, offers an advanced DevOps certification course. This course is designed for both beginners and experienced professionals, featuring live instructor-led sessions along with self-paced video content to help you become a skilled DevOps engineer. You'll master modern DevOps methodologies, practical DevSecOps practices, and also the use of generative AI tools in CI/CD pipelines, automation, and infrastructure management. You'll also work on 60 plus hours of industry relevant projects and case studies, real time labs powered by AWS, simulating production level environment, 15 plus in demand tools used across the industry. With 24/7 support, placement assistance, and EMI payment option, this course, without a doubt, can set your career to new heights. You can check out the testimonials on our Achievers channel, whose link is given in the description below. Also, visit the course page given below in the description and take a first step towards career growth in the field of DevOps.
So now that we have got our app containerized with the Docker, it runs the same way everywhere with no problems or any kind of production crashes. But here's the thing, building, testing, and deploying that container manually every time, well, that's clearly not scalable. And that's why we need CI/CD pipelines in the flow. So CI/CD stands for continuous integration and continuous delivery, which helps us automate the entire pipeline process from the moment your code is pushed to the GitHub to all the way into the deployments. And one of the most popular tools here to set this up is Jenkins. Jenkins lets us create the pipelines that build the code, run the tests, package the code in a Docker container, and even deploy it. All of it without any kind of manual workload. So let's see how the Jenkins ties it all together and make the DevOps process actually feel all automated and smooth.
Now, the next topic that we need to cover in our DevOps course is the next topic, which is the continuous integration using Jenkins and Maven. So we'll go one by one here. First, we'll look into what is Maven, then what is Jenkins, then what is continuous integration, and all this stuff. We will be looking at it practically again, like we did everything practically with Git, right? So this is the agenda for today, team. Whatever is possible in this one, we will try to learn today's session, okay? That is the main agenda. Now with Git team, we understood, remember that the developers usually work on a source code development or a code writing, whatever it is, they technically develop the software code and they always place it on the version control system like GitHub, right? Multiple developers will be updating the source code, the code for a software development, whatever it is, and update it into a version control system. Now, what we tried to do till yesterday, the team was all the dummy files only. But yeah, we need to understand the real source code first of all. How does it look like? Maybe something like that. Now, if you look into this team, you will find the real Java code. Basically, for example, if I go to this src folder here, and there is some predefined directory structure, everything followed by some developer, right? So if I go into this and say some real Java code, I mean, the code can be in any programming language team. In this course, we are taking an example of Java code. That's the only idea. But yeah, the code can be in any programming language, which may be written by simple different developers. But right now in this course, we are taking an example of Java code and we'll try to look into this. Now you see that the real Java programs, right? If you open it, all the real Java programs are written here. Now understand team, this is the source code, which means using this, you can actually build a web application, right? Remember, I'm just telling you upfront, this is basically a web application, like you access a website. So I understand that some developer has written a code, develop a website, simple website, right? So this is how it looks like, the backend code. When the website, it might be looking neater on the browser when you access it, but really in the backend, this is how it looks like, all the code written by the developers. So we'll be taking this as the example application, example website application developed by some developers, and we understand that what we're going to do or how we actually can go ahead and then start running it on a server, access it, and then understand the various process. Once a developer gives you the source code, what do we do? That is what the idea is. Okay. Here, the developer had given you the source code. The source code in the sense there is something, some particular development is completed with a requirement given by a client maybe. Now, what do I need to do with this code is the question here, right? What can we do? Or how this code is taken and run it on a server and then make it available for the end users. How do I make this software functional? Right? How do I make the software functional so that the end users can start using the software and enjoy the features of it? Maybe that is a simple idea, right? So what do I do with this code is a question. So understand team, the GitHub is now your version control server where your development team had completed a development of software. And then they said, hey, we are done with the development, take it and run it on a server. That's what is the single. Now, understand team, what we find on a GitHub like version control server is always called as your raw source code. I always call it as the raw source code, a raw format of the actual software that you have. Now, what do I do with this? Can I take this or can I simply copy this code, say git clone on a VM server and then say that my software is ready to use? Can I do that? No, right? Usually team, remember, whenever you try to in your laptop, right? So how do you install an application? Even it is a desktop application or anything, think about a simple scenario. Did any of the application that you installed in your laptop, did you get the source code of that, the raw format of the source code, or something like you got some executable file? Like what is that format you see it always while you're trying to install? It's basically some kind of the executable format, right? Correct. So keep it in mind that the raw source code cannot be run or installed on a server directly. It has to undergo some process to convert the source code into a deployable format, or we say that installable format, or you may even call it anything, executable format. Remember, team, I'm saying it, the raw source code, right, on a GitHub, like SCM tool. SCM is source code management, remember that, right? Cannot be, right, cannot be taken and run on server. Now, what do I need to do is that basically the idea, we need to convert the raw source code into, I'll say multiple names, into a executable. Now you may find this is what the regular word that you see in your desktop like applications. But yes, in the real world, we also say the same thing called as the installable format, or it may also called as your deployable in the sense you can deploy to a server, right? Deployable format basically, right? Now going forward, team, I may be using the word most of the time is called deployable because that's what we use in the real time, a deployed software or deployment of software, something like that. So you can call it as installable or executable. Both are, or all of them are one and same thing. That is the idea. So understand that the raw source code needs to be converted into a deployable format basically. Okay. Now we understood what to do, but how to do it. So the question is how to convert the source code into a deployable format, right? That is what all we needed to know. So how do I do that? Technically, what we see is that basically there is a process we follow, right? In order to convert the raw source code into a deployable format, there is a process we follow. Now that's what I'm saying here, the process of converting, right? Converting the source code, right, into a deployable format is called a build code process. What is this called? Understand, team? There is something called a process we're going to follow that's called as a build code process, or we simply say that we need to build the raw source code into a deployable format. We need to construct it basically. That's the idea. Okay. So how do I build the code now? How do I build a code or the building? You may think, right? Whatever it is. How do I build it? Now, this is where again we talk about something called build code process can be done using some build code tools. Simple, right? Like in order to record the changes of the source code, we use a Git as a version control tool, right? Now, in order to technically go ahead and then build the code, we might need some other tool that will help us in converting the source code into the next one, right? So build code process can be done using some build code tools. Now, there are multiple build code tools available, to understand it. It's like if I want to play a movie, I have multiple media players like VLC, Windows Media Player, QuickTime, something like that. To perform certain tasks in the market, we will always find a multiple solutions, right? So the build code process also can be achieved with the various build code tools, right? Remember the build code tools available in the market, right? And again, remember team, the scenario here is that, and we do have a multiple different types of programming languages, which I mean to say, in this case, we are taking the Java as a source code, means Java as a programming language to build the application code, right? But you do have a Python, you do have a .NET, you do have PHP or a Go, whatever it is, right? Now, what I'm trying to say is that based on the programming language used, we again will find a different build code tool. For example, I'm saying it, Java is a programming language for me for this scenario. So I can use a build code tool called Maven or maybe Ant, which is a very old tool, and say there is something called a Gradle as well, right? Again, remember, if the source code written by a developer using the Java programming language, now these are the build tools that can be used for build the code or converting the source code into deployment. For example, if I use a .NET, then I use something called MS Build. That's a different tool. If I have a Python based tool, so then I say py build, something like that. So depends on the programming language, right? There can be a different build tool you might have to use it. It's not the same build tool for all the types of programming languages. It is different from programming language to programming language. That's what you need to keep in mind, okay? Now, in the whole scenario, the course that we're talking in this course, basically that's what we said right here. It says continuous integration using Jenkins and Maven. So technically the Maven is the build tool. Now the question here, as I said, what is Maven here? If I understand it, what is Maven? Why Maven is coming into the picture for us? This is where we simply say that if somebody is asking you a question like what is Maven, you can simply answer that Maven is a build tool mainly used for Java projects. That is a simple idea. Okay. This can be a simple question, and the straightforward answer is always to be saying that it's a build tool. Okay. That is what the answer. You got it now. So the first question, what is Maven? Maven is a build tool. Now, why do I need this tool? Because we need to convert the source code into a deployable format. That's where a Maven as a build tool that helps me to convert the source code into a deployable or installable format, basically. Okay, that's a quick introduction about what is Maven. The intention, the purpose of all the different tools are same, right? But the only thing is that implementation side, they'll be a little different. Like if I use VLC Media Player versus Windows Media Player, the purpose, both of them is to play the movie, but they might offer you a different set of features based on the things you do it, right? The same thing here as well. The end goal of any build tool is to convert the source code into some deployable format, right? But yes, they may offer a little bit different features based on the program you use it or the purpose you use it technically. Okay, so now this is the quick introduction. We have it, right? Now you understood what is Maven and why is it Maven required here. That is the first topic to be covered today. If I get into a little bit more of Maven now, how Maven works for you. So let me open up a simple PPT so you can understand it. Right, so talking about a little bit more of Maven now, you understood why Maven is required. So again, if I talk about this in a more technical terminology, I told you a very layman terminology, something called Maven is a simple build tool. But if I say Maven is a software management and comprehension tool based on a concept called a project object model, in a simple way it's POM, which can manage a project build, reporting, and a documentation from a central piece of information. Okay, I don't want you to confuse with definition. You will understand as you start practicing it. I'll show you practically what is this POM meaning to you and everything. Again, what is a POM? At the core, if I say, as a fundamental unit of work in Maven, POM is an XML file. Remember, POM is basically an XML file that contains the information about the project and the configuration details used by Maven to build the project, right? So if I'm asking you to do the job, team, I need to tell you how to do the job. That's all, right? Similarly, if I'm asking Maven to build the source code, I need to tell the Maven how to build it. Now, how to build is what we give it through the XML file. That's the simple bare definition I can give you again. I'll show you this XML file. You won't be writing it. Remember, it's the responsibility of a developer who will give you all this data for you. All you need to know, how do I execute? Let's get into the part. Okay. So again, a project object model. If I just give you, let's say that the Java source code I'm telling you, within the Java source code, you see a file called pom.xml here. Simple, right? That's what I'm saying here. This pom.xml is the core if you're trying to use Maven as a build tool. Simple. If I open up this XML file, and again, you really need not to understand anything in this file, to be honest, right? It's all that the developer will do, and developer will write this file and will give you. If this file is not correct or accurate, if it is giving you some problems, maybe while you execute something, you can report it back to the developer. Developers will fix it. So keep that in mind. So don't worry that I have to write this XML. No, you don't need to. Okay, so in a simple words, I'm telling you, it has something called project information. Like this is a DevOps demo project. I'm saying it simple, and so on. So a lot of information in it. How do I build the project and blah, blah, blah stuff. I'll talk about this file in more detail as we start executing it. But understand that in every Java project, there will be a file called pom.xml, because if I use Maven, I must have this file. This is the file which I use to tell Maven how do I build the source code basically. Okay, now that's what the idea. Yeah, right? That's what I'm saying. Fundamental unit of work in Maven. It's an XML file that contains the information about the project and the configuration details used by Maven to build the project. The project.xml is in Maven 1. The current Maven version is around 3. So Maven version 3, we have it. So from Maven version 2, the file is renamed to the pom.xml. Simple that. Nowadays, you always see pom.xml. If you're working very older, say 20 years back, 15 to 20 years back, then you would have seen something called project.xml. Again, you don't need to worry about it. Forget it. Okay. Now, this is a simple basic detail. As I said, the project name that you have it. And one thing that you need to understand here is that the build life cycle, right? With Maven, we have something called a predefined build life cycle. All it says that in Maven, the build is run using a predefined ordered set of steps called the build lifecycle. So you don't need to do anything by your own here. Maven already has all the predefined set of steps that you should follow them, right? What step to follow, when do I follow, all those things you need to know. That's the idea. So the individual steps are called phases, and the same phases are run for every Maven build using the default lifecycle, no matter what it will produce it. Don't worry about what output it will produce. Just execute the phases one by one. That's all you need to do. Okay. So the build tasks will be performed during the each phase are determined by the, again, I'm telling you how the build is executed is always written in the project file. That is nothing but your pom.xml. That's what I'm saying. The build tasks that will be performed during the each phase are determined by the configuration in the project file, and in particular selected packaging. That's the idea. Everything is written within the pom.xml, how it should build everything, right? So the predefined steps, they will be like this. You simply see it as some of the most commonly used lifecycle phases is like validate, check the build prerequisites, compile, we'll talk about again, test something, running the unit test cases, package it, assembles the compile code into a binary build result, like the executable file we call it. Install means it is going to put it into some machine, blah, blah. Deploy it, it will try to deploy it somewhere else. So these are the predefined set of steps that we will follow, whatever is necessary for now, accordingly, step by step. Okay, this is just a basic idea. What is Maven and how do I look into Maven basically? I hope that I'm clear on the basic steps here. So now let's try doing it practically once by installing the Maven. Okay, what do I need to do now? If I have to start using the Maven, all I need to do is that we need to install the Maven tool and then start using the Maven tool. Just like you have installed a Git client on your EC2 instance. Now I'll be using the same EC2 instance, right? I'm not going to change anything here. So I'll go log in this one and I try to install the Maven. Remember, Maven is also command line tool, just like the Git. So what I'll do, I'll go here I log into the VM, then we install the Maven tool, then we're gonna just start working with it. Okay, so this is the one, and I say Ubuntu @ the public IP of my instance. Say yes. Good. Now remember team, these were the projects that are dummy projects we were working on till yesterday. Now I'm not going to use any of these things. The idea is that first of all, we already have a Git software installed here so that we can simply get the source code, whatever is on the GitHub, to my local computer. Then we need to have something called a Maven, MVN version. That you see that if I try to run a command called MVN, which is a short form for Maven word. So if I say MVN version, it says, okay, the Maven is not installed, right? But can be installed with something, it says like this. Don't follow this, okay? It might install some older version of a Maven if I simply follow this. I'll give you the instruction using which you always try to install the Maven, okay? So right now, we need to go to the Maven Jenkins, remember? So I have a folder here called Jenkins. I'll talk about what is Jenkins in some time. Right now, we're gonna talk about this. Jenkins and Maven comes in a combo. Let's say that if I go into the Jenkins folder, right? And there is a folder called install, right? Now under the installation folder, again, I'm just giving you the right path if you're looking for in the chat box again. Now within this one, I have documented all the steps that is required. And remember here, since we will be working on a Java project, right? A Java based project here. We also need to install something called Java on my machine, which may not be there by default again. It says that Java is also not found because I tried getting a Java command. It says it is not found. So what I need to do, since our source code developer had given me a Java source code, so I must have to install the Java. That is the first prerequisite. Then to build this Java code, we need a build tool, that is the Maven. We're going to use it. So we will be installing Java first. Then we're also going to install the build tool called Maven later. Then we start using them accordingly. Okay. So to follow the instruction, this is the folder I have it. Now I have the install Java instruction, install Maven instructions for now. So I'll just take this instruction as it is and I start executing on my laptop. Nothing but my EC2 instance where we'll be practicing all the practicals. I've just ran the add apt repository from where the Java needs to be downloaded. And I'm finally saying that apt install Java, which is an OpenJDK, remember, OpenJDK 17 version is what I'm installing it here. So this will install the Java software on your EC2 instance, okay? You can also install the Java on your Mac or Windows machines, which I don't want you to do that. Let's say that everyone will be having a common system, which is a Linux system. Then everybody practice on Linux system itself. It will be easy for us to understand everything. Okay, so now it seems that it's installed. If I try to hit the Java -version, now this time I see a response that the Java is installed, which is OpenJDK 17.0.14. That's what is installed. So that's fine for me. Now, once the Java is installed, the second thing is about installation of Maven. Okay. Now let's say that there are certain instruction. Again, I kept it here. So just follow the instruction as they are to install the Maven. Do not follow the default setup that Ubuntu may prompt you. Okay. The version that I'm installing is called 3.9.6 Maven. That is the specific version we are installing it as well. So I hope you know the basic Linux commands. We tried downloading the Maven tar bundle, which is a zip bundle. Then I'm trying to extract the zip bundle into a /opt folder, right? I think this command would require a, the sudo privilege tree. Maybe I'll switch to the root user if you can. Otherwise, it may fail. Remember that. So this is what you do, and run the other instructions as well. Okay. I'm just setting up something called a path variable for my Maven so that I can run the Maven command freehand anywhere. That's what all I'm trying to do here. Setting up the Maven home environment variable to access the Maven from anywhere. So I say that mvn -- version. Now you see that the Maven is also responding to us. Okay. Which means that now on the same EC2 instance where we were using the Git client software so far, the Git till yesterday we were using it. On the same instance, we now installed Java software because we're going to work with Java project, a real Java source code. And then we use the Maven as a builder tool to convert the real Java source code into an executable format. That is simple logic, or an installable format. So I have done all the prerequisite where we are trying to do this. It is the Maven home setting path. Technically, you see that this is right, Maven home. I'm setting that. This is where we install, right? If I go to the OPT Maven, now this is the installation path of my Maven where my Maven binary exists. Now, if I want to call this Maven dynamically from anywhere in my EC2 instance, I need to set this environment path, and I'm reloading that configuration. Profile is something like your profile configuration that to access the Maven from anywhere. It's like an environment variable we call it. Okay. Right. So now that we have successfully installed the Maven everything, now what do I do? How do I build the code is a question. Now understand, team, what all we have done is that we have taken a VM, right? And on the VM itself, we tried installing all the stuff. So this is my EC2 instance, remember? This is your EC2 instance or your VM. Basically, it's a Linux-based operating system, right? Now on this one, previously we installed Git client, which is basically that, and then say now install the Java software. And we also installed Maven software. Basically, this is what all we tried doing it. Right, so here it is. This is the EC2 instance, EC2 VM on which we installed Git client, we installed Java software, we installed Maven software. That's all we tried. So we are now ready, team. Now, how can I build the code? Basically, is that as I said, Maven gives us the predefined set of lifecycle steps, right? That's what we discussed here. It's like we need to use these lifecycle steps to do certain tasks, something, right? So I'll explain what are all those things basically. Okay. Now, the first thing, if I have to build the code, what do I need basically in my system? We need to have the source code. We already have Maven installed projector, right? We need to now have the source code, right? Without having a source code, how can I build the code? So technically, the first thing that we need to understand here is that we need to get the source code to my local, right? That is what all we need to do. If the source code is available in my system, then only I can go and build it or perform some action on that source code basically. So what I'll do first of all, how do I get that code to the local? How do I get a Git repository to local? When there is nothing in my system, it is like using git clone, right? Git clone and give the URL. Simple, right? Now that will download the entire source code to your local. See that we have a sample Java app folder created, right? If I get inside, now you see all the source code that was available in my GitHub is now downloaded to your local src folder, pom.xml, deploy folder, right? Whatever it is basically required or available on the GitHub now is available in your local. Now, once I have the source code available, now I can use a Maven to perform the build. We'll ask Maven, hey Maven, read the source code here and give me an executable file. That's all we're trying to do, right? What is a build code meaning here? Convert this entire raw source code, different files into a single executable file. Like you have a .exe file to install it on your laptops. Similarly, we take or we ask Maven to convert all these files into a single executable file, right? So as I said, that is where we have these validation steps. It means before you putting or getting your executable file, I can run something called validate, if it is everything good or not, compile, blah, blah. So what I can do here is that simply run the Maven commands like this, right? So mvn, the Maven, right? Like you are running the git command, like git status, git branch, something like that. Now we use a Maven command to run the Maven commands. Now I can run the first phase in my build lifecycle, which is the validate, right? I say mvn validate. Remember, this command needs to be hitting inside your source code folder. It can't be run outside, it will fail. It has to be inside a folder where your source code is present, or in fact, where I'll say where a pom.xml is present, right? Remember, inside my sample Java app folder where I have the pom.xml. If I don't have this pom.xml, this command will fail simply. Shall show you. Say that, for example, I'll move out this pom.xml to temp directory. Just a scenario I'm showing it. The mvn validate or mvn commands must be executed in a folder where the pom.xml is present. That is how you need to understand the scenario. Now, do I have a pom.xml in this folder right now? Now, what I have, if I run a mvn sum command, whatever it is, validate, now you will see the error itself, right? What is it telling you? So, technically says that our project execute, but where there is no pom, right? A project to execute, but there is no pom in this directory. There is no pom in this directory, which is called a pom.xml. It is expecting it. So understand, the mvn command is always should be executed in a folder where your pom.xml is present. Always to be done like that. Keep that in mind. That's why I'm saying Maven will read that pom.xml in the current directory and then start understanding how to build the source code. That is a main key criteria when you're running any Maven command basically. Okay, so what I'll do, I'll move back the temp pom.xml into current folder. Now I have the pom.xml in my current folder again. Now if I run the same command called mvn validate, now it starts reading and does something for you. It means it tries to validate the source code. It is also trying to download some dependencies if they are required something. Finally, it says a build success. It says that I tried validating the source code and everything is good. It says a build success. Whenever there is a phase, whenever there is a Maven step is successful, you always see a message called a build success. Okay. So validate is something, it is just validating whether the pom.xml is perfectly good or not. Apart from that, it does not do anything. It also tries to download some dependencies if required. That's what you see here. First time it downloaded certain dependencies. If you run for the second time, it won't even download that. Let's say everything is good. That's what you'll see a message. Says that from pom.xml, right? It says, okay, everything is good in the pom.xml and everything is good as per the pom.xml. I can continue with the next stages in the build lifecycle. That is what all you understand. If something is not good in the pom.xml, right, Shubhodhan, the pom.xml does not have the relative content or it is unable to find some objects, it will fail as well. Okay. Only thing, all you need is that the pom.xml to be the right format. or there is something that you mentioned in the pom.xml but that's not present in your source code to convert or build it, then also it will fail. That's how you understand. In case if build fail, we need to bug the error and send it to developer again to fix it. Absolutely, Nishtray. That's all you need to do here. Right, so now we have done a validate. Validate does not do much, right? Here, you can observe something, team, here right now. Maven validate does not generate any output. Rather, it's just validating whether the pom.xml is correct or not. That's all it does in the backend. But again, if I go with the next step, which is something called a validate compile or a test or a package, anything after the validate here, for example, will generate some output. For example, if I say package, remember a package, it says that assembles the compiled code into a binary build result. Now, what is a binary build result is nothing but your .exe. It's a binary format, right? It's an executable format or installable format. Another way it is also called as a binary format. So remember, the package is a command or a package is a phase. Maven generates your executable file directly. Let me run it and I'll show you. As of now, do you see any folder here called target? No, right? So understand that any of the Maven phase after the validate will generate a target directory, that is an output directory where Maven puts the result in. Some results are generated, right? Executable file is generated. That file will be done on this one. So I'll write simply called as package, right? MVN package. Now you see it is going to do something for it. Whatever it is doing it again, it's not your job. If it is failed, just go and report to the developer that, hey, this command is failing it. This is the error. You might find some error on your screen. Just go and give the error to the developer. They will understand. They will get you the fix done. Okay, now you can see that here at the end. Now, whatever it is downloading, forget about it, right? Now, at the end, it says that information, it says packaging a web app, which is a web application. It says assembling the web app into a folder called root sample app target. Remember, we're already under the folder called root sample app here. Now, under that, it says there is one more directory created called target. Now, under that, it is saying processing a var project. It says building a var, something, a sample app dot var. Assume that team, the var is just an extension like your .exe. Remember, the .exe is for your Windows-based applications, we call it usually. The desktop applications binary format is .exe. Or maybe you have .dll. If you have you installed something called .msi or .dll, .exe, something that you would install on your Windows machines, correct or not? Have you ever done that? .msi file, something. So the extensions are varied, team. It's not that you get always a .exe, understand it. The extension of a file, like it can be anything, but it's considered as an executable file. So what I'm trying to show you here right now, when you run MVN package, you see the some additional directory got generated called target. Now the target is the directory where Maven generates its results. It can be different results again. As of now, you see something different here. One thing that you need to understand here is called the sample app.var, because our Java project is producing an executable file called sample app.var. That is the idea. Now you can also see the size of it, which is the around 16 MB file, right? Now this is basically the executable, a web app executable. We will take it and run it on certain server, and then we can access it over a network, send a request to the application and access it over a network. I'll show you. I will also going to deploy this file, team. Remember, it's not that I'm just showing you right now like this. We'll also take this file and we'll understand how do we install this file on a server, then how do I access this application from a browser. All those things we'll do it, but one by one, not now. Understand for now that yes, the Maven package is a command which will produce the var file or the exact binary executable file of the Java source code for you. Make sense, everybody? MVN package. We also understood something called MVN validate. Now there is also one another command called MVN test. that you saw maybe. There is something called test, runs the unit test, compile code something, which means that I can run something called, again, remember mvn command must execute where the pom.xml always. So I'll say mvn test something like this. All are predefined commands, team, nothing I'm using on my own. mvn is a predefined command, test is a predefined command, package is a predefined command, validate is a predefined command, which is given by Maven. We're just going to use them accordingly. Now you can see that mvn test is basically running some unit test cases. What is unit test case? I'll explain again. For now, understand. Okay, it is running some test called 23 test it ran, and there are 0 failures and 0 escaped and blah blah it says. Okay, so technically these are all the different things that we do. Okay, so now understood that there are different phases in the life cycle that you may run in a sequence if you would like to, right? It is recommended that you follow a sequence of steps to understand. I'll explain those things in a minute. Don't go there right now. But yes, you can run any step directly if you want it, but it is recommended that you follow a sequence of them to understand more better and then more project results basically. Okay. But right now I'm running jumbled package first, test run later. No, it's not like that. We follow a sequence that I'll talk to you in a minute. But the understanding is that we can run any step anytime directly as well if you want it. It doesn't need to be run in sequence. You can execute any step as you wish if you want to as well. Okay. But the best practices is that you follow a sequence. That is what all you need to understand. But right now you understand that here, right? Now we are able to understand using a Maven simply, we are able to produce a deployable format of the entire Java code that you saw in the GitHub. The next challenge, team, I would like to talk here, right? The question here is that now we are following something called a build code process, right? The build code process end goal is to produce your deployable artifact or a deployable executable file. That is the end goal of the build code process. The end goal of the build code process is to produce your deployable or installable format of the source code. Then later we take that file and install it. Okay, done. Now as part of it, we understanding there are multiple stages. Say I do a validate to ensure everything is good, then I can compile, then I can run test. I can also do some other things in between. But the final stage is always a package here. Remember, the package is the stage where you get your executable file. But before that, it is also recommending you run these stages. So assume that I'm running them in a sequence as per the stages here. So validate, compile, test, then package, for example, scenario. So the question here is that team, now you understood that we need to run these steps. Before that, first we need to get the latest code. Whenever there is a change in the source code by a developer, that I need to get the latest code by cloning or by pulling the latest code first of all. Then you follow the steps: mvn validate, mvn compile, mvn test, mvn package, right? Any step is failing, we need to report it back to the developer, right? That is what is something we understood now. But the question here is that how many times we do build code in a day? Is it once in a day that we do, or is it twice in a day I have to follow this process, or is it like n number of times in a day we follow the same process? Now it is the same series of steps. Remember, git clone or git pull, then mvn validate, compile, test, package, the 5 steps, right, which are talking about. The same 5 steps, how many times do I do in a day? Is it once at the end of the day? Or is it maybe twice, maybe once in the midday and then once in the end of the day? How many times we do? So whenever the source code changes, updated. So every time there is a change in the source code, but frequency may depend on the project pattern. Absolutely, Bhavani, that's what I said. So remember team, it can be once, it can be twice, it can be n number of times. That is purely dependent on the project, right? That you can do it. Okay. So if I consider n times, understand here the scenario. If I consider n times in a day, let's take a number, right? Let's say day n is equals to 10. So the question here is that 10 times in a day, I have to repeat the same process. Pull the changes, pull the latest changes, then run, validate, compile, test, package. I have to repeat the same thing 10 times in a day. There's no change. The same series of steps, do it over and over again and again, 10 times in a day. Every hour you do the same thing. Sick, frustrated. You might be enthused, you might be very excited. Maybe the first 1 day, 2 days. From third day onwards, you will start annoying, boring, frustrated, anything else, sick, something like that. So if a task is repetitive, what is that you're going to do? You know the same task I have to repeat n number of times. What is that we need to do if something is repetitive, basically? Something like instead of you do it, let the machine do it. As a human being, I may get bored, but a machine softwares don't get bored, right? It's better that you automate the process of the build code process. Remember, if I take n times, right? Something repetitive, right? Something repetitive needs to be automated. So how to automate the build code process? Remember, the build code process is something we're talking. We clone the source code and we perform the build steps one by one in a sequential manner, n number of times in a day. That's called a build code process, right? So how to automate the build code process is the question. How do I automate it? How you think we can automate this? Now you're getting to the point, right? Now we understood, as per the picture here, you understood Maven, right? Now you understood with Maven, the task is repetitive for me. Now that's why we say that use the Jenkins. Now what is Jenkins here is the question. So if you look into this one team, I know I have something pre-written here. You can simply read them so you can understand it. So the understanding here is a team, how many times we build code stage execution in a day, multiple times can be 10 or 20, right? So repetitive work should be automated. So technically we need an automation tool. Now you can write your own automation. As somebody said, I can write a shell script or I would use a control and something, whatever it is, right? So you may develop your own automation strategy using your own liking tool, right? But in the market, we do have certain tools which are already developed and given to us. That is what we're talking as we need some automation tool. Now there are n number of automation tools that are given in the market. One such tool is called Jenkins. But is it the only Jenkins available in the market for automating? No. We do have something called TeamCity, Bamboo, you have GitHub Actions. If you go to the code build, Azure pipeline, something like that. So Ansible is something different purpose, Vinay, right? Ansible does not come under the build code automation. It comes under the infrastructure automation. Of course, that is also an automation tool, but it has its own different purpose. Okay. These tools have different purpose. So understand, right? So we need a tool that can help us automate the build code process. Again, I'm telling you, we need some tool or some automation tool that helps us automate the build code process. Upon a change in my source code repository, right? Upon a change in the GitHub, now I need to execute all the steps in a sense. I should automatically clone, pull the changes. I should automatically run the validate, compile, package, test. Everything should be automatically executed in a sequential manner. Now I need to build that logic. Now to build that logic, Jenkins will help me, right? Jenkins is a tool that helps us to automate the build code process. Understand that. Now, in a way, we call that Jenkins is known as a build automation server. Now, if somebody asks you in the interview questions, what is Jenkins? The answer should be straightforward in a single line. It's a build automation server, right? It is also called as your continuous integration server. Now, why is it called continuous integration server here? What is a continuous integration? Remember that we're trying to integrate the code from various places maybe, and also you're trying to integrate the various tools such as the Git, Maven, and Jenkins are integrated together, and you repeat the same process n number of times, right? Repeating the same process n number of times is a continuous process. That's why we are integration and continuous operations are happening here. That's why Jenkins is also known as your continuous integration server, or a continuous integration using Jenkins is what we're talking technically. So understand here, Jenkins is known as a build automation server. In other words, it also can be called as continuous integration server because it helps us integrating the code from various repositories, integrating the various tools like Git, Maven, Jenkins together to perform the build code process stages, right? Like I said here, we will integrate the various tools with Jenkins to perform the build code. Remember team, if I'm going to use the build code process now with Jenkins, it doesn't mean that we are replacing Maven with Jenkins here. Don't come to that assumption here. Jenkins is just a dummy tool, right? Now you need to tell the Jenkins what it needs to use, what it needs to done. Now what I'm saying it, earlier I was executing this command like mvn validate, mvn package, mvn test. Now we are not replacing Maven with Jenkins here, understand? We are gonna do the same task with Jenkins, which means instead of I am running the mvn validate command, I'll say, hey Jenkins, you run this command for me on behalf of me, right? So we will configure Jenkins with these commands here, right? Understand? We'll install Jenkins and we'll configure Jenkins in such a way that it will run these commands for you. It will run a git clone command on behalf of you. It would also run mvn validate, mvn package commands on behalf of you. And it's a tool, right? It's a software. Basically, it can repeat the same commands n number of times. It won't be bored. But if I run them, I'll be bored. That is what the whole idea is here. So are we replacing Maven with Jenkins here? No, right? We are not replacing it. Don't think that. So Jenkins is known as a build automation server, but it's not the one actually doing a build. It uses the various tools behind it to perform the build again. So that is how you need to understand. Okay. So again, I'm telling you the build code process can also be called as your continuous integration process. In short, it is called CI process. Continuous integration, in short, is CI. So you might be hearing something called CI CD pipelines. So with Jenkins, now first we'll construct a CI pipeline. Okay, we'll talk about the pipeline in a minute again. We will do the CI process with Jenkins, right? That's why Jenkins is known as your CI server, continuous integration server. With Jenkins, we can also perform something called CD, which is called continuous deployment, which I'll talk in the future sessions, not now. So for us, the focus for now should be on the CI. If you complete the CI process, then we'll go back to the CD, or we'll go to the CD process later in the future session. Until then, keep the CD aside, focus on CI. Okay. Now we're also talking something called a pipeline. Now you might be hearing CI pipeline, CD pipeline, or maybe a CI CD pipeline, something. Now what is pipeline here, right? What is a pipeline? In simple words, again, I'll tell you. Now we understood the build code process is also CI process. Now within the build code process, we have multiple stages, multiple steps, right? Like you have a cloning task, validate task, compile task, unit test task, package task, something. Remember, these are different tasks we have it. Now we will be running them in a sequential manner as we thought, right? So I'm saying that a multiple steps or a stages in build code process are executed in an order or a sequence to reach from start point to end point, right? So there is a start point, there is an end point, basically we talk about it. So if you are running the stages involved in a build code process, right, and executed without any manual intervention, then we call it as a pipeline. Remember, there are multiple stages I have it. Now, if I run all those stages in the build code process, one after the other, without any manual intervention, everything is fully automated. Now that's called a pipeline, right? A pipeline has a start and also an end. So you start from a start point, go step by step, and then reach your end point. So if you attach all these stages one after the other to run automatically, that becomes your pipeline. Okay. So technically we're saying a build code process is nothing but your continuous integration process, in short a CI process. So the build code process itself is nothing but your CI pipeline. Okay. Now I hope you are also clear now what is called a CI pipeline or pipeline meaning to you. So what is Maven? What is build code process? What is Jenkins? What is continuous integration process? And say what is a pipeline basically. Now, now it's that we need to start using the Jenkins to do every task we were doing manually. So thing is that we need to install the Jenkins, right or not? Should we install the Jenkins now? So let's start installing the Jenkins. Again, go back to the GitHub repo. You also find the Jenkins installation instruction here, as you can see that, right? So it says the install Jenkins blah blah, right? So let's go ahead and do this. I'll run the same instruction here available on my same EC2 instance. I'm not using anything new here, right? Go here. I'm just running. Hey, done. Finally, you can say apt get install Jenkins. Say yes. Now this will start installing the Jenkins team here. So once the Jenkins is installed, remember, unlike the Maven, Java, Git team, they're all CLI tools. Now Jenkins is basically a web-based application. You need to open it in your browser. It's not a CLI application or a CLI tool. Jenkins is basically a UI application, a user interface application. So you can open this in a browser. This is like your web application. Again, I'll talk. So you can open Jenkins in a web browser and then start working in the web browser directly. We don't work on the command line. We work with Jenkins on the UI part. Okay. So once we install Jenkins, as you can see, there are certain commands I have given to validate. So don't restart directly, team. Just check if you're able to see if the Jenkins is installed, first of all. Oops. Right. So this is a command to check if the Jenkins is running on your system, installed on your system. You can say it is active and running it 42 seconds ago, blah, blah, blah. Okay. So how do I access web-based applications? Using a URL. The URL would be always. Now this is how, team, if you look into this on the right side, I'll zoom in a lot for you so you can understand it. Now this is what you see, right? So basically on your EC2 or the server, we have Git line, Java, Maven. And remember, Jenkins is also being installed on the same thing. So technically this Jenkins is an application that runs on a port number called 8080. any web application that you access through the IP address of the server where you have that application installed with a port number of that particular process running on that machine, right? On that particular thing. So this is what it is. Now you can see the default port number as well. It appears here on the screen. See the HTTP port number, which is the 8080, as you can see on my screen, everybody. I'm highlighting on the right side corner so you can see that, I believe. So if you hit the sudo systemctl status Jenkins, it is also showing you the port number on which your Jenkins process is listening. Now, which IP address would I use here? Which is the IP address I need to use? Where we have installed Jenkins, it is on your EC2 instance, right? So you need to use the public IP of your EC2 instance, which is like if you go to the AWS console, you see that there is a public IPv4 address. Take that and give the IP address in the browser with the port number is 8080. And by default, it will be HTTP in the front, but you can also say HTTP something like this, right? Now this is how, if I hit it, now you should see the request goes from your laptop to EC2 instance and launches your Jenkins like this. And again, I'm telling you, in order to access the Jenkins, you need to know the port number of the Jenkins. By default, with your installation, it is 8080 always. No, it will not change. And there is an IP address of the EC2 instance, you know it always. So in your browser, you always have to hit something called http:// /ec2ip with port number of the Jenkins. Now that's what we just did it here. You can see it is responding back to you. But again, by default, you can say it is unlocked Jenkins, which means by default, it has a security administrator password to log in. Now it is giving you the idea like where this password is already available. The screen you see, it says /var lib Jenkins secrets. There is something called initial admin password. So what I can do is that I can simply copy this URL or the path on your UI itself and go back to the server where you install the Jenkins, which is your EC2 instance. Now, how do I open a file? You can use a cat command and then give the path or paste that you copied on the screen. Now you get it, right? If you hit it, now you will see some random numbers here, or with the alphanumeric characters, we can say that. Now you can see this is your password by default. We'll change it now anyway. So let's say that the first time when you installed it, you always use the initial admin password automatically generated as part of your installation. So you copy that password and then getting back to your browser and then paste the password in the administrator password field and then say continue. Okay. Now it will take you to the next page automatically if the password is right. Now on the next page, it gives you something called customize Jenkins. Just follow the same steps I'm doing it, team. I'll explain here on that. Now as a beginner, you always need to go with something called install suggested plugins. Now what are plugins with Jenkins? I'll explain later. But right now you just need to click on this something called install suggested plugins. Ensure you do that. So don't miss that out. It is very much important for us. So when you click on install suggested plugins, it will continue to the next page and it will try configuring a few things automatically for you, right? All you need is a internet connection properly set. So it will try to do this. Okay. So understand again, just click on the install suggested plugins. So it will continue to the next and it will start configuring a few additional configuration for Jenkins automatically. And this is all part of your Jenkins installation setup itself. So let it continue and then we will try to do. Okay, so let it finish. Okay, Now, once you see that page is done, team, and it will take you to the next page, and you also can see it is asking you to create your first admin user. Means you can use these credentials to log in later again to the Jenkins UI. Whenever you stop EC2 instance and come back later, you need to use this credential. So whatever you give it on this page, please remember accordingly. So let's say that I'll use an admin and some password for the admin, right? And say that my name is whatever the name you want to configure. You can say admin or Naresh or anything that you want. So I'm just keeping the same thing name here, gmail.com, something like this. Now you fill out the form. Remember, please do remember, if you forget them, you can't log into the Jenkins later again. So I'll save and continue. On the next page, it might give you something called Jenkins URL, which is same thing as in your browser. You can keep it as it is if you want to, and save and finish it up. Right? And then once you do the save and finish and say it says Jenkins is ready, now you can say start using Jenkins. Okay. Now if I click on the Jenkins, start using Jenkins, now this is the UI that you see it. Okay. Now this is the UI that you see. This is how you install Jenkins and launch a Jenkins UI so far. So I believe, team, I'm clear so far on the setup. Now, if you're having this UI in front of you, now the next task is to start build code process using Jenkins. We automate everything using this UI itself accordingly, step by step. So are we good until this point? Any questions? Any clarifications required? No? Okay, good. Right, so if you're clear, then I believe it's time for us to start using the Jenkins. Okay. And before I start using the Jenkins, team, I want you to be clear on something as well. Remember that you are installing the various tools on your EC2 instance. Do you know the installation path of your each tool you install so far? If you are working with Jenkins, if there is a problem, troubleshooting scenarios, you need to know where they're installed. So technically, we installed Git, we installed Maven, we installed Java, and we installed Jenkins as well, right? So every software has its own installation path. Like in your Windows team, usually it is always that you go and a C drive profile something, right? That's where you install everything. So remember that every software that we install on your laptops or on a system has an installation path. So just to show you that basically the way we understand, so the default installation path of your Java, which is user lib jvm something. I mean, if you follow the instruction which I gave you on the GitHub, these are the installation paths. But again, these can be configured when you're installing it. We haven't configured anything, so using the default paths, right? So this is your default installation path of the Java. Remember the path. This is where your Java is installed. That is /user lib jvm something. Now the Maven is installed under opt Maven. This is, again, if you look into it, this is your Maven installation path where the Maven is available. And your Jenkins installation path, or we also call that as a Jenkins home. By default, it is called a var lib Jenkins, right? This is where you see all the Jenkins related software binaries as well as Jenkins related logs. In case if there is a problem with Jenkins software, you can come back here and check the logs of the Jenkins to understand the problem of the Jenkins. Based on the findings, you can troubleshoot further. That is the area. So three important things to know here: the Jenkins Java installation path, and the Maven installation path, and the Jenkins installation path. The Jenkins installation path, Maven installation path, Java installation path are also referred as your Jenkins home, Maven home, Java home, something like that. Okay. When I say Java home, it is a Java installation path. When I say Maven home, it is the Maven installation path. If it's a Jenkins Java home, it is Java installation path, something like that. Okay. So keep these paths in mind always, and then you have to work on the terminal sometimes to understand the problems as well. Anyway, we will be configuring the paths again with Jenkins right now. So this is your Jenkins UI, as you can see, right? Now on this particular page team, right, on the top, you can see logout and login as usual, just like any other applications you see it. Now I can log in with my credentials, right? Log out and log in. Now you see this page. Now on the left side menu, you see something called dashboard. Below that, you see some options called new item, build history, manage Jenkins, my view, something. One important thing here is that your manage Jenkins. This manage Jenkins is same as your settings on your phone, for example, right? In a simple nutshell, if I say it, if I have to configure my phone, if I have to customize my phone configurations, I go to the settings of my phone and then I choose what I wanted. I configure what I wanted. Similarly, on your Jenkins, if I have to configure something, if I have to customize my Jenkins behavior, I always go to an option called manage Jenkins on the left menu, right? And if I go, you see the n number of options like system configuration, security, status information, all these options you will see. Choose the necessary options to configure, customize Jenkins behavior accordingly. Okay. Now, why I have come to this page, remember, the first task in Jenkins is to integrate the Git and Maven to the Jenkins. Remember that I want Jenkins to run a Git clone operation. I want Jenkins to run a Maven validate commands, right? So technically, we need to tell the Jenkins where I install Maven or where is the Jenkins Git available, all that stuff. Because Jenkins does not know, right? Does Jenkins know that I installed Maven here? Does Jenkins know that Maven is available in that particular folder? May not be, right? So it is your responsibility to tell the Jenkins that, hey, Jenkins, the Maven software is available in this folder. You may use it when I ask you to do something with Maven, right? That is what is called integration, right? We are integrating Maven with Jenkins. Similarly to Git. Say Git binary is available under say user bin Git something. So I need to tell that, okay, this is where the Git is there. Similarly, this is where the Java is there. So user lib something. So Jenkins will use all these different tools to perform the build code process. We need to configure them. That is where I've come to the manage Jenkins and on the system configuration, see system. And the second thing you see is the tools, right? Tools, that configure tools in their locations and automatic installers if you want to, right? So I'll go to the tools option here, click on the tools option. Now under this, you might find the default options already available, like say tools like Maven configuration or the JDK installation path, something. JDK is nothing but a Java, right? If I click on add JDK here, it will ask you, okay, give me the Java home, right? I'll say this is Java 1.17. You can give any name here, remember? I can say any name, that is also going to work for me. It doesn't matter what you write it, but write some meaningful names. Java home is nothing but the installation path of your Java. So where will we install? Now this is the path, right? Copy this path. I paste it here. Simple. If you want to install automatically, Jenkins can do, but I don't want to do that. We already installed Java. That is the idea. Now the Git, second one, the as a Git installation, it is asking you, okay, this is default, it is giving it something, okay, and says Git. Something if you want to configure the absolute path, say user bin Git, just give it as it is. Okay, that's how you can do. Now below, if you say something called the Gradle and Maven blah blah, but by default Jenkins supports the Java project, so it is by default giving all the Java related build tools here. But you can also add the build tools of .NET, Python, Go, anything you want. I'll tell you how to add them as well. But right now, let's say we configure Maven. So I'll say add Maven, right? Okay, 2 times added. So let me remove one. So add Maven, and I say Maven 3.9 something. I don't want to install automatically because I already installed. So I'll untick this install automatic option and I give the Maven home path. Maven home is opt Maven. So I'll go and I give it. Simple. Apply this, save it. Right? Now this is how team we need to configure the required tools according to your build requirement, according to the programming language builds you do it. You configure the required tools here always. Okay, so from this, go to the manage Jenkins and go to the tools to configure various tools. Now here under the JDK installations, we already have configured these paths, something you can see, the gate, blah, blah. Now, how did I get these paths here, right? From the command line, I'll show you if I do a history. Now, this is your Java installation path, right? And this is your Maven installation path. And this is your Jenkins installation path. And to get your Git installation path, you may run a command which git, something like this, you get it. Right, Neha? This is something which you will get to know as per the installations you do it. Okay. Now, once you configure your tools, now we are ready to tell the Jenkins to do some task. Right. So now that we have configured successfully, the next thing is that we tell the Jenkins a task, right? I want Jenkins to do some task. I want Jenkins to do some job on behalf of me. Understand here, team, I'm saying it. I want Jenkins to do a job on behalf of me. Whatever the job I was doing it manually, I want to give it to Jenkins. So Jenkins does it for me whenever I ask to do it. So to do that, basically, or whenever you would like to give a task to the Jenkins, we use an option on the left menu called a new item, right? Always use the new item on the left. If I click on the new item, it will give you a page where it will give you some options. Say new item, you give a name. Say, for example, I want to give a sample app, right? This is my sample Java app, right? As I simply call sample app, right? Underscore or dash something, validate. Means depends on the goal. Now remember, this name can be anything as your choice. I'm just giving what I'm trying to give it. Now, once you choose a name for your task, I want to do a validation first of all, then I'll say select item type, which is a freestyle project. Now, as a beginner team, you always go with a freestyle project, which will help you understand the basics of Jenkins and configure whatever you would like it. So I'll choose a freestyle project here. Then I say OK to it. Now, when I select a freestyle project and I say OK, it will open up something called a job configuration page. We call them as a job or a project in Jenkins, remember. I simply save if I want to, remember. On the dashboard, if I go back now, you see what you created. Now, this is simply called as a job in Jenkins, or this is the same thing we can also call as a project in Jenkins. It doesn't matter what you call, but this is what it is, right? Once you create and save it, it's an empty job right now. There is nothing given in this, but if I want to re-edit it, I'll click on the job. It will open up the job page again. Now on the left, you see the various options, like you can delete it, rename it, can find the changes. There is one option called configure it. Configure in the sense you can configure what you want again with Java. So I click on a configure, it will go back to the same page. Now on this page, on the left menu, you see the various options. Now you can tell the Jenkins what it needs to do, what this job needs to do, what task it needs to execute. We'll see that. The general, you can give just description of the job if you want to, and choose the various options here. We'll come across them later. The main thing we want to do here is that basically clone the source code, isn't it? What we want to do technically, where is this? Sorry. Right, so here, right? Now, what we want to do here is that first thing is basically to clone the source code, isn't it? Right. So we want to clone the source code, then go and run the various tasks on the source code. That is what we want to know. Okay, it's going too much, team. That's okay. Okay, my mouse is really bad. Okay, anyway, you understood, right? So technically what we want is that cloning it. So on the left menu, there is an option called as source code management. Now on the source code management, if you look into the page, it says connect and manage your code repository to automatically pull latest code of your builds. So it says, okay, there is none by default. We can choose Git. Even if you have a source code in SVN or some other tool stream, we can add them as well. By default, it is supporting Git for you. So let's say select a Git. Now, if I select a Git, it simply asks you the repository URL. Right? What is repository URL here? Your Java source code. So I'll take this URL, copy it, and then paste it in the box. That's it. Now it automatically detects it. Now it is also giving an option team credentials. Now when should I use the credentials here? Basically, when your project is private, you need to give the credentials, remember. Now, since I can't provide the credentials every time, Jenkins gives an option for me to store my credentials in the Jenkins itself. Say, for example, I'll add the credential Jenkins. It will open up this page, right? Now, where I can say the credentials, the username and password or something else, we can also configure SSH and everything. I'll use my password. So username of my GitHub, say this one, it is, I think, lead DevOps. Some username of your GitHub. And let's say that the password is nothing but your token team. Remember the token that we were using to pull, right? This is the token, right? Clone, push, basically you use that. I'll say this is my GitHub credentials, for example, right? So you save it with a proper name. That what is this? Now I'll say add. Now, once I add it, basically you can see from the drop down the right credentials to clone this repository. Remember, in case if this is a private repository, I must provide the credentials like this. If it is public, you don't need to actually remember. This is a public basically. Even if I select none here, it will still clone it without any issues. But if in case it is private, ensure you add a credentials and store your username and password here and then map it accordingly. Otherwise, the clone will fail. That is the idea. Okay. Now, along with that, you can also choose a branch you want to clone or any specific branch that you want to work on, the master or a main or something. By default, there is a master branch here, so I'm using a master branch itself technically. If you want to build code on a different branch than the default master, then you use it accordingly. Okay. So this section team just tells you that Jenkins is going to clone the Git repository on behalf of you. Just configure the URL. Jenkins will take care of cloning it, pulling the changes from the repository automatically. That's the idea. Okay, done. Now, first thing, Jenkins have to clone it. This is done. We configured. The triggers we'll talk later. Environment also we'll talk later. One important thing in this job is called a build step. Remember the build step, the building, right? We talk about it. The build step. What is a build step? Basically, what Jenkins needs to execute on behalf of you after cloning the repository. Remember, the build steps are something after we clone the Git repository, we run some build steps like MVN validate, MVN package, right? Those are called the build steps, the process. So the build steps is where you can actually configure whatever you want. Say if I have to run some Windows commands, I can run Windows execute shell, something like with the different options. Remember team, whatever the commands that you're running on your terminal, now these are all called as your shell commands, right? So shell terminal where you run it, that's why it is giving something called execute a shell commands basically, like we were running. So I'll say which git, I can run it, right? I can say touch nourish.txt. It's like, remember team, all these regular Linux commands that you are running so far now can be given to the Git. Sorry, Jenkins, right? Sorry. So in this case, if the Jenkins is going to execute a command called witchgit, Jenkins is going to execute a command called touch on behalf of you, and so on. So since I'm saying it, now you can also say, hey, Jenkins, run a command, say opt maven bin mvn validate something. Understand here? I can run simply mvn validate also. I can also give absolute path as you want. Remember, there is no absolute path basically, but this is an absolute path. It's your choice, whichever you want to give. A short or an absolute path always will work. So this is how I give it. So remember, the mvn validate is what we ran manually to validate the source code earlier, right? In this case as well, Jenkins will clone it and also perform all these tasks you have given in a single go. So I'll say apply it, save it. Now I have told Jenkins what to do, right? Within the job configuration here, I have told Jenkins, hey, you need to run all these tasks when I asked you to do it. That's all. But when do I ask to do it? That's my choice again. If I click on the job, on the left side, you see an option called build now. The build now is like you execute now, right? those commands, whatever it is, git clone, which command, all these commands you need to execute now whenever I click on the build now. When I say build now, which means I'm asking the Jenkins to execute them now and get me the results. That is the idea. You can also automate it further. We'll do it later. But right now I'll click on the build now option manually. If I click on the build now you see below there is a builds get started. Means it is trying to execute. You see the build is in progress. Just below this rename team on the left, you see that, right? The build is in progress. It is trying to execute. Whenever it says it is successful, you can see the green tick mark. But how do I see the results of it? The build number is 1. I click on this build number, like this, a link it will. I will open up that link basically. Like you see here, it is started by the user called admin and it is running time and blah, blah. On the left side, you do see the various options. Git, build data, blah, it says something. Some timings, how much time it took to execute this whole task for you, all the timing. Now you can say the console output. The console output is where the results can be seen on your UI. Like whatever we're seeing on the command line earlier, like the build output, right? The build success message, right? Where is that? This one. Say this build output, right? You see build downloading something. The same output is now available on your UI. I say the build success, blah, blah, right? So you see this, the same output, right? You see, first of all, it says, okay, let me zoom in a little bit for you. It says that using the GitHub credentials, blah, blah, and says cloning the repository for you and so on. So whatever it is, trying to write some data, right? If I try to look into it, it tries to clone the repository successfully. Once it tries to clone the repository, then say it is running a command called which-git. Then it is trying to print that output. Touch narration.txt writer. Then it is also trying the opt maven validate. Same thing output again, right? Downloading something. All the output that you saw earlier on the command line now is available here. Like you see at the end, it would say that the build is successful. The build success, right? Now you can see that now, since I configured once, now next time onwards, I don't even need to remember those commands. I click on a build now again. Means when there is a new change available in the source code, I can simply click on the build now. It will again start the tasks for you. It clones the latest task, latest changes, and then executes the same validate command. Run again, right? Whenever you are making a change in the source code, just click on the build now. It will keep building the same thing for you. That is the simple idea we're talking about. So there are certain stages we follow mandatory for every code. So technically, the validate you did right now, that is may do it or may not do it, that's fine. But there is something called a compilation. Then we have something called as a code review. Then we call it as a unit test. Then you may also do something called a code coverage step. I'll talk about all these steps. What are they one by one? Then finally package. Remember team, the final goal is to package it, right? Package is the step where you get the executable or a deployable format of the source code. But what are these stages before? What are we trying to achieve by using these stages above the package? Again, remember the sequence I wrote is the most of the time we follow the sequence, but it's your choice that you can alter the sequence before one, but keep the package as the last step always. Now, what is the meaning of each stage here? We'll try to understand. You already know the validate. Let's say that what is compile, what is code review, what is unit testing, what is code coverage? We'll try to understand now. Right, so understanding is a team. All these are of certain validation and testing process, right? So assume that, say, the simple scenario, right? Think about it. Whenever you try to produce a product as such, it can be anything, right? In this case, a product is a software. But if you talk about the product like maybe a car or a bike or maybe an AC or a computer or something. Now, do you think that, or is it a good practice that you think that without testing, without validating, should I give the product to an end user? No, right? Technically not. it is not a good thing at all. Now understand that team, before I package, means if I package it, which means that I'm ready to install the package on a server, which is used by the end user. So understand all these stages are certain validations and testing, right? Whatever we're trying to do about the package are certain validations and testing of the source code to ensure the quality of the software, right? Remember, in this case, the product is a software technically. Now we need to ensure that quality of that software product is absolutely good, right? At least some validations to be done so that the product functions well when we try to install it on a server, and the end user should not see the problem. That is what the purpose we are running all these stages about the package always. Now, since everything is a validation, now different type of validation is what we're trying to do. Now, what is a compilation meaning? Convert source code into a binary code, source code into machine, convert data into machine language. Now, it is also validation team. What we're trying to say is that we're asking Maven to compile the source code. Now, what is the reason we are compiling it? Remember, there is a lot of source code programs are written here, which are in the human readable format. Means as a human beings, we are the one who understands the lines of code here written and we modify it. But at the end of the day, these programs needs to be executed by the machine or a CPU computer on your hardware. So those things should understand these lines of code. That's where we need to convert the source code into a binary code, right? Whether it is convertible or not. Means sometimes if you make a mistake in the program, that cannot be executed in the CPU, right? On the binary side. So whether these programs written by the developers are or can be successfully converted to a binary code or not, that's the validation we're trying to do as a compilation. Means we ask the Maven, hey Maven, go to the source code, whatever is available, you try to compile and see whether the compilation is getting successful or not. Means whether these programs can be compiled, can be converted as a binary code or not. We're trying to ask the Maven to do that. If it is not compilable, does it make sense to package? Definitely not, because it will error out anyway. Even if you package it later when it's trying to run on a computer, it will error out. Some errors will be given. That is the reason we perform a compile step, not a compile stage basically. So what do I need to do in a simple nutshell? That I'll build a new item. I'll say, okay, sample app, right? Sample app, compile something. I'm just giving a name. I'll say select a freestyle project, say okay to it. Then I give the source code which needs to be compiled. So I'll select the Git again, right? I'll just give the project URL. Same steps team. If required, give the credentials and choose the branch from which you're trying to compile the source code. And then go to the build steps, right? Right now we use build steps and source code team. Later we use other options. Let's say now execute a shell. Then I ask Maven, say opt maven bin mvn compile, right? The compile is the option. Apply it. Now remember, this command should be properly written here, otherwise it may fail, right? Save it. Then say execute. Execute in the sense build now. When I click on the build now, the Maven will start compiling the source code, right? Then it will generate the results. What is the outcome of the compile stage? If I click on the build number 1, see the console output, it is trying to do something, whatever it is. It says build success, which means it is compiled successfully, right? There is no issues while I'm compiling it. There is no issues while the Maven is trying to compile the source code. One thing you need to understand before we go further anyway, team, understand it. Where are the results generated by the Maven? Maven puts the results into a folder called as target folder. But the question here is that where did Jenkins clone the repository? Now remember, as we're seeing it here on the stage, what is Jenkins doing first of all? Jenkins is cloning the Git repository, right? Where does Jenkins clone the Git repository on your server? I know you're seeing on the UI, but the operation is happening on the backend, right? Execution is happening on the EC2 instance. Whatever you're executing here is maybe on the UI you see it, but the actual execution is on the EC2 instance. Now, this is very much important as a DevOps engineer team where you see all the data. That's something we see above building in workspace. You see this message here? It says that, hey, I'm trying to build in a path of workspace called var lib Jenkins workspace and your job name. Understand, team, this is very much important with Jenkins. Jenkins executes all of its projects, all of its jobs under a default folder called Jenkins home workspace. Now, what is Jenkins home here? The Jenkins home is your var lib Jenkins, the default installation path. Now, under that, it creates a folder called workspace. You see at the last, right? So cd workspace. Under the workspace, it creates the jobs that you do it on the UI. Remember, there are two jobs created here. One is the validate, one is the compile. Now you see that it is generating the appropriate folders here. Now this is where it will try to clone the Git repository. If I go to the sample app compile, this is where you see it cloned all the code for you, right? It is cloning the Git repository under the workspace directory of the particular job. Now that is where Maven generates the target as well. If I go to the target is where you see the binary code. Remember, the outcome of your compile is the binary code of the actual source code, right? So what is a binary code in Java? It is called classes. If I go to the classes here, you see the same folder structure as DevOps demo utilities. Now here you see basically the binary code of the Java files. Usually that is the extension of .java. The binary code is the .class file. Remember, here you might see not understand something blah blah, something like this you see. So this is basically the binary format of your actual Java source code that's available on your GitHub. Okay, remember, the outcome of your compile step is the binary code of your Java source code. Now that's, if it is compiled successfully, you'll see all these things. If it is not compiled, any one file has an issue in certain line, if there is a problem, then it will not be successful, right? In that case, you have to ask the developer to check the error. Hey, this we are not able to compile. Please correct it and then push the code to the GitHub again so we can recompile and check it again. So I hope, team, I'm clear on this step called compile. What is compilation meaning and how do I perform using Jenkins as a step inside the Jenkins UI? Let's say we'll continue on to the next one, which is called code review. Right now, what is this code review? So for example, say that I have written an essay in English. So think about it. I have written an essay in English and then I have given that to you to review it. So what are all the things that you will review and give me the feedback on the essay which I've read? Grammar, spellings, the way format, grammar and spelling, number of words, logic, the punctuations, paragraphs, sentence formatting, contents, indentation, sentences. Now you understood, right? You are doing something. On what basis you are validating all these things? It's a predefined process, right? Because you're learning the English language from your childhood. Now you've come across, right, the various things throughout your lifespan. And you know now that there are certain standards of writing that English essay. Can I say that? There are certain standards that are used for writing spellings, punctuations, and all that stuff basically are defined or that are in your brain. So you're applying the standards in your brain against the essay which I gave you, then you are giving me your feedback. That is what all the understanding is. So that is what. So it is always validated based on the predefined standards, right? That you might be knowing it or you may not be knowing, right? So now you apply the same logic to the code as well. Now, initial days team, there was no code review process, right? Initial days in the sense, say, if you go back in time, say 30 years back or 3 to 4 decades back, where everybody started coding freshly, there was nothing like that, right? There was nothing like a code review process we went. But over the period of time, there were many developers who wrote the code, who made mistakes, who corrected those mistakes, right? And they have written some guidelines on developing a software. There are certain standards that are given by the developers to develop a new software always, because that is all coming out from their experience that the future developer should not do the same mistakes again. So they have developed some standards of writing a coding and then applying it into the process. Because we are in 2020s now, 2024, 2025, n number of developers have gone through n number of issues already. We should not make the same mistakes, which means you know that there are certain standards you can follow to get produce a better software. So what are we trying to say here is that team, when we say code review process, right? As a developer, as a fresher, right? Think about, I'm a fresher that I've joined in 2025, 2024 as a developer. Then I started writing the coding. I started developing some coding, right? Code something. Now, once after I develop it, did I really follow the standards that are written by many people already? Did I make some mistakes? How do I get to know them? That's where the code review comes into the picture. Okay. The code review is something that you check your code against the predefined standards and tell the developer that, hey, developer, you might be missing the standard that can cause issues in the software that you developed, basically. We validate this code and we highlight some issues from the code to the developer saying that, hey, developer, you're missing the standards in this code. Maybe better you follow the standards to have a better quality software delivered out to the customers again, right? That's what the process is called as a code review. Review the code against the standards and provide the feedback to the developers accordingly. So again, in this scenario, we're going to use some predefined rule set, something called a PMD. A PMD is basically a program mistake detector, we call it. I mean, it's a very lightweight, certain predefined standards given by certain things. Now, if you try to look into this PMD, just an example team, you can also use something called SonarQube or some other tools. There are many tools again, there are many different standards available in the market. For our scenario, I'm just using this particular basic thing. Okay. Now, what you see here is a PMD is an open source static source code analyzer that reports on issues found within the application code, basically, right? Now it says that PMD includes a built-in rule sets and supports the ability to write your custom rules as well if you need to. PMD does not report compilation errors, remember, it just does only the code reviews, right? As it only can process well-formatted source files. So understand here, PMD includes the built-in rule sets and supports to ability to write the custom rule sets as well. So we'll rely on the built-in ones only right now. So which means that whatever the source code available in this particular SRC folder will validate against the PMD rule sets, right? And again, who will do that? Okay, we'll ask Maven itself. Okay, Maven, go get the PMD rule set, then validate the source code against the PMD rule set, then give me the results. That is what all we're going to do it here. I'll create a new item, right? Say maybe code review, freestyle project. Say okay. It says good. The code review. I'll open and configure it. Again, I'll give the source code repo where I have my source code. Just copy the URL and give it in this one. Require configure it and say use the branch accordingly. Then build a step. And I use again the execute shell, right? I'll say opt maven bin mvn. Now here team, I'm going to use something called -P. This is a predefined syntax again. I'm not using anything on my own. Say pmd :pmd. Right? What I'm saying it, hey, Maven, use this pmd rule set. Try to get me the metrics out of the pmd and then try to validate the source code. That is how I'm telling it. Okay. So this is what all the syntax which is predefined to perform the code review with Maven and with the help of predefined rule set Maven, pmd. I'll apply this, save it, build. Just that you do it. So I'll click on this console output. Now it is trying to do something, team. It says build success. Okay, it was quick enough. It was able to get the pmd rule set and then able to validate everything. Now it says build is success, but you need to see the results, isn't it? Where is the target folder? Under the Jenkins workspace. If I go back here on the command line, I'll show you that there is a code review available, right? So if I go to the workspace, then you see the clone happened and there is a target folder. Now another target folder is where you see some results, say pmd.xml, blah, blah, something. Say Java unused code, imports, basics, some kind of a results it is generated, okay? But again, the same workspace team, so far I've shown you on the command line, but the same workspace can be seen on the UI as well if you want to. Like under each job that you see here, on the left, there is something called workspace. You see this? If I click on the workspace, you see the same thing. Now, if I go to the target folder, that you see the results. Now, all the results generated by the code review process here team, it's a PMD. Now it generated something called XML. Now this is the output. Now there are some issues maybe reported in this. Can you tell me the issues found during the code review by reading this XML file is a question. Okay, you are not able to understand it. So what do you try to do to fix it or read it properly? This is where team now the power of Jenkins comes into the picture. Let me tell you. Convert into a JSON or any other format, convert into another format. Now the question is that who will convert into another format again? Maven is generating XML. Now I want that XML is converted into a HTML and maybe convert into a nice visualization format. Now this is where team, you need to understand why we are using Jenkins for the build code process. So understand Jenkins is a very, very powerful tool, right? It will help you to do anything that you want technically. By default, it has some basic functionalities only, but you can extend the Jenkins functionalities to do any task you wanted. Now, what do I mean that? What do we mean by that? For example, team, I'll take again a general example. Let's say that I hope everybody is using a phone, right? Everybody using a phone. Which phone are you using? Android or iPhone? Maybe anything, right? Either it is an Android phone or maybe an iPhone basically. First, suppose whatever the model you purchase it, when you purchase your phone from the vendor, what you get in your phone is a basic applications, right? Vinay and everybody. Yes or not? What you get is very basic applications available in your phone. But do you stop with those applications only? Or let's say if I want to purchase something in Amazon, what do? Amazon may not be the default application available. So what you do is that you go to a Play Store, you go to an App Store, try to install what is needed. If I have to play a game, I'll install the game. So remember that the basic phone has a basic applications only, but you extend your phone capabilities by adding the additional applications as and when necessary. That's the basic thing, right? So you always extend your phone capabilities according to the requirement. Whenever there is a necessity of certain application, I'll go to either Play Store or App Store, download that, install it on your phone, and use it accordingly. That's by extending your phone capabilities. So think about it, team. The Jenkins software that you install is like your basic phone so far. We are trying to use whatever is default given. Remember, the Jenkins application that you're using so far is the basic Jenkins software. You're trying to use whatever is given as a default. But Jenkins functionalities can be extended as you like it, whenever you want it, in any direction you want it. Now that's where there is a concept called plugins comes into the picture. Remember, the application that you're installing from your Play Store or App Store are like plug and play applications, right? You plug it and play it with them whenever you want. So kind of plug-in, you do it. Now, same thing we're talking about the Jenkins as well. Jenkins also has something called plugins, right? Now, whichever the functionality you don't see in Jenkins, but you want it, you try to look for a certain plugin that will extend your Jenkins capabilities. So if I go to the Google and say Jenkins plugins, something. Now you go to a place called plugins.jenkins.io. Now this is like your Play Store or App Store, right? It says that here you have over 2000 plus community contributed Jenkins plugin to support building, deploying, automating any project, right? Somebody said, I want Selenium integration, right? I hope the spelling is right. So technically you see the Selenium plugins available. So what you need to do, you just need to install the Selenium plugin on the Jenkins. Now, if I have to work with Python based projects and I say Python, then you might find the Python related plugins accordingly so that you can build the Python code using Jenkins. Maybe a .NET related. So if I search for .NET related, you will find all the .NET related plugins available. Remember, by default, Jenkins was showing you only the build tools of Java because Jenkins is built on Java basically, right? Then you want some Python or Go or anything, there will be an essential plugin available, developed and available for Go. So that is what I'm trying to understand it, that you can extend the Jenkins capabilities, functionalities as per the requirement. Now that's why Jenkins is so famous out there, right? The kind of vibrant community that Jenkins has, you get a solution for everything that you look using Jenkins. Okay. You get all the newer plugins, updates to it very regularly. You can completely rely on this one. So it is an open source, completely free to use it, but you also have a very good community who supports everything on the Jenkins very properly, right? So yes, that is what we're seeing it. Now we can start installing the necessary Jenkins plugins inside your Jenkins. Remember, initial also you did something called install suggested plugins, right? There it is already installing a few basic plugins which are required. Now you extend them as you need it again. Okay. Now I'm hoping that team I'm clear on what is called Jenkins plugins and how do I understand them. If you're clear on that point, team, now why am I talking all these things is that I have certain plugins that will convert this code review results into a nice visualization format as well, right? Remember, there may be n number of build tools generating, right? There may be n number of code standards, different tools are available. You might get results in different formats, but again, not everybody can read this formatted files. So Jenkins is there for us to help in converting this code review results into a nice visualization format, more understandable format. So for that reason, I will install certain plugin here. So how do I configure something with Jenkins again? Always you go to a manage Jenkins on the left. Now on this system configuration, you see something called plugins, right? Add, remove, disable, enable plugins as you need it. So click on plugins. Now here on the left, you see something called updates to existing plugins, like your updates to existing installed applications, available plugins, like you're searching your Play Store, right? I can search here for existing Play Store like from this one. Already installed applications, you can see that as well, right? These are all the installed plugins already. So if I go to the available plugins and there is a plugin called warnings, I'll see, right? There is a plugin called warnings, or you can even search here something called warnings, right? This is a warnings plugin I'm talking about. Now see that here, it says the Jenkins next generation warning plugin collects the compiler warnings or issues reported by static analysis tools. Remember team, your code review is also called as static code analysis. The another name for this is static code analysis basically, right? So you may say static analysis tools or a code review tools, both are one and same thing. Code review standard basically, right? Says static analysis tools and visualizes the results. It has a built-in support for more than 100 report formats among all the problems it can detect technically, right? So it can be used with any type of programming, again, it doesn't matter. So that is the idea. So what I'll do on my Jenkins, right? I'm searching for this plugin, I select it, and then I say install on the top, simple. Now, when I install it, it will try to install whatever other dependencies if it is requiring again. So let's say it is trying to install some dependencies as well. That's okay for me. Now, once you install this plugin, then I can start configuring to visualize those results as well. Okay, so okay, now you see it is successful. So what I can do is that I go back to Jenkins dashboard. I'll open my code review again. Now I reconfigure my job. Now remember team here, we understood a source code section where we give the source code URL. Build steps, what Jenkins needs to perform after cloning the source code. Now after executing the build steps, we need to take the results of this particular step and then perform some other action. Now that's why it is called a post build action here. You see that? Under the build step, there is something called post build action, which means after the build steps are executed, everything is successful. We take the results of this post build actions and then perform some other action. That is why it is called post build action. It says define what happens after the build completes. Like maybe you want to send notification, archiving, trigger other jobs, blah, blah, right? So I'll drop down, you see the various options available, but one thing we are interested in is compiler warnings and static analysis results. We want to take the results and do something else with it. So I'll select that option, it will populate some page for you. Then if I check the tool we are using is PMD, remember, the PMD sets. Now the report file pattern is nothing but your pmd.xml, the results we had it. Take this out. Okay. Then you can just leave the other options as they are. Apply, save. Then rerun it this time. Now when I rerun this time team, it will also perform the post build action for me after generating the pmd.xml. It takes that and then converts into a nice visualization. How do I know? Okay, second build is successful already. If I click on the build, now you see some option called PMD warnings, right? On the left side, you see something called PMD warnings link, or this one. I click on this PMD warnings. Now you see directly the results of those XML in a more better way, right? You can see here. Okay, that's good. If I come below, it says files that has a problems, the issues that you see here, right? Now what issues it shows to you? It says that, okay, there is a properly loaded Java has some issue called unused code, empty code, like this. If I say property loader.java, 96th line having some empty code, something, right? If I click on it, it will even show you the code on the UI itself, basically. Now it says that a suggestion, avoid the empty catch blocks. Now remember team, developer is trying to do some exception handling, but it didn't fill the code completely. Does it make a proper coding here? Yes, team. Does it make a proper coding? No, right? It identified. Can I identify by reading the code like this? No, right? The tool is identifying for you. Now you can tell the developer, hey, it's better you write a proper code, catch the exception as well properly, technically, right? So we ask the developer to fix such silly mistakes here. Maybe he might have thought I'll write it later, maybe forget about it. So It's better that we identify such issues at the early stage of the development before we deliver it so that we can minimize the end user issues. Correct or not? Right or not? If I identify now, I can ask the developer to fix it. It shouldn't be identified after delivering the product, right? It should be identified at the early stage. This is how the code review will help us, right? You can see the code review will highlight all the issues available in every different file. Go with that and ask the developer to fix it. Simple. So this is what is the meaning of code review and how a Jenkins is helping us to perform the code review and visualize the result. If I simply use Maven, this is not possible. Jenkins is extending the way you actually perform the build code process as well. Okay. So this is the idea about your validate, compile, and code review, right? So what is called unit testing and then how it is performed here. So yeah, we're talking about the same source code again, we're talking here. So within the same Jenkins, again, we always have to build a new item. Yeah. So you can give the name, say sample app unit test, freestyle project, then say okay to it. The same approach as we did in the last session. So we just configure the source code on which you have to perform the things. Copy the URL and then put it here. Right, so here it is. And then say you will use the credentials if needed accordingly. Right, and choose the branch on which you want it again. Then the build steps. Under the build steps, you always use this drop down and then say execute shell. Then you give the goal, right, which is look to be OPT, Maven, bin, MVN. The goal is simply the test, right? The phase we're talking about it, MVN validate, MVN compile, MVN code review something, and then say MVN test to perform the unit testing, right? Right, so along with this team, you also need to understand something called the unit testing will also produce some results. Like the code review was producing some results team, understand that. Then we weren't able to understand that results because it was in the XML form. Now we used something called a post build actions that day by installing a specific plugin called warnings, right? Means you are in a way asking Jenkins to visualize the results that is generated by the build tools, whatever you call it, right? The goal of the things. So in this case as well, team, assume we are trying to perform some unit test cases, a unit test on the code which is given. I'll tell you where they are basically in a minute. But yeah, there is something you expect some results out of it. Now we always ask Jenkins to visualize the results. If you can go to the post build action and if you try to look at some options related to test results, unit test results here, you can see this. It's called a publish JUnit test results, right? Now, of course, obviously, like it says that the XML format again, because the Maven always produces the results in the XML form most of the time, right? So we need to understand that and we need to code and to generate that. So there is a path again. Remember, we always said the Maven generates the results under the which folder? Target folder. The target folder is under the always Jenkins workspace folder, right? Wherein you find your like this, right? So compile or maybe the whatever you did, right? Okay, let's say that we'll go back to the code review. Sample app, say code review. Now this is where you will find the target folder. Now under the target folder, you might find something like this. Now this is related to code review team because we haven't executed the unit test yet. You will not find any of the workspace for the unit test job here yet, right? After you execute for the first time, you might come and see here. But how do I know the path where the results generated? It would be under the target. The only thing is that you need to know the XML format, the XML names, which it gets it basically, right? So yeah, to do that, I mean, I can give you the path team. If you start working with, you will know that. So to just let you know that things as well. I'm not sure if I've told you this, that I have already documented these things in the last week, right? So if you go into this page, right, where you will find the post build action I mentioned for the unit test job, right? The post build action where you need to put this one, the publish JUnit test results and everything, and do this. This is all you need to do. So just copy this and then put it under the path here. Now the rest of the options will remain same thing. No need to change anything. Save it. Now, once you save it, let's say we'll execute it. So it is under the target, something called surefire reports. The Maven will create it, the directory structure for us. Then we have all the XMLs used under that, basically, not just the single XML. Now, once I save the job, let's say I'll click on the build now. Now, when I click on the build now, it starts executing, as you can see that. We can see the results, console output of that particular build number. Okay, it's trying to run some test cases. You can see this, right? It says performing the tests, right? So something it is being executed. So technically build success, it says total 23 tests were run. I'm just saying that we are performing the unit testing with Jenkins Preview. We just told Maven to do something. That's all I did, nothing else apart from it. Now within the unit test job that will be created, right? The unit test job, where we try to configure the source code repository, this one. And under the build step, we said, hey, Maven, go ahead and do the unit testing by using a goal called test. Then this will generate some results. So whatever the results generated, I'm converting into a visualization format using the post build action. Visualization, because I can see the XML here. If I go to this, on the left, you see the test results, right? That I can see that which tests were executed. See the test results? Right, so look at this test and they say there are multiple tests were executed, like test generic comparator, right? And say this one, blah, blah. See that something is being executed and something is being successful. If any of the unit test cases failed, what do? Who will write this unit test cases again? It is always done by the developer, right? Technically, if a unit test is failed, which means there is something wrong in the code, which developer needs to correct it. It's not the responsibility of me to do that. So technically, if a test is failed, I'll report the same error to the developer again. That is what all I'm saying it. Okay. What is the meaning of unit testing? Take a general example as your laptop. Think about how your laptop is built, right? Means if I have to build your laptop team, remember there are individual hardware components. So think about your laptop as a product, end product basically, right? The one using it. But before it is assembled into that end product, so there are different hardware components are produced, like your RAM, CPU, motherboard, or keyboard, monitor, right? All these are individually created, right or not? Every component is individually designed, manufactured, and then given. Then we assemble all this into a final product. That is the understanding you get it. Think about it. In this scenario, each individual component you're used to build your laptop is the individual unit, right? Individual unit manufactured separately by maybe a different vendors or maybe a same vendor. It doesn't matter technically, right? Now, each individual unit, say RAM as a hardware module, is manufactured and tested, right, successfully, and then given to you to assemble it, because something they can't give a faulty module to assemble it with your laptop, because if one module is not working, if any of this hardware module is not working, does your laptop functions at the end? No, right? Your laptop will have certain problem for sure, right or not? Now that's what we are talking, team. Individual units need to be tested thoroughly before you build an end product, the whole product that you see as an end goal, right? Now the same thing is with software as well. Remember that within a software code, there are n number of functions. Now if you know the programming terminology, right, we have something called functions, classes, methods, packages, right? In the software module, we call it. So technically, team, that each individual function, or in a way, team, I'll talk about, if I take any software, right, that you see as a Chrome browser right now is a software, right? Now in this Chrome browser, we have n number of features, such as say file tab, right? A file menu has a different function, maybe edit menu as a different function or a class function package. Now in this also you have each is an individual function, right? Can I say that each option that you see is an individual program or a method written back in the programming so that you're able to see this option here? Yes, everything is basically an individual unit. I can say that a different feature, that n number of features are being assembled into an end product, and you see all these features, right? Now, there are certain times where you might see some individual feature may not be working, right? Because it might have not tested properly. That is the idea. So understand that within a programming language or within the programs, there are n number of functions, methods are written, right? Each thing is this one. Say that generic comparator or Java. Now there is some functions are written here which can be tested individually, that this program may produce some specific feature, specific result out of it. Say that if I write a function to add two numbers, right? Think about it. If I write a simple function to add two numbers, what I can do, I can simply execute that individual function and test whether the addition of two numbers is working or not, right? Remember, this addition of the two numbers is a final goal maybe in the bigger application, but as an individual unit, I can test it as a developer and then give it to you. So that is what we're talking about it. So when developers writes these individual functions methods here, they will also have to test individually, right? All those test cases needs to be tested individually, and then say finally the whole units are individually working fine, so that we can build a final outcome out of all those things to produce a bigger product. That is what all the meaning of your unit testing. Okay, I hope you understood what is the meaning of unit testing here. A unit testing means that the each individual methods functions are tested separately by passing some values to it, right, by the developers using a test scenarios. That is what developers will do it. And those test cases must be given to you, because I'm running a unit test from here, which means that there are some unit tests are given to you that are part of your source code. Remember, so there is a folder called here src. Under that you see the main folder. The main folder here is actually holding the actual source code written by the developer, actual functions, actual features. The test folder here is maintained for writing or executing unit test here, right? If I go into this, you see that there is some execution files. The test files are given to you, test programs. So if I say test generic comparator or Java, so there is something, right? He wrote some program again to test, here is also passing some values. If you see it, there is some kind of the data is already interpreted, right? He's trying to pass some data here and passing it to the test cases. This is what I'll be talking about it. So technically, all the test cases are written here. Say here, they're saying that test generic comparator something, or let's say if I come test sort employee ascending, kind of, application may be related to some employees log or something. So they're testing the employee sorting, right? Employee name sorting, employee ID sorting, some kind of a test are executed here. You can see that. Say employee ID ascending, employee ID descending, some kind of a testing is done here, right? This is how you need to understand. Unit test cases are given by the developer, that you don't need to do anything. Ensure that within the source code that is given, the src folder is always used for maintaining the source code, the actual code written by the developer. There will be two folders here. Again, there is main folder. The main folder is where you find the actual source code, the actual application source code. Test folder is where the developer will keep the unit test cases, right? So that you can execute them automatically via the Jenkins. That is the simple idea. I hope that is clear now for everybody. What is the meaning of unit test cases? And that's what you see here, the test results, right? So when I go into this one, it says that it executed around 23 tests and all were successful. There is no issues in any test case we executed, which is good only, right? Now, what test cases were executed? You can click on this. It says something called test generic comparator, test log or something. We don't need to understand anything in this team. Don't worry about it. All you need to know is that is everything getting passed or not. If everything is passed, fantastic, good, no issues, continue further. If there is some test cases fail, report back to the developer that, hey, this test case seems to be failing it. Please check it from your side. What is there? I was saying that the main folder is where all the source code will be given by the developer or used for putting the main code. The test folder is always used for putting the test cases by the developer. That's all about it, Vaibhav. Okay. All the unit test cases are part of the test folder. Actual source code is part of your main folder. Okay. That's what all it's doing it. And then whenever you're running the test cases from the Jenkins will look, or the Maven will look for this test folder and then uses the programs written here, the automation test cases used here for executing the test cases. And it executes all these test cases and gives the results to you, that whether they are successful or failure technically. So as per this, now we're saying that all the unit test cases that were executed are successful. So there is no issues in the unit testing. So we can go with the next section. We are done with the unit testing as well, so which is good. Now, what is the next stage which we need to understand here is something called code coverage. As you can see, now we are done with the validate, compile, code review, also known as static code analysis. Now we understood something called unit testing today, which is also done. Now the next phase is called as code coverage, right? Now what is called a code coverage and why is it necessary again? It measures the percentage of code base executed during the testing, helping identify unit tested areas or improve the software quality. Remember, the main folder has the source code, right? And the test folder, we have the unit test cases given by the developer. We saw there were 23 unit tests executed. Now, the question is very simple. Are those 23 tests executed covered, right? Covered all the code in main folder? Can you guarantee me that the 23 test cases executed covered all the code in the main folder, which whatever the code is there, at least they were executed once and tested once. The individual units are tested. You cannot do that, right? Absolutely cannot do that. So we should validate the percentage of the code covered for unit testing. Mainly we can talk. There is a different case scheme, right? So in this case, if you try to understand it, what amount of main code was really unit tested, right? How do I know that technically? Is the developer performing the or gave me the unit test cases that covering all the code in the main folder? We don't know about that. So there should be a way to validate that. Means whatever the code in the unit test, again as the source code, you compare that and then give me a result saying that, hey, this unit test cases cover these methods, functions, packages only. There are some more functions which are not covered in this unit test cases, so you might want to improve it more. That is the idea. That's called as a code coverage, right? Remember again, a code coverage meaning is that we are trying to identify how much code was really executed, tested at least once during the unit test cases in the initial phase. That is what the idea is. So we need to perform that right now. We're going to do that technically, right? So what I'll do is that I'll give it a new item, say maybe a code coverage, something, freestyle, say okay. And then as usual, again, we can just give the source code, whatever we're trying to validate again as the things. So this is the source code. Use credentials if necessary. Use the branch accordingly. And say that here under this one, execute shell. We still use the Maven for the same task. Maven then say mv say verify. Now the goal is simply verify. We say that, hey, go ahead and validate, verify if all the unit test, all the code is covered under the unit testing, right? Now this is also going to produce some results, team, remember, which we need to visualize again. Internally, it uses something called as Java code coverage. Remember, there is a tool, the additional plugin that is used by the Maven or the Jenkins to validate as well as give me the results. The plugin is called Jacoco. Jacoco, in the sense we're talking about something called Java code coverage, right? If you type Jacoco, Maven plugin or whatever it is, basically you see it. Jacoco is a free open source Java code coverage library distributed under something. So we will use this particular thing, or the Maven actually uses this particular thing to validate, compare the source code with the test cases and give me the results accordingly. So the same thing we needed in the Jenkins as well to produce it. If I go to the post build action something, just to visualize those results again, I should find some option related to the Jacoco. Do you see any option related to the Jacoco in the post build action here? No. Okay, if there is no option, so what should I do? We go and add a plugin. Before I execute this, let's get that plugin to visualize that as well. So in order to install the plugins, we'll go to Manage Jenkins, go to the plugins, and then search for it, available plugins, something called as Jacoco. Yeah, there we go. There is also new plugin, so I'll install both of them. So say coverage collects the code coverage results, different tools like Jacoco and something, and then Jacoco is getting deprecated. We can still use it, but this is another one we get it, right? So we can use it. I'm installing both of them anyway. Let's see this. So let them install, then we'll try. Okay, now they are installed successfully. Yeah, Jacoco and coverage, both I'm installing it. Okay. So here it is. I'll go back to the dashboard and then let's get back to the code coverage, reconfigure that accordingly, and find some options in the post to build now. Okay, so now you say that there are two things. You can say Jacoco coverage report, or you can also say code coverage results, whatever you want to choose it, choose it. Say I'll use this. And from this, you can use the Jacoco coverage reports, right? Now it says something called report file pattern. Usually the report file pattern I already mentioned here. Let's say this is the one you need to put it here, right? That's all you need to put it, and then say apply, save, and then say build up. Okay, it's failed. Not sure why, but let's see that. It's a failed team, the first job which is failed today, which is this one. So let's look into the console output, what exactly it did, and then why is it failed. Now, whenever there is a failure team, you always go to the console output and find the errors that shows in the log here, right? So it says something, okay. Come to the bottom always to find the errors. Okay. Now it says that team build is success, which means the build actions are successful completely. And let's say that the post build action, I believe it's failed. Content is not allowed in the prologue here. A parse error is coming up. Exception occurred during the parsing, XML parse error. This is something related to the plugin team. Record code result marked build. I think it is this one, right? The last post build action is what is failed. Maybe issue with the plugin, something I need to check it. It says that there is some XML results, right? Let's see what results it produced here in the backend. The code coverage results, right? The post build action is failing it, so I have to go to the sample app code coverage. In general, this means that either absolute no longer being developed or may no longer work. Let's see that. I'll try to look into that. Okay. Sub exec. Okay, so let's see the team. I'll try to fix it. What is our maybe? Maybe we'll change the other option, I believe. Let's see. We'll try to. Let's say that I'll try to reconfigure the job. The other one. Let's see. I think it is the plugin can be the one which is doing it. This is the latest plugin came in, right? So I think it is just 18 days ago parsed out. So let's say that I'll remove this. Maybe I'll use the old plugin. Let's say that I'll have to change the code according to the blue year plugin, maybe a little bit. But let's say that I'll try, instead of using the coverage results, I'll just say Jaco code coverage report. Let's say that. Okay, this is giving me the option of exec by default. Let's see this. Maybe that is a plugin issue, team. Yeah, that's how I understand it. But yeah, that's what I'm saying it right now. The problem could be with the plugin. The plugin may be too early in this one. So we'll try. I'm trying with the other option called Java code coverage report for now. I'll try to fix working for that other plugin as well, maybe later. But right now, let's say that I'll rebuild it. I'll just change the plugin team, means the different option within the post build action. There were two operations, right? Code coverage results or Jaco code results. We'll try to use the Jaco code now and we'll see. Okay, this time it is successful. As you can see that maybe the problem with the other plugin, other option we have it. Okay, so now you can see the results that is shown here in the nice graph, or you can see the coverage report on the left. Yeah, very well. Now we can see the results, team, that are really shown good, right? That can be there. As you can see, team, here, there are two things, right? The green means that line is covered. The red means that line is missed, which means that the more red here, which means it is a bad, right? I could say that, as I told you, right, within the functions, we have like instructions, branching, complexity lines, methods, classes, something. It's all the programming language terminology again, forget about it. So assume that if I'm taking the class as a something here, it says that there were 11 classes missed, covered only 5, which means in the whole source code, I have say 16 classes, and I covered only 5 under the unit testing. 11 is missing it, which is really a bad testing, right? We can't say that it's just hardly 30% is tested. Methods only 20%, lines only 20%. So there are total 357 lines of code needs to be tested. Only 94 is tested. So which is, in a way, team, it is really a bad testing, I can say, right? If I get into the different name packages, say coverage breakdown by packages, you see that. So under the utilities, we have different files that are tested, right? Different Java files that are used for testing. Say string utilities is not even tested, right? Again, team, I'm saying that under the utilities or something, if I go to the main, under the utilities, there is something called string utilities.java, right? Means whatever the code under this particular file is not even tested somewhere. That's what this result is telling you. It is 0, right? Nothing is tested. Nothing is tested in payloader. In some of the files, there is something tested, something is not tested, something like that. So these results are really bad. Now we can push the developers to give us more testing here. Okay, whatever. So, right. So what you can see is that at the end of the day, we are understanding that the code coverage is really bad, right? Which really needs to be improved here. What you can actually do is that you can ask your developers to improve it. So it's simply that it is comparing, right, Joy? Because the developers provided some unit test cases in the test folder and the actual code is in the main folder, right or not? So it's simply comparing what is under the unit test cases again as the source code available. The plugin is just doing that for you, right? So whatever is this here, it has to be mapping with that technically within the folder itself. So it's not there, it means it is missed it. That's how it is working, Joy. Okay. Correct. It's not doing something, right? It's not analyzing the developers. Basically, it is that it is understanding what is given by the developers. It's comparing and giving us the results. That's all about it. Nothing else apart from it. Okay. It's not doing anything on its own. Okay. So now you see that the unit test, sorry, the code coverage is really bad. I can decide, team, to continue, right? I mean, if I'm feeling that I'm really okay, even if this is missed, I can continue for building the packages. Or if you really feel that this is not really good, I have to get at least 80% of the unit testing is covered, then only I'll continue. Then you push the developers to give us more test cases or put them into the Git repo, right? So that then we can execute it again. But right now, team, we are not writing any additional unit test cases. Leave it as it is. But in the real time, this is really bad testing. You have to ensure the developers are doing at least 80%. Then only you promote your code to be packaged. Packaged in the sense you can deliver the code to a end user. That is a simple idea. So now we are done with everything, team, though, assuming that all the stages I'm happy with. Remember, I'm happy with all the stages. I'm okay to package the code and deploy it as a software into a server, then I'll go and package it here. So let's run the last job here within this one, which is going to be a new item, right? So package is what I'll be trying, freestyle, and then say okay, right? Source code, I'll get the code, right? And use the branch and then say under the build steps, execute shell, sorry, opt maven bin, right? MVN package, simple. The package is the last phase we're talking about here right now. So save it. Now we don't have any post build action because we're not doing anything after getting a package as of now. So let's say that I'll do a quick build now. Now the package that we are producing, team, is called a var file, the extension that we saw last week when we ran the package manually, right? So that is the same thing. You're going to get it right now. Say here it is. If I get onto the build number one and look at the console output, at the bottom, you should see some packages produced. Like I can zoom in a little bit. Here you see that packaging the web app, assembling web app, so on and so folder, and it says processing the var project, building the var. As I told you, team, the extensions can be different from the packaging to packaging it. Now the Java executable files are always in the form of var or jar or maybe er, depends on the use case again. So this is the executable file, we got it. Now where is this file present? Technically, it's under the target. Now the target folder for package is under the workspace of Jenkins, technically, right? Now what I can do, let's say I can get back to the job and look at the workspace and say target. And under the target, you see this file, right? Which is around 15.8 MB. This is the one, right? Now, if I click on it, you'll simply download your local team. I can say keep it. Now within my downloads, I see the var file downloaded. Now this is the executable form of all the source code in this particular repo, right? A single executable file that you got with all the code that is given by the developer. Now this is the executable file that I can take it and install it on a server and try to utilize an application. Now I'll show you how to deploy this as well, so don't worry about it right now. But what we achieved right now is that understanding the various stages in the build code process, starting from validate till package, right? Now we have successfully built a package, which is great, understanding the above stages as well. Now what should be doing it next is a question. I can take it and deploy it as well. Okay, so talking about the further automation here. Now you can decide on the sequence of the jobs to be running, team. Okay. Now I won't say that, right? Remember the last step to be packaged, right? Before that, you can run any stage anytime you want it. So I can say that compile first, then validate. Doesn't make any sense, but yeah, we need to validate first and go compile. But yeah, compile and code review are independent of each other. So I can run compile and code review in parallel, maybe if I want to, right? Like the unit, I can perform the unit test first and then say that come back and do the compile job. That also can do. But mostly what I'm going to show you right now is that the sequence which I've done. So first validate, compile, code review, unit test, code coverage, package, everything. So one after the other will do what? Okay. So what we want to do here is that I want to trigger the validation on conditions, or maybe let's say that in this scenario, I want to trigger a compile job When I say compile job here, this one, whenever the validation is completed successfully. Can I say that, everybody? The sequence I'm expecting is that whenever a validate job is completed successfully, the compile job should trigger automatically before without I'm clicking on a build now of compile. Simple. Similarly, if the compile job is also executed successfully, build success, then code review should trigger automatically, right? The code review success, that unit test trigger successfully. If the unit test is successful, then trigger code coverage. If the code coverage is successful, then I'll say package also should be triggered automatically. How do I do that? What options Jenkins is giving to me for that, right? Now that's why, team, we have to reconfigure with some additional options now. What I'll do is that I'll go to the compile and I configure it. On the left, you see something called triggers, right? Now you come across the triggers options here. If I look into the triggers here, there is something it says, right? Set up automated actions that start your build based on specific events, like the code changes or a scheduled time something. That is what all we want to do, right? Now, looking at these 5 options here, can you tell me which option will be suitable for me if I have to trigger the build after the validate job is completed? Because I'm on the compile, I want to trigger the compile job whenever the validate job is completed successfully. So which option will be suitable for me out of those 5 options here? The answer is in the same question I asked it, after something, right? We'll explain the other one as well, but say that right now, the most suitable option is that we want to build after some other project, some other job is built. That is nothing but the second option here, right? Now, in this one, I'll simply say that, hey, watch the sample app. It says that it will list all the jobs you created earlier. I'll say that validate. Now, what I'm seeing here is that you watch, or we are asking the compile job to continuously watch the validate job, right? Whenever it is successful, and it says that trigger only if the build is stable. Or you have some options like always trigger even if the build is aborted or failed, something like that. You see this. What is a build stable mean? Build unstable mean? It says, it doesn't say successful, right? When the build is successful is not the option here. It says when the build is stable, when the build is unstable, when the build fails, when the build is aborted, something. So what is the meaning of build stable? Stability in general, right? Think about, team, the stable in the sense Jenkins, not successful really, I will say that. Jenkins will check the percentage of the time all the tests are passing. It's not about the testing basically. Say that I was executing the validate job 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Means assume that we ran the validate job for 10 times. Now the validate job was 8 times successfully completed, 2 times failed, right? Which means that build is stable. Remember, the percentage of the times your job is getting successful results into a build stable, right? So which means always Jenkins considers 90% should be successful, which means if I run validate job 10 times and I must be successful 9 times, then the build is stable, right? If it is reducing below that, if it's failed, if it's successful only 7 times and 3 times failed, build is not really stable, right? That is what the meaning of it. So it ensures that build stable means most of the time it is successful. It's all about it. Idea. Unstable means, okay, fine, whatever may be the failures happening it, that's okay, still execute the compile for me, that I can choose based on the requirement I have it. Okay, this is what the meaning of it. I can even say build fail, okay, still execute it. If somebody is aborting the build, means manually stopping the build in between, also you trigger the build again. Those are the options given by, if you want to be unsuccessful, choose always the build stable, something like that. So I'll apply it, save it. Now the same thing we have to do for all the other jobs, which means that now the compile is successfully completed, then I want to run the code review. So what I'll do, I'll go to the code review, configure it, then I use a trigger, then say build after projects. I'll watch this time is which job should I watch? Compile. right or not? Means the code review must be triggered when the compile job is completed. All I'm trying to say, save it. That's it. Now you repeat the same for, means we are trying to build a dependency to each other team. That's all we're trying to do here. So which means now the code review is successful or will be successful. And then I want to trigger a unit test. So I'll go to the unit test here. I'll configure it, triggers. Then I say build after, right? And I say sample app. What I should do? Code review, because we are under the unit test. So I want whenever the code review is successful, I'll have to trigger it. Simple. Save it. Okay. Now, once the unit test is successful, then I want to trigger the code coverage. Say configure it. Triggers. Then I use the same option again here. Sample app, unit test, right? The code coverage must be triggered whenever the unit testing is successful. Save it. And lastly, the package. When the code coverage is good for me, then I'll trigger the package as well, right? I'll trigger. Same option team for all the jobs, except the validate we didn't configure yet, remember, the code coverage. We'll talk about the validate job, remember. Now, we are still to configure the validate job here. If I go to the validate job is not still configured any trigger. We'll talk about some triggers here later. But right now, the understanding is that team, if I simply click on the validate build, the rest everything should be triggered automatically. That is what the idea, right? In a way. Now, the other question here is that looking at the screen, can you tell me which job will trigger after which job? So we need some kind of a visualization representation, a graphical representation that shows me the dependency to each other job. So how do I do that in Jenkins again? So there would be some plugins that we will use it right now to visualize dependencies as well before we execute that. So what I'll do is that team, I'll add a plugin to visualize the things basically a little bit. Say here, available plugin. There is something called as a build pipeline plugin. It might show you some kind of the warning. So forget about it for a second and say that we'll do install it. I'm just installing a plugin called build pipeline plugin. Okay. Okay, good that it is installed. Now I'll go back to the dashboard. Now here team, we need to visualize it. So we need to create a view for that. Now above the all jobs, there are two things you see, all jobs that you can see. And beside to that, there is a plus symbol called a new view, right? Remember team here, you have something called as a new view, right? I click on this plus button. Now you see some page called a new view here, and then you name it, whatever you want, say CI pipeline of my job, right? Sample something, whatever the name you want to give it. And choose something called a build pipeline view. Show the jobs in a build pipeline view, something like that. Say create it. Now, once you create it, it'll open up the configuration page for this pipeline view for me. Now you can use anything that you want, title, something. One thing important here is that something called as pipeline flow, right? Under that, it says something called layout is upstream, downstream relationship. Somewhere you see something called select an initial job. Now, what is the initial job in our pipeline here? What is the first job here in our pipeline we should have? Validate, right? So select a validate and then say apply. Then I save it. So now you got a nice view showing the dependencies. Everything is good, right? Now this is called your pipeline. Okay. Now the pipeline is, as I said, the number of stages in your build code process executed in a sequential manner, right? Now, if I simply click on the run above, The run will trigger your validate job, right? And once it is also giving you the color code nicely, the green is successful, blue is yet to run, yellow means running, right? Yellow means running. Just refresh your page to see. Yeah, now there you go. You can see that validate is completed, compile is completed, code review is now completed, unit test. Now it runs the unit test as well, something like that. So we have now done the pipeline creation, right? Successfully on the Jenkins. The different stages in your build code process are now sequentially executed automatically, one after the other, and reaching to the final stage called packaging of my source code, where I produce a deployable artifact or a deployable package for my source code, basically. This is something we call it as a pipeline that you can see clearly. So as we automated the major part team, then we want to execute some dependency, whatever it is, that one after the other in a sequential manner. Now this is what we're calling it as a pipeline technically, right? So the one job within this particular whole pipeline is not still automated to trigger it automatically based on certain conditions again. So one thing as such is come validate. Now you tell me, how should I trigger this job? Right? If I go to the triggers, now this job is the first job in our pipeline, so the second option will not be suitable for this one. So what other jobs what other triggering should work here? What do you think? Right. So we need to understand the scenario here, team, that again, the last three options can be something that we can look into, but each has its own thing here. Now, what is the meaning of build periodically here is that technically, as the name itself says, build periodically, which means say that every 2 hours I want to do a build. Now there is one what you call the issue in this one, right? Say for example, I choose the build periodically, which means I decided to run every 2 hours, right? Now whether there is a code change within the 2 hours is there or not, the pipeline will be triggered, which means there is no commits, there is no code pushed by the developer to the Git repo. But Jenkins says that no, you asked me to do build periodically, irrespective of whether there is a change or not, I'll run the pipeline. Does it make sense to run a pipeline without having any code changes? A big no. That's why the third option is not a suitable option here again. Okay, remember, the third option is not a suitable option, so eliminate it. Second option, eliminate it. First option, eliminate, because you still have to run manually. Now, the two options here is called as a poll SCM and something called a GitHub hook, right? The poll SCM is again a schedule, remember, but there is some difference between a build periodically versus poll SCM, right? Both are like a schedule. I give it like I can say that every 2 hours here as well within the poll SCM as well. I'm saying that go poll the SCM, which is the source code management tool. But in this scenario, we're asking Jenkins to check if there is really a change, means if there are any new commits available, if there is a change in the source code, then you trigger. That's called a poll SCM. Remember, poll SCM allows you to schedule to check the source code repo if there are any changes available. If there is a change, then Jenkins will trigger the validate job. Otherwise, it won't trigger it. So you can still go with poll SCM if you want a scheduled basis execution, like every 2 hours, go check if there is a change, execute. Otherwise, don't execute. That's the option called as poll SCM. So in this case, Jenkins will go to GitHub, check if there is a code change. If there is a change, trigger it. That is what it is going to do. If there is no change, it will not trigger it. That is the meaning of your poll SCM. Now there is one another option called as GitHub hook, right? Okay, let me show you this. Maybe I'll make it more for you. Within my drive that I shared with you already. So I'll just show you, right, so you can understand it. The GitHub hook. Now I just wrote the simple idea team. You have a GitHub, which is the remote server. Jenkins is your EC2 instance here, remember. Now, as I told you here, the watch GitHub and clone pull when there is a change, that option is called as your pull SCM, right? That's how you understand. But the other way around, we can ask GitHub itself, like we ask GitHub to trigger when there is a change, which is like whenever there is a new code added in the GitHub repo, we want to trigger the Jenkins. We're going to configure something on the GitHub, right? That's called something a webhook configuration. We say that. So we'll ask GitHub itself to trigger the Jenkins when there is a change available. So you can choose either of the option team. That will be the more suitable options. I can say that. So what we're going to implement here is something called this one. And I'll leave the other option to you. You can just schedule and see it accordingly when there is a change available. Okay. So let's do the GitHub hook configuration. That's what most of the time people use it in the real time as well. Whenever there is a change, you trigger it. That is what we're going to do. So for the validate job, I'll just say GitHub hook configuration. So I'll just save it. With this option, I'm not doing anything on the Jenkins side except selecting this option, right? Remember again, on the Jenkins side, you select this option as a GitHub, and then you need to configure in this GitHub repo to trigger this. You can even use multiple options if you want to, but that's your choice again. I can even select poll SCM as well because it's a checkbox, right? It's not a radio button, Prasanna. It's a checkbox. Yes, you can allow to use multiple options as well if you want. Right. So once we save it here, now on the GitHub repo, remember, okay, I'll give you the document as well, team, so that you can follow that, a step-by-step guide that I already documented here. If I go to the configuration, okay, this one, right? Trigger build with GitHub webhook is the option which I'm talking. I just wrote a text for you to understand step by step so you can read it. This is the same thing I'm going to do. Okay. So on the GitHub repo, so navigate to the settings on the GitHub project that you have it, which is the step one. So this is my GitHub project. The settings of the project just below this search box, do you see settings of the project? Again, remember, this repo has to be forked into your account if you have to see the settings. Remember, if you try to configure my GitHub URL like learn DevOps sample DevOps, you cannot see the settings of your own and you don't have access to my account, so you can't see it. All I request is that you always have to fork this repo into your accounts and then use the settings of your things. Okay. So I go to the settings. On the left side, you see something called webhooks. Click on the webhooks. Okay, I have configured many times with it. Now you see something technically add webhook on the top, right? Open, click on the add webhook. If it is prompting you for your authentication, please do that. Let me do my authentication. Lead DevOps, right? E13855. Okay. Now you can see as soon as I authenticate, we'll go back, or I'll go back to the webhooks again. Add webhook. Now you see this page. Now on this page, you see something called as a payload URL. Now remember, team, the payload URL is nothing but your Jenkins URL, right? The GitHub should trigger talk to the Jenkins. So the payload URL is nothing but your Jenkins server instance, which is HTTP IP address and the port number of the Jenkins. Or simply you can copy paste from this. Where is this? Yeah, this URL, right? This is what I'll copy it and I'll paste it here. Now we're not done with this URL yet. Ensure you forget this one. Use the address and ensure that you add a slash GitHub webhook to the end of it. That is what we're going to do. Right? This is how you do it. So Jenkins IP address, port number slash GitHub dash webhook, which means this is going to trigger what you select as a GitHub hook here. Whatever the job should trigger with this is going to select it. That is the idea. Now, once you do it, the content type, make sure it is application JSON. That is how the JSON accepts it. If there is a secret, you give it, otherwise it's not necessary, right? SSL verification, by default, verify SSL certificate. We don't have this SSL, right? So I'm disabling that SSL, something like I do. Now, if I go to this, just send a push event, means whenever something is pushed into your GitHub repo with a branch that you selected on your Jenkins job, that will be happening. Or you can say, send me everything, whether there is a pull request or maybe somebody is cloning it, somebody is forking it, right? The different options given. Now, if you want to select an individual events, select individual events. Like it will give you many more options for you. Actually, we don't select all these things in real time, but this is the idea, right? What I can do, I say pushes, pull request reviews, uh, pull request. In fact, I can say, right, when somebody make a release, I can do this. This is the simple options I'm selecting it. Add webhook. Now, once I add webhook team here, now you see at the end something which I configured. This was not triggered yet. So what I have to do simply is that I need to make a commit in my GitHub, right, project right now. But before that, I also save it here on my Jenkins. Now, so far team, I'll show you something. If you take any build here, just for understanding, if I look at the console output, the first thing that you see is called as started by user called admin, because I logged in as admin so far. I was the one who triggering this validate job so far many times. So it is telling you the first line who actually triggered the job, which is started by the user admin. This is the one you see it, build number 6, right? Build number 6 is the last build we have it for the validate job. Now the build number 7 should happen automatically when there is a change, when there is a new commit happening in this particular thing. So for example, assume that the developer is pushing some code from their local, but technically I'm editing on the GitHub itself for your reference. So if I go and say I'll open this property loader.java, I'm not making a real change. So we just have to go there, add something, star something, and I say commit it. I'm saying that update property loader.java, commit changes. Now assume that there is a change in the property loader.java pushed by a developer to the GitHub. Simple. Now, since I already configured it, if I get back to my Jenkins, now you see the 7th trigger happened already. Now, did I trigger this? No, right? If I look at the console output, who started this time? It started by GitHub push, right or not? I didn't trigger it. Remember, I just made a commit on my GitHub. Now that triggered my validate. Since the validate is triggered, remember the whole pipeline will start triggered in the backend, right? Like you see, now it is sequentially started executing all the jobs for you. That is nothing but your final automation, where you see that from now onwards, whenever there is a change happening in your GitHub code, if the developer is pushing some changes here on every commit, the build will be triggered for you automatically. So this is nothing but we call it as the fully automated CI pipeline for your sample app application. Simple. Okay. I'm hoping that I'm clear on GitHub hook configuration. How do you do? And if you are doing something in your local host, which is in your personal laptop, remember the GitHub should be able to reach out to your laptop. For that, you need specific connections. If your laptop IP is pingable, reachable from the GitHub, it will work. Otherwise, may not be. So ensure that you configure your laptop is reachable from the internet using your router setting somewhere. So this is the first topic that we have to cover within the Jenkins team, Maven pipeline. How do I build each job, project, plugins in Jenkins, right? That is one thing you do. Maybe as a DevOps engineer, if you are given an option from the development side to do build pipelines. Now it's for more of a DevOps engineer who are not a developer. So you might want to understand the Jenkins administration a little bit more, right? Controlling access to Jenkins, and then say that maybe building a distributed builds, helping developers more. We will talk about that now. So the next concept that I would like to talk is something called distributed builds in Jenkins. So what is distributed builds in Jenkins, and how do you understand? Since now we have completed the CI pipeline successfully automated team, so let's focus on some Jenkins administration activities, which is required as a DevOps engineer always. Anybody, whoever it is, doesn't matter, but the concepts we're going to talk now are more important as well. So one such topic is called as distributed builds in Jenkins. What do you mean by distributed builds in Jenkins? We installed Jenkins on a machine that is nothing but our EC2 instance, correct? We installed Jenkins application, Jenkins as a tool on a EC2 instance, right? Or that you may call it as a server, technically, which comes with certain capacity always. Say, in our case, assume that if you have taken a T2 micro, which is a free tier instance, which comes with one CPU, 1 GB RAM, and say 8 GB of disk, right? Is that the capacity of your EC2 instance, everybody? The free tier instance that you're taking? Now here, Jenkins server or as a process running, correct? Now understand the logic here, team. It's very simple to understand as well. Now I'm saying that on your EC2 instance, which has disk capacity, you're running something called Jenkins server, and it's a process, right or not? Can I say? Here, unlike the Git, Maven, and Java, Jenkins is basically a process. How can I check the process on my Linux box? I can run some command called ps-ef, and I say grep for the process you're looking, Jenkins, right? Now Jenkins is running as a process. Now what do you mean by Jenkins is running as a process? A process that uses your CPU and RAM. Any process that is running on your computer, any application that you launch on your computer team, which consume some resources from your computer or a server, which is nothing but your CPU, RAM, and disk most of the time. Correct? So assume that my Jenkins process is already consuming some CPU, RAM from this particular EC2 instance. Now, along with that, understand team, whatever the tasks that we are running using this Jenkins process, certain other task is also executed as a process, which I mean to say that if I trigger a validate now, which means it is running it, what it is running here, if I go and check in the backend team, right, I say Java something, along with the Jenkins process, now you see that it's running a validate process, right? A validate as an execution means while executing it is a process, it runs something, produce some results, the process will exit automatically. That's what you see it, right? Now you see it is running a compile process, which means, of course, they're running in sequential manner, one after the other. One process completed, the other process started executing because we built that thing in a sequential manner. So it is running in a sequential basically. Now you see it is running code review, that every task, every phase in your build code process executed as a process on the computer that Jenkins is running so far, or it is executed by Jenkins as a process. And remember that while you're executing this process would also consume some CPU and resources, CPU and RAM. Is every task running here is executed as a process, which would also consume some CPU and RAM for sure. Now, understand that there is only one pipeline we built on my Jenkins. One application pipeline is what we built it. Now think about the same Jenkins is used for running multiple pipelines. Say there are 10 applications I have. Now I constructed 10 different pipelines with the different stages of each pipeline. Now assume that all those 10 pipelines were triggered at the same time, parallelly. Yes, right. There is a possibility that all those pipelines would be triggered in parallel at some time. Can be. Now assume that if all those pipelines are triggered parallelly, which means that there are 10 different processes started executed parallel in my computer in the backend. Now with a 1 CPU, 1 GB RAM, what would happen to your system? It will hang. It will slow down, first of all, right? The first phase is that it will get slowed down. Now, finally, it is not getting some resource, then it will try to hang it, then crash it. Performance is gone, right? That is the idea. Now, how do I improve the performance here then? Two options, right? Two options. One, you can increase the capacity of the same machine, right? One, we can increase the capacity of the same machine here, which is a vertical scaling, we call it. Means instead of 1 CPU, 1 GB RAM, say I can choose a machine with say 16 CPUs and say 96 GB RAM. That's a huge box that I have it. Yes, I can run 10 different pipelines easily with that capacity. Agree with me again? That is the first option. We can actually run everything on the same machine by increasing the capacity of the same instance. That is one option we have it. The second option is that, let's say I want to build a Windows related project. The other pipeline that I want to build it, I want to have a Windows related project where I would like to execute some .NET modules and everything. Now, can I run some .NET related code easily on a Linux machine? Because my present machine is a Jenkins Linux machine is running it. Can I execute something Windows related task on my Linux box easily? Does it really support all the time? May not be, right? Maybe, may not be. Not all the compatibilities can be done here like that. So think about it. For that, I would need a Windows machine, right? Maybe it's more comfortable if I want to execute some Windows related jobs. It would be a Windows machine circuit. So how can I ask my Jenkins to run something on a Windows machine if I have to? So two scenarios team I'm talking about here. Yes, you can increase the resources of the same instance where you're running a Jenkins, right? To run more pipelines in parallel. That can be one option if you want to choose it, but not the right option always to do a vertical scaling. There can be something called horizontal scaling, which I'm talking about adding more capacity by increasing the number of servers, which is like building a team, right? Think about it. If you're overloaded in your team, what would you do? You try to share your workload with the other team member. It's like sharing the workload with team members. When you have more team members, you can simply share it so that your work is being distributed. So every team member gets enough room to complete the task easily without exhausting themselves, right? That is the simple idea. So the distributed builds concept is all about that team, right? The concept in Jenkins we are talking is called as distributed, right? Builds. Now, this is also called as your, in a way, a master agent concept in Jenkins. This may also called as your master slave concept. Again, master slave is not really, a lot of people may not feel comfortable in pronouncing those words, so people use it. The final thing I would say is called as a controller agent. The most convenient thing, which I would always prefer to use, is controller agent concept. Now, what do you mean by controller agent again? It's like you're building a team, right? You have a team leader who distribute the work into the team members, right? That is the best option. We always have it. Not every team member like you share it easily until unless if there is some manager controlling the team members, right? Otherwise, people say that, okay, why should I do your work? But if your manager says, yes, you do work, that's it, right? That is a simple idea I'm talking. The controller agent concept we're talking here are nothing but distributed roles. Now remember that the Jenkins instance that we are using so far can be called as your Jenkins master or a Jenkins controller. The instance where we installed Jenkins application, or in a way from whichever the server you're seeing this Jenkins UI, Jenkins dashboard, whatever you call it, whichever the VM you're launching the Jenkins UI from, that machine is always your Jenkins master, or it is called a Jenkins controller, right? Now, so far you executed all the builds on the Jenkins master itself. Say we installed What all things we installed here? Installed Git, installed Maven, right? Installed Java, of course. Now, of course, we installed Jenkins server. That is what we did here. Now, the idea here is that instead of overloading your Jenkins master instance to run n number of pipelines, n number of jobs in parallel at the same time, we can ask Jenkins master to actually distribute its workload to another instance, which means this can be your another EC2 instance, say another EC2 or a server, can be anything else, you have it. Now this can have its own capacity again, like 1 CPU, 1 GB RAM, and I see that 8 GB of, I'm just taking the free tier instance capacity again always, right? Now this one also can be any operating system you have it, say Ubuntu, Linux, right? And remember team, since we want to execute the same pipeline maybe here, the Java related builds I want to run on my other instance, then again I would install the same thing. Install Git, right? Install Maven. Let's say that install Java. But here we're going to install something called as Jenkins agent process, not the Jenkins server that we install on the Jenkins master. That is the different one. Now we're going to install something different here, something called as Jenkins agent library or a code or software basically, right? Agent software technically. So here we install a Jenkins server software. Here we're going to install Jenkins agent software. Then we will connect them, means we'll ask Jenkins master to delegate the work. I'll show you how do we configure all these things now. So technically we'll ask Jenkins master to delegate the work onto this instance rather doing it. You can see that process, right? Jenkins GitHub is a server and client. Here we have it. It's not technically master is delegating to client here something, but the idea is that only. Now, the flexibility here with Jenkins is that the agents can be running on different flavored systems, which means that I can have a Windows machine attached as a Jenkins agent to the Jenkins master, which is running in a Linux, which I mean to say here. This is again a EC2 or a server. You can talk it with the similar capacity, maybe 1 GB RAM and say maybe a 30 GB disk, which is the Windows requirement usually. But what I'm seeing here is that you can have something called as Windows, right? Windows OS simply, not like that. Now here also team, remember in the Windows box as well, we can install all the related stuff. Say if I want to run a .NET related project, what I do, the Git is mandatory everywhere, install Git here. But instead of installing the Java, let's say that I will install the .NET software. Here we install in Java, right? Because it's Windows mostly. So anything related to .NET or something like that. Now I can install the required, build tools as well. Accordingly, say that MS build, something like that. Whatever the build tool that is used to build your Java, the .NET project, you can install that. But at the end, what we say is that we install Jenkins agent software here. So in a way, Jenkins can distribute different type of builds into different type of agents and run without conflicting each other. That is the main understanding of why distributed builds are mandatory in Jenkins we talk. Because remember that I can't install all the different type of tools in a single box that can conflict with each other projects maybe, because each project may have a different set of dependencies to be configured, different set of server requirement would be there, something like that. So I can choose an agent process wherein I can build a different type of project easily without conflicting with some other projects, because Jenkins is one tool which we use to build all types of projects. All type of programming language projects can be built with Jenkins. So if you do not want the conflicts happening between the programming language builds, then you use a different build servers. That is nothing but the agent servers, agents which are connected to the master. Master will control the agents and then delegate whichever the build has to go to which server, and then parallelly execute them as well without any issues. That is the simple idea. I hope that I'm clear. What do you mean by distributed builds in Jenkins and why is it important as well here? Distributed builds helps you to delegate the workload, distribute the workload into different servers so that Jenkins master is offloaded from execution. And Jenkins distributed builds even allows to build different type of projects with different dependencies without conflicting with each other. That is the main concept we're talking here. Okay. So what I'll do, I'll create a new launch instance again, the second instance. I'll call this as your Jenkins agent. Now I'm using the similar operating system team Ubuntu, right? And I would say the T2 micro itself, right? And then say key pair, the one which I want to use to log into the instance. And security group, I'm matching with the same security group which has the one, which is iPad. Okay. And I'm leaving with the defaults, something like that. Okay. And if you want to change the operating system here that I can use, maybe 2204. Not SQL we wanted, right? So 22, this one. So because the master is running on 22, so I'm keeping the agent as well in 22. That's it. Now this is how we select instance and say launch instance. Simple. Now that should allow or show us the second instance here running. Now you can see that the second instance is called Jenkins agent. You can start creating as many EC2 instances and start doing it. That's how you do it. Now, why is it taking launch wizard 1? Now I have to attach to the iPad, right? Security group. I did attach it, but why is it created one new? Okay, so what I'll do, I'll ensure that the rules should be same there. I thought of adding it to this one, but I didn't add it. Okay, so anyway, can I attach another security group to the EC2 instance? You know that, right? I'll leave it, but let's say that. How do I attach it? So here it is, right? So technically instance settings, and then you need to go and do that. We need to. Yeah, change security groups. Okay, iPad, add security group. Thank you. I can remove this and save it. Thank you, guys. Now I updated it. Okay, under the actions, it is security, and then go this one. Okay, fine. Right, so here it is. Now you see that I have changed the security group to iPad instead of launch wizard 1. So ensure that both master and agents are on the same security group, this so that they can communicate with each other without issues. That's all I'm trying to do, and then I'm using the same keypad. Okay, so anyway, now we are good with this. So let's say that I'll just go and then log into this server first of all. Right. Now on the right side team, I'm logging into this agent, SSH-I, the same way, Ubuntu at the rate, this one. Okay. Now on the right side team, the 126 here is the agent box, and the 66 is your master box, where we already have the Jenkins is installed here, right? Right, these are the Jenkins is already there here, which I'm not going to touch it. Now on the right side team, on this machine, we need the Git. First of all, to clone the repository, so Git is available. I'm not going to reinstall again. And let's say that we try with the Java. The Java is not there. So mvm version. Now the Maven is also not present. Now, after that, we need a Jenkins agent. I'll show you how to install Jenkins agent as well. But before that, let's install the Java. Let's install the Maven on the EC2 instance, the new one which we created right now. Now, to follow the installation team, again, you can follow the same steps that we have used earlier from the GitHub, the Jenkins folder, right? So under the Jenkins install folder, where I have given you the installation of Java and Maven. So I'll follow the same instruction here again one more time. Okay. So I'll take here and I just install the Java first of all. Once the Java is installed, then we can go ahead and install the Maven as well. Now, if those two are settings done, then we'll start configuring the link between the master and agent servers. Okay, now the Java is installed successfully. See the Java hyphen version. Now the Java is good. Now let's install the Maven as well. So the same instruction again, I'm following it here. Okay, done. And I'm just going to set the other thing as well. Okay, so good. Now let's run the mvn command, mvn hyphen version. That we have the Maven is also installed successfully now. Now we have both all the tools team required, remember, as we discussed here. So the installation of Git is done, Maven is done, Java is done. Now all we need is a Jenkins agent software and the link to the master to the agent right now. Now to do something team, we need to tell the master that which is the agent server. So for that, we actually need to do some configuration on the Jenkins UI itself, right? That is something we can see here from the Jenkins dashboard. You can go to the Manage Jenkins. Now from the Manage Jenkins, under the system settings team, you see some option called nodes, right? System configuration. You have system tools plugins. Now you see something called node. The node is nothing but your agent VMs team that you want to connect to the master, that you need to tell the Jenkins master that's your agent, right? So here it is. I'll say add, remove, control, monitor various nodes that Jenkins that job runs on. I'll click on the nodes option. Now you see some default node called built-in node. The built-in node is nothing but your master instance itself, where the Jenkins jobs are being executed so far, right? But what I can do is that I'll just say simply configure a new node that Jenkins would run the jobs on going forward. Now here team, the node name, you can give anything. That's your choice, right? I'll say this is my Linux agent for Java projects. Again, that's your choice, whatever the name you want to give it accordingly. But I'm just giving it more meaningful. A Linux server where I'm going to execute some Java project, right? And say this is going to be a permanent agent for me. Then say created. Now, once you create a team, it gives you some more configuration that you needed. So the description, you can write anything. And the other option you see here is called number of executors. Now, what is this number of executors is that theme? Remember, now again, the agent VM is also EC2 instance team, remember, where Jenkins master is delegating a job, right? Now, when the workloads are very huge, there is a possibility that the Jenkins master can even delegate multiple jobs in parallel, correct or not? Can Jenkins master delegate multiple parallel things, multiple parallel execution on the Jenkins agent? There is a possibility as well, right? Now we are telling that how many parallel executions can be done on the agent VM. Now the executors are nothing but your number of concurrent bills. Understand here? The maximum number of concurrent bills that Jenkins may perform on the agent node technically. We are controlling that. Remember, we can't blindly send a number of things and make the agent also hang, something like that. It's better that you decide that based on your capacity of the agent. If the agent has, say, 4 CPU, 16 GB RAM, maybe I can run 4 jobs, 10 jobs in parallel. But if the agent VM has only 1 CPU, 2 GB RAM, 1 GB RAM, then I can run only 2 builds in parallel maybe. So you configure this number of executors based on the capacity of your agent VM, right? The other EC2 instance we're talking technically. Right now I'm giving 2 here, but it suggests that always you need to give number of CPUs is equals to the number of executors. Means if I have 4 CPUs, I'll say 4 executors. If I have 16 CPUs, then I'll say 16 executors, basically. Simple as that, right? Input, output based and everything. That is a simple idea. So I'm just giving this 2 team. That's your choice again. Understand that this is a number of parallel builds Jenkins master can delegate to the agent. Now the next point here, it says that remote root directory. Now what is this remote root directory? Is that team? Like I told you, remember team, here we got something called Jenkins workspace created as part of the Jenkins installation, right? Now you see something here, Jenkins, varlib Jenkins is a Jenkins home. Under that you have a workspace where all the execution results were generated by the Jenkins, right? So if I go to the workspace, you see something like this. Now I want similar thing here on the agent side. Understand here, since we did not, or we are not going to install the Jenkins software or a Jenkins server, we technically have to configure the workspace location where Jenkins will generate the results on. Simple, that remote root directory. In a simple way, I can create any directory here under any location, say /opt, say I'll say mkdir Jenkins agent home, I call it. J agent home is what I'm giving it, right? J agent home. Now this is the path I'm saying it, right? Instead of varlib Jenkins, where you see the workspace on the master, on my agent side, the workspace will be available on opt J agent home. I'll just say this one. Remember, this path must be created on the agent server. Then you configure it here accordingly. That's your choice. Okay. I hope that I'm clear as well. Now the label, you can give anything again. Agent 007. Now the label can be anything as your choice. I'm just giving as agent 007 accordingly. Okay. Now we're also telling the master about how to use this node, right? That is where we see some option called usage. Use this node as much as possible. Means give the first preference to the agent to execute. If the agent is full, then you will run on your own. Or only build jobs with a label expression matching that node, which means that I can configure a specific job with certain label that this job should always run on that node only. That is what we're saying it. So we use the jobs to run or select a specific job to run on that particular node instead of using everything. But right now I'll say use this node as much as possible. That is okay for it as a condition, right? Now you can choose either of it, right? Not both of them basically, right? Use this node as means any job would run on that particular node. But if you have certain condition like wherein you have a Windows related .NET execution but cannot go into the Linux machine, right? In that case, I use this option. Simple as that. Okay. I hope that is clear. Now launch method, it says something different options again. How do I launch the agent? How do I install the agent? It says launch agent by connecting it to the controller or launch agents via SSH option. These are the 2 different options given. So I choose this first option here. I can use SSH as well, but I'm not using this. Okay. The second thing. Now availability of this agent, keep the agent available as much as possible, right? Which is like, it's not showing the options. It says bring this agent online according to the schedule if you want to, or say bring this agent online when it's demand and take it offline when it die, idle something. You choose any options team, depends on the requirement. Technically you choose it. But right now I'll say that keep this agent online as much as possible or keep it online always simply, right? So that I can run anytime I wanted. The process will be running continuously there. So this is how team we can choose the different options one by one. Okay. And I save it. Remember team, we told the configurations here, but this agent is still not online yet, which means it is not started yet because we haven't installed any Jenkins software here, right? Did I install any Jenkins agent software here? No, right? Technically, we haven't installed any Jenkins agent related software yet. That has to be installed, then need to be launched to connect to the master basically. That is what we're going to do now. Those instructions are given by the Jenkins master itself to you. Means if I open this Linux agent here for you, now it gives you some instructions on how to install the agent software, how to bring up the agent as well, right? It says this is the one, something like that. Run from the agent command line if you're using a Unix, something like that. It says that, okay, take this command to download this agent.jar file, which is the actual agent software. A simple lightweight utility, we call it. Now, if I see now, this is where you see the agent software is downloaded. Now, the agent software is a simple one, team. It is just an executable jar file. That's it. Nothing else apart from it. It's a lightweight file. Now, once you downloaded the agent software, then launch that agent software. Say java-jar, and this is my master IP master port number. Understand here? I'm trying to launch my agent by connecting it to the master address, means telling the agent that, hey, that's your master, go and talk to that guy. This is something you're giving it, and the secret configuration, everything is required. So I'll take this command and I execute it on my agent. Now you see that it says the info is connected. Right? You see it, everything, info connected, blah, 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 blah. Right, so which means that the agent should come online here right now. Say if I refresh it, now you see that agent is connected, right? Which means our second VM is now successfully up and running, that I can run the jobs on right now. But there is one challenge here, team, is that now you see that the agent processes start on the terminal, right? It's not giving me my terminal back, which is like foreground process if you know something. How do I run a process into the background on the Linux? If I do a control C, now what happens? Now my terminal is stuck here. Remember, my terminal is stuck here. If I do a control C, right, now the agent process is gone. If I check any process running, I don't see anything, right? Now remember, team, it's necessary that you run the agent process into a background process. That's what you do, or simply I can do an ampersand at the end. No hub, also you can try it. That's also good. So if I do an ampersand at the end of the same command, it automatically creates all the no hub everything for you. Right, now you see that. Now it's simply connected again one more time. Let's say that Java. I see that my Jenkins process is running, or agent is up and running. So when I say agent is up and running, come back here, go to the nodes and check it one more time. Now it's still available for me, right? So agent is connected without any issues. So technically, this is a simple idea that the way you launch an agent. Now, once you launch an agent, team, what should I do now? Should I trigger the job? Will it go to that agent or not? Say if I go to the validate and trigger it, now where does it run by default? Now the 9th build which I'm seeing it, I'll say console output. Now here, team, you can see that it's really running on the agent. How do I know? Can you read the output here? The third line, started by user admin, running as system. It says building remotely on Linux agent for Java projects, agent 007 in workspace OPT JAgent home workspace and small validate. Now, without you telling anything, team, remember Jenkins by default, Jenkins master, in this case, the UI, basically, by default, it always checks if the node is available or not, and then delegates the job into the node as a first priority, right? If the node may be busy, then it might take the load. That is the idea. The idea is that by default, you don't need to say anything. Jenkins will start triggering everything on the node itself. So if I go to here, you should see the workspace got created, right? If I go to the workspace, you see that the job started running. Validate, compile, unit test. Maybe the code review ran on the master again, right? Depends. I'm saying again, team, it's not guaranteed that which job would run on which VM. It dynamically chosen when the job execution start. At that point of time, master validates whether node should run this or not, then automatically choose a node available and then run it. That is a simple idea, right? So I see the validate, unit test, compile, code coverage, maybe the package. Yeah, package. Now you can see this team except the code review, everything ran on the node itself here. That is how you see it. So in a way, now you can see that master is delegating the workload onto the agent, which means you have done the distributed build successfully. How do I attach a node to Jenkins master and start configuring or start executing the jobs on the node side rather executing on the master side? Simple. Yes, all of you. Are we good with the Jenkins master agent right now? Now, what you saw is that Jenkins was dynamically selecting the agent, right? But what if I want to ensure that the code review always runs on agent only, or all this pipeline should always run on the agent only? I should never execute something on the master. How should I select that? Okay, so that's where you need to configure the agent. Say for example, we saw that code review did not run, right? So 7th build of code review still ran on the master only. But I want to be sure that the code review runs on the agent side itself, or any job you choose a team. It's not the code review I'm saying it, but any job that you want to ensure that you run it on the agent only. Agent only, again, remember this configure is like your hard coding that way it should run. Otherwise, you dynamically select either master or node like that. Now, under the general section team, you see an option called restrict where this project would be run. Right? It says restrict where this project can be run always, no matter what. It has to be running only on that specific node. Now, I can choose master itself if I want to. Built-in. The built-in node is nothing but your master. Or let's say that I can say Linux agent for Java projects as a agent name, or you can use the agent label as well, which is agent 007. You can use anything, agent name or agent label, that's your choice, right? Or the original name and so on. So this is what I like it. If you're confusing with this name, I'll say that Linux agent. This is the agent name we configure. I'm using the same agent. Okay. And I save it, which means from now onwards, if I trigger a build for this code review, it always goes and runs on the agent side one. This is like a manual configuration. You have to do it always. Depends on your requirement. If you want to ensure that Jenkins master runs this job only on a specific chosen agent, then you configure it within the job by restricting the job project to run on a specific node always. That's your choice. Again, you do it according to your requirement. Okay. Are we clear that how do I choose as well? Yeah, this is one-time setup for build. In the subsequent build, it normally choose the same agent again. This is one-time configuration, you do it. What happens if the agent is down? Will the code review run? Yes, team. If my agent gone down, will the code review run in this case? Say for example, I'll just show you, right? Nodes, and I say go to this. Let's say that mark this node is temporarily offline. Means I'm saying that, okay, offline. Means this node is offline right now. Remember, you hard-coded projector, right? I said this node is offline right now, disconnected by the admin something. Now, if I go back and then execute the code review, it will stuck, right? If I say code review, build now, now you see it is stuck here, right? It won't continue. It says that it has to run on the Linux agent for Java, but it says it's offline. So it can't execute. Until the agent comes online, it will not continue. It will be in a pending status only. That's the disadvantage of restricting a job to a particular node. If you do not restrict it, then this time it would have gone to the master mainly. Because the agent became offline, this would have run easily on the master itself directly because agent is offline. But if you hard code it, remember, until that agent becomes online or available, the job will be in a pending state itself. Okay, that's what is a disadvantage if you restrict it. If you don't restrict, there is a possibility it can go to anything. So if I go to the nodes, right, and I bring this node back online, now code review started triggering it. Simple. That is the idea of how to do the things here. I'm hoping that I'm clear on what is distributed builds in Jenkins. How do I configure it? How do I see the advantages of having a distributed build architecture basically in Jenkins? What is the advantage? What are the use cases where we'll use the distributed builds in Jenkins? That's more important. As a Jenkins administrator, you always have to build the agents. You should never run something on master. Master is used only for administration activities, configuration, parameters, everything. But agents are the actual things which will run the builds for you always. Okay. For example, I have 4 agents where 2 are Ubuntu, 2 are Windows. And can I label the first 2 as agent Unix and 2 others agent Windows and use restrict option? That you can do it. It won't stuck in that case, right? Because it looks for the agents with that name you have given. Then it will choose whichever is online. That works for you, Prasanna. Right, so this is about the distributed builds in Jenkins. One other topic which I would like to talk for today, team, that is called Jenkins Security. Now, what is Jenkins Security, team, is that what you're doing after you log into the Jenkins UI. Means here, team, so far, I have a full access on the Jenkins which I created. Means I'm kind of administrator which I can create, delete, modify anything on my Jenkins. This is not the same configuration you want to give it to everybody, especially if you are as a Jenkins administrator, right? And depends on the team. Let's say you want to give a separate access to the dev team, you want to give separate access to a QA team and so on. How do I configure that? That is where Jenkins Security comes into the picture. How do I add different users? Least privilege access, whatever you call it, a minimal access to the users based on their role. It is also called as a role-based access control. A role-based access is what we are looking for basically. So if there is a fresher who just joins my team and then we are asking him to go and review it, but he shouldn't be able to delete by mistake as well anything, then he should have a read access maybe only. So those kind of access can be enabled on the Jenkins as well, team. All you need is to configure that access accordingly. But again, so far the users that we have created, this user is also available something called as Jenkins own user database. Means where is this username password is saved so far, right? So to know that, team, basically if you go to the manage Jenkins, now you see something called security, right? Under the security you have something called users that you can add, create everything. If you want to configure something else, you can go to security as well. If I go to the users team, first of all, now I see the default user called admin. Now, if I can add multiple users, I can go ahead and add it as well. Say user 1, some password I call it, right? And I say user 1, I say user 1 at gmail.com. Create users. So likewise, team, you can add n number of users to the Jenkins if you want to by using the create user option here. So you can say user 2, right? So say user 2 at gmail.com. So this is how, team, you do it, but this is not the right option, right? Basically, how do you configure the users in real time, team? How many users can I add it like this one by one? where this user configuration is saved basically, right? Now you can see this team on the top, it says something called Jenkins own user database. You see create user page on the top, you see that dashboard, it says it is called Jenkins own user database. Now where is Jenkins own user database? Is that team? It's under the Jenkins server, right? It is under the Jenkins home. There is a folder called users that you see here. Means anything that you create on the users on the console team, it comes and sits as a configuration data here, simple. Like you see that user 1, user 2, admin, all the users are maintained in the XML format here. Now this is nothing but your Jenkins own user database. Simply it maintains it on the file system of your Jenkins server. But again, if something happens to the server, we lose all the configurations again. There is a way to backup as well, but this is not the right thing. The security team is always to be controlled from an external user databases, which is like your LDAP or maybe Active Directory, something like that. So if you want to integrate such external user databases to the Jenkins team, we can also do that. Instead of using the Jenkins own user database, we can also configure external user databases. So if I go to the security option here, the by default option under the authentication you see is a Jenkins own user database. That's why you got that option. But if I switch this to LDAP or maybe some other things, if you're not seeing AD here, which means you're missing a plugin, you can go ahead and install a plugin called Active Directory and you see the option here called Active Directory, which is AD basically. Or you want to use any other authentication method from your things, you can use that accordingly. Okay. Yeah, if I select LDAP, it will ask you the LDAP server details wherein you can configure groups and everything accordingly. But again, I'm not going to use LDAP for this session. We will use Jenkins own user database itself. That is the first option. Now I'm also giving that because I'm using this, I allow the users to sign up, rather I configure the users like this, which means before I was configuring it, like it's like you sign up on any of the social media team, remember? If you go to a social media and then say there is an option called sign up or register yourself something. Now you see this team. This is the Jenkins URI which I'm giving you in the chat box right now. There is an option called register here. Now you all can register by default. You can give your name, say I call it as Naresh, right on my Naresh itself, naresh@gmail.com. And I say some password, create an account. Now, what happens if I create an account here? You will be seeing the users. Technically, I'll log in with admin user for a scenario. Now, if I go to this left side menu, manage Jenkins again. Now, if I go to the users, now you can see that you guys can register your name. You can set your own password and you can log in yourself. That's okay, right? If I go to the security itself, now you see that authentication is done via the sign up option, but authorization, it says that something logged in users can do anything. That's why you are able to see everything is there. But instead, I change the mode of what you can do. I'll say matrix based security. Now I'll choose the users who can do what. I'll say authenticator users can read. Whoever is authenticated. Now I'll say authenticated users can also read the jobs, not anything else, right? I'll say add user, admin. Now admin is the super user right now. You can do anything. Say that. Only admin gets the full access on this one. Any other authenticated users will have only the read access. Apply. And I save it. Say for example, Naresh is logging in right now. Now Naresh logged in means Naresh is able to authenticate, but what options Naresh is seeing it on the left? Or any one of you who registered, can you see what all the options you're seeing? Yes, Steve. What all the options you're seeing? Same as the screen that you see it, right? You don't see manage Jenkins here on the left. You don't see the new item to build new jobs, something like that. You just see the read access for the jobs as well. Now within the read access, you don't see anything related to the job, right? You can't execute, you can't configure. All you can do is just check the logs, maybe. Console output is all you check it. Anything else? No, you can't do it. Simple. So you see that I'm able to control the access of whatever you're trying to do. Okay. Now, if I just go ahead and say again as an admin should be able to see everything. That is the default. You see manage Jenkins and everything. Now, for example, here I'll add manage Jenkins again. I'll go to the security. Okay, now I'll say that I'll add a user called Naresh. Okay, there's a typo I did. Say here Naresh, right? Yeah, Naresh is a user. Overall read permission. Now Naresh can read jobs, move jobs, can see the workspace, right? Can build a job, can cancel a job, right? Can configure the job, right? But can't create or can't delete it. Means he can perform all the options on the jobs except create and delete. Okay, create and delete options are not given. I'll say create maybe again if you want. I can also add any other user, say user one, read access, overall read, and say configure. Now I'm not even giving the configure, but say user one can build and cancel the jobs maybe. That's it. Overall read something. So this is how team you individually select options basically. For that, you need to give the plugins again. So there is a plugins of role-based access. You create a groups first of all, and then add the users to the group, and you put a permission on the group itself directly. Press enter, right? That's how you can do it. So I'll just show you in a minute. So I'll log out again. Just a scenario. I'm just checking it. Say Naresh. Now Naresh can see these things. Right, Naresh can see the new item now. As you can see that previously this was not available for Naresh. But if I get onto any job, Naresh can see now the workspace changes, build now, configure. But say he can't delete option, right? Delete option is gone here. That is what you can see. He can create but can't delete, but configure existing jobs if he wants to. That is what you can see it. Any job you open, you can see that. The build now option, he can see, configure options, he can see, save options can be seen. Simple. Log out. Now, if I say as a user one, for example, now the user one can't create a job. He can't see the new item. Now, if he goes to the compile, now we see that he can see only build now, but can't even configure it, right? Can't even modify the existing job, but rather he can just say build now and see the results. Just giving the action to build and see the results. You don't need to configure, customize anything on the jobs again. So this is how you configure the RBAC for each user or the groups maybe. That is how you do it, right? Simple. For the users, yes, I can reset the password, right? Means as an admin can reset the password for any user if they forgot or something like that. For example, like this, admin at 1, 2, 3, 4. Now, if I go to the right, so manage Jenkins, I can see each user and their configuration, right? Users, say for example, Akhilesh, right? I can see the account. Now what I can do here, I can just go and see the password or disable the password or something like that. I can always set it. I can check whatever you wanted. See the password. I can't see the password, but say that I can update the password for him if he wants it, right? That I can do it. In case if you forget the admin password, then what I have to do is that I need to disable the security first of all, right? There is a way that we can disable the security completely and then log into the console without a security and then reset the password for admin. That's what you can do. Right, so coming to the group side, if you want, maybe you need to install plugin called role-based access control and then add the groups with that. Let's say that role, not this one, right? Available plugins. So role-based authorization strategy that I can do it and then say install. Prasanna, this is what you can do it. The complete authorization strategy will change for you. Right. Once I install the plugin, if I go to the security, right now under the same authorization strategy, I'll get one option called as role-based strategy here. See that? Now within the role-based strategy, you have to get it or you have to change something before that. Leave it without changes. And before that, if you look into the manage Jenkins here, where is this? Here, if I go, yeah, now you see that, right? Manage and assign roles. This is where you start doing it. So role to add, say the dev role I added first, like that. The role itself we add it, and later we add the, assign the roles to the permission users. Say QA, add. Now overall read permission, I give it accordingly, something. I'll save this for a second, for example. Now assign roles. Now under the assign roles, basically the admin, part of the dev and QA, or you can say add user, say for example, Naresh, and then add user to the dev group directly. See this, right? Add the users to the specific group, first of all. Now you apply the role, first of all, what the role should have it. The role should have whatever the privileges you selected here. Then you come back and assign the role to the Naresh, the dev role. So it will apply for that, basically. That's how you do it. Okay. You can also add groups in case if you have a group name from the ADs, right? In the local, we don't have groups anyway, but if you are connected to a AD or LDAP something, you get those groups and add the entire group to that particular role. You're done with that. Okay. That's how you do. Right. So this is the high level understanding team. Again, I want all of you to explore these options, and then go ahead and try it out. But again, as you explore more, you'll find more options accordingly, but all you need is a practice.
So quick info guys, Intellipaat in collaboration with Microsoft offers an advanced DevOps certification course. This course is designed for both beginners and experienced professionals, featuring live instructor-led sessions along with self-paced video content to help you become a skilled DevOps engineer. You'll master modern DevOps methodologies, practical DevSecOps practices, and also the use of generative AI tools in CI/CD pipelines, automation, and infrastructure management. You'll also work on 60 plus hours of industry relevant projects and case studies. Real time labs powered by AWS, simulating production level environment. 15 plus in demand tools used across the industry. With 24/7 support, placement assistance, and EMI payment option, this course, without a doubt, can take your career to new heights. You can check out the testimonials on our Achievers channel, whose link is given in the description below. Also, visit the course page given below in the description and take a first step towards career growth in the field of DevOps.
Now that with Jenkins handling our CI/CD, things are starting to look pretty automated. Our code gets built, tested, and deployed without any kind of manual steps. But now, the question is, what if we need to make updates to the infrastructure, like spinning up the new servers, adding a database, or a load balancer? Doing all of that manually can be risky and error prone. Rebuilding everything from scratch also takes time, and making changes directly into the live environment that can easily break something else in our workflow, or the worst case, it can bring entire production down. Now, Terraform solves this for us. It lets us define our infrastructure as a code, and that is why it is called a IAC, or infrastructure as a code tool, which means we can version it, automate it, and roll it out just like we do with our application code. So now that we have automated the pipeline, let's take it further and see how Terraform helps us to automate the environment it actually runs on.
We understood about the configuration management team. The next topic that I would like to start is called Terraform, which is the infrastructure as a code. Thank you. So have you heard something called infrastructure as code, everybody? Infrastructure cloud formation. Right. So what do you mean by infrastructure? Okay, you might have done through the cloud formation that I'll be that. But yeah, what do you infrastructure as code? Bring up resources, writing code to provision infra resources, creating resource using. All right, so let's understand first of all what do you mean by infrastructure as a code. Then we'll start understanding called the Terraform, right? Now, if you read the definitions team from anywhere, I mean, I'll try to give it in a very layman terminology if you read it carefully here, right? Now, what do we mean by infrastructure as code? Now, first of all, you need to understand the word called infrastructure, right? Now, when we talk about the infrastructure team, it can be different in terms of different industries, right? So if you talk about the IT industry and a software field, the infrastructure means that the basic infrastructure is always a data center, right? The data center is where we keep all the hardware, right? And we try utilizing that hardware or the resources to call it to do something with softwares. That is what all the idea, right? The basic infrastructure in a software industry team is always your data center. The data center is where we keep all the hardware that is required to build servers so that can run the softwares on top of them. That is right. So again, remember, we use hardware to create servers that can be physical or servers. Idea. Now, how do I create this servers team? If you understand so far, we can purchase the hardware. Now, think about the situation team right now in the current market. You might be easily able to use a AWS like infrastructure or AWS like cloud platform servers. But if you take it back 20 years, right? Say early 2000s or before 2000s as well. If I have to create a server, if I need to get a server, first thing is that I need to go and purchase the hardware, right? Whatever the capacity that I require, I'll purchase the hardware. Then I assemble the hardware. Then I try installing the operating system. Then it becomes a server for me. Correct or not, team? Have you ever known, right? That is what we used to do, right? Previously, before 20 years, that is exactly what we need to do. Every time I need a server, every time I have to purchase the hardware with specifications and then go and assemble it, then install operating system, then becomes a server, right? That's what we say that. Initial days, we always used to purchase hardware servers. But with the evolution of technology that we see that with the evolution of software and going above the expectations, we say that we started using the cloud infrastructures. It's like you're utilizing a software to create a server again. Now we can use the cloud service provider like AWS portal or a UI to create the servers. Those are usually the virtual servers that are enabled with the software called hypervisor. Right? So that is how the industry has changed. The way we create servers has been changed, right? Now, that's what we're talking about now. Infra can be created. And if you're able to create with softwares, then that can be automated as well. Now, that's what we're saying it. If you create, when I say infrastructure team, remember the basic infrastructure we always talk is server. Now, on top of a server, you might run different servers again, different softwares and everything, like a database or like anything else you want to run it, right? Like Jenkins or whatever we're talking, right? This way. So if you create the infra with a script code that is called infrastructure as code, in simple words, if anybody is not heard about it, keep this definition in mind, a simple definition. If you are trying to create some infrastructure, especially the servers first, with a script, with some automation script, then that's called infrastructure as code. Now, there are many tools in the market to do this task, as everybody said initially, right? That your formation. Remember, what are the tools for implementing AC? Now, cloud formation, that is AWS, means if you're working on AWS cloud, AWS by default has this called cloud formation, right? Now, you write a code, you write some YAML script and then execute it, and it will go on provision something on your cloud, like maybe EC2 instance, or maybe create a group, or maybe create a VPC or a subnet, something like that, right? So whatever you want to create something on AWS cloud, you can use it. But similarly, team, every cloud service provider has their own IAC tool. Like for example, in the Azure, we have something called Azure Resource Manager. Just like your cloud formation, you do it. Now, if you go to the GCP, which is Google Cloud Platform, you find something called, and so on. If you go to Oracle, you have something, you have Alibaba, you have something else. So there are many cloud providers. Each cloud service provider has their own native IAC tools embedded in their platforms, right? But again, when I keep switching my job, if I keep switching the cloud platform as well, I can't learn all these different tools to perform the same type of activity. Now that's why team, we want some tool that can, right, that can be helping me to provision, create infrastructure across clouds. Again, we're saying it, the above are something called cloud specific tools, right? So we can use a third party tool, right, which is not specific to any cloud that they given. There is some tool called Terraform, now which is provided by a company called HashiCorp, right? So Terraform is something again called a infrastructure as code tool, remember. Now, the beauty of this tool is that it is cloud agnostic. When I say cloud agnostic, which means that you can use Terraform to create provision infrastructure either on AWS or Azure or GCP or Alibaba or Oracle Cloud. You name it, you can do it on that, right? So Terraform supports every cloud out there in the market. So technically you can use Terraform as a single tool to provision infrastructure to create a server on any type of cloud available, right? Now, it is not only the public cloud teams. Now, remember, when we talk about the cloud like AWS, Azure, GCP, those are meant to be public clouds, means anybody on the internet can access it. But we do have something called private cloud setups such as OpenStack. And if you're not aware of it, forget about it. But I'm saying that if your organization decide to not to use your public cloud, they can set up their own data center as a cloud, which is like using a software, right? So that's what the idea. So the Terraform can work even with private clouds as well, private cloud solutions as well, which are available in the market. So Terraform is one-stop shop. We can say that, which supports many cloud platforms to provision, automate infrastructure creation, right? So this is what we're talking about technically, the infrastructure as a code, which is also mandatory. Remember, the main goal of DevOps, as we said in the day one, automate everything possible, right? One of the main goal that you are working with DevOps implementation is called automate everything. Whatever is possible to automate, do it. Now we're talking about infrastructure. So we already talked about configuration management, which is the automation of change implementation on existing infrastructure. Remember, there is a difference between the configuration management versus the infrastructure automation, infrastructure as code, right? Now, the configuration management is implemented on already an existing infrastructure, already created servers. The servers are already readily available that we can log in and then implement changes. That is called configuration management. Now, how do I create the servers? So far, you were seeing that we were creating the infrastructure servers required by using the AWS portal. But I don't want to use this UI to create this EC2 instance. Rather, I want to write a script that can go ahead and talk to AWS and then create servers for me. Create 100 EC2 instances, maybe something like that, right? That's what is called infrastructure as code. And that can be implemented with a tool called, clear about it? Now, then we talked about a configuration management tool called Ansible. Then I also told that there are a couple of other configuration management tools in Puppet. So my question to you here is that, can I use Ansible to create the infrastructure on the cloud like AWS? Is that a possible thing or a not? That's right. Ansible is not Ansible is config. No. Okay, so let me ask you another question. So can I use Terraform to log into a server? Saying no. But the hard truth here is the team, and right? The answer is, let me tell you that we can use Ansible to create EC2 instances, to create anything on the cloud reason. Okay. But again, let me tell you that we can use Terraform CLI only. We can also use Terraform to log into a server and then install Java as well. That is also possible. But understand, team, we don't use across functions. Remember that Ansible is there even before the infrastructure. And remember, team, the softwares evolve, we keep adding the n number of features to your existing software. That's what the incremental model of software development is. Now, remember team, initially the Ansible was only purely for configuration management, and it is in the market when it was initial release happened in the market way back maybe, right? It was only a configuration management tool, means using Ansible, I would be able to implement changes on already existing servers only. But think about the enhancements, the features that are added to Ansible over a period of time. Yes, they extended the Ansible capability also to become an IAC. But we don't use Ansible IAC, remember team. Its primary role is to implement configuration. It's like you are having multiple skills. Like you have a primary skill, you are a subject matter expert in one tool, so you know it, right? That is what your primary area of expertise, you call it. And it doesn't mean that you don't know the secondary area, right? You also might be knowing the secondary tools where you might not be an expert in them, but you know something about it. Correct or not, Tim? Can I say that, everybody? Do you all agree with that? You all might be expert in something, you know end to end of what you're expert at, what your primary skill technically. But you also knowing the secondary skill where you might know something about it, but you're not really worried about whether you completely knowing it sometime. Means you don't really worry about implementing it fully. You have to be master in one at least. That's your primary skill we talk about. So think about the Terraform is master in infrastructure provisioning. So it does the best of it in infrastructure provisioning, infra management. Where Ansible is master in implementing changes in the existing infrastructure, managing those changes in a better way and efficient way, right? So technically, you can use either of the way, but the idea is that you have to use the tool meant to be, right? So what I would do in this scenario is that I always use Terraform to provision the infrastructure. It's the best tool in that area. Now, once the Terraform is provisioned infrastructure, let's say that I'll ask Terraform to invoke the Ansible. Just a logical thinking, I'm saying it. DevOps is all about integration of tools, team, remember? That's what we taught, right? The end goal of your DevOps is to implement a solution to provide the end-to-end automation, right? From the development hands into the production environment, you have to work through it and deliver the code from the development side into the end customer. Now, in order to do this, team, it's not possible with one tool, definitely. So we have to integrate the tools where necessary to develop a full automation. So remember, we already know the Jenkins. So with Jenkins, we automated the CI, right? Just I'm giving you the ideas, how do we do it? Now, once the WAR file is available, let's say that we need to provision infrastructure, which means in order to deploy my WAR file into a EC2 instance, so we need a EC2 instance to be created. So what do? We can ask Jenkins to invoke a Terraform, right? Just like Jenkins was invoking Maven something. In the same pipeline, what I would do is that I'll ask Jenkins to invoke the Terraform. A Terraform will go and provision. Now, once Terraform provision the EC2 instance, I have to install Java Tomcat on it. So then I ask Terraform to invoke Ansible. Then Ansible goes there and install Tomcat Java and everything, right? Copy the WAR file and deploy everything. So you see that it is all the integration of tools to extend your work one by one, right? That's all we're trying to do. I hope you got the points, what we are trying to do here. To implement a full end-to-end solution, we need to learn the tools, integrate them into a one single bigger pipeline where you can achieve the end-to-end task of your development or software. So again, team, if you talk about the Terraform architecture a little bit, now how do you implement Terraform, or how do I work with something? It's very simple that in order to work with Terraform, we need to install a software tool that I need a place where it can be installed. So let's say that it is a EC2 or a VM, right, where we can install the Terraform software. So we have an OS, usually we're taking, right? Now on this instance, we're going to do the install, right, tool or a software, you call it. That is what you do, right? This is the people do it. Now the idea is that here, by executing some commands of Terraform on this instance, we are expecting that Terraform would log into a service, right? It can be any cloud team, I'm telling you. It can be your AWS itself again, or Again, the EC2 instance is on AWS, so I agree. So this can be AWS, right? This can be, or this can be GCP and so on. Anything that you want to do it. So we'll give the necessary credentials to Terraform tool. So Terraform tool will make a login to the cloud service portals and then start executing the necessary resource creations and all those stuff. That is the main idea. This is a simple architecture that you can always see it. This is also kind of push model architecture because we execute scripts on the Terraform VM that will necessarily push to the cloud and then start executing their account. That's the idea. Okay, so now in order to implement this particular solution, so first we'll take a VM and we'll start installing Terraform on it. So the one VM, sorry team, so here it is, right? On my AWS account again, I have created a VM that I name it as Terraform VM. That's all about it. Just a simple EC2 instance like any other EC2 instance you created so far, right? So let's log into this VM and then we'll start log checking it. So I have already configured the DevOps user as well, team here. So let's say that we can log in with DevOps user. You know how to set up a DevOps user. The same password, which is 2881234, right? Now you see that this is the VM that we have it, right? Now what I can do, if I quickly check if I have the Terraform installed here, say Terraform, right? -v, sorry, it's Terraform, right? Okay, so there is no tool called Terraform is installed on this VM. So what we have to do is that simply go ahead and install the Terraform software tool. By default, it is a CLI tool again. There is also Terraform Enterprise we have, which can be a UI based tool. But again, the Enterprise comes with licensing and everything, which we cannot use it straightforward. So that's why we'll rely on the CLI itself. Okay, so what I'll do, I'll go to my GitHub account again, the Learn DevOps Labs repo, from where we've been using the scripts and everything. So here it is. Now I have all the codes here, team. Let's say if I go to the install, where you will find the necessary instructions to run, right? So just follow the instruction here, team, whatever, to install the Terraform. So I'm just running the regular apt commands again to download and install the Terraform software utility on my Ubuntu instance. Just that apt install or apt get install Terraform is what I'll be running. Now, once you installed everything, so you can just check by Terraform version command, right? If it is installed, then you will see the response of the version. Now, team, we have successfully installed a Terraform utility on my server. That's good. The first part is the installation, which we did fantastic. Now, the next part is the team, the Terraform, or whenever I execute a Terraform needs to log in to the cloud service. How do you log into your cloud account is the question here. Remember, in order to log into any cloud, by default, you will have certain credentials, right? Now, what are the different ways that we can log into your AWS console, basically, or AWS platform, basically? The authentication we're talking, root and a user, right? The default is the root user, who is basically an administrator, like the entire account owner, we call it, that performs the task requiring unrestricted access. But again, the team, it is not a good practice that you allow some automation to have an unrestricted access on the, right? That's because, again, I'm telling you, anything that you create on your cloud is, right or not, team? Any resource that you create on your cloud is going to be charging you something. Now, if your automation is something provisioning unnecessary resources, which has unrestricted access, everything, which can lead to unnecessary cost for your organization or for your itself. So in order to avoid such situations, we have to give a limited access. Means whether the script is trying to go and try to create some VPC, then authentication is that, hey, you're not allowed to do this, right? That's a kind of security policies you may implement it. Depends on the situation. Again, I'm talking about it. In order to do this, team, never use the root user credentials, which is not recommended. You always have to set up a user with a specific privilege. Again, I'm telling you, you have to create something called a second method of logging into an AWS account. That is by using something called IAM user, a user with an account that performs the daily tasks and also have a limited privileges so that it cannot be misused to create unnecessary resources, unnecessary cloud resources, we call it. So how do I set up the IAM user first of all? For that, we need admin access anyway. So I'll log in with my root user credentials first of all, right? And then we'll start creating, a IAM user with a minimal privilege, whatever you want. Okay, and I have MFA enabled team. Let me enter the code. I hope you all have MFA. Finance 7. Okay, so now you see that I'm able to log in to my account with root credentials, which means that it is having unrestricted access. I can create anything that appears on this screen for me. Under the section of menu, I can go and create any type of resource as I want. That's there. Now, in order to avoid such situation, we have to create a user by going to a service called IAM, which is called Identity Access Management. Means you can, top search box, you can type in IAM and you see something called IAM service. Click on IAM and it will take you to the IAM dashboard, just like your EC2 dashboard. On the left, you see something called access management, wherein you see you can create users, roles, policies, and all that stuff, right? So users is what we're trying to do. Now I see no users are available for me except the root user. Now I have to create a user first of all. On the top right, you can say create user. Okay, now I'll name this as Terra user something. You can give any name as you wish, remember. That is one thing. And the second option says team, provide user access to the AWS management console. Remember team, when we talk about this setting, which means the user should be logging in via browser. But are we expecting this user to log in via browser or a login? What is the method of login for Terraform user now? It should be a script, right? It's a programmatic access, we call it. It's a script-based access, not the console. So you do not need to enable the console access for this user. We'll enable the programmatic access, means when a program executes, it will log into the same account with certain credentials. In a command line approach we talk. So I'm not enabling the console access. So I'll go and say it is asking you to add a user to the group if you would like to, right? I don't have any groups as well. So copy permissions means if you have an existing user and you want to replicate the same permissions for this new user, then you can say copy permissions from the other users. Now you have attached policies, existing one means what access this user would have, right? Now remember team, this is the existing policies which Amazon already providing you, with which you can have some access to the user, some resource access to the user. But if you want to create your own policy which has custom access again, you can also define that. Right now we're not doing that. Say I'm going to attach all the existing policies to my user. Like team, I want to have this user to create an EC2 access, EC2 resources. So I call something called Amazon EC2 full access. That's something I'm doing. It's user can have access to all the sections of EC2 dashboard. Now, similarly, I want to say S3 full access means I want to have user to have create S3 buckets and delete S3 buckets and all that access, giving it. Okay, so the user to have VPC full access. So I'm saying that a VPC full access as well. Likewise, you choose the policies. I'm telling you again, you select each policy. That's what you're going to do and say next. Now see that this user has access to only create EC2, S3 and VPCs. Rest of the things the user will not have. The DynamoDBs, RDS DBs, you talk about any other resource on the cloud, the user will not have access to. Only these three things are there. But again, if you want to go and edit something, go to previous. You can also have administrator access team if you want to. Not really necessary, I'm telling you again. You should never give an administrator access to the user, which is equivalent to become a root user, right? So this is what I'm saying it, but right now I'm just giving it for a reason that we need to have some access. So this administrator access is not required, not recommended to give it, but I'm just giving to demonstrate a few things quickly without having permission issues. That's what I'm trying to do it. Okay. So you just give the permissions accordingly to the user and then say finally create user. This is what the way we create or instantiate a user on your AWS. Is an IAM policy same in AWS as your GCP? They work in the naming conventions can be a little different, right? Because in the AWS, we call the VMs as EC2 instances, but the same VMs on the Azure is called as VMs only, Azure VMs basically, right? The naming conventions are a little different, but the policies will remain same thing. What type of an action you want to do, what level of permission you require to that resource. That's what is defined by the policies on the each cloud accordingly. Okay. Just the naming conventions would be a little different. Otherwise, everything. So in this situation, we are doing this in Ubuntu through AWS, but if the company not prefer AWS, in that case, we need to do this if the company prefer to GCP. That's right, Joy. It's the same situation, right? You go to their cloud and create their necessary things. Absolutely. So what I'm saying is that if your company is preferring to use the GCP, then yeah, there is a way that you log into GCP as well, right? Programmatically, you just create that. That's it. So in this case, we're just looking at the AWS with the respective clouds have their own implementation of authentication authorizations. Remember team, here we have just created a user and we have given necessary privileges to it. But remember, how do I use this user credentials in my scripts? That is the next question. Now remember team, in order to access from a script, we still need some kind of the IDs and passwords as well. That's where you just need to click on the user. We are not done yet, remember. We just created a user. We gave the necessary privileges this user can do on the Cloud9. The credentials are still required. So in order to generate the credentials for this user, right, the username and password, which I should use when I want to log in as this user, that's where I click on this user again, remember. Go to the users page, click on the user. Now under this user, can IAM handle a security for temporary access? Yes, it will. IAM is all the way to set up any type of an access to your AWS account. That's can be implemented on this team. As you can see, when I click on the Terra user, you see the brief details about this user again, like you have the permissions that the user can have, user has it. If the user has part of any group, you can see some tags. But the security credentials. Now there is a tab here called as security credentials, right? Under the security credentials team, it will again ask you, hey, do you like to have a console access to this particular user? You can enable the console access. Console in the sense on the browser. We don't want this user to be console access, right? But we want something else. When do I enable multi-factor authentication for this user? I can add, but I don't want to. Now there is a third thing which is called access keys. Remember, now this access keys is a mechanism team to authenticate to the AWS via programs, via scripts basically. It says that use access keys to send a programmatic calls to AWS from AWS CLI, AWS tools or PowerShell and so on, something. So whenever you think about accessing the AWS resources in a programmatic approach from the CLIs, you always have to generate something called access keys for a specific user. So I'll say create access key here. Okay, now it will ask me like access key best practices and alternatives. It will suggest it. Say command line or now this is a third-party service team. Remember, Terraform is a third-party service that will try to log into the thing. So I'll select this as a third, right? And then understand this time on your screen like you see right now, like your GitHub access token as well. Means if I move out of this page, this value will not be visible again to you anywhere, right? You have to store it before you go out of this page. There is also an option called download CSV file in the bottom. So I'll click on that. So technically it will download a file to my local. which is called Terra user access keys.csv. If you open, you'll have something stored in, right? Okay, so now this is the keys I have. So what I'll do, I'll keep it aside, then I'll say done. Now again, I'm telling you, as I said, if I go to the users, click on users, security credentials, right? If I go to the access keys, where is this? Yeah, here, right? Access keys, there is one access key you see it, but you can't see anywhere the secret access key team. Even if I drop down here, you can say deactivate it or delete it, right? But you can't have the same thing again. If I want to have a new thing, you have to create a new access key again. Remember that. So that's very much security reasons it will do that like that. So this is the idea. Anyway, we have now access key and the secret access key as well. Now that I can use with Terraform to log into my AWS account to create something. Now we install Terraform, then create here, right? Create an IAM user on cloud, right? And generate necessary, right, login credentials that we can use in Terraform scripts. Simple. Now it is the same thing for each cloud, that in each cloud you have to do the similar settings so that you don't. Remember that on AWS team, create IAM user on cloud and generate necessary login credentials that we can use in the Terraform scripts. So we will have some file here. We'll create and we'll provide them a code. Clear now about how do I create IAM user? How do I create some secret access keys to it? Now, once you're done with this, now the next thing is that now we need to start writing the Terraform scripts, right? Now, in the Terraform script where I can configure credentials first and then I can start asking to create some resources. So how do I write Terraform scripts? Okay, so in order to create IAM users, first go and search IAM Ankita. Right now that will take you to the IAM dashboard or IAM page. Or if I search IAM on the top, you'll see IAM. Just click on it. It will take you to this page. On the left side, you go to users. First, you need to create a user with the necessary credentials, everything, with necessary permissions, everything. Once the user is created, then click on the user you created. Then go to the security credentials. And if you drop down, there is something called access keys, right? Wherein you can just say create access key, choose the necessary service, and then say it, right? And then give a name and then create access key. That will generate the necessary access key that you can download. And this is your access key and the secret will be there. Ankita. All right, so all right, understood. The next thing is that, as we're saying, we need to understand how do we write Terraform scripts. So the question was that how do I write Terraform scripts? What language do I? You can use your own VM itself, Fredo. It doesn't matter, but ensure the internet connectivity. Can always, but again, you can create resource on the cloud itself, right? So using Terraform, you can install the Terraform in for sure, where you install Ansible, Jenkins, everything for sure on it. But the target should be the cloud. Good. Now, the idea here is that whenever you start working with Terraform, Terraform gives its own language called, right, or it is also called as TFL or TCL, really. Now, when you start working with Terraform, it's not YAML, it's not fully JSON either, right? It's basically called as Terraform configuration language, or it is also called as your HashiCorp configuration language. Now, it is pretty similar to the YAML and JSON, but a little bit of syntaxing will be different. That's about it, right? But if you know the YAML and JSON, you can easily write. Very discussed, right? So Terraform configuration language team, that is what we're going to use it. The main purpose of Terraform language is declaring resources which represent the infrastructure objects is what we call it, right? Again, Terraform configuration is a complete document in Terraform language that tells Terraform how to manage a given collection of infrastructure. A configuration can consist of multiple files and directories as well, something like that. Okay. Now, I don't make this complex to you, so let me make it, right? How do I write Terraform scripts? That is where if you look into. We use HCL or TCL to write Terraform, the only prerequisite that you need to know. Now, all the Terraform scripts must end with an extension called .tf. Like you had the YAML ending with .yaml. Now, all the Terraform scripts, right, must end with an extension called .tf. Like you can say that a.tf, vm.tf, infra.tf, something like that. That is the first rule to know when you're writing HCL. Now, within the Terraform scripts team, we use mainly two keywords that is called providers and resources, right? Within the Terraform scripts, you keep hearing two keywords. You keep writing two keywords. One is called providers. One is called resources. Now, what is a provider here? The provider is nothing but a cloud service name. The provider, cloud service provider, you call it. So you define all the cloud authentication information like regions and all that stuff in the provider configuration data, right? And remember, team, the second thing is called resources. Now, the resource is something like on any cloud, anything we create is called a resource. For example, EC2 you create is called a resource, or a security group you create is called a resource, or keys, S3 buckets, VPCs, etc., etc. Whatever you try to create on any cloud is technically called a resource in Terraform terminology, right? That's all you need to know. Okay. Now, after knowing these things, these are the two important things. We do have some more about them later, but the idea is that these are the two important. But along with this team, within the scripts, again, the way you write these two keywords are using the logic called arguments and blocks. Now, again, team, it's a very simple thing. What are Terraform arguments? If I talk about, oh, wait a second. Yeah, here it is, right? Now, when I say arguments, right? Arguments in Terraform, script, right? Now, those are like your YAML key value pairs team, remember? In YAML, how do you write a key, right? Colon, space, value. Now, this is your YAML syntax, correct or not? That is called simple YAML key value. Now, arguments in Terraform team are same as a key value, but here we write something called key is equals to value, right? This is Terraform. Okay, it's a very simple idea team, I'm telling you again. If you know the YAML key value pairs, now here also we have something called key value, but in the Terraform script, we always write them as key space equal to space value. That is mandatory. Okay, this is what all you need to understand. This is how we write in this one. Make sense, everybody? That is called arguments in Terraform scripts. Any key is equals to value in your Terraform script is known as your argument, just a Terraform way. Now, the second thing in Terraform is called as blocks, right? Blocks in Terraform script, right? Now, what is a block? It's like you're describing a properties again, describing a resource, which means that again, remember a block is written with the resource block, we call it, or it can be, we call it as a block, the block type, and you open and close. Understand, team? There is a block type, and within the block type, we keep writing the arguments. Like say that again, if I have to create a EC2 instance, for example, I'll say that instance underscore type means, remember team, when you define create instance, you see that, right? T2 micro or something like that. So this is a block type is nothing but say I want to create a resource called EC2 instance. That is what I'm saying it. So within the block, you will see a multiple key value pairs, right? Let's say that I want to assign a key to this instance, which I'm creating it, or say that key underscore name. Remember team, the key that you create, right? The PEM file you created, say that iPad something, the key name, you have it. the number of EC2 instance you want to create at the count is equals to something like you mentioned. The number of EC2 instance you want to say 20 instance I want to. So now this is how you write a block team. Remember, a block describes a properties of a particular resource. Let's say that in this case, type, which can be a resource, and say that I call this as an AWS underscore instance, the type of resource I'm talking, right? The type of resource and the purpose, something we call it. The example here, I'll do it like this, for example. The block type is called a resource because AWS instance is called resource. Now, type of resource is nothing but your AWS underscore instance. And the purpose is that I'm saying that, hey, I'm creating for this development purpose, I'm creating this instance. There are 20 instances with T2 microtype with a key assigned as iPad to it. That is how you do it. Now, there can be n number of other parameters like the storage, the security group. You can assign everything. Now, everything you assign this as this one. So this is called a block execution or a block within the Terraform script, right? So you have all the arguments embedded inside the blocks or placed inside the blocks always. A block is always open and a closed curly braces. Now, when I say a block type here, you also can have a block type called provider block, right? Provider service. And then you have a provider information, right? Like this, say, you can say that, something like the provider information, all you do what. Indentation does not matter in means I can always write anywhere the keys here and there. That should absolutely work fine. Okay, so this is how you do it. So there is a provider block, there is a resource block, there is something called as an output block, something like that. So you have a different block types. You also have a variable block, something like that. So you have a different type of blocks to define some kind of a data within the script itself. So that is why I said here it is called a block type of purpose, and then purpose block type instead of type of resource. That's what, right? Type. So this is the idea, team. You get to know other things one by one now. So, but I believe that you understood two important things in your Terraform scripts are always the arguments and blocks, right? A block type resource you want to create on purpose, and like this, and say different block types like provider, variable. All right. So now, team, you start writing your Terraform code, right? Maybe you can choose a directory where you want to write it. You can write anywhere. It doesn't matter. Remember, right now I'm inside the home DevOps. I can write here itself. There is nothing in it. But if you would like to place all your code into a specific directory, say that Terraform code, I mean, it's not mandatory, I'm telling you, but you can do it. So let's say that T code folder. So remember, I'm writing all my Terraform code related to a block. All right. So now the first thing, team, remember, the first thing that we want to do is that we want to log in to the cloud service. For that, we need to write a provider block. Remember, so I'll create a script, say VI, right? Remember, team, file name can be anything. As simple as that, I'll say a.tf. The extension must be tf. That's the rule. The name can be anything as you want it, right? Or I can say that here aws.tf, right? So I'll simply do this. Open the file. Then you write the necessary block here, say provider AWS, right? Always put your provider name within the double quote stream. That is what the idea. Now within this one, the block always has an open curly brace and close curly brace. Now within the provider block, now we tell the credentials. Remember that it's not just by defining the provider we can log in. Now what is the purpose of provider block here? We want to provide these credentials within this program script here. So Terraform uses them to log in, right? So what do you call this? Is called access key. This is called a secret access key. So what I'll do here is that access underscore key is equals to give the access key that you have, right? And I say that the secret underscore key is equals to this other value, which is secret access key. We have it. Exactly give what you have. And that's it. All right. Now, along with this team, there is one more important key we can use it. Now, remember team, the spaces does not matter here. You just keep it according to your only. Now, one thing you need to understand here, team, that on your AWS, if I have to create a resource, the first thing that you come do is, yes, team, on any cloud after you log in, if I have to create an EC2 resource, where exactly or what exactly the selection you do is that it is the region, right? I hope you all know what are AWS regions here. AWS regions are the geographic locations where AWS data centers are present, where your hardware is available, right? And then wherein you can create a EC2. Remember team, one specific thing, once after you log in, it is mandatory that you must choose a region, correct or not? Without choosing a region, can I create any resources? Yes, team. Without choosing a region, can I create any resources? Definitely not. So it is necessary that you need to tell in which region you need to create resources to Terraform as well. So for example, remember the EC2 instance of Terraform is available in my which region? Right, this instance, right, which I'm just showing to you right now, where I install the Terraform is available in my North Virginia, which is called US East 1 region. But I want to create resources in US East 2 or maybe US West 2, whichever the region you want, you choose it. Say I'll select this Oregon, which is the US West 2, right? Remember the region I'm choosing it, the Terraform now have to create resources on a region called this region core team, which is predefined by AWS. You need to choose the value, which is US-West-2. So in my script, I'll say that, hey, region is equals to US-West-2, something like that. Okay. Likewise, we can configure some other details as well about the cloud. Remember, the first thing is always the authentication data, which is mandatory. The second thing is that the region that we want to create a resources in, right? You can choose like this. Now, this is called a provider block, simple, a very, very, very simple provider block. Am I clear? The first thing, remember, you can have a provider, you can configure multiple providers as well. It's not necessary that you have one provider in one file. Within a single TF file, you can have multiple providers as well, like this, right? Instead of calling as aws.tf, I'll say that move aws.tf. I'll call that providers.tf. Means I want to configure multiple providers, right? So I simply renamed it to make it more generic. Say, along with the same thing here, I can write the second provider, and again, provider. I'll say that, right? When I say Google, which means that I want to connect to a Google Cloud. So you need to go to the Google Cloud account, generate the necessary IAM credentials, and use it here accordingly. If you want to connect to the another cloud, let's say Azure RM, we call it technically. That is nothing but the provider name, something. If you want to connect to the Alibaba, then you have provider Alibaba. If you want to connect to the DigitalOcean, then you have provider DigitalOcean, something like that. So in a single TF file, you can configure multiple cloud data as each provider with its own block type and with its own data available. Okay. This is just for example. You don't need to provide anything here. That will still okay with it, but you can't authenticate to it. Simple as that. But AWS will appear now. So this is called a provider block, provider data that we usually write within the Terraform file, the one file we have. Okay. Now, once we have this particular file, the second thing is that assume that Terraform will now use its credentials to log into AWS, right? And say that now, once it logs in, it has to create something called a resource, right? Now the resource team, I'm saying it again, on your cloud, anything that you want to create is basically called a resource. Means, say I want to create EC2, that's a resource. I want to create Elastic Kubernetes service here, that's also good. I want to create a VPC, that's a resource, right? So I want to create something called DynamoDB, that's a resource. I want to create Elastic Cache, that's a resource. Something like everything that is available here is in Terraform terminology called as the resource, right? So one simple thing we always use is called compute EC2. So I'll take an example of basic this one. So this is how you do it, right? If I go to instances, oh, sorry. So what I'll do, I'll create another file called vi ec2.tf. Means with this, I want to create a EC2 instances. Now the thing is called a resource, the keyword, which is a predefined keyword. As I said, everything is a resource. And you have something called AWS. Remember team, the EC2 instances are called AWS instances as well. The name here itself says instances, right? So this is a predefined keyword as well, given by AWS to user. As I said again, I'll creating this for the development purpose. So I'll give and then open and said again team. Now just to give you the idea that how do you start writing this? You can also have them on both of the same file as well, Projecta, but right now I'm creating separate. For more modularity, always separate them. But the answer is yes, you can do. Okay. Now the idea is that team, how do I write the data within this block? I'll give you a few keywords, right? You can do anything. This resource is a fixed word. AWS instance is a fixed word, predefined word. And yet you want it. Remember team, whenever we're creating EC2 instances, we need to have some idea that what you're trying to do. So if I click on launch instance on my, launch instance on my browser team, you can see that it prompts me for something called name and tags, right? The name and tags are something like you add a key value pairs, name, test VM, something like that. But you also have multiple tags like env, right? And say, this is my dev and so on. You can create multiple name and tags or tags basically, right? These are called tags that we are assigning to the instance you're creating it, resource we're creating it. So the same thing can be written in your script at this, right? So I'll say tags. Remember tags is equals to, I'm saying it. And remember you can write multiple key value pairs, right? When I say tags here, the tags are nothing but the multiple key value pairs. That's why I use a sub block here to embed all those key values into it. So I'll say that the name is equals to the same test dash VM, right? And I say that env, right, is equals to say that. Remember team, just like you give it on the cloud, key value, key value, key value. You can give any key, any value as you wish. I remove it right now. That's now I'm saying it. How do I write the same section in my script? Is this one. Okay. Now, once you understand that, it's okay. The AMI. Remember team here, the AMIs are very critical in launching your VMs. So technically you have this AMIs like Ubuntu, Mac OS, Windows, something, right? How do I choose this AMI from my command line, from the script? Now you need to look for AMI ID. That every AMI that you upload of your own AMIs, means if I upload my own AMI, or if AWS is providing me some public AMIs, understand that every AMI has a specific ID associated with it, not just the name of this one team. If you look at it here, below that there is an ID given, which is called AMI dash blah blah blah, right? Now remember team, this AMI IDs are specific to region again. Remember, if I select the Ubuntu image under the US West 2 region, this is the ID. But this ID is not same if I switch to the region called, understand team, the AMI IDs are region specific. So be sure that you choose the right AMI IDs to tell the Terraform always, right? So I'll say copy this value and I'm saying that, hey, AMI is equals to this one, right? Now Terraform understands that, okay, when it goes to the things, it will identify the AMI with this and then try to create something called Ubuntu 2404 instance for me accordingly. That is a simple idea. So say that I'm selecting this. Confirm the changes. Yes. Now this is selected. Now once you select the AMI, then you go to the bottom, then you select something called instance type. Now you can choose any existing instance types here like this. That is what I write is called as instance underscore type, which is equals to say that t2.micro. whatever it is predefined value team. Remember, all the instance IDs are predefined. You have to use exactly the name what is defined by AWS here again, right? That is something you use it. T2 micro is what I'm using it. Now, the next thing which I'm seeing it here is called the key pair login. Now, either you can create a key pair or you can also use an existing key pair. Now, understand theme here, I don't have any key pairs existing, right? Now, there is a way that we can create key pair as well, but I don't want to create key pair with script immediately. So I'll say create now, right? iPad US, right? I'm just giving it and I say PAM. I'm just downloading it. So assume that there is a key pair exists called as iPad-US West, right? That is what I'm seeing it. So I do something called as key underscore name is equals to iPad-US. Something. Remember team, exactly whatever the key pair name you have it, give it so it will be assigned to that. We have a way to create key pairs as well. I'll show you that in the next examples, but the idea is this. Assume that you're attaching an existing key pair for now. Now, similarly, team, I can also attach an existing network settings, which is a security group, remember. I can always select an existing security group. Say you have default. By default, there is only one security group called default, but you also can create a security group and then go and do that, right? And you assign the necessary policies accordingly, correct or not? The security groups, then I'll say that, hey, security underscore groups. Now, can I attach multiple security groups to a single instance or not? Yes, team. Can I attach multiple security groups? That's up, right? An instance, remember team, here it is a checkbox, not a radio button, right? To choose either that or this. Basically, it's a checkbox, which means that you can even select multiple options. Now, what I'm trying to say is that team, the security groups is basically a list of security groups. Again here, the security groups are a list of security groups that we can assign to the instances. That's why team, whenever you think about writing a list in the Terraform approach, use a square braces. This is the same thing you use actually in the JSON as well, right? Now, if you have a second security group, then I say something. Remember team, we are trying to attach two security groups to that instance we are creating technically. Right now, we don't have to, so I'll attach only the one which is available, which is default, but yet you keep in the square braces always. That is the idea. Now, likewise, now if you go to the storage, we can configure the storage. Now, I'm not doing everything again. If I go to advanced details team, you see that there are n number of parameters that we select map to instances, or you might leave with the default values while you're creating EC2 instance, right? But technically, you can control all these parameters that you see on the UI from the script itself. But again, if you're not using some value, it will use the default values again, like you have all the default values here, right? That is a simple idea. Including the user data also can be kept within the script. Now, the last one, which I would like to say, the number of instances, that 2, 20, 10, whatever you want to hear, you see this, right? So I can say the number of instances here by a keyword called count is equals to 2. I can even say 20. I'll say 5, which means that I'm saying to him, hey, Terraform, create 5 EC2 instances with the type of T2 micro with this AMI, which is the Ubuntu AMI, and assign this key name and assign the security group to all the instances, basically. That's what the meaning of. I hope this makes it sensible. This is one single resource we are trying to create with Terraform. So now you have two important Terraform scripts. One is a provider script. One is a script called EC2, which is a resource script. This is how you write scripts. You can write multiple resources within the same script. Once you write the scripts, now we need to start executing the script with a command called as, right? There is an installation of Terraform. We understood the way we write the Terraform scripts, right? We just see that the provider block configuration, how to write it. And of course, the resource configuration, like how do I define a resource and I start working. Talking about the way we execute Terraform command stream, the Terraform workflow is we call it. Now, since we already wrote the scripts, now what you need to understand is that Terraform architecture a little bit more depth, right? The first command in Terraform team we always do is called as Terraform. Remember, we don't use any script file as an input team. Remember that you choose a directory where you write the Terraform scripts. Right now it is a T code. Now, whenever you perform or whenever you execute any of the Terraform operations, right, the Terraform by default will read all the .tf extension files automatically. Remember, I can't say that Terraform init provider.tf, Terraform init ec2.tf, Terraform something with some file name. That is not possible here. You can't provide a TF file as an input to the Terraform command anytime. Like we did Ansible playbook and playbook name. No, that's not how Terraform works here. Terraform commands will automatically read the .tf files in the current directory where you perform a Terraform execution or a Terraform commands basically you run. Okay. The first command which I'm running here is called as Terraform init. That is the first command. You must run it no matter what, always, whenever you do. Whenever we run a Terraform init team, now it will try to initialize some backend plugins. Now, Terraform also works in the model of plugins team. Remember, the way we see that Terraform can work with any type of cloud plugins or clouds out there, right? Now, Terraform bundle that we install, for example, the Terraform CLI we install, not has the all logic to connect to all the clouds. So how it connects to the various clouds is that Terraform uses a plugin concept again. Terraform extends its functionality using a plugin to connect, create resources on a specific cloud, right? So Terraform uses AWS plugin to connect to AWS. Terraform uses Google Cloud plugin to connect to a Google Cloud and so on. So that's the basic architecture of the Terraform you can know basically. I'll show you, right? Terraform architecture. If you look into this Google and then look for images, you will easily find, right? Okay, so if you look into this basic architecture team, now you see the Terraform core, the left side basically, right? The Terraform core team is nothing but the Terraform binary that you install, which Terraform, if you run on your summon, you see that this is installed, right? Now this is just an executable file team of a size, let's say 87 MB, right? This is just one simple executable file that is installed when you install the Terraform CLI. Now this executable file is called as your Terraform core, right? That is the actual software utility that is helping you. Now the Terraform core will use the plugins. The plugins are nothing but your providers. The reason we have written the providers here is that the providers.here, or we're telling the Terraform that, hey, you download a plugin called AWS, then you download a plugin called Google, then you download a plugin called Azure Arab, something like that, right? Now that's what you see in the output team when I run the Terraform init. It says initializing the backend. Now you see the initializing the provider plugin. Understand? It is trying to install the provider plugins onto your system. Say it is trying to install the provider plugin called Google, or also Azure plugin, and also the AWS plugin, because within the provider we wrote 3 providers. So it is trying to install the 3 provider plugins. Now again, from where this is actually installing it, just like your plugin repository for Jenkins team, we had it. There is a plugin repository for this one. Is called as registry.terraform.io, right? If I look into the, okay, let's click on this, right? So registry.terraform.io team is the registry or online repository where we have n number of Terraform plugins again. Now you see the different type of plugins here. One is called providers. Now, if I go to the providers page, now you see that the different plugins available like AWS, Azure, Google Cloud, Kubernetes, Alibaba, Oracle Cloud, and so on. You see n number of plugins here to make changes. So if I go to the AWS plugin, that's what you see. The latest version is 5.93. This is published 2 days ago. Now that is the same version it is installed here. We say that 5.93.0. We can also use a specific version installation team if you're not interested in latest version, we can also tell the Terraform to install a specific version. All you need to write in the code like this, right? It says that required providers, hey, AWS, go to this and install this version, change the version number here, something like that. You can change the code a little bit. So the simple idea, team, we're talking about, remember, Terraform again will rely on the plugins to connect to the various cloud providers. Now to install your plugins, we need to run a command called Terraform init. So it is mandatory. Whenever you introduce a new provider or whenever you want to get the latest plugins of your provider, we always have to run the command called Terraform init. That's the first command in your Terraform work. Terraform init will initialize your necessary plugins using the provider configuration. Just like the git init, it will initialize all the necessary things for you. Okay, so now you can see I ran it again, but says that it is already installed this time using the previously installed. Now, the second question is that where did it install the plugins? Now I said Terraform init is installing the plugins, but where did it install? Where did my Terraform init installed the required AWS or Azure or Google plugin? This is very much important to you to know. Remember, guest team. I know it is a EC2, right? That's right. But where in the EC2 is my? Definitely the EC2 instance we are using it. Where exactly within this EC2 instance, which path under this EC2 instance? Understand, team, it will always install in the current directory where you run the Terraform init. Right now, I ran the Terraform init within the home DevOps T-code folder. So the plugins are always installed within this current directory, right? If I do ls-l, you might not see them, but because they are hidden with ls-al, you see something called a folder created called .terraform, right? Remember that this .terraform is a folder where it holds all the plugins. You can see that providers registry.terraform and HashiCorp, and I say that here, you see all the plugins, AWS, Azure, Google, and all that stuff. If I go to the AWS, and this is where you see the plugin installed, right? Plugin is nothing but again, some kind of executable format. It's there, is the idea. So understand, team, here, Terraform installs the plugins always in the directory where you run the Terraform command. Right now, I ran the Terraform init within the T-code folder. I was able to read the provider configuration that which plugins are required and try downloading them. Now, if you want me to prove that for a scenario, which we already installed, remember, but if I remove these directories, rm-rf, .terraform, say .terraform log file something, whatever it is created. Now there is no programs or no Terraform available. If I go and install Terraform init again, it will try to read them again, right? Like you see, it is trying to install a down. Since removed it, that's gone. Terraform again, don't find them. So technically it goes and install them again. So installing something again. You understand, team? Terraform init will always install the necessities required by Terraform to connect to a specific. If I try to run the same command again, since they are already installed, it will try to validate if it is matching the required version. It will not install it. It will say that it will try to use this. As we go, we can see previously installed version. This is the first thing. Be clear. The Terraform init is the first command in your Terraform workflow, which will initialize the necessary plugins required by Terraform to connect to the simple. Now, the second thing in your Terraform, since we have the necessary plugins now, we can start initializing a code execution. The actual code execution will be now ec2.tf create a resource, right? Now, we can do a dry run, team, before you even create this EC2 instances. Say, for example, I would like to do a dry run. That's where we run a command called as Terraform. Again, when I execute this Terraform plan within the current directory of T code, it will try to read both provider.tf and etf. It will use the provider.tf data to authenticate, and then it will use the ec2.tf to create a resource or dry run of this particular thing. So if I do a Terraform plan, you will see that what Terraform will create. right? It is just a dry run, remember. It does not really create anything on the cloud. It will just say that, hey, if you want to create, this is what's going to happen on the cloud. Okay, now you see, it says 5 resources to add, 0 to change, 0 to destroy, right? Now, if I go on output, you see a lot of data. It says that, okay, this will be created with AMI. Some values will auto-generate after the creation, something it says. Okay, now you see that it says something. A lot of values will be known to you after you. Now that's great. Now, how do I do this one? It says that, hey, you didn't use the out option to save this plan. That's fine for me. So Terraform can't guarantee to make exactly these actions if you don't apply. Whatever it is, right? It says that now the third thing in your flow is called Terraform apply. Terraform plan is just a dry run. Now, if I really want to create these resources on the cloud, I use something called Terraform apply. If I do a Terraform apply, now, because it needs to authenticate and then calculate all the things required. Yeah, it says, okay, this is what it is. Do you want to perform these actions? Terraform will perform the actions described above. Only yes will accept this up. Yes. Now again, I'm not hitting enter. Before that, I'll show you on my as well. If I go back to the EC2 instances page, there is nothing available here. As you can see that there are no resources, no EC instances. Now, if I say yes, now Terraform will start creating it. Creating. Minute. Refresh. Now you see the instances are running, right? The 5 instances we requested, the 5 instances are running. Now it says it is done within 30 seconds, right? That's how you create a team called infrastructure code. Now it is easy to create. Now it is also easy to destroy as well. Like I can ask the Terraform, the last command in your workflow is called as Terraform destroy. Simple, right? Now we just created 5 EC2 instances with these IDs it is generated. But I'm also asking Terraform, hey, I don't need this infrastructure anymore. Destroy everything, which means terminate the EC2 instance which I created in this scenario. If I say destroy, that is the last statement in your Terraform workflow, which we call it. So it is easy to create infrastructure. It is also easy to destroy infrastructure with a simple Terraform commands here. That is the idea. Okay, it is again confirming that, hey, I will destroy these 5 resources. I'll do about it. And when I say yes, now it says it is destroying, which means it is going to terminate the instance system. It is not stopping it. We can stop in a different way if you want to, but the idea is it is going to terminate them. It says that shutting down now. In a minute, it will also go into a state called. If this is done, right, so you can see destruction complete for a third couple of instances. A couple of them are still in destroying phase. 40 seconds elapsed, 50 seconds elapsed for those instances. Maybe something is happening. If I go and refresh here, okay, you see that 3 of them are terminated, 2 of them are still going through. Yeah, destruction completed after so on. So now you see terminated. One more instance to be terminated here. We're still waiting for the last instance to be terminated. It's taking a long time. Now, anyway, it is done. So if I go to it, I see all of them are terminated. So we'll do multiple times this try. Give me a minute. We'll do that again. If it's this useful, what is the major? The drawback is again that, right, how do you manage the infrastructure? If you don't manage the infrastructure well, if somebody hits it, so there is a production right? I created using a Terraform apply. Now production is up and running and user education. Some silly guy came here and then did a Terraform destroy my production. It's gone, right? Production is gone and user is gone. So technically it is all down. That's what I'm saying. It's so powerful to create. But again, if you good control over the destruction, then it is easy to destroy even a live system, which is going to be very dangerous. It's the drawback, I would say. Terraform manages the infrastructure state in a different way. Managing the Terraform states is the different part. That's what I feel it. Again, there are some good controls to make over it. Otherwise, it can be destructive as simple as we created. Anyway, keeping that. The team, you all understood how easy it is for me to create infrastructure and also delete infrastructure with Terraform commands, right? Terraform plan, Terraform apply, Terraform destroy. So wait a second. What Projector said something. Why did init took only provided as TF and not EC2? That's how the init is designed by Terraform, right? When you do a init is designed in a way that it should read all the provided blocks only. It's not even taking the provider.tf. Remember, Terraform commands will read the actual blocks, not the files, right? So it will try to read only the provider block when you do a Terraform init. The rest of the commands will read all the resource blocks, including the. What 2 steps you want me to show you next? That's what I said. We will do it again. Give me a minute. I'll show you, or we'll try to create more resources and we'll try to do more of them. All right. So now it's the simple idea that we have just created something called ec2.tf, and wherein you're able to create multi-sources. Correct. Now you say that I'm reducing the number of instances. Team, I don't want 5. So, okay. So now I'll do a Terraform apply again. This time it will create only 2 instances for me that you can see. Yeah, you see that it says, hey, 2 resources to add. I'll say yes. Now it start creating 2 resources. Now if you come and refresh here, you should see all of them in running state. Now, right? They just created, that's still initializing phase. You do that. This is simple. Right? Now you see the 2 instances are created. Right? Now it is also easy for us to update team. Remember, now if I re-execute a Terraform init command or Terraform apply command, will it create 2 more instances? I said we already created 2 instances. Understand the situation here, team. Terraform had already created 2 instances and 2 instances are up and running. If I run a Terraform apply again, will it recreate 2 more instances, or it would say that, hey, you already have 2 instances? What would it say that? So it won't create, right? That's what you're saying, if I understand correctly. Create. If it more prasanna, that defeats the entire purpose, right? Every time I want guys. Every time if I create 2 instances, how does it make sense for me? It doesn't make any sense, right? We want always 2 instances with it. After created, it should know that it is created already, right? So if I run the Terraform apply again, I'm executing 2 times, but doesn't mean that I want 4 instances created, right? I want only 2 instances. That is my design. I never said I want 4 instances. I want only 2 instances. If I keep creating 2 instances every time I apply it, then I will defeat, right? My infrastructure is growing, right? Doesn't make any. So Terraform is intelligent enough here. Understand that Terraform will not create again once it is. This is called as idempotent, guys. Remember, keeping the desired state is always necessary. As per the code, I want instances. Whether I execute 100 times, it should say only 2 should be available, not 100 times into 200 instances created. No, that's not how it should work in the real time. The desired state, what you have written in the code is your desired configuration. No matter what, how many times I execute a script, it should always maintain the same desired state. Remember, this is what I require. What I require is basically desired, right? Unless you destroy, it won't reapply again. That is what we understand. Correct. So the code needs to be modified if you want more instances. Absolutely. Right, Fredo, right? Now, if I go and say that ec2.tf, hey, instead of 2, I want 3, means, again, this time it won't create 3. This time it won't create 3. It says that, hey, there is already 2 available. Let me give you 1 more. So it becomes 3. Remember, what you mention in the script is what is desired. The total number should be that much only, right? That is what the idea is basically with Terraform or anything, anywhere. The desired configuration is like what you mention within the code always. Now you see it says only 1 to add because 2 already exist, right? 2 resources already exist for me, so it will create only 1 more. That is what the idea is. Simple. Say yes. Yes, I want to have one more. That is what I do. So it's creating the third instance now. You should see the third instance coming up. The third instance has come up now, right? That is what you see. And if you want to change in the script team, remember, for example, in this scenario, again, if I do a ec.tf, hey, instead of T2 micro, I want T2 nano, right? So far, I have all the instances running as T2 micro, T2 nano. Now, what does it do? Will it delete T2 micro and create T2 nano? Or will it just update? It should just update, right? That is what. So it is not going to delete them, team. In order to update the instance type, what do? You just stop the instance, update the instance type, right? You just go to the instance setting, instance type change, and you put it to a different instance and restart it. So Terraform will do exactly the same thing for you, right? It will stop the instances first. It will just update the instance type and it will bring it back again. That is what Terraform will do. Terraform will try to match the Terraform state, means Terraform scripts what you given always. So Terraform will try to match your infrastructure according to what you define. You can also change the key pair name. It will update the key pair name in the things, right? Can I change the key pair to the EC2 instance structure? From the AWS console, can you update a EC2 key pair to the EC instance? If that's possible, the Terraform can do that. If it is not possible, that AWS is not allowing you to update a key pair of instance, then you can't do with the Terraform. That is it. Anyway, right now I'm just changing that T to nano. Say that Terraform apply. So I'm expecting that the T2 micro should be changed to T. What if you change the key name? Again, if it is allowed, it will update it. If it's not allowed, it will not update. Count to 1, this destroys 2, or we'll say, of course it will destroy 2 joy, right? Of course it will destroy 2 and then keep 1 and update the 1 to T2 nano. So you can see that it is changing instance type to T2 micro to T2 nano for all the instances, right? I'll say now it's modifying the instance type. That's what you see. So if I use update, now you see all states, it might be stopping them. You can see that the stopping, right? Stopping state. Now you see 3 of them in a stopping state, right? And I go on all states again, say that because they'll be stopped and then, stopping and then stopped, then update. You see the T2 micro here still. Let's see or wait for a minute. See the stopped will change to T2 nano, right? Now see the T2 nano. Now it's running. Now the other 2 are still in stopped. Okay, it's doing it. Now it is T2 nano, it is pending. The last one is still stopped. Doing it for you, right? Say T2 nano now. T2 nano, everything became T2 nano. That's what you see here as well. An update is going on, right? Even with different user login accessing the same file, it will check the login base, right, Indra? Terraform worries about what's written in the script, not the user you're executing here, DevOps, right? Terraform is not worried about the Linux user here. Terraform worries about the AWS configuration, right? Terraform needs to know AWS login. With which user you're executing this, the Linux user does. So that's the idea, team. We're talking about how you actually can understand how Terraform is creating resources, updating resources, right? Or it will try to maintain the desired state, like exactly what's in your script will be present on the cloud. Not more, not less, anything. It will make sure that exact configuration is applied. If there is a configuration drift happened on the cloud, you can just rerun it, will bring it back to the original state, which means that, hey, somebody logged in and on. Then to do, say somebody logged into my console, those who have access, then I say they change the type to T micro again. That I really, I'm going to show you in a 10 minutes. This is all real time, only you do it, right? There's nothing left. All right, so here it is. Now, if I reapply it, it will change it back to the T2 nano again, which means that if there is a configuration drift in the real environment as well, you can use the Terraform code as the baseline, right? As the desired state always. So which means if there is a drift, I'll rerun, it will match, ensure that my infrastructure is back to the original position, which I exactly wanted. So this can be version controlled by putting in a Git as well. You can easily track who is modifying the code, that what is happening exactly, and all those things can be controlled easily. That is what the benefit is here again. Okay, so anyway, keeping this aside, let me show you a couple of more as well. Not only the EC2 instance, right? Say that you try to create multiple things. So if I go to AWS here, now I have multi team I've written. So if I want to create S3 bucket, then this is a code. Resource AWS S3 bucket, say S3B something, and I go and do this, right? It is the same block type team always you give it. Say, remember team, I can write something called s3.tf separately, or let's say that I'll just change to ec2.tf. You can even write multiple resources within the same code instance, right? If I want to be sure, remember team, you need to be sure about the S3 bucket. Name is unique across the regions. So I just mentioned some random names, right? Now again, this time, what is missing? If I run Terraform apply now, what it will create? If I run Terraform apply now, what it will happen? Will it only S3 bucket? Only S3 bucket should be created because the EC2 instances are already present with the required configuration available. Only the bucket should create. So Terraform apply. All right, so you can see the 3 instances are refreshing it. There is only one to add. Only the S3 bucket will be created, right? So say yes. It will try to create only the S3 bucket. Done. Let's go. So if I go to S3, right, I should see an S3 bucket with some name. Here you see the bucket, whatever the name you have given is created successfully. Or if I want to create, what else you want to create, for example, again, I'm just taking the code. I can write team, but again, remember it will take time. So let's say I'll go here, I'll get something called security. So I'm just creating something called security group. Hope you know the security creation, right? This is called a security group creation. Okay. So I'll call this as again the sd.tf separate here. Now try to understand the terminology team. I'll tell you in 1 minute. Say the resource AWS security group, the purpose something like that, and the name is something. Remember team here, you can give any names, right? And say a description of this one. Remember team, you just need to recollect the way you do it on the UI. Let me show you, right? So if I go to the EC2, for example, now remember the page that you're doing it always here, right? Where are the security group? When I create a security group, you remember this page, right? So there is a security group name. So that's your security group name here. There is a description field. So the description field is one. Now there is a VPC that I need to write my VPC. I'll write it in a minute. Just give me a second. There's also VPC I mentioned. I think it is there at the bottom. Yeah, here it is, right? There is a VPC ID that I'll get it, right? I just get my VPC ID and then place it here as well. This is memory field, right? And coming the inbound rules. Now, what are inbound rules, team? Remember, it is the incoming traffic in team, everybody. Is the inbound rules are nothing but your incoming traffic, and outbound rules are your outgoing traffic from the EC2. That's where we say that here is the ingress. Remember here what we're saying? Now here the ingress means that it is the incoming traffic or inbound rule 1, inbound rule 2, inbound rule 3, inbound rule 4. Remember that you can add multiple inbound rules, right? 1, 2, 3, 4, 5, 6 and all this stuff. Like this you can add multiple inbound rules. Each rule here is the ingress block again. Now ingress, open and close. Now it says from port to port, protocol is TCP. Now remember team, this port is called AT, which is a HTTP port. So you choose a protocol. Let's see that here is something called as a HTTP. When I select HTTP here, you see that a protocol is always TCP. So I mentioned protocol is TCP. Now the port number range, which is 80. When I say 80, which means it is choosing HTTP here, right? So which is from port to port is 80, which means I'm using HTTP. And the CIDR block team, remember from where you allow it, the source we're talking, the source is like anywhere IPv4. Now you see that this is what. The meaning of anywhere IPv4 is the 0.0.0.0 CIDR block, we call it. That's what I mentioned, which is like anywhere IPv4 is what I'm mentioning technically, right? Even if you want to write description, you can also add a description here. Right, ingress and egress in script. Ingress is inbound rules, always. Egress are the outbound rules. Now, this is the first rule. Then you have HTTPS, I believe, the next one. If I go and select the HTTPS, where is this HTTPS? Yeah, here. Again, it's a protocol is TCP 443, anywhere IPv4, something like this. That you see, it's the same. We have it. Now, this is something, team, kind of ICMP all traffic. The protocol is ICMP here. Remember, not the TCP protocol. It is the ICMP protocol we're saying it here. All ICMP, right? You see that all ICMP and is like this one, right? Now, all means that here from and to port -1. It's like everything. -1 means to everyone basically. In the case of ICMP. Now, the next port is ingress again, which is like your from port to port, which is 22, which is in a way SSH, right? So we can select SSH here, 22 port number, anywhere IPv4, something like this. The same thing which I mentioned as well. Now, the last one, it's egress. Remember, we are done with ingress, ports, ingress rules. Now we are saying that it is an egress, which means that you need to go to the outbound rules, right? Now, outbound rules, I selected all, right? Which is always by default, protocol is all, port all. Now, see that protocol -1 means all here. Now, the from port to port was 0 means it's all port range again. That is what the meaning of this. And the CIDR blocks are again here, this one idea. Now, remember, team, the tags again are something like below tag. There's a tags, you can always add a key value pair. That is what all you're trying to do. The same tags which I mentioned in the script. The tags which requires an equals to here, sorry, the typo in the script. -1 means all. 0 or -1 means all ports and all protocol, right, projector? When I select something called all traffic, what is the port? All, right? Which is can be mentioned as 0. From port to port is 00. Protocol all means that again I keep it -1. Means if I keep it -1 here, that protocol becomes all here. That's the idea. That's all else. All right, so all I need is a VPC ID, team here. Let me grab the VPC ID from the default security group. This is the VPC ID, right? The same VPC we are creating in, so I'll keep the same, right? I'll just go and mention it, simple. Right, this is how you do it. So again, team, I'm telling you, I know this looks very big in this program or a script basically, but this is one-time configuration. You do it and it can be used anywhere in it, right? All right, so let's execute it. Now again, I'll do the Terraform apply. One more resource to be created. Remember, you already have 3 EC2, 1 S3 bucket. Now this time it is going to initiate a new security group with the name we mentioned, which is the website. Right, you have S3 bucket, everything's good. Say there's only one thing again, which is create a security group. All right, done and created. So let's go and do it. Here it is, web server SG, this one, and open it and see the rules, team, if you want to. Click on SG. Now you see the rules added, inbound, right? All ICMP4, ICMP, all something, whatever you want. Same thing, right? Outbound rules, all, everything is good. Exactly what you can't specify the, as I said, there is a today present. You can't specify a Terraform file which you want to execute. No, that is not possible with Terraform apply. Terraform will always read everything or all the TF files in the. These are the 3 different TF files we have. It will read all of. Sorry again. In case of S3 bucket creation, we have changed name every time. Why are we changing the bucket name? You gave one name in the bucket name. Why would it change it? If you change the name, this is the name of the bucket, right? It won't change. It will keep the same. If you give a different name, then it will create a new bucket altogether, right? Considering that it is a new bucket. What you're saying, Mukesh, you want to create a new bucket every time? Is that what your requirement is? Do you want to create a new bucket? Then you take this as a value as an input, right? Because you hard coded some name, it will try to create the same bucket. It will try to see that the bucket exists. It won't create one. Now, instead of passing this value here, I'll pass it while executing it, like variable concept we discussed in the playbooks, right? You can variabilize this parameter, provide a new bucket name every time. If it is a new bucket name every time, it will try to create a new bucket every time in the scripts. But the idea is that you need to variabilize this and pass that as an input. Otherwise, you need to modify the script and then enter a new name every time you execute apply. Okay. All right. So this is the understanding. Okay. This time again, it won't create anything because all the resources are already at the desired state. Means what we have in scripts is already created on the cloud. So your scripts infra, it does not change anything. It simply says that Terraform has compared your real infrastructure against your configuration and found no differences. So no changes are needed. Terraform will clearly state. Understand here, right? One thing is about how do I write this each resource block? From where do I know this words? Now I know that I'm writing it blindly and I'm giving to you, but how do I know what keyword should I use here? For creating AWS instance, it is instance. For S3 bucket, it is S3 bucket. For S-security, it is security. But in order to create a key name, what should I do? In order to create a DynamoDB, what should I do? Right? How do I know this information is the question. That's where you always have to look into the Terraform documentation team. Like every plugin has its own documentation. Remember, we are being specific to the AWS here, right? If I go to this, if I'm being specific to the AWS, go to the AWS. And then on the top right, you have something called documentation. Terraform maintains a clear document, everything. So one thing here, if I click on the documentation about the AWS provider, then you see the left side, there is, right? It's an n number of resources that you can create, right? On the left side, you see Terraform supports all these type of resources to be created using the scripts. Now, what we did right now is a EC2. So on the search box, I'll say EC, right? Let's say that the EC2, you have EBS, data sources. I see that this is an Elasticute cloud. Now, under this team, you have all the predefined resources. Like, remember, this name is not my own. This is a predefined name given by the AWS to me. So how do I know that? You need to go to the AWS documentation, Terraform AWS documentation, and find that exactly. If I want to create an AMI copy, this is the one, right? And say EC2 host, blah, blah. You see that, right? There are something, AWS underscore, right? Now, this is what the user used it. So remember, team, it is always necessary to know the right to. So the example as well, how do I use this? It says resource AWS instance web blah blah, something like this. Okay, and now within the AWS instance as a resource type block, now these are all the keywords which I'm using it. AMI instance type. Remember, team, every key which I'm using here is a predefined key, which again is given by the AWS to you. Now these are called arguments, right? I said any key is equals to value is called an argument in Terraform script. So that's the reason, team, within a block, you have arguments like this. Now this each argument has a key value. All the keys are predefined. Values is what we do recording. So this is called arguments. So on the right side, you see something called argument reference that is supported by AWS instance resource type. So if I say argument reference, now see that argument is here. Now technically use an AMI, associate a public IP address, availability zone. Now see, team, there are n number of keywords that are predefined in this documentation that you can use within this block. Like we used tags, AMI, instance type, key name, security groups count. Those are the one part of this one here, right? If I, you should see what we use, right? Where say here is a key name like this, right? This is a key name parameter. Then you have something, various other options as well. Like, remember team, all these things can be written within your script, like the security groups here, right? And the tags here that you can see that I'm highlighting again. So these are all the default, a few keywords I used it, but understand that all you need to know is that you need to explore the keywords based requirement, start using them within your script, automate everything as necessary. This is what the idea is. Okay. From where do I find all these keywords, or what resource type I should create and what keyword should I use it based on the understanding? If I want to create DynamoDB using AWS, then I search for a Dynamo, right? You see that here, DynamoDB table, right? You see multiple table, something tag, global state, contributor insights, and everything, all, right? You can just see this idea. So if you have anything like a key pair, say AWS key pair is a resource that you see that. And using this, I can create a AWS key pair and attach my things. I have to go and attach the keys like this, right? What else you have to create it? For example, I want to create a VPC, right? Maybe something called AWS underscore VPC something resource. Should be it. Where is no AWS VPC in here? It says VPN. Yeah, here it is, right? VPC peering, VPC, right? AWS VPC resource. You can see this is the idea. So I'm just showing so that you can follow it as you want it. I can give you one important thing from where do I get the examples, and the documentation is also part, everybody. How do I get to know the keywords I use resource type? It only uses the push command used till now, or do we have a pull command also? There is no push command, right? The push model we got it. When you do a Terraform apply, it is kind of a push, like you push the configuration. Asking me that, hey, if there is an existing resource, I want to import that resource information to my Terraform and manage via Terraform. The answer is yes. We also have something called Terraform. Okay. We can also import the existing resources which are not created by the Terraform. Right now, Terraform applies the one which is creating something on cloud, and it is managing those things. What about the ones which are not Terraform? If I manually create some EC2 instance, right, like this don't launch instance and everything, can I manage this one with the thing? Say that test I do. Let's say that I'll select this launch instance. Now, can I manage? The answer is yes, we can do. There is an option called as Terraform import option, right? We can say Terraform in, right? You just need to use import existing infrastructure resources like this. Say, need to say Terraform later. But other important thing that you need to understand now, if you're all clear about the documentation part, from where do I get the resource name and then the parameters I would use within the resource block, always whatever I'm using it with SG or what I'm using with, ec2.tf something, all these things are fine. Now the next thing is that really Terraform knowing that what is already being created means if I do a Terraform apply, Terraform says that, hey, which is already there, but how does Terraform know? How did Terraform able to validate what is already existing? How is it able to validate the real infrastructure against? What's your answer? How Terraform is keeping the track of real infrastructure, which is all. Now you understand here the statement. Terraform has compared your real infrastructure against the configuration and found no difference. How Terraform the real infrastructure and comparing with through the key name? No. Why key name coming? Key name is specific to EC2 instance. It's not related to AWS login or something. Key name is specific to EC2 instance. Understand, team, this is where you need to understand the way Terraform is managing the infrastructure after it is created. Remember, Terraform is not just creating the infrastructure. Terraform also can periodically look at the infrastructure is matching your desired configuration or not there with the configurations you do it. By default, it is not, but you can configure Terraform in such a way that it will go check, validate infrastructure, make sure that it is matching the desired state every periodic seconds, right? Periodic. So how it is able to compare it is a question. Now that's why, team, if you look into the current, do you see any extra files apart from the doc? Do you see any extra files apart from the state TF? There is something called TF, right? You see that within the current directory, there is a file called TF state. There's also backup of the TF state. See that? So here it is, team. If I open this TF state file, now you see that Terraform is generating the configuration of the resource it is created, right? The resources, under the resources, it says that, okay, the type is AWS instance and the instances. Now each instance information is available here. See the AMI ID, the ARN, the associated public IP values. You see this, right? It has all the information about the current instance which is running, including the instance ID, right? Including the instance public IP, private IP, all the information is stored here, right? Including this, you see here, the public IP, private IP, the DNS values, default parameters, default storage, all the things are maintained. So understand, team, in the Terraform workflow that we discussed, again, just to give you the clear picture, what's happening when you run certain, right? If you read Terraform workflow, team, there are 4 commands we use so far: Terraform init, Terraform plan, Terraform apply, Terraform destroy. Now, team, Terraform init command downloads the necessary provider plugins to the local server. Then Terraform uses these provider plugins to connect, login, and create resources on the cloud environments. That's the idea that Terraform is doing it. Terraform plan reads all the Terraform scripts, which is start.tf files in local server inside the directory where the Terraform command is executed, then does a dry run of them. Now the actual thing here is a Terraform. Now the reads all the Terraform scripts in local server inside the directory where Terraform command is executed, starts creating the resources on the cloud. Now that's what you saw, that everything was able to create it. Now it is not only creating things, team. Once the resources are created, Terraform creates a file called terraform.tf state file on local server about the info of all the resources it created. How the Terraform TF state file is generated, it is part of your Terraform apply itself, right? The terraform.tf state is a file which has the real infrastructure which is created by Terraform, right? That's what we're doing it. Now that's how, team, whenever I reapply it second time, hey, it is validating the TF state file against what's in the cloud. If it is matching that exact state, it says that is good. If it is mismatching, then you will try to reapply the configuration again. That's what it is doing it, right? Remember, team, whenever you apply the Terraform apply command second time, it looks at the TF state file, try to take this configuration, compare it with what's in the cloud, right? It logs in, compares it, generates the templates and compares it. If it is equal, says nothing to change. If it is changed, then it has to apply the change again. That is the idea. I hope that makes sense now, how Terraform is becoming ideal. Now, it is same applicable for Terraform destroy as well. How Terraform is able to identify the resource it created and deleting only the resource it created. The scenario again here is, right? I have all the instances running, right? Remember, this test VM is what I created manually, not by Terraform, right? T2 micro is manually created. But if I do a Terraform destroy now, team, it will destroy only other E3, EC2 instances. It will not touch. Able to understand that? because test is not part of your state. Is test is part of my TF here? The test EC2 instance is part of TF state by any chance? Definitely not. That's why it won't touch that, right? It won't touch that basically. That's what I'm saying here. Terraform will maintain this TF state as part of its creation and deletion, right? Getting the points here, reads the local terraform.tf state file in the current directory where the terraform command we run, and deletes all the resources as per what is available in the file only. So the terraform state file is the heart of your team. If suppose if I move out the state file to another directory, Terraform will recreate again everything. If I delete this Terraform state file, what happens? Terraform will recreate everything because Terraform does not have a value stream anyway. That is the reason, team, I'm saying it. Terraform state is the key in entire workflow. Okay. Now we can see the Terraform state files, Terraform state configuration like this. Terraform state. Did I miss? Okay, I need to give, sorry, the Terraform state list is what I. Now, if I do a Terraform state listing, remember it reads the state file, it will tell you what resources it is created, technically in a short form. That you see, okay, I created AWS instance 0, 1, 2, 3. And then I created AWS S3 bucket, S3B, and AWS security group, S3 So this is how you see the resources created by the Terraform. So far, that is exactly what is in the state config file. Now I can know about a particular resource. I know opening a file, state file is a very big one. You can't read it really. Means if I open the state file, can I read, understand the information? Remember, it has around 600 lines. I can't read it easily. To know about a specific resource, remember, we say a state list, right? It will tell you the resource. Now, let's say that I can do something called Terraform state show. Give me the information about this resource. Out of all the state file, I don't mind. Okay, it'll give me what exactly is available on the state of this particular on the cloud, right? You see? So it will print the information onto screen in a more readable format as well. You can see this. It is printing all the information about your S3 bucket here, right? See that it's printing the S3 bucket information in a more readable format, step by step. This is the idea. So Terraform state list will tell you the resources created. Terraform state show will help you in knowing about a particular resource created, right? This is something. And let's say that Terraform, say that I'll do a Terraform state. Remember, can I destroy a specific resource? The answer is yes. Do I do what? If I say simply Terraform destroy team, it will consider all the resources in the state file available. But instead of that one, I can say that -target. Hey, target only the deletion or a destroy of the security group. Or maybe let's say that I'll destroy this instance out of 3 instances. I'll destroy only one instance, right? They say Terraform destroy, target only that resource. The rest of them don't touch it. Simple, right? So this is how you can control what to destroy as well. Next. So now it says that, okay, there is one to destroy, right? I'll say yes. Go ahead and destroy. Now, whenever the destroy happens, Terraform state will update, which means that this instance configuration is now removed from the terraform.tf state file automatically. Remember, Terraform destroys not just deleting the resources, it is also going to update the TF state file to not to have this configuration anymore. So Terraform destroy modifies the state file as soon as they deleted, that will remove them the state file as well automatically so that it will be there. That's why if I do a apply now again, in the apply command, there's one missing, so it will go and create a new instance again for me. That's how it works. So if I go and check on, so one of the instance will be disappearing here. That is going in a terminate, right? You see shutting down here. That is what is going. So this is the instance ID is this. Okay, that's how you can validate it. So you can see the instance ID, right, which is 5039. right? 5039 is what it is getting deleted. Simple. The shutting down is happening here, but it is also going to terminate it accordingly. So team, is everyone able to follow me that how important the Terraform state file is here? And then how do I know about the Terraform state file? Now you deleted some instance, right, Prasanna? The deleted configuration goes into the backup file. Okay. Means I can know that what was deleted from the backup file. The backup file will have the instance still. Say here, if I go and check the Terraform TF state, right? If I look for this instance, you see that this instance information is available in the backup file, which means that by default, if you delete also, we can use the backup file to restore the configurations again easily. So Terraform creates a backup before creating or before it actually deleting the infrastructure. Right. Just one step back, we can say about how do I destroy specific instance as well, specific resource as well. Again, if I remove it, technically it will delete all the resources for me from the count. Nice. Okay, so now if I go, one point you have told us like we can import any instance into TF, but can we do just opposite? Is nothing but you're applying it, creating a resource with Terraform. That is anyways there with the Terraform's default. So anything which is not managed by Terraform can be brought into the Terraform management if you want to. That's what. So when you have two files, TF, which has two conflict about the action, EC2 instance, what will understand your question? You're saying that if I have ec2.tf, say right, which means that there are two TF files which is describing the similar configuration or not. Is this what your question is? The two files have the same exact. Okay, try running it and see. This was already declared something. It says that the resources are duplicated. You can't have a duplicate resource names here. What you do is that instead of anything, you can change to something else. So it will work for you. Okay. The purpose must be different in each file when you're doing the same type. All right. So this is not pretty complicated, Vaibhav, and compared to. But again, the answer is that there's a concept called Terraform modules as well. Okay, and then you have to use a different folder structure to maintain the different state file, because remember each environment should have a different state file. So you have to use a different folder structure for each dev, QA, and prod, something like that. So there is a predefined workflow. So you need to delete that block from the saying it. All you need to do is that right now, if I go and check my TF state file, after I do it, there's nothing in the TF state file, right? So here, if you look into it, since we destroyed everything, but what you can do is that you can manually edit the file and remove that particular block. All right, so can this workflows graphically shown somewhere to understand more? All right, so let me show you a good example. I know we are creating individual resources, but think about in a real scenario where I would like to really set up a big infrastructure for my application deployments. So that is my team. Here I have made a scenario, for example, like this. You need to do it from the scratch, team, within your. That's right. In the real time, people may use Terraform Enterprise if the company budget allows it. But again, the company budget is not allowing to use Terraform Enterprise. Say they can develop their own internal tools for that I can say. But Terraform CLI is used everywhere in every. Right? The Terraform Enterprise could be from big organizations, startups. If you really provisioning infrastructure with Terraform, it should be end to end. Means it's not like you create S3 bucket and blah blah. It's like you create from the scratch. Like means whenever you set up an AWS account team, whenever you would like to deploy some specific applications with isolations, we start from right. So you create a VPC, you set up specific subnets with subnet siders, everything, and then you go and create some route tables like how do the traffic load into the VPCs, securing the VPCs and all that stuff, and associating specific cider values to your EC2 instances, creating a security groups, creating network interface. Again, team, if you want to become an expertise on the Terraform, first of all, you need to be expertise on the cloud platform, right? The more you know about the cloud, the more Terraform automations you can do it. That is a simple idea. So technically, here I'm just giving a simple example. Like these are all the tasks which I want to perform. Say network setup, create a VPC, create internet gateway, create custom route table, create subnets, associate subnets with route table, right? Create a new security group with the port numbers what I wanted, network interfaces and attach them to the subnets. Then finally set up an EC2 instance and also deploy a web server on it and deploy the code onto it and all this stuff, right? So this is the simple scenario I have it. I have to set up this end to end. Now I need to write it out. This is where, team, if I get into this, you have all the necessary code here. It's a big file having multiple resources, remember, and these things I can take out. So starting from here, you can see this, right? Creating a VPC, resource AWS VPC with specific CIDR value you wanted. Then creating an internet gateway, AWS internet gateway, and then associating that to the. Remember, team, here, when I get the VPC ID, I'm using something called a variable like, right? I'm saying that, hey, AWS VPC, test VPC ID. Why I did use like the team? Just now we spoke that whenever Terraform creates a resource, it gets the information about this and update. Where does it update the information about the resource? Every resource information is updated into the TF state, right? Now remember, team, just like we have the Ansible variables like inbuilt, right? The gather facts, right? Think about it. From the gather facts, we are using the team. Whatever is in the TF state file can, right? Remember, from within this TF state file, we can grab the values which are generated and use them or pass as inputs to the next scripts as well accordingly. So for example, like in the case of EC2 instances generated, I get the EC2 instance ID, right? Somewhere EC2 instance ID is there, this one, right? Now similarly, whenever I create a VPC, do I have a VPC ID as well in my state file? Have it. Once a VPC is created, the VPC ID generated must be part of your server shard. So that is the logic we are implementing here, dynamically grabbing the VPC ID and then associating that with various rows again. This is what I'm doing here. First, creating a VPC. The state file is updated with the VPC ID, VPC information. Now, in the second resource, when I'm creating AWS Internet Gateway, that requires a VPC in which you are creating it. So you need to get the VPC ID under VPC, which VPC you're going to create Internet Gateway. So how do I get the VPC ID here? That I'm using this AWS VPC as the thing, and whatever the name you have given here, which is a test VPC, and the ID. Just like here in this scenario, again, I'm telling you. So in this scenario, right, this is an EC2 instance, right? So the AWS instance we're talking about, the instance, the type is AWS instance. That is what I'm saying it. And the instance 0, which is the first instance basically. And the name, right? Remember, AWS instance, the name is anything, and the value, which is going to be the ID. Simple as that. From each of the file, we can get like this ID, which will get this value and added in this VPC ID section. So it will get that again. So that's what I'm saying it. Now this is what I'm assigning it. So create VPC, get the VPC ID. Under that VPC, we create Internet Gateway. Now the same thing for your AWS route table also associated in the same VPC ID. Same thing which is for all the resources, right? Now VPC ID, under this, we are creating some subnets with this standard block and availability zone assignment, everything like this. Here we're seeing that it is a US East 2B something, which means the thing is going under US East or US West something. Everything is like the team. Again, I'm getting the subnet ID from the previous subnet creation and associating the route table to the subnet, something like that. All the values ingress, right? Here also getting the VPC ID while I'm creating a security group, for example, like this. All right. So this is the logical idea that you dynamically grab some values from within the state file and start creating the things accordingly, right? So here it is, and the availability zone is US West 2B or East 2B, and say that key name that you want to everything. Okay, let's create this and see it, everybody. Will it work? So I'll take this code entire. Now remember team, here I'm just gonna create another folder, not the T code. Say I don't want to touch with this. I'll say that mkdir, right? The big infra I'm creating it. I'll go inside. Now this where we don't have it. So vi my infra .tf, and I just paste everything here. Now you need to update use your team, remember key name, the key name which is existing again as it. What was the key name? We had it iPad. What is the key name we have? US West, I believe. And remember, this is not the East. Basically, we are using US West, so use the West. And remember, wherever the US East you had it, ensure you use the US West, right? Is something because the region we're using is US West scenario. Here as well, I'll say US anything US dash E, no pattern found, right? Every key, right? If you just write the high level key and then remember the few keywords and say that, hey, rest everything I did, but I'm not able to remember the keyword exactly, then that's okay for you. At least if you're able to write a few keywords right, and then it's good enough. Okay, now since this is a new directory team, remember there is no plugins available in this particular directory. What I should do, what is the first command should here? I also need the provider team directory. I also need the providers, remember. So I'll copy the provider from that here. Without a provider, I can't log in anyway. So these two things. Now the first command we need is Terraform init. This directory is entirely different than the previous directory. In order to know the plugins, always should be there. So now it is again reinstalling the plugins into my done. Now I'll say Terraform applied. I'm hoping that it will create. And remember team, some of the resources you're creating with this file are maybe chargeable, so be careful. I don't want you to get charged. Again, if you're okay to test charge with the limited values, then go ahead and do it. Okay, now you can see that it says, okay, 9 things are going to be created. Say yes. I'm hoping that everything will go. There we go. We can see VPCs, subnets, internet gateways, security group. Okay, there is something is wrong. What is wrong here? It's a warning argument is deprecated. Okay, VPC is deprecated. Use domain and do it. Create EC2 instance operation, run instances, HTTP response for status code. Rizwan, it is not the permission since the AMI ID are region specific. This AMI ID does not exist in the US West 2. That's what it says, right? It says that this AMI ID does not exist in the US West 2 region. So it's a bad request that you're doing it. So I have to get the right AMI ID that we used earlier. So this is the right AMI ID in the US West 2. And let me update my infra.tf. Yeah, here it is. It can't be same since earlier I was with the US East values, right? So I was thinking that we're creating East. Now wait, if I run the Terraform apply again, the previously created resources anyway already created, it will do whatever it's saying again. This is not IAM user issue, how it's an IAM. It is just the AMI ID not found in the US West. Anything, nothing related to it. Say yes. Now whatever is the idea. So let me show you on the browser. My browser got closed team. Let me reopen the console. First thing, if I go to the VPC, right? You should see the second VPC created apart from the default in my case. Right? So if I go to the VPCs, yeah, there you go. You can see the VPC with the CIDR we mentioned, 10.0.0.0.3. That is the one which I mentioned in my. Where is this? Okay. Yeah, here it is, right? VPC with this CIDR block. Okay. What else we created? Internet gateway. Yeah, the gateway 1 is created and attached to the new VPC. But I can see that. Some route tables we initiated RT1, which is created as subnets. Subnets we created a subnet just now, which is associated with the latest VPC. You can see this is the new VPC created, right? And what else we created here? Some elastic. Yeah, there is an elastic IP also I created. Security groups as well. We can see the team, everything is created. Test SG1 something, right? We can see the custom VPC. Okay. Now, along with this, if I go back to the EC2 instances, then I should see some test instance might. Yeah, the test instance is what is running it here as well. So you can see here today, a big infra that we have an end-to-end solution here. No, it was just a warning, right? It was already created, so it won't recreate again. It was just a warning. It was, if it would have failed, it would have recreated, but since it is not failed, it won't recreate. It was just a warning. We just need to look at the code, some deprecation. I believe that I'm clear on how Terraform helps you to build your infrastructure and then automate everything possible. I hope you got the points here. What is the meaning of it today? How do I write Terraform scripts? From where do I get to know the data to write the script, which is Terraform documentation? And of course, you understood the Terraform workflow and Terraform, right? We try to understand, team, what do you mean by infrastructure, especially in the industry? And what are we trying to achieve here is that to create some servers to host some software applications. That's the main intention of this entire IAC automations we're talking about, right? So the basic infrastructure is always your data center where you keep all the hardware, and then using that hardware, you start building the servers, either physically or either virtual. So yeah, in order to create these servers, team, previously we used to do it manually, all by hand, but with evolution of technology now, with the evolution of cloud environments, we have it. Everything can be automated with a simple scripts, right? So if you can create some servers, if you can create some infrastructure that is required to run your application softwares again, that's called infrastructure as code, right? That's what we were talking about in a very high level. Yes, again, we said there are many IAC tools out there. Most of them are cloud specific, we talk, right? Which is like the cloud formation within the AWS that can be used for, building or creating anything within the AWS itself. Similarly, Azure has something, Google has something, and so on. Like every cloud service provider has something of their own. But again, since we need to work with multiple clouds in certain scenarios where you might want to have one tool that works with every cloud, that will be the good one to learn, right? We look for something called cloud agnostic, right? So that's where we started talking about some tool called as Terraform, which is given by a company called HashiCorp, right? So that's what we understood first. What is Terraform? What is infrastructure as a code meaning?
Just a quick info, guys. Intellipaat, in collaboration with Microsoft, offers an advanced DevOps certification course. This course is designed for both beginners and experienced professionals, featuring live instructor-led sessions along with self-paced video content to help you become a skilled DevOps engineer. You'll master modern DevOps methodologies, practical DevSecOps practices, and also the use of generative AI tools in CI/CD pipelines, automation, and infrastructure management. You'll also work on 60 plus hours of industry relevant projects and case studies, real time labs powered by AWS, simulating production level environment, 15 plus in demand tools used across the industry. With 24/7 support, placement assistance, and EMI payment option, this course, without a doubt, can set your career to new heights. You can check out the testimonials on our Achievers channel, whose link is given in the description below. Also, visit the course page given below in the description and take a first step towards career growth in the field of DevOps.
Alright, so with Terraform, we have automated the entire infrastructure setup from servers to networks. Everything's code now. But just because it's all running fine for now, it doesn't mean it will always keep running smoothly without any problems in the future also. So we also need to monitor our system, track the performance, and try to catch the issues early and make sure everything's actually working as expected without any kind of issues in it. And that is where we need the monitoring tools like Prometheus and Grafana. Prometheus helps us to collect the metrics, things like CPU usage, memory, request rate, while Grafana turns that data into the beautiful real-time dashboards to make that observability easier. So let's wrap this up by looking at how monitoring works into DevOps workflow, because automation is great, but visibility is what keeps it alive.
So the topic is going to be Prometheus and Grafana, okay, and we are going to have the discussion on the same. What exactly is the Prometheus? What exactly is the Grafana? So after I have explained to you, okay, once I have completed the explanation, we will see how the Prometheus and Grafana works, but with the help of a case study as well, so that you guys can go ahead and relate, like, no, to it better, that what exactly this Prometheus and Grafana is used for. Okay. So, talking about Prometheus, okay, the very first part over here that you can see, Prometheus and Grafana are considered both as a monitoring tool, okay. But in short, if I would say that Prometheus listens to the matrices. What Prometheus' job is to listen to the matrices, okay, metrics, okay. Not only this, it can also scrap metrics. The term that we use here is scrap metrics. Basically, it is able to go ahead and check what is going out with the system or wheresoever it is being installed or downloaded. Its job is to listen each and everything. Okay, that is the main job of Prometheus. But we as a humans would like to have a pictorial representation of the metrics, correct? Metrics is generally in the form of the numbers, in the norm of in the form of the percentage, in the form of greater than equal to, it would be like, no, in the form of various numerical digits, okay, which give us insights. But the things are clear to us when it comes into a pictorial representation or into a form of an image, or especially into a form of a graph. Now, to have these matrices properly being displayed, so that we can figure out what is wrong with our infrastructure, which is wrong with our application, okay, you need graphs, and for that we go ahead and have Grafana. So Prometheus or Grafana are not mandatorily to be used together, but in production now these are used, Prometheus and Grafana together only. As I told you, Prometheus has the capability to run the various kind of matrices, okay, on the system or wherever you want to scrap the details. However, when these details have to be displayed and has to be understood for getting a better insight, then this Grafana has to be connected to the Prometheus, okay, or you can say Prometheus has to be connected to the Grafana, so that whatever the details, okay, whatever the data it extracts, whatever it is scraps from the system, from an infrastructure, from a application, it would be redirected to the Grafana, where you can see it in the very great pictorial form, which would be easy for the people to go ahead and track what is the current situation of their infrastructure. So that is what this is also called as. Prometheus and Grafana are also called as monitoring tools. Monitoring tools. Because it helps you to go ahead and, like, no, continuously monitor your infrastructure, which means you do not have to manually, continuously, an agent has to set, keep scrolling, keep running the queries again and again to go ahead and find out what is wrong with the system. No, everything that you will set up, okay, is going to be tracked by Prometheus and would be displayed by the Grafana in the most best pictorial way. And that is also in your hands. What data do you want to scrap? What information do you want to scrap? For an example, you have an infrastructure, which means you might have a AWS EC2 machine, you might have an Elastic Beanstalk, you might have the Azure App Services, you might have any services. Now, within the CPU as well, what is important for you? What you would like to go ahead and find out? Would you like to go ahead and find out the CPU throughput? Whether you want to go ahead and find out the system load, whether you want to find out the RAM usage, whether you want to find out basically the disk storage, whether you want to find out the networking load, everything. So that is in your hands, what actually the details you would like to scrap from any system, from any infrastructure, and then it has to be displayed in the Grafana, not mandatorily, but it is going to be very good in an appealing way, so that people would be able to understand their system better. The company, the Prometheus was created somewhere close to 2012, 2012, and the company which has created the name is SoundCloud. Prometheus is a metrics scraper and Grafana is a pictorial tool which can go ahead and represent the details extracted by the Prometheus into a better insights. Okay. So let me go ahead and tell you what is the working of Prometheus. We'll go to the official website. So this is the architecture. This is a very in-depth architecture of Prometheus. Let me explain you each and everything. Okay. Now see, here you might have a system. Let's say you have a system here. Okay. This system has to be tracked. Okay. Now you would have a tool, let's say, called as Prometheus. Now this Prometheus tool is capable to scrap the details you want. The details could be the CPU load, the CPU throughput, the system load. Apart from the system load, it could be a disk load, the disk storage, the RAM usage, the networking load, and a lot of things. So let's say you have the Prometheus. Okay, now you want to get the details from this computer. Then let me tell you the very first thing that you are going to use it. You are going to use Prometheus target. If you want to bring any, see, Prometheus is capable to go ahead and get, like, no, scrap the details. Okay, but for it to connect and listen to any device, okay, and listen to any device, okay, it needs a tool or a utility here as well to go ahead and control this or to interact with this computer to get the computer details or your infrastructure details. It needs a utility installed here as well in the system. So these kind of utilities are called as Prometheus targets. The very famous example of Prometheus target is node exporter. What? Node exporter. You have another called as C advisor as well. So basically, if you want to simply install Prometheus on a system, that is fine. You can directly do that. But if you want to go ahead and get the details of the system, okay, of a computer, of an EC2 machine, then a node exporter has to be installed, which means a Prometheus target has to be set up on your particular virtual machine. Now what happens? These Prometheus targets are installed, can be installed on 10 virtual machines as well. Okay, one Prometheus, okay. Then you can have different node exporters. That is your Prometheus target node exporter. This can be installed on different system, and these node exporters are going to be called within Prometheus. How? With the help of a Prometheus.yaml file. Within the Prometheus.yaml file, you are going to mention the installed node exporters, okay, depending upon what you want to extract. Okay, let's say you have 10 systems and you want to continuously monitor your all 10 systems, then in that case the Prometheus target, which are nothing but the node exporter. Okay, one of the famous example of the Prometheus target is the node exporter. These node exporters have to be installed on those 10 virtual machines and simply would be connected in the Prometheus.yaml file. Whenever you connect Prometheus exporter with the Prometheus YAML file, the name given to it is called as job. Just like in Ansible, if you guys have learned, in the Ansible, you go ahead and define the task, correct? In the same way, in the Prometheus.yaml file, you will tell that there is a job and you will connect these node exporters to the job. Okay. So these run on different port numbers. We are going to see it very soon. How we install this, how we set up this. Okay. So this is the very first thing which is called as node exporters. Okay. The very popular example I have given you is the node exporter for this Prometheus. Okay. This is one thing where you want every time at an every interval, okay, at every time duration, you want continuously to track a monitor. You use Prometheus targets like node exporter, as I told you. Apart from that, if there are short-lived jobs, okay, Short-lived jobs are basically the jobs which exit very quickly, okay? But there could be a situation you might have to go ahead and track each and everything. Then in that case, by default, what happens, okay? These jobs are stored in push gateway. So these are also going to be tracked by targets only, okay? The target will have two kind of jobs. You can understand it in this way. One, the short-lived jobs, okay? One is the normal job, which stays for some duration in your system. So the short-lived jobs are always pushed to a kind of a is a kind of an API, is a kind of an storage. You can understand it. So such kind of jobs are pushed to the push gateway, so that it always remains to till the push gateway, because these jobs would exit very quickly, so there won't be any kind of history. So whenever there are any kind of short-lived jobs, then the targets, basically the targets which are able to track these short-lived jobs, immediately push the data to the push gateway, because this push gateway is capable to store the details of the jobs which are no longer existing with us, okay? So there are two things that we have learned. First of all, simply targets accessing the job and accessing the matrices and giving it to Prometheus, or you can say Prometheus connected with the Prometheus targets like node exporter, to pull the matrices of the system. These targets are installed on the devices that you want to track. Device 1, device 2, device 3. Apart from that, if there would be any kind of a short-lived job, then this target is going to basically track such kind of jobs, and it is also going to push it to push gateway, because since these are very small jobs, no history would be maintained for that, so their data is immediately given to push way. Now Prometheus also checks for the push gateway, okay? So either the job is long, directly getting from node exporter, or it is getting from push gateway. The jobs, the details, the matrices would always come to the Prometheus server. This job would always come to Prometheus server. This. Fine. Now, within this Prometheus server, okay, you have three main components. Retrieval. This is the main component which pull matrices. So definitely the Prometheus server is pulling the metrics, but which component within the Prometheus server is responsible for getting the matrices, for pulling the matrices? That is retrieval. Now, these matrices also have to be stored somewhere. So that is what you have TSDB, which means time series database. What it is? It is time series database. Okay. Now to store these kind of matrices over here in the time series database, you can use HDD, hard disk drive, as well as the SSD. SSD is quite faster as compared to the HDD. Then we have the HTTP server. Now why we have the HTTP server? So Prometheus server runs on a specific port. It runs on a specific port. So for having API, for its connectivity with the various other tools, as Grafana also has to be connected in the future, it would need an HTTP server. It's simply anything that is capable to run on internet, that you can view over the internet, would require some HTTP or some HTTPS server. So the third component of the Prometheus server is the HTTP server. Okay. Apart from that, Prometheus can also use the service discovery as Kubernetes or the file add to automatically discover new targets. This is a very rare scenario that we use over here. Very rare, okay? Because whenever we go ahead and decide node exporters, we keep a track of it, which are connected to the Prometheus servers. Fine. Now you can see that Prometheus server has a web UI, due to which you are able to access the Prometheus over the Chrome. Then either the Grafana or any data visualization tool can be connected to the Prometheus server. Point number one. PromQL is the language that is used to find the matrices. PromQL. Okay, it is a language. It is a language. I'll show you when I will be writing it. Okay. The third is the API client. In case if you have any third party tools, and you want to connect to the Prometheus server, that is what it has, API clients, which means any third party tools can be connected. Not only this, then you have Prometheus alerting, which means if any condition, let's say you have written a query and the metrics that you got is not meeting a specific criteria, then you can also generate alerts on the email ID, on the pager duty, or to any of your connectivity. Which means if the metrics that you are finding, so in short, what is the logic? Let me tell you. Here we go. So basically what you have a system. Okay. Here in system, you will have a node exporter. What is the job of the node exporter? To track, to scrap this system matrices. This system metrics. Now this system, okay, to this node exporter will be connected to the Prometheus, which will be installed in this system. So the node exporter will be connected to this Prometheus using a prometheus.yaml file. Now this Prometheus will be connected to the Grafana. Now Prometheus can be also accessed at a specific port, let's say 9090. Apart from that, Grafana can be also accessed on a specific port, let's say called as 3000. So either you can run here the queries for which you would be using POMQL. Whatever the query you would be writing here, it is going to check to the node exporter, and node exporter will scrap the same queries for you, and it is going to return back to you. This can be displayed here on port number 9090 as well, but Prometheus does not have that smart pictorial representation. That is the reason these queries then are forwarded to Grafana. So we'll move towards the hands-on. Okay, so I'll have an EC2 instance. To create an EC2 instance, we will go with at least T2 medium. There is no such limitation or restriction, but since we are going to install two tools, I need a good RAM, a good processor, and a good storage. So I'll just launch a machine. I'll name it as Akshit Prometheus Grafana instance. We'll choose Ubuntu. 24 version would be sufficient. I'll select T2 medium. Keep your login. I would have a keep here. Network settings will open all the ports. So I'll just click on edit. I'll select all traffic. Storage I'll change. I'll keep the storage to 12 GB. Okay. So as for now, I have just created an EC2 instance. We'll click on view all instances. So you can see this, our machine is under the initialization process. The status check will be passed in few minutes, I believe. Fine, I'll do one thing. I'll just open it and I'll try connecting to it. I'll click on connect and we'll click on connect. The very first thing what we are going to do is, okay, before we start setting up all this, we'll also have a look on the case study, what it says. So the case study is about infrastructure monitoring Prometheus and Grafana in action. So the problem statement is in which situations you guys would be using this Prometheus and monitoring. Okay, Grafana says in today's rapidly evolving infrastructure landscape where systems are dynamic, distributed on, often containerized, for ensuring optimal performance and reliability has become increasingly challenging. Organizations require deep visibility into their infrastructure to proactively detect issues, analyze performance and trends, and respond to system anomalies in real time. That's true. To address this, there is a need to implement a scalable and efficient observability stack that can continuously connect, visualize, and alert on critical system matrices such as CPU load, memory usage, and system load averages, which means all the relatable or the needful CPU or your infrastructure details. This case study focuses on deploying Prometheus and Grafana in a production-ready environment to establish a robust monitoring and visualization framework for real-time infrastructure health analysis. What is going to be the objective? To implement a robust monitoring solution using Prometheus and Grafana for real-time visualization, analysis, and alerting on critical infrastructure matrices like the CPU load, memory usage, and the system performance. So with our task, we are going to perform all such things once we have done the installation. We are going to set up a system where our Prometheus and Grafana is going to continuously monitor our system. It's all the required load, the usage that are going to be important for us. Not only that, we are also going to visualize these metrics into the Grafana by executing relevant PromQL queries. What we are going to analyze, the historical, the past trends, the real-time performance, the metrics correlation over various time ranges. Okay. Then we are going to also set up the alerts in the Prometheus to proactively notify when the system load average exceeds 90% of the total CPU capacity. Okay. Not only this, we are going to additionally check other thresholds for the memory and the other CPU utilization breaches. So that is what we are going to do in this case study. We have an EC2 instance, so let's start with it. Okay. So this monitoring tool is installed on the operating system only, and if we are not using cloud, the process will be same. The process would be always same. This tool is going to be installed on operating system, that's true. Just like your Jenkins, just like your Ansible. Okay, they also need an operating system. That is the reason why you get that. Do you want to install it on the Debian version or the Fedora version or the Ubuntu version or any other versions? They have different installation commands for different operating system. In the same way, you will have it for Prometheus and Grafana. However, installing it is a slight different way. You do not directly get commands. You have to download the tar files and then you need to extract them. Okay, so that is what we are going to see right now. So first of all, I'll update the machine, sudo apt update. This is much required. And the very first thing that I'm going to do is I'm going to install Grafana on it. Okay, we will keep our monitoring tool ready. Then we will install the tool which is exactly going to pull the matrices. Okay. So for Grafana installation, we can simply come to the Grafana here link. Just type for the Grafana installation. Here we'll come to install Grafana. You can see Debian or Ubuntu. Okay. So this is the link. So here you will get all the commands. Installing Grafana is quite easy, not tough. Okay. So you have the prerequisite packages you can check, okay, that you should have. However, this your system would always have it. But still you can just copy and you can try running on it. You can paste this. For the very first time, I would always advise you guys to please install it one by one only instead of creating a bash file. So that in case if you're getting any error, you would be aware that, okay, which exact command is giving you an error. So this is another command which is just creating a separate directory for the Grafana management. And then you are accessing a URL, okay, which is the JPG key of the Grafana. Once this is done, we are going to import. We have already imported the JPG keys. Now we are going to add this to the repository. The key has been added. For beta, these are the stable releases. These are for the beta releases. Okay. So it's completely up to you which one you want to go ahead and run on it. It's completely fine. Either you go with the latest version, the beta, which means we are which are having the preview features. Okay. So I'd always recommend you to go with the stable one. Then you can give an update once again to the machine. That is what it is asking for. After that, we are going to install the Grafana. Sudo apt install Grafana. So it is going to occupy your 169 MB. That is the total size of the Grafana. And if you want to install the Grafana Enterprise, you can install that Grafana Enterprise, which means it is going to be the paid version of it. Okay. So now once this is downloaded, we will check first of all that whether the Grafana has been installed or not. So sudo service status, one second, yes, okay, misspelled it, service, grafana.service not found. So what we will do is sudo systemctl status grafana server.service. So the name of this is not grafana status but a grafana server. Okay, so it is inactive by default. You can see it is inactive by default. So for that we need to enable it. Okay, so we are going to just make it start. We'll wait for a few seconds and we'll check the status once again. The Grafana is now active, which means on the top of your machine the Grafana has been installed. We'll just copy it. We'll open a new tab. We'll access it on port 3000. And here you go. So you have downloaded your Grafana, and by default the details are the username and the password is admin. So once you do that, it will ask you to reset your password. It is asking you new password. So give your password that you don't share it with anyone else. So this is what it is suggesting you. However, we are going to give something else. The Grafana dashboard has been properly created. In case if we have to create our infrastructure, okay, then what is there? So in a system we have installed Grafana, but Grafana is a monitoring tool, correct? Grafana is a monitoring tool. It needs a data source. What? It needs a data source that should go ahead and give it the matrices. So what we are referring to, basically, this is our monitor, this is our system. On the system, port number 3000, port number 3000, okay, Grafana has been installed. Grafana has been installed. Okay. Now, Grafana is a monitoring tool. Okay. Monitoring means visualization tool, graphic tool. Collaboratively, Prometheus and Grafana are spoken as monitoring tool. Okay. So basically, Grafana is the visualization tool only. I'll take my word back. So it is a visualization tool. That is fine. Visualization tool that will display the matrices in the form of graphs and better insights the way you like. Okay. Now here, have any graphics, have any graphs in this Grafana? You need matrices, no? Yes or no? You need matrices. You don't have it. You don't have that matrix. Correct? Why? Because you need a data source. You need a data source. A data source to the Grafana from where the matrix will come. For that, on this machine, you need to have Prometheus. You need to have Prometheus. So our this part is ready, but it is useless until unless our data source is not ready. That is what we are seeing right now. Okay, we'll come back. Perfect. Now here you can see an option which is called as connections in the Grafana. In left hand side panel you have just few options. The bookmark is your normal bookmark which you want to go ahead and save. You want to use it more often. Start basically is the one which you more like, just like a Gmail function where you can star your emails that you like. Dashboard we are going to create. I'm going to teach you how to create dashboards. Explore is basically running queries. Either you can run query in Prometheus, but once Prometheus is connected to your Grafana, you can also run your queries here directly in Grafana. That is what an advantage is given to you. I'll come to you process by process. Okay. Drill down, I'll explain later on. Alerting, you can generate alerts over here. In connections, you can see the connections, you have data source. Correct? Can you see everyone data source? So you can connect it to Google Analytics, you can connect to Adobe Analytics, you can connect to Amazon Aurora, you can connect it to Astra DB, you can connect to Amazon Redshift, okay? You can connect it to AWS X, have Azure DevOps connected to it, you will have Cloudflare. There are multiple data sources that can be directly connected to it, okay? And you can go ahead and track them. For us, what we have to go ahead and find out Prometheus. So in data source, we can click on add data source. Within add data source, we have Prometheus to connect. Okay. But do we have any details? Do we have any details? Where is our Prometheus or something? Currently not, correct? Because we haven't installed any Prometheus as for now. So data source, we'll leave it right now. We will leave it, okay, because we don't have the details of it. First of all, we'll come back to our instance, and what we are going to do is we are going to install Prometheus, correct? Now installing Prometheus is quite easy. It's better that you always create a user practice that everyone should not be able to access your Prometheus. So we'll just create a user first of all. So sudo user add hyphen no hyphen create hyphen home hyphen shell bin shell in the build location false Prometheus. You can have a user created, that's all. Then you need to create directories for Prometheus, mkdir etc slash Prometheus. Okay, so you are going to create a directory at the etc location for the Prometheus. Similarly, you will also create in var lib to save the logs. Okay, sudo mkdir, one in etc, one it is in var lib, and then same. So we just created a user and we have just created a directory in etc, and now we are going to create a directory in basically your var lib. Now once these directories are created, what we need to do is we need to go ahead and download the package. Okay, so where you can get the relevant package, let me take you here, prometheus.io download, this one. Now see the latest version that you can see. First of all, you don't have to install for Darwin. Darwin is for Mac. This is for Windows. This is for Linux. Since we are practicing for Linux, we'll do it for Linux. But however, let me tell you, there is a change in the version 3.3 of Prometheus. They have removed the default working of it, having console libraries and everything. So I would say you should not go ahead with the 3.30 version. Instead, use the stable version, and that is this 2.53.4, the Linux. This one. This is going to be the stable version. So what you do is you simply copy its link address, come here to the EC2 instance and run wget and paste this URL. Okay. So you'll just hit enter and it will start downloading that particular tar package from this location. Refer 2.53. 2.53.4 version. We'll check our EC2 and we'll do ls. Prometheus tar file has been downloaded in our system, correct? So we are going to extract it. For extracting the command, what we have tar for the tar files, and then we have the version, the way you want to go ahead and basically unzip it. So tar -xvzf, and then the tar file, the same tar file name. If you will press tab, you will get the entire this one. So it is going to extract all the libraries, all the files which were present in the zip file. Okay. Now what we have to go ahead and do it, we have to copy all these files. Okay. So cd Prometheus will go within it. We can see this. You have console libraries, you have consoles, you have Prometheus, you have prometheus.yaml. Now what we are going to do, we are going to copy these files. We are going to copy these files, okay, into the correct location, that is under user local bin or respective files in etc Prometheus, like consoles and everything. So different files which are unpacked here, we are going to move it at a different most relevant location of your Linux operating system for its proper functioning. So the very first thing is, let's say we are going to copy the Prometheus folder, this Prometheus, okay, to user local bin. Okay, sudo copy Prometheus in the user local bin. One done. Then there is something called as prom tool. Prom tool, we are also going to move. I have moved Prometheus, I'm moving prom tool. The prom tool would be also used at the same location, would be also moved to the same location. The prom tool, the Prometheus folder has been moved. The prom tool we are moving right now, okay, in the same location. Talking about the consoles folder, we are going to move it. Sudo cp Now this is a folder which is not empty. So we will use -r, okay, for the recursive movement of it. Okay. Then we are going to move it under the etc Prometheus. Where? Not in the user location bin. The consoles have to be moved in etc Prometheus. If you remember, we created a directory over here, mkdir etc Prometheus, correct? So that is where I am just copying this consoles folder. I'm going to move this consoles folder to etc Prometheus. Okay, fine. Now once this is done, we are going to copy our next file, which is your libraries. So sudo cp-r console underscore libraries, and this is going to be moved under the same location, which is etc Prometheus, this one. Perfect. And now the last, which is the YAML file. No need of license and nodes, no need of moving the license and node. These are all theory. So Prometheus dot YAML, we are going to move under the etc and then the Prometheus here. So we'll just go to cd etc Prometheus just to check whether all these files are being moved or not. So we got the consoles, we got the console libraries, we got the Prometheus.yaml, which means everything has been properly moved into this. Okay. Now once it has been done, we'll go back. We'll simply go to cd home ubuntu ls. We have this unzipped file, we will be there only. Okay, where we have seen all these files. So just we are here back at the page where we were working before. Okay. Now what we are going to do, we are going to give permissions. Okay, we are going to give the permissions to the entire Prometheus and everything. Okay. So see, we have just copied all these files. We have just copied all the files. Now we are going to give them the permission. So we are going to give the permissions to the folders, all these permissions. Okay, so once this has been done, the permission has been done, what we are going to do is we are going to edit the prometheus.service file. Okay, so we'll just check sudo nano etc. In system you have the service, systemd, you'll have system, you'll have prometheus.service, or we'll just do ls. We'll come here, we'll just go to this location, see how many services we have. We'll have a Prometheus as well. We do not have a service file yet for the Prometheus. So what we'll do is we'll just go back. We'll just look for ct etc Prometheus ls. We have the file prometheus.yaml, sudo nonno prometheus.yaml. We'll open this. So in this YAML file, there is no such requirements that we have to go ahead and change. So let me try accessing this service somewhere here. etc systemd system. Well, let's do one thing. We'll try running this service now. Sudo systemctl daemon re-execute. This is, I'm just trying to run the daemon once again. System daemon reload. Then we'll have enable Prometheus. Sudo systemctl enable Prometheus. Says unit file Prometheus service does not exist. Okay, we'll go back first of all. Just look for this file. Okay, the file hasn't been created yet for Prometheus. That should have been created. Give me 1 second. Let me go ahead and troubleshoot it once. We have the package. Fine. We have this package. We have copied all the files within here. Okay, I'll just copy the files once again. The file should have been copied. We have to give the permissions. Okay, let's do one thing. We should be able to create a file then. Systemd system and Prometheus dot service. Okay, so if we do not have a file, we are not getting a file by default, then what we are going to do, we are going to create this file. Okay, Prometheus dot service, and I'll tell you what content has to be added to go ahead and make sure that the Prometheus service keeps everything in running. So what basically we have done till now here is we have installed a tar package, we have unpacked it, we have copied all the files to their relevant location, and we have given the permission to it. Now, just having the tar packages or the files is not going to help us. Then in that case, since we want Prometheus to be running and anything to be in a running state, we need to be it in a service form. So that is the reason why we are creating a Prometheus dot service. Okay, I'll just copy this. We'll just copy this description, wants, what do you want, service, user group, type. Okay, you'll just copy this as it is, and we are going to paste it over it. Okay, so basically it is telling that whenever you are going to start, okay, you have to go to the user local bin Prometheus folder. You have to check for prometheus.yaml, you have to check for Prometheus folder, you have to check for Prometheus consoles, you have to check for Prometheus console libraries. Correct? These are the files basically we have moved. That is what we are telling it, that please consider them while running as a service. On these libraries you have to run as a service. We are going to save and exit. Okay, and now we are going to just run the commands. Okay, let's say sudo system ctl daemon re-execute. We'll give reload. We'll start our services. Well, I have these commands, you'll have it. So see, the enable service has been enabled, and we are going to start the Prometheus. Luckily it should start. Now let's go ahead and check whether it has been started or not. So for that, sudo systemctl status Prometheus. Okay, systemctl, misspelling. So you can see here we have it in active, up and running. So let's see how does the Prometheus looks like. Okay, so we'll just copy this IP address. We'll go to the port. We'll look for the 9090 port. So 9090 port is the port where your metrics run, your Prometheus gets installed. Okay, fine. Now you can see over here you have the status. So alerts, basically if you are setting any alerts here, you can also set alerts over here, but since every data would be in Grafana, so it's better to go ahead and create alerts also there. Because see, whatever you can do from Prometheus can be also done from the Grafana that we have installed. Okay, can be also done from the Grafana. The best part over here is then why to go ahead and switch to these tabs again and again. Since this is your learning time, so I'm opening each of these portals. However, there is no need to separately access the Prometheus and Grafana as for now. Okay, so whatever the queries that you want Prometheus to fetch from your system, okay, you can go ahead and do it, write the queries here, as well as you can come to the Grafana and you can run the queries here as well. I'll show you, but as for now, this is how we have installed the Grafana, in which the data source we haven't added it, like the Prometheus into it, because we were not having Prometheus. But as for now you can see we have installed Prometheus, which is running on port number 9090. Here you would be able to see graph, here you would be able to see status, and that is something which is more important. Okay, so in status you have to come and check the targets. What you need to come and check the targets. So localhost is where my EC2 instance, where my Prometheus is up and running. So since you can see that the state is up, which simply means that yes, the Prometheus is successfully is running on my local host. But let me tell you, you cannot go ahead and track system properties just with Prometheus. No. What I told you, a node exporter, a Prometheus target should be also installed in the system to which you want to track. It will keep scrapping and your Prometheus will be coordinating with that target again and again. Correct? But before we go ahead and jump into the process of getting the details, okay, of a system that is mentioned in our case study of our infrastructure, let me show you a few things. Okay, so can you see the matrices are going to be displayed over here where at this point. So I'll copy this link and I'll try to open in the browser, but as soon as I do it, okay, if I will do this localhost 9090, this Chrome browser will understand my Windows PC. Correct? It is going to take it as a Windows PC, and in Windows my Prometheus is not running. So instead of localhost, I'll give the IP address of my EC2 instance. I'll copy it, I'll come here and I'll paste it. Now, can you guys see some kind of matrices? What exactly it is? What exactly it is? Let me tell you. Right now, these matrices are not coming of your system information. These do not belong to your system information. What Prometheus is showing you right now, the IP address of your machine, the Prometheus 1990 slash matrices, okay, what it is showing, how the Prometheus application is working on your system. How the Prometheus application is working on your system. Basically, this page shows Prometheus, which is built on Go programming language. Yes, these are the raw information telling that how Prometheus is working on your system. Let me tell you, Prometheus is working on the Go programming language, okay, and it is showing you how it is managing its own memory, okay. So I hope you can see this Go cycle automatic GC cycles total 9. This one. Go GC cycles automatic GC cycles total 9. It simply means that GC is the garbage collection. Now Prometheus application, since it is a monitoring tool, it scraps the information. Okay. So what it does, it has to check at every 1 second, 10 second, 15 second, correct? In case if it will not do the garbage collection, then it is going to waste a lot of memory. So that is why by default the Prometheus has a garbage collection feature. The working is basically has it's the garbage collection feature. What it is showing you right now. So basically here it says 9 automatic garbage collection cycles have been completed by the Go runtime since the app started. This one. It says 9 times your application has done the garbage collection cycles on your system right now. On your system. Then you can see Go GC cycles, forced GC cycles total 0, which means no manual intervention or no forced garbage collection cycles have been performed by triggering the application code again and again, which means whatever the garbage collection process Prometheus has done on your PC for itself to keep up and running and keep itself alive, it has done 9 times. However, manually it was not being triggered a single time, because we haven't done it. We haven't triggered it again and again to go ahead and perform the garbage collection. Similarly, you would have duration seconds count here. Go GC duration seconds count is total number 9. So apart from that, you would also see here quantile. See here, the total count is 9. Apart from that, quantile 0, quantile 0.25, quantile is 0.5, quantile 0.1, quantile is 1. So what basically this quantile and this raw information is being generated by Prometheus? What it says how long garbage collection process took. How long, for how many seconds garbage collection was on pause, just to think, just to process, just to perform, just to happen. Okay, so in the quantile 0, as you can see, okay, 2.52 milliseconds, 0.25, 3.2 microseconds, not milliseconds, sorry. Here the total sum count, here the total second sum count you can see was total these many microseconds. So basically it is telling you that your garbage collection is very fast for this Prometheus application. Similarly, you would have Go GC, where we have it, gum limits. Here, see, Go GC gum limit bytes 9.2233. Now, what does this mean? Okay, the word gum limit is basically it is telling you the memory limit is set to a very high value, which is negligible. You can see this 9.223372 to 036854. Then you have E plus 18, which means essentially there is no limit set on the Prometheus application to run, to perform on this device. Now similarly, there would be heap memory, there would be different metrics. But are these the metrics useful to you? Let me tell you, these metrics are only useful to you in case if you want to understand that whether your Prometheus app is working fine or it is not working fine. So this is good for the people who would like to monitor how fast their Prometheus application is tracking the system. Because if the Prometheus is itself down, how it is going, how it will be capable to go ahead and give you the correct results of the other interested queries that you would be looking into, correct? Not only this you have accessed in the browser. In case if you want to access it in within the machine, that's quite simple. What you can do is curl localhost port number 9090 slash metrics. So the same things that you were seen on the browser can be also accessed here. Now let me show you some graph over here. So we'll come here, status we have checked, it is up and running. It is able to show you that, okay, what are the Prometheus matrices. It is showing the matrices of its own application as for now, not for the system, because you haven't set up the node exporter. Okay, you haven't added any target here, which is connected to a machine where you want the things to be scrapped. But still, let me show you a graph how the Prometheus is working. So go to the graph. In the graph, you have to run here the expressions. Okay, you have to run the expressions over here, which means the POM-QL query. So let's say process CPU seconds total. So it already has a list of lot many expressions. You can just look for it. So all the relatable metrics. So right now the matrices that are available are only available of the Prometheus application, because that is what is running on your system, and your system has not allowed any permission to fetch Prometheus any information, because you need a third utility for it. So as for now, I want to see the CPU seconds per total. Okay, what does this matrix tell you? What does this matrix tell you? The total number of seconds that the process Prometheus itself took to run, which means basically the total number of seconds is spent on CPU by Prometheus application. Okay, so I'll just run it, execute it. Okay, this is a tabular format. It shows you, yes, it was able to connect. This is the graph. So basically, as per my system time, not my local time, but my system EC2 machine time, it is telling that approx, I believe, from last 10 minutes, 10 minutes from the moment we have installed it. Okay, this is the continuous graph. It has been continuously increasing this way. Let me change this to 15 minutes, 15M. This time for last 15 minutes, the graph would change. So what it shows, basically your Prometheus has been continuously utilizing the CPU. Here it was 0.19, here it is 0.2, 2.1, 2.3. I hope you guys can see the information changing, the actions getting added. Correct? Now, you would think that the Prometheus application is continuously running, and that is what it is continuously increasing the CPU seconds. Why it is always in a straight line? Why it is always increasing? The Prometheus is continuously running, that is one thing. But why it is not a flat line? It should run simple straight line. Why it is increasing? Why it is in the increasing format? See, this query that we have run is called as a counter metric. Is a counter metric. Whenever you basically go ahead and find out, okay, matrices where you are figuring out the total CPU usage by a specific application, it is referred as a counter metric. So let me give you an example why it is increasing again and again. Okay, so let's say your app used 0.5 seconds in the very first second. Okay, in the very first second, okay, of our time, the Prometheus application took 0.5 of the CPU, used 0.5 second of the CPU. Then in the very next second, okay, it would have used 0.2 seconds, let's say. It might have used 0.2. Then let's say it would have used 1 second, 1.0 second in the very next second. Okay, So what happened? In 1 second, 0.5. In the second second, the application used 0.2 to run, 0.2 seconds to run. Then in the third second, it used 1.0. So if you will total it, okay, how much it is? It is 1.7 seconds. So what is happening in every 1 second? Whatever it uses gets added on, in this metric, in this graph, in order to display you for every second. For 1 second, let's say it was 0.5. In the other one, it happened 0.2. But in the 1 second, what it will do? 1.2 from here, 0.2. Understood? Then 1 in the third second. In the fourth second, this. That is the reason why you guys are getting it in the every time it in the increasing order. In the increasing order. Okay. Now you can see over here, this application is fine, everything looks good. We are able to see the graphs of the matrices, okay. But still, it is not that interactive. It is not that interactive. Then in that case, what has to be done? Now let me repeat the same thing on the Grafana dashboard. Okay, I'll just close it. Okay, let it be there here. Okay, now let's connect Prometheus and Grafana. Let's connect Prometheus and Grafana. So we'll come to the Grafana dashboard. We'll come to the data source. We'll search for Prometheus. We'll open it. We'll tell where our Prometheus is running. It is also running on HTTP localhost port 9090. Correct? This is the location where it is running. Then authentication, keep it no authenticated as for now. Rest, these are the interval behavior. How often do you want it to scrap? Every 15 seconds do you want to scrap Prometheus? Okay, like check Grafana. Grafana will be checking Prometheus, the details coming from Prometheus every 15 seconds. Every 15 seconds. Okay, that is what it is checking over here. Rest looks everything very good. No issues. Okay, performance options you have the Cortex, Mimir, Thanos, the better performance and the better one that you will have. Okay, now that's fine, that looks good. You will just click on save and test. So it says successfully queried the Prometheus API, which means Grafana is able to easily find out, easily able to access the Prometheus. Okay, now let me show you the same thing. I'll just click on save and test. Fine. We'll come back here to explore section. Explore, everyone. Okay, now the query I was running in Prometheus. Okay, the query I was running in Prometheus. Now since the Prometheus is also connected to the Grafana, in Grafana also we should be able to run the queries. Okay, so for running queries in Grafana, which basically eliminates running any queries here because it is not that interactive. So what you will do is you will come here in the Grafana, you will come to explore. You have already connected the Prometheus, which means whatever the data Prometheus will have can be also accessed in the Grafana. Now here there are two modes. There are two modes. One is the builder, one is the code. Okay, so when we click on the code, here you can write the POM-QL query. Here you can write the POM-QL query. So the query that we have written over here is this: process CPU seconds total. I can copy and I can paste it over here. Point number 1. Either since you guys are very new to it, you do not know what exactly the query you need to run here or what would be the syntax of the query. So just click on metrics browser. When you click on metrics browser, here you would be able to see each and every information. Now definitely let me tell you, you need to go ahead and learn, you need to go ahead and explore yourself that what does these different queries mean. There would be n number of queries, there would be n number of customized queries or the custom queries. Then in that case, what you need to explore a little bit. However, you just come here and search for CPU and it will show you the CPU related. So this is process CPU seconds total. The same thing, how much, like, no, see, total user and system CPU time is spent in seconds. The Prometheus application has how much spent time on the CPU. Just select it. Once this is selected, you will come here where you have an instance. Come to the instance, click on instance, and you have the local host. So basically it is going to tell you that, okay, the machine which is running your instance, basically your local host 9090, how much the time has been invested on it. There is one more option here apart from instance. There is something called as job one. When you click on job one, it shows Prometheus. Now there are two options. The query you have already selected here, CPU, okay, process CPU seconds. So when you don't select job, when you select instance and you select here this localhost, it is going to show you that how much this application, okay, basically has invested time on it. So we'll just run it. We'll click on use query. So you can see over here. Now it shows the correct time. It shows the correct time from 4:15 onwards till 4:35. Till 4:35, it has been a continuous increase. Can you see the same graph from the Prometheus coming to this? Which means if you have connected your Prometheus, okay, to your Grafana, there is no need to go ahead and check things over there. You can directly check things here itself. Okay. Now, similarly, you can just change the time. You have a lot of things to do. Okay. You just check for last 15 minutes. That is the part of your case study. So you can see how it has been increasingly going. Okay. Not only this, you can also convert it into form of bars. You can look at in the points. You can look in the stacked lines. You can look for the stacked bars. So this is the query. This is the graph. This is the result that you are able to find. Now, similarly, when you click on builder, this is how it shows. Just it has converted it into a button form. See, metrics is process, label is instance, which is localhost 90. In case if I'm converting it into a job and the job name is Prometheus. So now what we are checking, how much job Prometheus has invested its time on process CPU per second. Let us run this query. So you can see a slight change as compared to the Grafana spending time on your CPU as compared to your Prometheus. So your Prometheus has been running from 1614, 1614:30. Okay. Whereas if I'll change for your instance of your local host of your Grafana itself, a slight change you can see. However, everything almost remains close. Now to get the better insights, okay, so why to see that how much Prometheus is working good on your system? We got to know that, okay, the Prometheus is working enough, like, no, is working fine on your system. So what we will do is, now we are going to perform our case study in which we are going to scrap the details of our infrastructure. Okay, we are going to scrap the details of our infrastructure now. That what is the CPU load, what is the CPU percentage, and everything. Okay, so how to do that? First of all, we need to go ahead and install the node exporter. Okay, and then the node exporter will have to be connected with the Prometheus. And since Prometheus is already a data source of Grafana, there won't be any need to come here and run queries. We'll directly come to the Grafana, we'll explore it, and we'll do everything. So first of all, this is how we have seen the graph chart, the same graph chart in the Prometheus for how Prometheus is working on CPU. It was working great, and you can also check it from this IP 9090/metrics. That can be simply done. Now let's see the real-time things that you would be tracking. Once you have made sure that Prometheus is working fine on your CPU, the garbage collection and the process is continuously up and running. There is a continuously increase in the graph, which means your application is running very fine on the CPU. Okay. So now I'm going back to the EC2, and what we are going to do is we are going to install a node exporter. What? A node exporter. Let's do that. So first of all, you need to go ahead and create a separate user if you want to create. So sudo user add -no create -home. Whatever the user you want to create, you can do that. -shell win false node exporter. One more thing I would like to show you, whenever we are coming to this metrics here, let's say I'm coming to here to the metrics, where I click on metrics browser to search for the metrics available, you can see there are no metrics that are starting from the word node, The reason being here is the node, all the queries that start from the word node will be coming from the node exporter, okay, to the Prometheus. Since node exporter is not installed right now, you cannot see here any node exporter kind of metrics. Okay, coming back to this EC2 instance, so we have created a user. Now what we are going to do, we are going to install the node exporter. Okay, so to install the node exporter, there is a GitHub link. So Prometheus, what you need to search is Prometheus node exporter. This GitHub link, you'll come here. Now you should have releases. Let me look here. Here you have it. Just click on it. So you can see over here, there is a node tar package. Okay. Now, if you guys are aware, the EC2 instance are the AMD. In case if you want to check, come to your instance and you can search here in this AMD. It would be displaying here the AMD. Whatever you instance, whatever the instance you create, it is an AMD. AMD will search here just. You can see here the AMI name is AMD. That is the reason you will come to this GitHub link and you will just look for the Linux one and the Darwin one, this one. So I'll just copy link address. We'll come here, we'll search for wget. And let's do one thing. Let's not install the node exporter here within this location. Let's go back, ls. Okay, we'll install the node exporter here. So wget, we'll paste the link and the node exporter is getting installed, downloaded in our system. We're just going to unpack it, tar-xvzf and the node exporter tar.dz. So you can see this, the node exporter has been extracted and these are the files that have been downloaded. Okay, the license, the notice and the node exporter part here. Okay, so what we are going to do, we are simply going to give the permissions. First of all, we are going to move it. We are going to move this node exporter to a user local bin. That has to be done with every tar file that you do. Okay, once you have extracted it, what you do is sudo move, either move or copy. Both things work well. Look for node exporter. Okay, AMD64, and we'll try to move it where? In the user local bin. Okay. Now what we are going to do, we are going to give the permission to it. Sudo node exporter node exporter, where our has been moved in user local bin node exporter. We have given the permissions. Okay. Now what we are going to do, we are going to create a service file. So when we installed Prometheus, the Prometheus files were unpacked and they were moved to the correct location. Same thing has been done here as well. Now what we are going to do, we are going to create a service file for the node exporter to keep it up and running always. So sudo nano /etc system d system. Within the system you will have node exporter dot service. So we are going to create a node exporter service. We'll just check the spelling. Node exporter service. So in this service file, you will add this document. We'll have this document. We'll just copy it and we'll paste it. I'll save and exit. Okay. And now what we are going to do, we are going to enable the node export service by just running sudo system ctl daemon re-execute system reload sudo system ctl start node exporter service, and then we are going to enable this service. Okay, so whenever you run an enable command with any of the service, what happens, it creates a sim link with the system. Okay, exporter service has been up and running now. We'll just check for it. So sudo system ctl status node exporter service, it shows it has been failed as for now. Why? So we need to go ahead and check it. We'll just try to give it a start once again. So what it says, node exporter service Started node exporter service main process exited. Okay, so we'll do one thing, we'll just repeat this process. Okay, we have this node exporter service. Just come up here once. We'll just create the user. We have this user, it already exists. We have already unpacked this file. Okay, 1 second. We'll clear this ls. We have unpacked this. Let us unpack it once again here. Okay, the file is unpacked. In that case, we are going to move it. Okay, sudo. It was not moved within the folder, so that was wrong thing. Sudo mv node exporter dot amd, and then you have to use this much data. That a node exporter has to be created first. Okay, the node exporter has to be moved to user local bin. Okay, the node exporter folder within it has to be moved. Okay, that we have missed last time. We'll give the permissions to this node exporter, and after that we are going to create this service file in the node exporter only. Okay, you have this data. I'll just remove this and I'll just copy paste it once again. We'll paste it, we'll save, and we'll exit. This time it should run. Let's see. Let's try accessing it on 9100. So our node exporter, which is a Prometheus node exporter, has been installed in our system, which means now the architecture looks like in this way. This is my PC. In this PC, to track PC details, I have a node exporter. What? I have a node exporter, Prometheus node exporter, which is running on port number 9100. 9100. What it is going to do? It is going to scrap system details, my infrastructure details. Okay. And this node exporter is going to give all the details to my Prometheus, which is itself a capable tool where I can write my PromQL queries, and based on my QL queries, node exporter is going to scrap the details. Either I do it on Prometheus, or I have a Grafana where also I can run the PromQL queries, where I've already connected this Prometheus to the Grafana as a data source. So either I run here or I run the query here. Anyhow, I will get the same results. I'll get the same results. But yes, if you want a good visualization, Grafana has to be used, Prometheus has to be connected. But meanwhile, for Prometheus to get the PC system details, node exporter has to be connected to the Prometheus. So that is what we are going to do right now. Okay. So what we need to do for this, we'll go to the EC2 instance, we'll come back, and in case if you want to check the status of node exporter, that also you can do here. So you can see it is completely active and running. Now what we are going to do, we are going to configure, fine. I'm going to configure the node exporter to my Prometheus. For that, I need to go to the etc location where my Prometheus file is present. etc Prometheus ls. I have a Prometheus.yaml, correct? We'll edit this Prometheus.yaml. That we are going to mention a target of Prometheus, that where the Prometheus has to look to. Now within that, we are going to come to the scrap configurations. As I told you, everything that you add as a target or you want Prometheus to do, it has to be added under scrap configurations, okay, as a job. So here what we are going to do, we are going to copy the same way. We are going to define it as -job, job name, what node, the node details you want, the instance detail you want, okay. Then the same static configurations, static configs, and within this -target. Now the previous job was what? The previous job was, okay, that Prometheus was checking the local host directly, which means Prometheus was only able to go ahead and tell that, okay, how the Prometheus is running, okay, on this perfectly or not, okay. However, In this target, we are going to mention local host and pick all the queries, pick all the information which is being stored at 9100. That is my node exporter. If you remember, if you have just seen that, the node exporter runs where? It runs on port number 9100. That is why here in my prometheus.yaml file, I have mentioned that job name, static configuration, and the target is 9100, which means Prometheus has to reach out to the node exporter, and node exporter by default is capable to interact with the CPU details, the system information, and keep checking the details, they keep checking the stats and the information of the system. Okay, so I'll just save it and I'll exit it. After that, what we are going to do, we are going to rerun the Prometheus service. So simple sudo systemctl or start or restart prometheus.service. Simple. You'll hit enter. We'll come to the Prometheus dashboard. We'll come to the status. We'll come to the targets. Within this target, can you see right now the node is 0/1. You got a new option. It should be 1 by 1. What? It should be 1 by 1. Okay. We'll give a refresh once again. So my node exporter has been connected as a target to the Prometheus. Okay. Now it's completely up to you whether you run the jobs, whether you run the queries here regarding the CPU, or whether you do it on the Grafana. It's completely up to you now, guys. Okay. Now, let me do one thing. Now, let me show you how do we create dashboards. Okay. Now, we'll come here first to the dashboards. Okay. So, let me just show you one of the node exporter queries. Okay. So last time we came here, we searched for the CPU seconds, and the same we will come here and we'll search for node. I believe you can see number of node queries which were not present before. Correct? Number of node queries which were not before because node exporter was not working. So what I will do, node CPU seconds and then the total. What it does, this query shows total cumulative seconds the CPU has spent in various modes like user, system, being idle, and everything since boot. When the computer has your system, your infrastructure would have started from the last time, from the very last time. From that moment, node exporter is going to show you how much CPU has spent the total cumulative seconds on different settings. Now coming here, now you can see here job CPU 1 over here. So come to job name is node. Correct? The job name is node. Now since right now these queries are running under the Prometheus data source. Now within Prometheus there is something called as node exporter. So that is what it is showing right now, that okay, you can fetch the details from the node exporter. Okay, you will click on it and you will use query. You will click on use query. So can you see from this moment of time, the node exporter has been extracting the details. Okay. So I'll just change it. I'll just go ahead and make it of last 5 minutes. These are the graphs. So these are the details that are being displayed to you. Now, what is this green time? What is the blue time? The blue time is basically the idle time. What blue time is basically the idle time. Okay. You have the green, the processes that run and everything. Okay. See these many details that you get over here. The CPU, the instance, the mode, the total number of things are being running for it. Okay. But are you really able to understand these things? Are you able to understand this raw data? Not as such. I hope you might not be able to understand this raw data at the same level if you would have given some good idea about it, a proper naming, a numbering to it. Okay, then the things would have been quite easy. And for that, we create our dashboards. Okay. However, let's say you are running any query over here, like let's say you have used this query, you can click on explain. it will give you fetch all series matching the metrics and the label filters. Okay, what you can do, you can add it to the dashboard. You can create a new dashboard, add to a dashboard. Okay, new dashboard. So click on open in new tab. The dashboard will open, not the local host. The local host has to be changed by the machine's IP, where your computer is actually running. Okay, so basically you can come to the dashboard. Okay, click on create dashboard, and in the new panel, see by default it is taking the current query. So you can edit it and you can just name it. The name will be changed. Instance, what we have found, CPU usage from last boot. This is going to be your very first Akshit, or which instance we are tracking. We are tracking this. We will copy this and we'll give it as a dashboard name. Various insights to the CPU, to the infra. Click on save. Okay. So whenever you will go to the dashboard, you have a dashboard here for this machine, and you can see here that yes, there is one of the queries that have been provided to you. But this is tough. The tough in the sense that you are not able to understand these, like, no, these graphs, these points. What does this green line mean? Okay, however, you can see this. The mode is written as idle. The green mode, okay, that you can see over here. Please see this. When you bring on it, let's view it. In the last line, when you have the number 4873 in the pop-up, the mode is written as idle. Okay, which means your system was idle here. Okay, coming to the blue line, the mode was still, it was waiting, and these are the user operations that have been performed. Okay, so a lot of things can be done, but before that, let me go ahead and bring and help you to create all the relatable CPU matrices. Okay, now see, the point here is, okay, this was one that, okay, CPU usage, we have found that how much CPU time has spent being idle, being given to like no spending the time on user activities and waiting for the activities to perform with this respective pink, blue and green line. However, if you want the RAM details, the networking details and a proper graph, then in that case what you do is you come here and look for node exporter dashboard, Grafana dashboard. You'll get an official Grafana dashboard here this way. You'll copy the IE to the clipboard, come here, come to the dashboard, click on new dashboard, click on import, copy and paste the ID and click on load. Provide a name, node exporter for April 20 infra. Select a data source, Prometheus. Prometheus is the data source which is going to provide insights to the new dashboard. Click on import. My dashboard has been created successfully. See, my CPU is not busy. It is just having 0.700%. My system load is 0% right now. These two are same. You can delete any one of them. These are duplicates. So you can just try deleting it. You'll have it option over here. Edit. You have an option to delete it here itself. Remove. Okay. This is the RAM used. Increase the sizes. The swap memory. The root used. The CPU cores. How many cores? 2 cores. Uptime from last 1.5 hours. This computer is up and running. RAM 4 GB. Okay. Swap memory 0 GB. This is once again the same one, so you can remove it. Remove the unnecessary information that you don't want. Then coming to the CPU memory and net disk. Okay, so you can see over here the CPU basic details, the memory basic details, the network traffic basis, what is the network incoming and outflow. Okay, disk space used basic. Okay, then you have CPU memory net disk, system processes. Now you here you get the better details. Okay, like the green memory that has been used in the memory stack is by applications. Yellow one is used by the page tables. Blue one is the swap cache, which is negligible. That is why here the swap cache is 0. Okay, So different disk input output rate, what is going to be. So the entire your CPU detail is present in front of you right now. How these are being displayed to you in such a graphical way, question when you will have it in your mind. You need to just simply come here. You need to click on explore. Now when you will click on this, okay, we'll just save it first. Okay. You can see here the POM QL is written at the back end. Can you see everyone? So it's not a dashboard only. Somewhere for every dashboard that you are seeing, for every dashboard that you are seeing here in such a versatile way, okay, this way, let's say, node exporter, the second dashboard, if you are able to see this option, this kind of graph, the reason here being is this query, and then the mode of things that have been selected over here. So the stack lines, let's say if I will change it for last 30 minutes, you will change the graph. You'll see the different graph. Last 15 minutes, correct. I'll just click on run query. So last 15 minutes, it will show this data. I'll come back to my dashboard, and if I'll give a refresh, you will see different data over here. Okay, let's say you do not want to display it like network traffic basis. It is being shown for how much? Come here, click on explore. It is showing you for last 3 hours, and these are the queries. The queries are something either you learn POM QL in very detail separately, or as I have shown you, it is already available in today's world. Okay, you just need to go ahead and find out the correct sources. So when I make it for 15 minutes, you can see this has been changed. This query has been changed. Now, if I want to run it, okay, and add it into the dashboard, you select add to the dashboard, existing dashboard. For the last 15 minutes, it will be added in the same dashboard. Click on open dashboard. You can see a new query has been added over here. See the network details, the receiving input output, the sending output, everything. And even you can see this network traffic basis. Now it is showing you for how much? For last 15 minutes. For last 15 minutes. Either you edit one by one. If you want a specific graph to show you a specific detail, you need to open it, explore it, and then check it. Otherwise, you can simply change this directly to last 30 minutes. Okay. Last 5 minutes. The graphs will go ahead and change it. So this is how you create dashboards, and you keep monitoring the details that you want. You'll have all the memory details, the backend details, okay? Now in this way, what you can do for your practice, you can target some other service. I've used EC2. First of all, you can try the same thing, okay? Exploring and checking the things in detail. Otherwise, you can look for other services as well. Try to create POMQL queries. However, the connectivity remains the same way. You'll come to the explore, write a POMQL query, and you would be able to see the results. Just like here, let's say I come here to dashboards. Within dashboard, I want to see the RAM used. I will copy the query of it. I'll open it. I'll get to know that here, okay, this is the query for RAM. I'll come back to my own dashboard, explore section. I'll run this. I'll click on run query. Okay, we have to go ahead and select this first as well. The metrics browser. The metrics from where it has to run. Okay, this, the labels, the instance, the job, the node. It's a node memory. Let me select the node memory. Node memory. Met total bytes. Let's say per CPU bytes. We'll just run it for node memory per CPU bytes. Okay. Fine, we'll come back here. Okay. So see, there is one more thing that can be done here. Let's say you have this RAM used. As soon as your PC will go ahead and the RAM will be utilized more. Here you would see a change in this graph. Okay. And let me show you that as well. For that, you can do stress testing. You can do stress testing for that. So just install apt stress, the application that increases the load on your system, and then run the stress test. And we'll see in our dashboard whether it is working for the real time or not. We'll come to our dashboard. I'll close the excessive links. Very nice. This should go ahead and change. The system load, the RAM used, This will slowly change. We can also select the refresh in every 15 seconds. However, we should not change it very oftenly. So this Grafana dashboard is automatically going to refresh every 30 seconds. And since our machine has a continuous load right now on it, you will see the changes over here. You'll see the changes over here. We'll give a refresh. RAM changed to 15 to 16%. Can you see the CPU busy? Can everyone see the CPU busy? It was hardly few percentage was there, 1 to 2%, I believe. But now it has been changed to 75%. 75%. But this is how the connectivity is done in the Prometheus. You will see the various changes. Okay. You will keep watching here, like no, keep giving the refresh, and you will see the different updates over here. So that is how basically you track your system. The system load is now 71.5%. So this will keep on increasing. The load will keep on increasing. Okay. So once you have set up Prometheus, a node exporter and a Grafana properly, you would be able to go ahead and get the details of it, of your entire infrastructure. You can track. Okay, the CPU got 100%, you might have to add more CPUs, or you might have to go ahead and get into the EC2. Okay, and you have to go ahead and see which process is utilizing more thing. In case if it is not important, you have to delete it. Okay, so let's say if I'll do here the control X or the control C, I've stopped the process. Since I have stopped the process, that should go down. It should slowly it should go down. Can you see the CPU percentage is 64? So that is what, in case if you are going ahead and becoming a DevOps engineer in the future, and you have to monitor all these things, you would be able to find out all the infrastructure details. You will explore it time by time. What are these details? Okay. However, you can see this green shows idle. Okay. The purple shows busy other. The yellow line that you have here has a different thing, busy system. So the values that you can see, the low weight, you don't have it. The low weight is the one which means your computer is not able to process anything in a complete hang state. So slowly, the graphs would change. You would get to know a lot of things. Okay. So, however, this is how you go ahead and use Prometheus and Grafana together, observing your entire infrastructure. Okay. Now, one more thing, the alerts I am going to tell you. So, you can go ahead and set up the alerts as well. Okay. So, creating an alert. So, let's say you want to have an alert when the system loads, with the system load exceeds 90%. So what I'll do is I'll edit it. I'll take the query. The into 100 that you see over here is in the percentage form. So what you are checking, average node load, the load of your instance, which is marked as node, and the job is job. Okay. Count, basically this is another query where you are checking that, okay, what is the total CPU per second count over there. Okay. Into the percentage you are getting. So in case if you want to create alerts, you will come to the alerts, and in the alert you have to create a new alert. Come to the alerts, click on new alert rule. New recording rule is also there in Grafana, which means what was happening on this screen, what was happening on the system would be recorded as well for you. So you'll come to new alert rule. In this alert rule, you will give a name. Let's say system load alert. The data source is Prometheus query. For the system load, you can mention the query. Okay. And what you will mention here, when the query is exceeding 90%, one thing, add folders and labels. You have to add a folder where your alert records will be saved. Okay. So click on new folder, click on alerts, create. You also have to create an evaluation behavior, evaluation group, how it would be evaluated. Alerts evaluated, create. Then configuration, where would you like to have the alerts on your mail? So let's say viewer create contact points. In the contact point, you can set up your contacts, edit, give your email ID. Let's say email, and you'll be giving your email ID, let's say akshit@gmail.com. You'll click on save, connect. Okay. You'll come back to the alert, come to the manage alert groups, new alert rule. Once again, we have to fill this option, custom alert, Prometheus, metrics browsers, let's say system load, or they say CPU, node memory per CPU bytes, or processor CPU seconds. Condition. So here you can see this. I'll just add 2, or let's say 90%. Select a folder, alerts that you created, evaluation group, create a new evaluation group, alerts evaluated. Choose the contact point email, any notification message, review alert, required immediately. Enter a description, looks like CPU has spent 90% on users and other activities. That's all. You'll click on save rule and exit. Save rule and exit. So you will have an alert. Right now this alert is a normal state, is in the normal state. Once it reaches to, it exceeds the 90% of the CPU load, it will be converted into a firing state, CPU percentage. But for that, it should go ahead and pass this. That is your 90% of the process CPU load. Just open it. So here we can also add queries, or let me go to another dashboard where we have created the dashboard, this dashboard. In this dashboard we created, we'll open this edit, and this was for node CPU seconds total. So let's see what does the graph says. We'll change it to bar chart. We can also change it to stats. We can change it to the pie chart. What are the total seconds? What are the total usages? We have different options. The blue line shows the mode is steel. The pink, the purple is the user one. Okay. So the load is not still, it's up to only, I believe it's not up to the 90% of it. So alert will not be triggered in such case. But yes, once it reaches, it is going to trigger your alert. So you can go to the dashboard, go to the alerts. So here it is not showing you anything, alert rules, custom alerts, and you can see over here. It is a normal condition right now. Once it is above 90, it is the threshold is going to be above 90. It is going to generate the alert in the most firing, in the firing mode. However, as for now, it hasn't. Okay, then in that case, I'll just ask you guys that, okay, please try to explore Prometheus and Grafana from your end as well, because there would be many PromQL queries. There could be different requirements that you might have to search it from your end. Okay, that what actually you need, whether you need RAM memory, whether you want CPU average, whether you want CPU max. So based on such requirements, you are going to go ahead and write the PromQL queries, and then you are going to check it as well. Okay, so that is what the Prometheus and Grafana and this session was all about. Okay.
So I hope you understood how this all fit and work together in a DevOps workflow. So let's take a quick recap of what we learned. So we started with the Git to manage our code, used Docker to package the code, Jenkins to automate the deployments and building of the code, Terraform to spin up the infrastructure, and finally Prometheus and Grafana to keep an eye on everything. And that's the DevOps infinite loop in action, where we code, ship, run and observe continuously on repeat. Every tool plays its part, but it's how all they work together, and that really brings DevOps to life. And once this flow is set up, the teams can move faster, catch the problems earlier, and spend less time on fixing and more time on the building. And that's the real power of DevOps. It's not just tools, but a mindset backed by automation, collaboration, and continuous improvement. So that's it for this session. Kindly hit the like and subscribe button if you liked the video.